it is. They're 500 kilometers each, and then these squares are subdivided into smaller squares, subdivided smaller squares. But there's the grand big square, which is like 2,500 by 2,500 kilometers, and it's surveyed flat using 90-degree angles, not spherical geometry. But they slap it on a globe. I can show you a picture of what that looks like when they slap it on a globe. Give me a second. It's actually pretty instructive and visually shows what we're talking about, because there are a lot of points embedded within this image that we can get into. Give me just a minute. I'm scrolling. I know I've got it right here. It's an ocean of content in my shared drive. Here we go.
Do you know what ratio scaling is?
Ratio scaling? Yeah, like you've got maps of different scales.
No, not maths. Sorry, not math. Sorry, but like in math in general, like ratio scaling.
Yeah, like you'd use for projected geometry.
Yeah. Well, you could use for, like, I guess, any numbering system. It doesn't really matter. But when I look at how this is derived, which is WGS84, which I know you mentioned it's derived from, right? Like, you didn't refute that.
It's derived from the
scale
stars.
Any points on this back and forth. Like, if it's derived from WGS84, but then it's
not derived from. It's not derived from. WGS84 is itself derived from the stars, but the survey's done using 90-degree angles. That's flat. You can overlay a spherical coordinate reference system like WGS84 onto it, and you're not going to get the same coordinates. I mean, that's what was depicted by DJ up here. You can see latitude and longitude, just like with the image that I slapped down there. Look where the prime meridian is. Look at all the parallel squares to the prime meridian.
This probably doesn't mean much to you. I recall in a previous job I had, I was automating sitemap generation. You know what a sitemap is, right?
Mm-hmm.
And I was using like satellite imagery purchased from the US government at the time, which I believe was 3-inch scale, which is super high definition. I recall using that imagery relative to the survey maps they would give us from like the California government at the time. And I could just directly convert back and forth with like no issues.
Yeah, coordinates are arbitrary. Just like with GIS, you can choose any number of 100 different datums, different reference ellipsoids.
Yeah.
They don't match each other. You can also use a flat datum. You can use and import a moon datum.
Yeah, sorry, that's kind of what I was getting at, is that I could just flatten the GIS data and then project that on like, satellite imagery.
Yeah. You could, but you won't have verified measured distances that way.
It was accurate enough for like
how do you know?
Half a meter. Oh, we tested this because physically.
Hold on. Half a meter. Yeah, I get that, but hold on. How do you know where you are in the first instance? If you're going to invoking,
I was just giving the example of like the sitemap drawer.
Yes, it's circular.
Like No, I'm not. Okay, so what I was meaning is like I can convert back and forth like pretty accurately. Like, so what I was getting at is this coordinate system is derived from. But then if you say it's not, it's like I recall doing when I did the sitemap generation. I took the high quality imagery. I took the essentially the boundaries of you know what a parcel map is, or no?
Yeah.
Yeah. I took the like boundaries of the parcel maps, and then I projected that so I could like line up the imagery. It's not perfect. It's like for about half a meter, but it was accurate enough for like rough site plan generation, and like I could use like image detection at the time. So what I'm curious about is if these things line up like perfectly, and I'm using the external data. How did the like what do you mean by like the flat map is perfect? Like how does satellites work in this case?
Also, perfect within what error bound mean and over what distance, because errors are going to propagate. So like you begin with a square mile that's on a flat surface, it's going to be about 99.77% as flat as a curving parcel on a globe that's 1 mile by 1 mile. And that error gets bigger the more you stretch out. So, I mean, at a local level, it's going to be statistically insignificant whether you're using a flat or a globe datum. I mean, nobody disputes that part. Now, how do satellites work? Well, satellites bake in a lot of the circular reasoning we were talking about, like with GPS. Now, I don't mean the satellites themselves, it's more about the receivers. The receivers receive range timing signals from GPS, bleepity bleepity bleep with their packets in them. Also coming in from them is information from the ephemeris and the nautical almanac, which itself is computed based off of spherical assumptions. But the bleepity bleeps can be mathematically computed to work on any topological surface you want, flat or globe or lunar. So it's arbitrary. As long as you have one coordinate reference system and you stick with it, it will be internally consistent. And what we run into is people that claim that they validated those distances given by the coordinates using the same coordinate reference system in the first place. What we need is an external validation of those distances of the coordinate reference system.
I mean, I went and physically checked like survey pegs in real life after doing this. It's pretty accurate.
Yeah, like so there's broadly two kinds of surveying. There's planar surveying and geodesy. You're probably familiar with both. And geodesy is foundationally derived from combining astronomy with planar surveying.
Okay.
So latitude and longitude historically are derived only from the stars and humans' perception of them in the celestial sphere. We're kind of back to that conversation.
Okay.
There's no other way to get latitude and longitude without invoking the stars. And this includes the sun, particularly for longitude. It's very helpful. And clocks.
As you say, it's derived from the stars for lat and long?
Absolutely. Your latitude is based off of an elevation angle to Polaris. And your longitude is derived from where the sun is at its peak in the sky at your time relative to Greenwich Mean Time or some other prime meridian that you can use. I mean, and a calculation of hours and angles based off of that.
I mean, that might have been originally, but nowadays they say they base it off the shape of the planet.
Well, yeah, they projected the sky onto the sphere using the logarithm tables that I mentioned. This gets back to that. The globe was created out of math, based off of humans perceiving the sky and choosing to perceive it a certain way. That's all the globe is. And for the past few hundred years, everybody has been trying to shoehorn planar geometry, planar surveys into this concept over and over and over again. And they make a fallacious assumption that just because the coordinate system they created out of math works, that the globe is actually the Earth itself that they're walking on. That is the map territory problem in philosophy and semiotics. That's affirming the consequent in philosophy. That's mathematical underdeterminism and the philosophy of mathematics and the philosophy of science. Okay. This is fallacious thinking. And when we measure it flat and observe it flat, especially as DJ has shown, we're debunking that logical process with empirical evidence.
So deriving that, we're on a ball because there's other balls above us is what you're refuting? Is that correct?
We're refuting the reification of the globe from astronomical surveys. with terrestrial measurements. That's as succinctly as I can put it. That's what we do in 24/7. Sets us apart from all these other crazy flat Earth groups.
So what does reification mean? I don't think I've heard that word before.
Concept reification is when somebody imagines something to be true so much with such detail and conviction that they conclude it has to be true.
So it's essentially willing the truth. So it's like
ever have a delusional girlfriend?
I mean, I'm not trying to shit on religion. Sorry, I'm not trying to like shit on religion, but it's like religious people, right? It's like
totally.
It exists because it has to exist. Yeah,
totally. That is the globe problem in a nutshell. And believe me, it is harder. Listen, I didn't come at this easy. I've been looking into flat Earth for about 5 years. I came in at this hard and very skeptical, man. It's been harder for me to accept that the whole world is apparently delusional with this reification fallacy than it is to accept the hard empirical evidence of a flat stationary existence that I know to be true. It's harder for me to accept that the world is fucking crazy than it is to accept that reality is exactly as I see it. That bothers me a great deal. Because I know how the globe was created. I just described it to you out of math and philosophy. And I know what reality is based off of my firsthand real-world measurements that I've done, which comport to all the others that we've done in our community. And I have read the claims of other people who say that they've measured the globe, and I understand how their concept reification factors into their claimed globe measurements. I understand how the field of geodesy works, which uses the globe to contort planar surveys to a mathematical datum.
Okay, so the whole debunk the globe argument comes down to the fact that they assumed it was a globe and then did the projections and then used the math to essentially just infer what they thought to already be true. Is that correct?
That's correct. And it hasn't stopped there. It hasn't been perfect. So over time, they started to introduce all these ad hoc patches. Think of it like new downloadable content for the globe for the past 100 years. This includes astronomical refraction models that are not based on reality.
You would revisit things, right? Like to make sure it's correct. Like if you come up with a technology. Oh, I lost them.
I heard you cutting out while you were talking just then. I wasn't sure if it was on my end or.
I said, wouldn't you revisit like what you deem to be true every now and again when new technology comes out just to confirm it?
Yeah, like I'd like to do that. I mean, I'd like to see if somebody can present me compelling globe evidence and dispel flat Earth thing. I'd be done with flat Earth overnight, man.
What would be compelling evidence, I guess, in your eyes?
Well, based off of what I've seen, what it will take is a verifiable surface measurement. Okay, so what I was saying before, like the globe concept initially, when it was conceived, wasn't perfect, and they've had to do ad hoc patch updates to make it work.
Well, astronomical refraction things when new technology comes out, right?
Well, hold on. They had to introduce unfalsifiable ad hoc explanations. Refraction models that exhibit no physical component in reality, comporting to anything that we experience meteorologically, like what DJ was saying. Refraction conditions, for example, that are unsupported by the weather conditions that are present. That's one. Secondly, the stars not comporting to a sphere as exactly as they need. So they choose like 57 of them. Call those the navigation stars. Highly selected, gives you a limited field of view of the sky. And then, when the stars do not come to their appointed time where they should be for Earth to be a globe, they introduce the geoid. That's right, the gravimetric model of the globe, which is based off a reference ellipsoid in the first instance, where they assume that gravity is distorting starlight, and this helps them adjust latitude and longitude.
Okay.
This has been going on. We can go through history and look at all these ad hoc, unfalsifiable explanations and see what is happening. It tells a tale of people trying to shoehorn all their observations into a globe model.
Okay.
Their magnetic profiling of Earth doesn't comport to a globe. It comports more to a flat Earth. And this is a problem in like satellite geodesy, where they do study Earth's magnetic field and Earth's gravimetric readings, and they don't fit with each other. Gravimetric meaning...
Okay, that one.
What? Yeah?
That one. There's gravimetric readings.
Yeah.
So you're telling me that let's see, okay, you said gravimetric. I was thinking electromagnetic.
No.
Okay. Never mind.
Okay. So the gravity geoid lumpy ball of Earth with its lumpy spherical harmonics don't produce the geometry that's supportable by the magnetic profile of the Earth as a globe. And throughout the literature, they're
yes,
like,
it does.
Look, no, it doesn't. I can provide examples. It happens time and time again.
You said magnetic.
Yeah,
I can provide examples too.
Okay.
Yeah,
okay.
Hold on a second, because we're having a conversation with
Okay, I'm sorry. I'll be quiet.
Yeah, with the other guy. So yeah, you can go after him.
I mean, I've got some interesting, like a Himalaya study. I've got some satellite studies that were done where the two models don't fit, but we can get back to that later. I've also got to go to work in about 20 minutes.
Sorry, what was his question in the immediate? I'm actually curious.
Yeah, go ahead, Ryan.
It'll take more than 20 minutes, and because of what he's talking about, I'll have to pull up the research. I think that one of the easiest people, YouTube suspicious observers, and watch some of their videos. That'd be the easiest thing for me to do. I could just post a link.
Yeah, I'm familiar with Ben Davidson, and I understand some heliophysics. So,
okay.
What about it?
The other planets instead of our solar system, including the stars and outside of our solar system, and the pole shifts are, what do you call this? Observable? Measurable?
Yeah, within an interpretive frame, you can reinterpret the frame towards a flat cosmology. And you still don't have the dynamic components, the actual physical causes of any of these things. Like the pole shifts and the magnetic coupling of Earth's magnetic field with the sun and all of that can still be happening. Just got to alter the coordinate frame of reference.
Okay.
Because we don't have any dynamic measurements. Oh, so hold on. Because we don't have any dynamic measurements of anything in space physics that's verifiable, because it's all saddled with the same problems that I was explaining previously with regards to the coordinate reference system of Earth, which are actually propagated outward into orbital models for space physics, because we don't have any verified physics of any of this stuff. It's all calculated based off of kinematic models and not dynamic models. We can easily alter the coordinate reference frames towards a flat cosmology and preserve the effects that we see, just understanding them in a different way. So anyway, on to the Southern Cross? Yeah, so that's about, is that 23 or 25 degrees or so off of Sigma Octantis?
So there are multiple islands in the south, like you can see it from Hawaii. But Hawaii,
yeah, I used to live there. I used to see it from Hawaii on my backyard.
It just depends on the time of the year. Like sometimes throughout the year you can see it, sometimes you can't. But it's on the horizon. But you can observe it from the southern islands, and I enjoy listening to you. Most people I talk to here are I just get straight muted.
Right. No, I got you. The reason why the Southern Cross
at least
is visible,
you can talk.
Yeah. The Southern Cross is visible from the Tropic of Cancer because the northernmost extent of the Southern Cross is offset by the same degrees in the sky as the Tropic of Cancer.
All right, so the Earth is at an angle as it rotates, according to the spherical model.
Right.
Which would allow...
And call it flat Earth, the ecliptic is moving north and south in the sky.
Right.
Same thing. We observe the ecliptic moving in the sky in reality. What needs to be proven is that Earth is a sphere that is tilted in an orbit.
What I'm saying is that virtually any time of year in these southern locations, there are different locations that you can be standing at in these areas so that you can observe at all times at one of these points. You know, if you're in one location in the south, you fly 5 hours in one direction, or just have a person standing on an island in the ocean. At any point, it will be nighttime in one of these areas. And any person from any of those areas can observe the Southern Cross in the sky, regardless of what time of year it is, as long as you are far south. I'm curious how that is explainable according to the flat Earth model, or how that's possible.
I'm curious what you're imagining. I'm curious what you're depicting in your head, because I could probably guess what it is, and I can tell you why it's not what.
No, I'm good. So I'm interested. Go ahead.
All right. So I'm imagining. I'm imagining you imagining that flat Earth is an azimuthal ecliptic.
Right.
Yeah. Right. So you envision flat Earth as a pizza map, right? Sorry. Flat Earth to you is a pizza map, correct?
Something like that, sure.
All right. All right. Sorry, I relogged so I could hear you better. Yeah. So pizza map. Okay. They show Antarctica as a ring around the furthest extent of the map. That's not flat Earth. That's not how people in here represent or discuss flat Earth. That is actually a globe. And it's displayed flat with a non-uniform scale. That ring of Antarctica, if you apply the scale of the map properly, because it's a globe representation, that ring around Antarctica is actually a single point. And the radial lines that come out from the center of the map, which are meridians, those are longitude. If you apply the scale, those are actually converging to that point at the farthest extent of the map. But many flat earthers don't understand this. They don't know that there's a little scale formation.
By any chance, is there any kind of data link? Or if you ever do, I'm highly interested. I'm not very good with big words. My IQ's stupid high, but I don't read. I listen to podcasts. I'm a truck driver.
I got you, man. So yeah, we got truck drivers in our community. I mean, what better way to exercise the brain than to go on a long haul with this conversation blaring in the background all day? This conversation's hard to have. If you're not used to talking about this, it's very difficult. It's exercising parts of your brain that you probably haven't had to use. Many of us didn't have to use prior to entering this. I mean, I was a hot mess when I first got involved with this. I didn't know my ass from my elbow. I had to learn a lot and gain experience having these kinds of discussions. And many of us are well practiced at this, but it didn't come easy and it didn't come naturally. I can tell you that much. So don't worry about that, man. It's okay. Now, as far as content goes, this is the best place to hear it. Really, I can't think of any other place on Earth that I'd want to listen to Flat Earth 24/7.
I listened to somebody give an explanation of a fourth dimensional hyperspace location as being the reason why they could see the point from any of the southern like in my model, any of the southern hemisphere locations, and that didn't make any sense to me. I mean, I understood what he was saying, but the reason in my head why that wouldn't make any sense to me is because based on the flat Earth model that I see with the pizza, with the pizza or with the sphere, a fourth dimensional hyperspace location would be observable regardless of where you were standing, no matter where you were.
Right.
The possibility of seeing it would be real regardless of where you're at. So I don't know if that's where you're going or not. I just wanted to save you some time. I'm not, like I said, I'm not good with big words, but I'm pretty damn good with concepts.
Sure. I was
you can dumb it
so
down,
I
I'll be able to follow you, no problem.
I brought this up a long time ago in the context of how GPS receivers chain together local tangent planes around a globe, because local tangent planes are flat geometrically. Absolutely. So how do you have a topology that is both flat and looping in all directions, x, y? And you need to invoke a higher spatial dimension in order to do that. And that's kind of how the Earth-centered, Earth-fixed concept works, because all points are going to be equidistant from the radius, and all points are also flat at the same time. So this is just, I'm not saying reality. Maybe somebody else heard what I was talking about and claimed that reality is exactly this. I mean, it sounds really cool, but there are going to be some obvious issues, like what you pointed out, if that indeed is the case. It means that you could look in one direction far enough and you'd see infinite instances of your own ass.
Right.
Nobody can do that with telescopes or anything. We hit like a cosmic microwave background.
Right.
Yeah, that's a big one. But we got the cosmic microwave background in the vertical dimension. So if that is the case, we couldn't prove it. So, and there may be something to that in itself, supporting the geometry, but this gets into crazy wild ass speculation.
Okay.
But yeah, I mean, mathematically, that's how they reconcile local tangent planes being chained together while also looping, is they use higher dimensional geometry. They have 4 spatial dimensions. That's really all that this ended with, was that it's a fascinating point, and it doesn't prove anything either way.
It is a hypothesis, a theory that
it's the mathematics.
It's necessarily been proven, but it is potentially possible.
I'd say distantly, remotely, potentially possible that reality is a looping manifold of some kind. Doesn't even have to be spherical if it is. If it's not, then oh well. But consider this though: the globe is already a looped manifold, just in 3 spatial dimensions. So the idea that you go in one direction and end up where you started, the globe is a Pac-Man Earth.
Well,
because the surface of the globe is 2 dimensions.
I've been studying religion, and the books of Enoch have references in it that I believe a lot of the stuff inside the books of Enoch, and one of them has a outline that really sounds a lot like a flat Earth to me.
Oh yeah, the Bible is full of people's descriptions of their world, the near Eastern cosmology itself, encompassing Mesopotamia and the surrounding areas, is a flat cosmology, and this goes back thousands and thousands of years. It's not a radical thing to suggest that. The what?
Mazzaroth or Mazzaroth.
The Mazzaroth.
I was just curious. Yeah. So most of the stuff I see in the Bible, I should have heard about,
but I don't know.
Most of the stuff I read in the Bible, whenever it talks about stars, and there's ridiculous quantities of symbolism. There are a lot of references to it. And I've debunked in my head how like a lot of different things could be this. It could also be this. It could be this too. Like the four corners, it is where the land was divided between Noah and the sons, and that those 4 points where the rivers were would be the four corners that where the land was divided. Like there's the pillars that the earth is on. Like there's a whole bunch of stuff I've gone through. I'm sorry, ADHD. I'm bouncing around because I've had a lot of questions in my head.
I got a gift for you. Man. This is an old book with beautiful line drawings and great references called The Earliest Cosmologies. And it's a comparative study of all the cosmologies of antiquity, from Egypt to Babylon to the Far East to the Nordics. It's a gorgeous book. I've got it in PDF. It's in the public domain. I'd like to link you to it.
I don't read too much, but if it's audio, there's
it's not audio, but
oh, it's gonna be rough. I work like 60 hours a week. When I'm not driving, I'm at my house, right, with my kids. It's gonna be rough. I'll look it up. There's a book called the Oahspe that describes how gravity and electromagnetism, what keeps Earth in its rotation. This is global model, right? It describes events that explain revelation, the different color horses. I know Ben Davidson goes over some of it. But the Oahspe has a much more detailed scientific explanation for all this stuff, and I don't know why, physicists and whoever else, it's like they've never seen it before. It's written by a dentist in a really short period of time. He said he was inspired when he wrote it, but whatever. He talks about the galactic current sheet, that as it approaches, that the electromagnetic field around our solar system will weaken, and that the poles will begin to shift on the planets, and of course the sun's poles flip according to outsider science, would flip every 11 years, but the fields of all the planets will weaken, and causing the Earth to potentially wobble to and fro, toss and turn. It explains. Anyhow, the sun would, the different colors, the sun would change. It explains many novas. It explains mass debris fields coming in, and anyway, it's really interesting. It's OAHSPE. Very long book, and just for times, just to save time, I would skip to the cosmology sections of it. The rest of it,
okay.
Eh.
I mean, listen, there may be some kind of, like, call it a pole flip, but consider how, if you were to transform the reference frames, how that would look on a flat Earth.
Exactly.
Right?
It's on a flat Earth, same thing. Yeah. You're right.
The stars would end up rising from, like, the south and setting in the north.
You're right.
And there would be a point potentially in the north that you could go to, or point potentially in the east you would go to, which is your new north, and stare straight up and see a new pole star that's staying fixed in its location, and all the stars in that area appear to be rotating around that. And there's some suggestion geologically that Earth's magnetic field was about 90 degrees oriented from its current position. There's some geology, right, some rocks that bear this out, and some people have determined where the old North Pole would have been, and I think it's somewhere east of Madagascar.
Yeah, I'm familiar with all those too.
Like
there's another one that's interesting to consider too, about what the sky used to look like. You're probably familiar with this one if you're familiar with the suspicious observers. This goes more along the lines of flat Earth. Let's see, the Sapphire Project.
Is that the plasma cosmology people?
I think is what it's called. I think so. Yeah, I think so. Where the sky used to be purple or something.
Wall Thornhill.
All the planets used to be lined up in a straight line, and you could see. That sounds right. Yeah. Anyhow, I don't have any more input with any of that stuff.
It's cool, man.
I'd like
we all
to
look
see
at the
this,
same weird shit as you do, so don't worry. I gotta go. Pleasure talking to you.
dude,
Hope you
thank
hang
for
out with
talking like
us.
a person instead of like the aggressive dudes. Hey,
No
let's
problem.
see. Was it Master Yoder? Earliest cosmologies. Okay, awesome. Thank you. Yeah, I'll go grab a link for the other one. Thank you. Thank you for
For
talking.
long haul trucking, there's an app called Speechify that uses AI to read PDFs, and it's way better than like anything else out there. It costs money, but you can slap a PDF into there, go to archive.org, download the PDF, throw it in, and then it'll read to you. And it doesn't sound robotic.
Dude,
it skips over
thank
footnotes. Speechify. Yeah.
It's literally pulling it up right now.
All right. All right, man. Take care. I'm going to be listening.
Thank you.
I can't talk, but hope you have a good day.
Copy. Ditto. Same.
How's everyone doing?
Pulling up Speechify.
Yeah, I'm here. Oh, not much, but we're tired.
What brings you to this channel? Curiosity?
No, I was talking of you guys earlier.
Okay. What was the conversation of? What was in here?
Oh, sorry?
what was your conversation of? I wasn't here.
Oh, sorry, I didn't realize you were here. I was talking to Master Yoda, and I was asking him about his worldview. It was like I came to the conclusion that trying to use like photos and whatever else is not relevant. So I was just curious what the actual like model that you guys follow is, because I know there's a few competing ones in flat Earth spaces that I've spoken to people about.
Yeah, there's a lot of people that claim that the Earth is flat, and then they have different perspectives on how they relay information to the public. So it just depends what forum you were on. So in this forum, however, we're describing the Earth as it is seen outside and witnessed by an observer. So you can go outside and see the Earth for yourself. You don't need to cling to some idea of a construct, like some mathematical model, or perhaps, some sort. That we were saying.
No, because I spoke to people in here like 3 years ago.
Wonderful. But what
anyway.
I like, yes, like I hate to say
I'm not trying to argue.
like,
I was just saying that
I know you're not trying to argue, but I'm saying though, like, so what? Like, what is the end game for what you're bringing forward? Like, are you wishing to figure out if we think that now?
I was just talking to you guys. I was just asking what models you guys use, or like what you guys believe in, because I've observed that it's changed over the years. So I was saying that's the whole point.
So it's okay. So it's a stereotype fallacy. You're saying you guys, as in a community of everybody who says flat Earth, that doesn't work.
Well, I just mean this channel.
Well, this channel as well. Like, there's many individuals in this channel that would adhere to what you might say is the idea that people are saying flat Earth is. Should be like some sort of pizza disc idea. I get it. But I'm telling you that people in here right now wouldn't adhere to that.
Yeah, I didn't say the people in here right now did.
Okay, so now that we got that out of the way, what is that it?
Well, no, you just went on a tangent about something unrelated.
No, this is related. Your question was, what do you guys adhere to? A pizza disc? And I'm like, no.
I didn't say.
So how is that a tangent
you brought up
unrelated,
pizza
sir?
Disc.
Yeah, how is that a tangent unrelated? I'm specifically directly answering your
Because you asked
question.
me like if it was the AE map, and I was like, no, because I remembered the map it was.
Okay,
it was,
then clarify what it is. Like, Bled, just all you gotta do is just say,
let me
this is what I'm...
dude. You're arguing right now.
Wait, talking is showing? I don't get it. Like, what do you mean?
Dude, you're arguing right now. I wasn't arguing.
Yeah.
Like, be respectful.
Okay, you're just not gonna police the tone that's going on in this room. All it's being asked from you, Bled, is to clarify what you mean. Do you mean that you're gonna present something in the text chat? Well, what is it? I just really want to get to the bottom of, like, what are you asking? Are you asking if we adhere to a model now? It's really
Why
not...
are you putting words in my mouth, dude?
He's asking for you to use words. He's only talking because he wants you to clarify. Now, can you do it?
Okay, I talk now. Anyways, I remember historically when I talked to people in here, they showed me a modified Azuma map.
Okay, time out. We've walked past that.
Yes, you asked me what map it was referred to. I just answered the map. That was it, dude. That was the whole question. You just went on a tangent.
What map was that, dude? You didn't present any map. Like, I'm still waiting for it.
I was telling you the name of the map.
What was it?
Oh my god. It was the modified Azumaful map.
He referred to it as the AE pizza map. That's how he referred to it, actually.
Hey, say your accent's a bit heavy. Modified Azumaful? Is that what you said? Is that what he said, Jedi? I can't hear the bloke.
Yeah, that's what he said.
Okay. Yeah. Okay. Yeah. Congratulations. Now you said the map. Right. We don't adhere to that. Good.
Yeah. I could tell that I just spoke to Yoda before.
Okay, that's good. Now what?
Dude, why are you being argumentative right now?
I'm not, dude. I'm just saying, what's next? Like, is that it? Like, we just wanted to know if we adhere to that Azumaful map. It should be Azumaful equidistant projection. But you probably don't know the full of it. Thanks for that. You could mute up when you do that, J-Dog.
Dude.
What'd you say?
Look on the chat, raised by goats.
Okay, so then why is he asking that now?
Yeah, I don't know. Why can't he just use his words?
Ask about the map.
He doesn't. If he spoke to him for 2 hours,
once again,
and he knows there's no pizza earthers in here, that raised by goats was here.
Words in my mouth.
I'm reading what he's saying, dude. He said he spoke to Sporadic for 2 hours solid.
Again,
he knows there's no pizza earthers in here.
You're putting words in my mouth.
Okay.
He's just reading what was said. This is really confusing.
Yeah, guy's
Massive
emotional.
Respawn from Blair. What do you mean respawn?
Oh, what's he on about? What does he want?
I don't know. He's distracted, dude.
Okay, well, I asked before, what you guys believe in, as in you in this case, right?
He's resetting. Is it literally resetting? I'm asking for you guys what you're asking for. Dude, we've already gone past that. I'm like, if you spoke to Sporadic,
dude, I'm not asking about the shape of a map. I was asking what sort of philosophy you go by in this case, because everyone I've spoken to today has different ideas.
That's great. Philosophy is a different thing than a map. Yeah, it's a different thing. It's not the same. Now you're asking for a philosophy. Right?
You're bad at this, dude. You're talking down to me.
I'm bad at this? I'm repeating what you're saying.
Dude, all you're doing is talking down to people.
I'm not talking down, bro. I'm like, this guy's
I had a peaceful conversation with the other guy. You're not being respectful.
A decent conversation. What is going on, man?
He asked us for a model, didn't he, as well? He did ask for the model, didn't you? Blah is your name, is it? Or Glenn, what is your name? I didn't catch it. Sorry. You did ask for a model. What was our worldview and model? Do you remember?
Yeah, I asked for like a worldview, and then you guys said observation.
Yeah.
Worldview?
Yeah.
What do you mean by worldview?
Good luck today.
Dude, why are you trying to soundbite me right now?
What? It's like
No,
you
it's
said
a valid
that. I want to know
question.
what you mean by that. That's all.
Yeah, it's a valid question. You know,
Okay, so the other guy I asked
we're really
him
not
about.
being antagonistic. Okay, that's not our way. We're not being antagonistic. We're being
One of
sincere.
you are.
Yeah,
Let
he
talk.
thinks we are. He thinks just
Well,
like
AV
want to have a
is being
conversation with
antagonistic.
it. Bro, I just want to ask like questions, and it's like I'm clarifying for the audience what's going on. And it's like you're being like a precious little princess, dude. Oh, you guys are just this and that. I'm like,
No,
bro,
you
just
are
have a
being
conversation,
antagonistic.
man.
If I spoke to you
I
like
still
this, you'd be
want to
upset
know
with me.
what you mean. Can you explain what you mean, please?
By worldview?
Yeah.
Okay. Well, the last guy I asked why he was a flat earther, and I went through his whole belief system, right? And with Yoda, he explained that the reason that he believes that the globe earthers are wrong is because they started with the presumption that the earth was a globe, right? And then they did mathematic projections, and then they answer the questions by using the presumption it's a globe. Okay? That's what I got off of Yoda. So when I asked about you guys, because you're different people, right? Would you agree you're not the same person?
Okay.
No,
I'm with you. Don't have to be facetious, but I'm with you.
Jedi, wasn't he asking what he was asking Yoda, what worldview he has? And then Yoda was saying that he was talking about the globe, which is not Yoda's worldview.
Yeah.
He's getting a little confused. Like,
if you want to ask the question, why do you guys say that the Earth is flat? That might be a simpler question for people to ask instead of what's your worldview.
That's a bit malformed, yeah.
So, do you want to know why people like us say that the Earth is flat? Is that what you really want to know?
I mean, that's what I was asking the whole time.
Yeah, I know. So this is why I'm having the conversation with you, because it feels like I have to decipher some kind of cryptic clue. So you're actually asking, why do we say the Earth is flat then, aren't you?
Can you not be aggressive?
What?
Right, I'm going to go walk the dog. Dude. What's the fucking point?
He's not being aggressive whatsoever at all.
Let me have a word with him. Let me have a word with him, please. Let me just have a word with him. Look, your name is your name Blah? Please help me here.
I mean, you can say it however you want. It's a four-letter word.
Yeah, can you pronounce it for me, please? Please.
Blair.
Blair. Thank you very much. Okay, so Blair. So Blair, right? Basically, when you ask the question, what is your worldview? That's not relating to the topic matter as such. It's like you could be talking politics or something, philosophy and things like that.
Well, so it's inferred if we're in a flat earth chat.
Cut him off. Don't cut him off. Don't cut him off.
Please let me finish. That's all. Remember, I'm being sincere to you. I'm not being. I don't think I'm better than you. Put it that way. Right? I'm just trying to reach you. My colleague Jedi just explained to you that, and Miggy here, AV, that the question was malformed, which can give you a wrong response to your question. So basically, you want to know why flat earthers are saying the earth is flat. Okay, now, one thing you must remember is this. Flat earthers don't believe the earth is flat. So please sear that into your brain. We don't carry the belief of the flat earth. We actually know it from the tests that we have done and observations, okay? That's all I'm going to say. And I'm going to put you back into the hands of Miggy and Jedi to actually try and have this, because I know it's going to be a good one. Just take your time. They're not being antagonistic to you. Please drop that. It's not what we do here. All right? Sorry about that, Blair. Accept my apologies. Thank you.
Okay. Yeah, I mean, Jedi got a bit frustrated because he really was just trying to have a conversation with you. And so where we're at with this is, people come in here and it seems like the questions they're trying to ask, they're malformed. They're not asking directly what they really mean. And I think it's hidden behind the fact that they don't want to be held accountable for things they say. I'll give you an example. There was people that come in here and ask us about time zones. How do time zones work on a flat earth? That question is malformed. They're asking about a day and night cycle. How does that work? How does the sun and moon react to the Earth being a horizontal plane versus the idea of it being a globe. So there's a distinction of like the type of way to ask a question. So some people have to decipher what you mean by what you say. That's what Jedi was doing with you. That's all he was doing. And, you know, it's like you didn't want to relay straightforward what you mean. And that's all we need. We need clarity. We need to know what the person's saying so that we can respond correctly to their questions. That's it. And I was laughing because it's like, dude, it seems like people that come in here, they have to be very cryptic in what they're saying because they're tiptoeing around, like not saying the wrong thing. But if you're not afraid and if you want to speak the truth, then you don't have to be tiptoeing. You just say straight up what it is. Straightforward, straight up. This is how it is. I'm asking this question. That's it. It should be simple, but I don't know. You don't have to feel like everybody's aggressive or whatever. Just, I guess have a normal conversation with people.
I had a normal conversation with the other guy.
Yeah, you've already mentioned that, dude.
Yeah, I know, dude.
You already mentioned that.
I don't know why you're going so in depth with this. Anyways. Actually, now I'm curious. How do time zones work in what you believe anyway? Because, yeah, how would that work in the model?
Do you mean about day and night? Once again, I'll clarify. Are you really meaning time zones or day and night cycle?
Oh, sorry. Yeah, day and night cycle, I guess, would be better in your case. I was just repeating the thing you said before.
I'll say that because I usually understand that the meaning behind that is you're trying to figure out how the sun and the moon operate on a horizontal plane, not the fact that we have trade and commerce business hours working. Like that's something different, you know? It's related, but it's not really the same because I'll tell you like this. It depends on where you are on the earth. You could be in the north, the far north, where they experience more daylight hours. And so they're going to be doing a lot of business, you know, during those daylight hours. But at the same time, if you're in the opposite direction and you're experiencing a lot of night, you still have, time zones are going to affect the reason how you do business. So that's something separate from like the actual sun and moon or daylight, nighttime, that sort of thing. Yeah, so geographically, it's kind of laid out as I guess if you go to timeanddate.com, you'd be able to see the path of the sun. So it's just used as a map, like a square map, and it puts the sun at a different part of the location geographically on the earth, like whatever country's experiencing daylight. But there's no real, how can I put this? The sun moving across the sky doesn't give us an indication of like a geometric shape, or doesn't tell us any information of anything about like the ground. It just shows us where the sun is at a particular time. So, and the sun is what really guides us into knowing what time somebody's experiencing daylight. So we're going based off of that. So I don't know if we're not. It doesn't have anything to do like, okay, so in the globe versus flat, like it doesn't have anything to do with the geometry of Earth, like because of the Earth being a round ball, you're on the daylight side of the Earth. You know, it's all it is the sun for flat Earth. It's just moving across the face of the Earth, and certain people are experiencing daytime wherever the sun is. And as far as the light can reach, it depends on where it's at, you know. So it's all we can tell from what people are asking this question from is that, yes, certain countries experience daytime and certain countries experience nighttime, but it's never going to be that if you have a horizontal plane and you have a light source, that light's going to shine on every country, or should, if you have a horizontal plane. It's never going to be that. Like if you there's this like meme going around
so
the
the sun is a torch?
I don't know, but what do you mean by torch? Like a flashlight?
Like, yeah. Like you said, a sun's like horizontal light source. Or did that cut out?
The Earth is horizontal. The sun is above that. Now, whatever it is, I mean, it is. Nobody knows like what it's made of or whatever. But what we can tell is that with like twilight hours is that wherever the sun is before it approaches, the hues and the colors of the sky change based on the variance of luminosity that the sun is giving as it's approaching or it's leaving. And you can tell that, right? You can see the different colors in the sky that change. Like, in the morning time, it's like an orangey red tint. And so the light that's present, the luminosity, or how much the light the sun's giving, depends on the where it's at in the sky as it approaches. So it's a more white, brighter light as it's like right above you. But that's really, it's not like a mysterious thing for us to say like, well, how does it work? We're just seeing the sun do what it does as it moves across the sky into our location and away from us. There's not like, some profound thing that we're going to be able to tell you, and this is how it works in the flat earth. It does like a sine wave or something. It's not, we just see it from whatever country. The only important takeaway that you get from here is that it doesn't tell us about geometry. It doesn't do that. The sun only does, what it does is just marks time as we know it from daytime and nighttime. So people have been using the sun for telling time ever since people constructed the convention of time. Or the passage of time, I should say.
So the view is that the sun doesn't, the sun just is, I guess.
The sun is a mysterious thing. However, it's not like you can say that it shines on every part of like if a horizontal surface, we know that light attenuates through a medium. There's a certain few key things that you can understand because light does things through the mediums that we live in. So air is a medium. It's composed of many different types of gases. And if you notice that when it passes through water is a different type of medium. And the light that travels through water has a different type of extinguishing limitation as it does through the air. So we know that every medium that light passes through, it doesn't pass through that medium forever. That idea doesn't work because it has a medium that it's going through. So, for example, if you're going on a clear day and you're diving under the water, it'll have an extinction limit as you go farther down into the water. So.
Okay. So you mentioned variation in color, right? Like if I shine light through water, it's not the exact same color as the light was initially.
Yeah, I mean, depends on what's the volume of water you're using. Like if it's a small amount, you'd be able to see that light through a certain distance, but as you increase that distance, that light will not penetrate as far, as much volume as you can give it. So the more volume you have on water, the less light you'll see.
Okay. So could you not argue that when the sun comes over I'll just use the word horizon for the sake of speech, could you not argue in that case that then the sun is then influenced by the volumes and mediums it travels through? And being the atmosphere in this case, so you would have the eye color change.
For sure. Yeah, we noticed that. It's an observation that we make.
So doesn't that break your prior point?
Why?
Well, if you go back and you repeat what you said about the color, the luminosity, right?
Mm-hmm.
Sorry, I'm just reading the chat. Sun figured it all out.
You're very distracted, aren't you?
I'm working in the background.
On top of that, you're having a conversation with me, you're working in the background, and you're reading the chat?
Yeah.
I mean, what benefit does it do you when you can't focus on one thing? Does that mean anything to you?
I mean, I am focused on you for the most part.
No, you said I'm reading the chat. That's not focused on what I'm saying.
I looked at the chat for about 5 seconds.
You're distracted. I'm just pointing out the obvious, man. Like, if you're going to have a conversation, just have it, you know?
Okay.
Yeah, Miggy, I posted an image that I took back in 2011. The sun is in the image. It speaks to what you were saying about the sun moving through medium.
Mhm.
My point is, does that look like a sun that's 93 million miles away, for example? It's an interesting image, 2011, right?
Yeah.
Off a
Thanks for
mountain,
that,
I was
Jen.
on my way up.
I just didn't want to derail from where we're at with it. He's trying to figure out the attenuation of light, and it's obviously a well-established fact. So I don't know. Yeah, I don't know what's so crazy about that idea that you can.
Well, you didn't say that to begin with. You gave me some magic changing color box in the sky.
Did I say magic changing? I say the sun is mysterious.
Yeah.
Yeah. What about that is like confounding you? All right, so if I
Well,
say
it's the
the
way you
sun's
described
mysterious,
it, right? Like you didn't use clear language, I should say. Sorry to cut you off.
clear language. The sun being mysterious is not clear. What about that is not clear?
It's not that
Let's put it
word.
this
It's
way.
the other words you said.
What? What are the words?
Do you willfully try to forget things, or
No, I'm actually. What I'm doing is you're making these bold claims that I'm confusing you. I'm not. I'm very clear in what I say. I know what I'm saying. When I'm saying it, why? But I think you're making up things where you're just confusing, and you're not pointing out where the confusion is.
I didn't
You're
say I was
confused, I think.
confused.
Well, number one, you're distracted.
Okay. I'm asking
That's
you
obvious.
I'm asking you these series of questions because I'm curious if you have a logical worldview. I'm not asking
do.
whether or not it's correct or not. I was just asking.
I do
if
have
it
a
was
logical
consistent.
worldview. Everything operates within the parameters of like the physical world having coherence to the things that have been discovered and understood within the realms of like applied sciences, for sure. I'm not outside that. See, the worldview of the Earth being a globe operates outside of that boundary. They operate in the
Why-
hypothetical. They operate in the the ideal way of thinking about like cosmos. We're not doing that here. We're operating within the parameters of known applied sciences.
Could you expand upon the statement you just made about
Which
the
one?
globe model working outside of that?
Sure. Okay, so this cosmic perspective of the idea that we are a globe spinning in the vacuum of space in a solar system inside of a galaxy and so on and so forth. It keeps going. The lore just continues, right? So it works outside of the parameters of anything that can be verified and tested. So thereby negating the fact that anything that we can talk about outside of our known existence in this realm that we exist, you can't test and verify anything outside of that. So all of that is a mystical, magical world that it's basically Santa Claus for adults, right? People love to hear that there's other worlds out there. There's galaxies and other locations. And it's that type of lore belongs in science fiction novels, but not in reality, where you and I exist. That's how.
Out of curiosity, if you say that other planets are like these fantastical places, like they don't exist, like these other worlds, right? I should say not planets, worlds.
You can describe it anyway. It doesn't matter.
Okay. Why would you say they don't exist if we can see them through a telescope per se?
Yeah, there's one way to say what you're looking at and another thing to describe what that thing that you're looking at is. So the thing that's being described as what you're looking at is what I'm in contention with, not with the observation of what you're seeing. If you're seeing a light in the sky and you're saying, "Hey, that's Mercury, that's Mars, that's Venus," I will agree with you. That's what you call that, what you're looking at. They named it. That's fine. What it's described as, however, is going to be what I'm in contention with. Is that clear?
Let's take.
Hold on, is that clear?
Yeah.
Okay.
Yeah. So, let's take Mars for example.
Sure.
What would you say Mars is?
I wouldn't say it is. I would just describe what I'm looking at. Mars looks like something that I can see in a specific color band that I see it as. That's about it. Observation is where it just really starts and stops. I can't gain any more information other than maybe perhaps a place where it will be, like in the sky. So a positioning of it being in the sky and or what I can observe as far as like denoting everything that I can tell from my vantage point.
So by observe in this case, do you just mean with your naked eye, or would you?
No, I mean you could use technology in this particular manner, but there's not much more than we can do other than just detail what we see. You can't. How can I say? You can't put forward what it is, the elemental composition. You can't say that with certainty. I mean, people have been doing their best guess at it. It's called. They consider it like observe. Okay, you can cut me off. Go ahead.
Oh, sorry. I just want to add an extra detail. So in the case of like these other planets, like of course we can't dictate the actual material. Like let's say, I don't know, like in another galaxy, or maybe you can. I don't know. I'm not an astronomer or whatever it is. I can't tell you that. But for objects that are or celestial bodies, as I'll put it, that are close enough to us, like let's say Mars or Mercury or whatever. So if they are visible and we have high resolution telescopes that show us like what it is, or you're saying that we don't know what it is, but like show us what it looks like. Would you say that why would you say that Mars, for example, is not a planet?
I'm not saying it's not a planet, what they're classifying it as. I'm saying what they're describing it is what I'm in contention with.
Sorry, I should rephrase that, yeah.
Yeah, you could look at something and say, this is Mars, Venus, Jupiter, Pluto, whatever. That doesn't affect anything that I can say I'll be alongside you. I'll be like, yeah, okay. You can say that's what it looks like. I mean, yeah, we could do this with the moon. Yeah, you can look at the moon. You can tell me what it looks like to you. I can stand right beside you and say, yeah, it looks that way to me too. Everything you've just seen and said it's got features, it looks like it's got shadows and all. I'd be like, okay, yeah, I see that. I have no problem with that. Like, I'm not gonna be like, no, that's not what we're seeing. Why? Why would I do?
What would you say is the highest resolution photo we have of any celestial body other than the Earth?
No idea. I haven't been on a search for the highest resolution photo of anything that we could see up there. Nor will I don't really need to. I mean, if you present something, that's fine. You can present whatever you like.
If I can just interject there for a second. With Mars, what we tend to get are artist renditions images, CGI images. That's what we tend to be getting. And as Miggy was saying, when he looks at Mars, he only sees, it's a light. It's not something that's got terra firma, ice caps. We don't see that through any technological optical equipment using the eye to use that equipment. Okay, right. So when you look at Mars, it's not something you can say, "Oh, that's got terra firma. I can see the ice caps and craters and that." We don't see that through a telescope. Okay.
All right. Yeah, I think I pretty much covered that with him. So I don't know if there's any more questions.
Well, yeah, there is.
Go ahead.
So we have satellites on Earth, for example, around the Earth, I should say. What's to stop us, for example, from putting a satellite around another one of these celestial bodies?
Well, the problem is there's a bunch of fantasy that's attached to the Earth being a globe, and the reasons that you think satellites can exist in a medium that you've never understood to even exist. So seems to be a lot of steps before you get to the place where you want to put a satellite around another planet. You'd have to walk through logical steps to get to that place. And that means that you'd have to take me from ground all the way to the place where that satellite is, orbiting a planet. There's so many things that you've had to make an assumption on before you get to that place. So many things. So that it's a layer cake of nothing but assumptions. If we were to start from the ground, right? You say, okay, you got a satellite, the guy who's making it at a company He's preparing that satellite. Like we talked to an individual who comes in here. He works for Amazon. His name is Josh, and he works for the Kuiper satellite program. And I was questioning him on things about like, you know, the logistics of how to get a satellite from production to actual inside of a vehicle and put it there and take the payload up to where it's supposed to be deployed. Now I'm talking to him about these things, but he doesn't have like firsthand knowledge of how these things occur. He's going based off of information that's been given to him. So, you know, what to say. That's fine. But the only thing I'm saying about it, what you would have to do, I'm going back to what you're saying about a satellite orbiting a planet. You'd have to go from taking information from that guy, the one that we speak to that comes in here. He's taking information from somebody else telling him what's going on. So you're about maybe 4 or 5 steps removed before you get to the place where you think that satellite is getting actually put up into a location in the sky where it is. So the point of verification it never occurs for you as somebody who listens to information about this. You're like so many steps removed from you being someone who can verify this information. I'm laying it right now on your lap so you can understand. The only thing you can tell me is what you think is going on. In no way can you verify the steps and procedures that it would take to get such a thing into the place where you think it exists. Does that make sense?
Sure, but that's how like every job works. I don't understand everything about how
I agree.
it works.
I agree.
I guess
I'm not disagreeing with that, J-Dog.
Yeah.
But what I want Bled to understand, I want Bled to understand.
It doesn't really hurt it for me though that he
It
doesn't.
doesn't matter, J-Dog. I don't think you're not Bled. Okay, so let Bled, kind of go through this. Everybody has their own way of approaching the topic, so he's doing it his way, and I'm actually wanting him to do that. So, okay, the purpose of this room is for that people they can take their, whatever their conversation is to a logical conclusion. Yours might be something different, J-Dog, than his. So you can't answer for him, or you can't interject like you're talking exactly like he's thinking, because he might go a different way than you. So his mind is different than yours. Maybe that's the way he wanted to go. Maybe that's not. But you're kind of completing his thought, and that's not. I don't think that's cool.
I feel like I'm the flip side to what you said though, because
I know, right. But like he can speak for himself. Yeah,
I agree with you on that. I agree.
Okay, well, that's all I'm allowing. I want him to, because all right, so we're all here, we're in the same boat, right, together. We're all in the place where we're hearing information. We have to find a way to critically think about how to interpret that. That's what we're here doing in this chat. Yeah, we're all hearing the same information. I'm hearing the same information, Blaze. Same thing. We're hearing stories about vehicles going up to a location where they're said to reside and so on and so forth. And, then they go from, low Earth orbit into taking them around different planets and stuff. We're all hearing the same stuff. So it's about how we can have a conversation to critically think about and discuss these things. That's going to make the difference. Whether you're going to wake up tomorrow and be like, Earth's a globe. Silly flat earthers.
Yeah, I get what you're saying, AB, there. And you know me, I've been here for a while. But yeah. I think the problem with taking that stance is it creates a standard of evidence, or a standard for what would convince you to an impossible standard for anyone to reach. And
yeah, well, let me
just give me a moment to explain what I mean.
Everybody.
Yeah, I understand what you mean. I get it. So it's like if you speak to an individual that's and you mentioned a Kuiper program, so I'll just use that as an example. If you speak to an individual in that Kuiper program, you'll only accept from that person as knowledge, not speculation or assumptions, as knowledge of what they directly work with within that program, that particular individual.
I
right?
agree.
So then that says, okay, so who in this program would have the broadest application of knowledge with all the steps from the beginning to end, from the beginning.
Hold on,
right,
Kirsten, that
would
depends.
Be somebody. I'm saying it would be somebody that's higher up. But if we get too high up,
time out. No, hold on a second. No, higher up is, I think, okay. I get what you're saying, but no.
Right.
So,
but my point is that the higher up we go, the less, the more you'll introduce like you'll find them less credible because they might be the ones that are promoting a lie or whatever.
No. Wait a minute. Right. No, that you're projecting what I would say. You can't do that. That's why I'm stopping you in between. Why you're continuing? Don't project what I would say. And I totally disagree with that second part where you're talking about the higher up positions. No, what we do is examine every, like say, I'll give you an example. Like Josh, he works in a specific portion. Departmentalization is what it's called, right? So every department handles something specifically different than the other. They're not one higher than the other. They just do different jobs. Okay, so in his case, he works with like PR and relaying information and that sort of thing. So he's got to do the best he can. I mean, he probably relays information to other companies to sell his product, right? So he has to be more efficient in how he uses his words. He has to relate to people, that sort of thing. So within his job, what he does, he has to do his job efficiently and make sure people understand the Kuiper program based on what his task is supposed to be, right? Relaying information the easiest way possible so that people aren't confused, especially companies that want to purchase from their, company. So that sort of thing. So he does something different, right, than the guy who handles the satellite that's going to be commissioned to do a specific thing for their program. So it's not a higher up, it's someone else and does a different job. So I'm asking him specific questions that pertain to his specific job. And then I will do the same to like somebody else that says, okay, I don't manage PR. I do more, testing. So that's what I do. So then I'll speak to that guy about what he does specifically to his job. I'm giving more of a thorough look for someone who's inquisitive about the process. I can't be in this realm that we have this conversation. I can't be somebody to dismiss somebody who's doing something that's applied. That would be disingenuous of me, yeah? Wouldn't it? Especially if I'm questioning the narrative and if I'm not going through the process of like, okay, I want to know what this guy does and that guy over there. What is it they fundamentally do that affects this specific program? Like I have to. That's what I'm doing. I want to make sure that we're not like just accepting information for the sake of accepting it. And then, why not be critical about it? Even you guys that believe the Earth is a globe, let's just put it this way. If somebody said that they're testing a satellite in a specific manner and you're like, that's just not true. How would you know if they're doing the thing they're saying or not? You'd have to figure out if it's something that can be applied or if it's just some phony baloney information they're giving you, yeah? Oh, what's wrong with that? Like, do you guys see anything wrong with that? You being Globers, I don't...
No, you raise an excellent point, Miggy. Excellent point every step of the way so far. Thank you.
So sure, if I hear that there's a satellite program, I'm not going to necessarily go around and be like, yeah, they're making all this stuff. I'm going to say, I heard there's this satellite program where they're working on this. Like, I'm not necessarily going to speak with confidence in it. But I do believe that the people are doing what they're claiming to do most of the time until there's something that's suspicious. But then again, I don't apply a lot of thought to that either. Like, it's not like I'm going around saying, they're making satellites here. They're making satellites here. Everyone, look at this. This is true. This is fact.
Yeah, I know, because it's almost like, J-Dog, the problem we're having here is you're adhering to the greater point that the Earth is a globe. So to you, it doesn't matter how the sausage is made so long as it's made. You're not going to peek behind to see what's going on behind the curtain. You just like, dude, I don't care so long as the end result is a sausage. Like,
yeah, I don't see it that way with the globe because I've looked into it. But yeah, I get what you're saying.
Yeah, like
can we get back to Blair though? Can we get back to Blair? Okay, please.
I can do a personal example with the James Webb.
It's Blair's conversation. Can we not let Blair and Miggy get on with it? You're interjecting with the stuff you know about. Blair is on his trip and it was going well. Can we get back to that, please? Okay.
Yeah, Blair, if you have anything more to add, or do you think these gentlemen are going to be able to speak for you? I don't know. Like you're going to yield the floor to these guys? It's up to you, man. See, this conversation is kind of open right now, so everybody's taking pot shots at what you started saying. So, what about it, man? Do you want to continue, or I'll give it to you?
I mean, it's really your room, dude. Like, the sort of questions I'm asking, if you can't tell, are more like questions to let you talk, right? Like, it's not like I'm saying I have a refutable point, blah, blah, blah. It's like, the way I'm phrasing my questions is trying to get you to explain what you think or, like, you believe. Like, the point of it is so that, like, I don't pretend to know what you, I guess, are trying to say. So I'm not trying to put words in your mouth, if that makes sense.
Yeah,
So, like,
a part of what we do in here is make sure that everybody has an equal footing on being able to critically think about the topics. It gets to a push and shove sometimes. That's the nature of the beast, because we're talking about something very provocative, like the nature of reality. So of course you're going to be upset because I'm saying the Earth is flat and you think it's a globe. Yeah, duh. But the problem we got to figure out is do we have merit to say what we're saying, or are we just an internet meme that you think we are? So that's what's at stake here. I'm going to prove to you, each and every one who's ever this on the side of globe, that you can ask your questions, and perhaps let me challenge you, and you'll find out whether or not you can defend this holy grail of knowledge that you think you have, that the Earth is a globe.
I mean, it's more so like the question framing is to check if you have a consistent worldview. Because if you said like one thing and then completely, I guess, what's the word, like contradiction? Like, let's say, I'll tell you like this. On that point, arguments have changed in the way we've said it. We've gone through some of the arguments that we make. The overarching position that we have is that the Earth is a horizontal plane and that the Earth is not in motion. So outside of that, how we present arguments, I think that's the more nuanced way that you could say that I have changed things over time. We've gone over some of the arguments and reviewed them, and we need to workshop some of them because they are not laid out as concise as we'd like. So of course, we're striving for excellence in the realm of making sure that the information is being conveyed in a well, concise, understood manner. Yes. That's what we're doing. So yeah, things have changed. Our arguments might be a little different, but in no way does that negate the fact that the Earth changes from being horizontal and it's a planar surface. Yeah.
So,
I guess to clarify with the satellite questions, it's more so like I was curious, like what you believe like if it's real or if it's not, or like if it isn't, like why is that, or if it is, like how would they work, for example. Like, that's the whole satellite thing. Like, it's...
Hey, you want to know how satellites work on a flat Earth, is your question?
Yeah, that would be the end result. But I was just letting you talk about, like, what you believed up to that point. You know?
Well, there's a lot that we can say about them. The technology does exist. I mean, for me to say that doesn't exist is... I mean, I'd be a fool to do that. But how they are up there is a whole entirely different subject that you and I probably can argue till the cows come home about. The most important thing that we can take away is that the technology does exist, that we would say satellites can exist. And then there's this idea in a fantasy realm that satellites are in a place where they cannot exist based on a whole bunch of confounding variables. And if you have any questions about it, we can. If you have any questions about it, I think. Hold on.
I was just saying, like, he knows.
Hold on a second. RTH. Hold on. Let me just say this one bit, and I'll let you go. So, like going from point A to point B, right? There's a lot of confounding variables that you would have to overcome if you're going to put the satellite in the place where you think it exists. And I want to walk through that with you, but I'll let RTH finish. He wants to interject. Go ahead.
I was just going to say, we all know how to put something in the sky, right? Like, you know, ask him, right? That would be if you were tasked with putting some object in the sky, what would you do? It's like if somebody tasked me with, like, let's say space was real, and like,
is he cutting out?
Chris, we're going to a new planet. Yeah. We need a vessel to take all of Earth's water. I'd be like, oh, okay.
You're cutting out, bro.
All right. Is this any better?
Hold on. Give it like
every 5 seconds you're cutting out for 2 to 3 seconds. Yeah. So we're missing big
I don't know if you're far away from your router or something. It's really bad, dude. Like, we're not hearing everything you're saying.
All right, I'll try again. If not, I'll just I'll go on mute.
All right, do one more time.
If you had to put something in the sky, right, and they're like, the government's like, here's $1 million, you got to put something in the sky, make sure it doesn't fall down for like 2 days. What would you do? I'd put it on a balloon. Like, I don't know how else I would keep something up there for that long. So, like, if he's like, how do satellites work? Well, how would you do it? Knowing everything you know about physics, what would you do to keep something in the air? You wouldn't just shoot it out of a cannon and hope it just stayed up there. You would put something on it that let it float, right? Isn't that kind of common sense?
I mean, maybe my brain works slightly differently. I wouldn't use a balloon per se. Like, if I made the observation that there were things floating above me in the sky, like I looked through a telescope and I'm like, and let's just for the sake of argument, I should say that space exists in this case, right? Just for the sake of argument for this. But if I looked up in the sky and I observed like celestial bodies floating, I would first question like what makes them float, and then I guess if you want to really test to see if it's truly like a gravitoless vacuum, you would just launch a rocket in the sky or something that gets high enough and then see what happens.
All right, so the point of contention where RTH and you might have is the place where you think some things can go up and exist in a region where maybe RTH would have contention with. But here's the problem.
They don't fall down.
Yeah, here's the problem. You'd have to provide evidence that what RTH can do, and what I know that can happen, is you can actually show evidence of balloon satellites, satelloons, right, if you will. But they're still called satellites. You can still see evidence of that technology happening in the way that we know that it can happen. Now, on the other hand, you're proposing an idea of something being suspended, or rather having a decaying orbit around a globular spherical planet. So there's like maybe 4 or 5 leaps of logic that you're doing, versus where RTH was like, dude, you can just go outside, put something on a balloon and see it go up. And that's easy enough. That's about as easy as it gets. However, you're saying that the place where this thing resides, it has to actually go beyond Earth's gravitational pull. And then once it does that, it has to go into a decaying orbit that's falling around the Earth at a specific rate. Now, that's something fantastic to think about. It's extraordinary. You have to present extraordinary evidence to back up the extraordinary claim. RTH, on the other hand, doesn't have to do that. There's a big difference.
I wasn't so much thinking of like, in the case you just mentioned, like it becomes a globe. Like, that wasn't the argument. It was more so if I observe objects floating in the sky and they're not falling and they don't look like they have wings like a bird. The idea would be like, if I get high enough, what happens, right? That would be the experiment that I would conduct.
Yeah, but what we're dealing with, though, is you're going to have to, at least at some point, accept the fact that they're up there, right? You're going to say, okay, we got satellites and they're up there. So everybody's probably agreeing on that point so far. Now, where they're at is another point of contention. Where are they? Are they in an altitude you believe them to be, which would be in a region where you think there would be a vacuous environment? Do you believe they're in a vacuous environment? That's the other thing. So you're starting to go into the leaps of logic here, where RTH didn't have to. These are the questions you're going to have to ask yourself, because if you think they're up there in a vacuous environment, is that the case? Do you think that?
I don't.
Yeah, the clouds are up there too. That doesn't mean we can make something float like the clouds, right? Like, let's say, again, even giving to you that the moon is this physical object in an orbit, does that mean we're capable of doing that as well? It doesn't mean that, right? Like, so just because a bird can fly in the sky, and we see the bird, must means we can get up there too. That's not, you got to show it how it's done. Right? Like, yeah, okay, we can build the plane. Now we can fly like the bird. Okay. You're saying we can orbit like Saturn. How do we do that? What did we build? What did we just shot a piece of metal out of a cannon so fast it just never hit the ground? Like, that's, like you said, you're just taking leaps of logic. of these things that might happen.
That would just be a
okay.
physical experiment.
Just a second. I'd like to interject as well. Just want to draw your attention to 23 minutes past the hour. I've posted some images, a collage, if you will, of images that explain the current situation of communications, and the satellite question is being asked. If you look through that, also it gives you my position anyway as to why I contest the idea that satellites are there. Just have a look. And it's just part of the conversation. Thank you.
Well, Jen, I will say that it is a bit of a straw man with the picture that shows satellites do not exist, and it talks about the intercontinental submarine cable system. It's like people who claim that the internet is delivered throughout the world by satellites are people that are ignorant of how the internet is delivered through the world.
Well, I posted a video of the cables that are being repaired, and during the narration, it tells you how the cables work and how much communications pass through. And they say 95% of communications, internet communications, financial transaction communications, email and everything goes through that cable. That's 95%. Okay,
how
can we argue with that?
But because that exists, doesn't mean that satellites don't exist.
I'm not saying they don't exist. I'm not saying that.
Yeah,
he didn't say that.
Right.
Well, the image says that, and that's why I was talking about the image itself.
No, please don't put that forward. It's questioning the satellite. That's why it's there. Yeah. It's a question. And if you look at my collage, you can see that there's methodical logic there. I'm not trying to straw man you. No way, man. Okay, because I posted images that show what the satellites could be like, and Miggy hits it like a drone with or balloons attached with equipment that's there. Okay, we're questioning the validity of satellites. That's all. Thank you.
Yeah, they were always talking about telecommunications happening on satellites, and Jen is pointing out the fact that that's incorrect information. You guys are being misled to believe that that's the case when those same companies appeal to ground stations. So we already know this, and he's trying to cover that with you to like 95% of the communication. So it's
I'm
just
saying
really
that other than laymen who don't understand, who's promoting the idea that the internet is delivered throughout the world by satellites?
You would be surprised. Let's put it that way. You're not hearing the conversation long enough, Kiro-san, that the reason why Jen has constructed all the points that he's making is because that's how many times people have said that's where telecommunications and such come from satellites.
Yeah, well, any Glober who says that is wrong, right?
Well, says you. So says you, but you can't think for all the people that are out there, dude. You know what I mean? You can't speak for everyone.
Now, if we're talking about like sat phones, or we're talking about like
non-ground
based cell phones,
we're not.
Those are different.
No, I know. We're not talking about that. We're not talking about
that. Would be. I'm saying that would be like the 5% of the communication that is not ground based.
Your point is well noted. The point we're making is that you are one person on the internet, and there's hundreds of thousands of people we've spoken to over the 10 years we've been doing this that will say the opposite. Sorry, but that's just the way it is. People are misinformed, and we're here to correct them.
Well, I understand that. I get, and I would tell them that they're uninformed as well. But just because my point is that just because 95% of international communication is delivered through submarine cables,
your point
does not mean that satellites don't exist.
It was well noted.
But do you agree that image itself is a straw man of what informed people say?
Dude. You've already. I don't know how many more times you want to belabor the point. You've already made it. We need to move on. Like the whole point, it was RTH speaking to...
No one's denying satellites.
Yeah, RTH was speaking
to... We're denying the method.
Yeah, and not only that, it's just like logistically, right? Where are they really, in what region? There's a lot of question marks that you guys think they're already answered. They're not. Not in anything that can be applied to understand, those regions that they say they reside in. There's a lot of things that we understand with applied sciences, with materials, elements, and such, that could not reside in a specific region where they say they are exposed to the environment that they are in. There's no way. It can't work, dude. And it goes against logic and reason. Let's put it that way.
Yeah, I mean, I will say that is a positive claim, and I would ask, if we were in like an actual debate, I would ask you to prove that claim, because now because that's distinctly a positive. Like you just made 3 positive claims there.
We proved that balloons are real, dude. We proved you can use a balloon to suspend something. Like, okay, so now where's the orbit?
That alone doesn't mean satellites don't exist.
No.
Okay, but that doesn't mean orbits are possible, right?
Yeah, but he keeps.
It doesn't mean they're not.
No, do you hold on, Wilson? You're resetting back.
Say they don't exist.
RTH just did. RTH just made that connection, and I'm telling him that's a false connection. That's a faulty logic.
Everybody's saying that the technology exists. You keep making it sound like we're not saying the technology exists. That's what you keep trying to make it sound like we're saying.
If we go by what RTH just interjected, he specifically said we did prove that it's not possible because we proved that balloons exist. Or however, paraphrasing a little bit, I don't remember the exact words he used, but he made the connection. He made the. I mean, if RTH, you want to restate what you said, just so I make sure I have the words right.
He could say it again. I know what he means. So,
but it sounded like to me that he was making the connection of balloons exist, so satellites don't exist, right?
No.
Now maybe he meant they're not needed because balloons exist, and that's a different argument.
Listen.
But
just because balloons exist doesn't mean anything else does. So I'm not making any connections. Okay, so I'm saying balloons exist. Yeah, we put cameras on balloons and send them up. Amateurs do this. You can do this. Get a kit on Amazon. It's like $100.
Yeah,
you can do this. Okay, so now I'm only asking, where's the other part? You said there's this other way of sending cameras up there. Okay, can I get an orbiting kit from Amazon?
Right. And the reason why I connected it to it because I asked AV and I said.
I'm going to have to stop you, bro. I want you to... He responded to exactly what you were saying. Can you respond back to him without strawmanning him? Just respond... Like, what he said, is that true or false?
No, what he said is true, right?
You can't get a kid from Amazon. Yeah. Okay, so he's...
And I said I agree in the middle when he was talking.
You need to wait. So after he made that point, he said, how can you do it the other way? The other way which you think they exist up there. He's asking you now because the positive claim now is on you. You think that satellites can exist up there in the region where we're saying they cannot be. So now he's asking for you to. Well, yeah, he wants evidence of that.
Let me just clarify. Let me just clarify the reason why I took RTH's interjection as how I did, right? Because I said to you that you made some positive claims, and can you support those claims, right? And those positive claims that you made those positive claims, right? And I said that, and then he interjected and said, "We already proved that, right? Your positive claim, right?" And he said he is saying that you guys proved your positive claim by showing that balloons. That balloons can do this, right? And that's why I said that he is using that to prove your positive claim, and your positive claim was that satellites can't exist out there. So
what?
Exactly. He interjected that.
Dude, you're twisting up what everybody's saying. Like I'm saying, RTH is saying, Jin is saying, the technology exists and it can be in a specific region, just not in the place you think it is. Okay, so there's missing information, and so now we're saying, okay, we're all saying technology can be above our heads, moving about, not denying that. Now it goes back onto you. You're going to have to provide.
Sorry, Miggy.
I haven't made a single positive claim here, so I don't have anything to. I don't have a burden to prove.
Yes, you did.
What positive claim did I make?
That satellites exist in a specific region which you think they do.
I did not. I never said that.
Okay, so then are you denying the fact that satellites exist in a region where you think they are?
No, I'm not making a claim either way. I was just saying you made a positive claim that they can exist there, and you said it just doesn't logically make sense, right? So that's a positive claim.
I didn't say logically. It's not just, hold on. It's not just logically, physically. So in applied science, like you can't have materials existing in a region which they say these sensitive equipment is supposed to be exposed to radiation, a vacuous environment, heat and cold that they're exposed to. There's a lot of things that where they're saying the satellites that have these like sensitive equipment are exposed to an environment. It doesn't work, dude. There's nothing that you can tell me that like what we understand about these elements that these satellites are made of can exist in that environment. Not alone to mention that you couldn't even get to that location. So I'm going more of a logical and a more physical way. I don't know what you're doing, You're imagining that they're in a location that just exists because you believe it. I'm asking, just like RTH is, for the evidence of you making the grand claim, extraordinary claim, that they're in a location where I don't think you can verify.
I never made that claim, so I don't have a burden of proof.
All right,
here,
then. So then you can't. Here's what we're pointing out. Then if you're saying that,
I was addressing your positive claim that it's not possible,
and it's proven. No, RTH and me and everybody here, Jen, we all agree that satellites and the technology does exist, and they could be using balloon technology. We all know that. Everybody knows that, and or some type of drone technology. Like there's things that are that's available, right? So there's things available to us that we know that things can exist as far as technology being above our heads. We're not denying that. There's an extraordinary claim that's on the table. That's where they're said to reside. That's what's at stake. I can't make it any more clear than I just done. I can't.
Yeah, I get exactly what you're saying, and I don't have an issue with what you're saying specifically. Except for the only thing I would ask of you from what you stated is support for your positive, like direct evidence for your. Oh my God! Hold on, AB. Please just let me get this out real quick. Okay. Oh my God. You said that they can't exist in this region because of X, Y, and Z, right? And I said, well, that's a positive claim. I would like you to support that claim. And then RTH said, oh, we already did prove that because weather balloons exist. Or
We're
because,
going over it again.
because amateur. That doesn't logically follow is my point.
We're not going to reset back to... Look,
can we just move forward?
Yeah,
can we move forward?
We can move forward because
let me speak now, please.
Do you at least understand what I'm saying?
I understood what you said. Let me speak. Thank you. I understand what you said. What I'm trying to say is this. We have the right to contest the idea that satellites are in the 22,000 mile zone or even at 300 miles off the Earth's surface. We have the right to contest that. And that's what we're doing. Okay. Can we move on now? Thank you. Bloody hell.
That was it. It seems like, some of these people really want this to be the case. They want this to exist in the way that they believe it does. Otherwise, they have to question more things. But the thing is, like Jen pointed out, we are contesting it for that very reason. Because everybody just takes it for granted that they're in the location they believe that they are in. Like, duh. All right. So back to the content, right? We're talking about this because it seems to be like a really... contentious point for anybody that comes in here. Bled, did you want to add to something?
I want to add.
What does the other guy want to add? You go to him first if you want.
All right, Sasha.
You are sending a satellite in the region where it's 10 to minus 17 torr, but you produced on the Earth vacuum only on 10 to minus 6 torr. You cannot produce 10 to minus 8 torr. How did you test equipment? Did you test it on 10 to minus 6 torr because you cannot produce on the Earth more? And you're sending that equipment in the pressure what is 1 billion times lower than what you can produce on the Earth.
Yeah, Sasha's restating what I stated earlier.
Yeah.
So he's stating what I stated earlier. So we're back to most of us have been here throughout the duration of this particular conversation. So you might not get people that answer that because we've already covered it, Sasha. So
yeah, but that's what he's saying. That's not my claim. That's the claim. That's not his claim. That's the claim of the
that's what Jen said. Jen said that's what we're contesting, and we have the right to. Because if you're a critical thinker, you can pull up any information to say, hey, how does this actually work, dude, with the physics that we know and the materials that we can work with and exposing them to temperatures that would exceed the elements, structure and integrity. Like, it could break that. Like, so we're not just going to be like, okay, it can exist in this magical place where, temperatures can vary in a vacuous environment. Like, dude, like, what do you think we are? We're just going to accept everything? Like,
well, we can talk about those individually, right? Like I think you've probably already heard that temperature and heat aren't the same thing, right? And then just because temperature is just a measure of the average kinetic energy that exists in the particles in a particular volume of
so what?
Whatever
So
volume
what?
you decide.
Yeah, so
right. But in order for that temperature to be air quotes felt, right, you need collisions of those particles to transfer
that's baloney. That's baloney.
energy. Right.
That's baloney. You know why? Because they have to test the equipment here on Earth. You're speaking a bunch of nonsense.
That's fine.
You're like a
What's wrong with
satellite
that?
apologist, dude. You're an apologist. You don't need to be.
I'm just talking about temperature, not satellites right now.
Here's the thing. They test for those environments on Earth. That's okay. Per the guy who was in here, right? He works for the actual satellite company, the Kuiper program from Amazon. Every time you guys talk about this, I'm going to pull him back up because it seems like you guys are losing your marbles when I'm talking about this. It's not some imaginary where you don't feel temperature up in a place, in a region where it's not the same as it is down here. No. That is not going to fly. Do you know why?
That's not where I was going with the temperature.
Do you know why? Do you know why? Because
can we just talk about these individually?
No, I'm going to talk about this. I'm going to hammer down the point that you just brought up because you think it's something that you can talk about where temperature is not the same thing as heat and cold. Like, no, they put these satellites under stress test. According to what he told me, going based off what he's saying, they take it to a thermal chamber and they expose those components to, and this isn't verified by him either. So I'm just telling you on the basis of what he was saying. He said they put him into a thermal chamber where it exposes that satellite to varying temperatures of something in the ballpark of negative 100 to like positive 300 degrees.
Yep.
So
something like that.
Yeah, something like that. But he says that's what they're exposing him to. So your bullshit, like apologist story of like, oh, it's not the same thing. No, it is because they're testing him here on the ground. So there goes your whole argument about what temperature is and your apologist way of saying it's not the same up in smoke because they do test these things in the environment, specifically in these thermal chambers, according to what he was telling me, the way that I'm telling you. So
yeah,
they're bullshit, dude.
They're called thermal vacuum chambers. Yeah, I know.
Yeah,
I know
so it's bullshit. It's bullshit. What you're saying about it's not the same. No, they're big, dude. They have to. They have to expose them to those temperatures.
Can I get in here now?
You can have a point, dude. Like,
yeah. But the thing is, you were trying to bring up. You didn't. You completely strawmanned it because I wanted to talk about temperature specifically and why it can mean different things depending.
No, I don't care about it meaning different things, dude. I don't care about it meaning different. I don't. That's
if you don't care, then why mention it as a refutation?
Yeah, because of the fact that I'm saying specifically when it's applied to this, the components of the satellite. When they put it into the thermal, shut up, Kiro-san. When they put it into the thermal chamber, they're going to expose those components to the varying temperatures. Specifically, what he told me, every 45 minutes it fluctuates from cold to hot. So these components are going to be exposed at a varying temperature, according to what he was telling me, in these thermal chambers with real temperatures, not fake temperatures that it wouldn't feel up there in that vacuous environment you think they exist in. So they're doing testing here on Earth. Yeah? So it negates everything you're arguing of, I just want to get into temperature. No, I don't care about that because they're doing real testing.
If you don't care about it, then you shouldn't bring it up, AV.
No, I'm bringing it up because it's something that they do, not something that you imagine.
And I never said they didn't.
Okay, then that's over with because now we know that they're exposing these components to the temperatures here allegedly.
In a vacuum chamber, for one. Right, so when you measure the temperature in a vacuum chamber, it doesn't mean the same thing as temperature. Like if you have something at if you have 75 degrees. No. Please let me.
No. Because of the extreme variance of the temperatures, they have to submit this components to. They're not just going to come out with say, oh. Well, now that it's a vacuum, that it's not going to feel any of these temperatures. So it's like nothing. Don't worry about it. All we got to do so you won't feel any temperatures, just take all the air out. Therefore, the components in there won't be exposed to any dangerous heat or cold fluctuations. Do you trying to layer cake bullshit me? No, it's not going to work. That's why you got stopped. It's not going to work.
Miggy, we can make an analogy with the submarine. It's the same thing, You cannot send the human being on the bottom of the ocean with the submarine. Do you know that?
I'm not gonna. I just want to talk about this specific thing, Sasha. Sorry.
Yeah,
I don't want to be derailed to.
Yeah,
I know, sorry, brother. Sorry, brother. I don't want to be derailed to that. I do want to stick to this because Kiro-san's challenging this point, and he's saying that it's different. It's not the same, according to him. So, them putting it in a chamber, varying temperatures at those degrees, doesn't mean anything then, because it's not going to affect it. I mean, it's in a vacuum. It shouldn't be affected. All you got to do is take all the air out, and then therefore the item that's in there will not be affected by varying temperatures. According to him, I'm not going to listen to that, dude. That's bullshit. They wouldn't put it under stress test if it wasn't going to be stressed. My God. All right.
Yeah, AB, I never said it wouldn't be stressed, dude. That's why I kept trying to get involved. I never said it wouldn't get stressed, right? Here, you did. My point is that if you have something in a vacuum chamber and you measure the inside of that vacuum chamber at 75 degrees, it's not going to be the same thing as 75 degrees in your room. Right, that has air that can transfer that energy.
I need to interrupt you. And also, it's not the same if you put that in 10 to minus 17 torr like you put in that chamber. It's not the same. It's very, very different. You've made good example now. It's not the same. Where is the air? That vacuum chamber. That's correct. And that vacuum chamber is not the same like a vacuum of the space.
Yeah, I want to speak to Helioskeptic's point in there. Where they talk about it being exposed to dangerous radiation outside of the Earth's magnetic field. That's kind of like the story that we hear from them guys, right? Whoever's proposing this, but that's what they do. The atmosphere, what is it? Magnetosphere. I don't know what they call it, but it's protecting the Earth, the globe, from dangerous radiation from the sun. They're saying that it would be exposed to a dangerous environment and such, and the things that get put up there are in a harsh environment. They've already told us this lore. It's not like that can be negated by, it's not going to feel a thing when it goes up there. Dude, you're trying to argue for a stress test that's not really stressing the components of that satellite.
No, I'm not. I'm not making that argument.
No, you can't.
I'm not making that that the test is irrelevant, right? Obviously, it's relevant, right? But when we hear the idea of this particular layer of the atmosphere is 4,000 degrees, but it's also not nearly as dense as air on the surface of the Earth. So just because you're in that environment doesn't mean that any object in that environment will immediately feel 4,000 degrees.
I'm sorry. Right? But that is a story that you just made up, and they made up.
Yeah.
That's a story.
Because let me just say something quickly.
Go ahead.
The temperature that you're talking about, let's say 4,000 degrees, that's going to be there, and the object is just going to keep heating up. It's not going to be able to get rid of that heat. There's no way to vector it off.
Right, but how fast will it?
Or to radiate it off.
How fast will it go up to that temperature?
If it's going to be there for years, it's going to be detrimental. Okay.
Yeah, if it's sitting in the thermosphere, but we don't put things in orbit in the thermosphere.
You, man. Yeah, you do. What do you think the ISS is, bro?
Yeah.
What do you think the ISS is?
Wally.
It's in the thermosphere. What do you mean we don't put things? Oh my God. It resides in a thermosphere. That's where the ISS is. Where people allegedly are in. Doing spacewalks and whatnot. You need to be updated on your lore. All right, I guess we're losing some of the main people that we're talking to because Kiro-san wants to talk about how this is not going to be a problem. They're sending vehicles up there, payloads in that region. So what was being contested earlier was, do satellites exist? It seems to be something you guys bring up, and we're like, Jin belabored the point. RTH even weighed in. I was telling you guys the same thing. And it just seems like we're coming back around to now temperature variations and how they do not act the same way if you're saying they're going to be in a place where they're telling you that the temperature is a specific set, whatever temperature it is up there. We're going to progress the conversation forward. Anybody else wants to come in here and discuss with us? We are challenging right now the narrative of the Earth being a globe and or the different parts of it. Like right now, the idea that the sky is a vacuum in any way. Are you going to have to be able to produce some evidence of that? So we want to know if anybody can weigh in on that. Sky vacuum, you want to do that? It's a particular part of lore that either is or is not the case for the realm that we exist in. Not necessarily a point for flat Earth and globe Earth, but definitely one if you want to contest whether you know that it is or not.
I provided this concept before, but I can't remember if you were involved in a discussion when I brought this up before. But it's the idea of, so whenever you have a differential of gas pressure, there's a force, a measurable force, where the higher pressure moves towards the lower pressure to equalize, right? And then if you add the downward acceleration as an opposing force, regardless of the cause of the downward acceleration, just that we understand that it exists and there's a force that can be measured relevant to that downward acceleration, is that, so if you have a differential pressure that is that creates less force of equalization than the downward acceleration, then you won't observe an equalization between those two layers. And so the idea is that, so even on a flat Earth without a container above it, at some point as you get far high enough above the Earth, the differential pressure is less force than the downward acceleration. So that could be an explanation of how you get an atmosphere next to a vacuum.
Bro. Yeah, there's a layer cake of assumptions you made within the context of what you just said.
What assumptions are there?
The downward acceleration. Let's see. What you
don't accept that the downward acceleration exists?
What? Dude, okay, so you're so far removed from reality that you actually believe this is true.
No, the downward, I'm talking about little g, not big G.
Well, little g is just an observance of things falling through the medium of air. Is it not?
Right, and that's a measurable acceleration. That's a measurable force.
It's an effect. A measurable force?
Yes.
Yeah.
Every time you weigh something, you're measuring the force of the downward acceleration that's exerted by an object.
Yeah, so you're just seeing something react in the medium that it's in, right? So an object and medium relationship. The object and medium relationship.
That's a positive claim. I'm just talking about the force itself.
It's a positive claim, dude.
I'm just talking about the force itself.
Yeah, what, dude?
Not why the force exists or what causes the force.
What's the force? What's causing that?
Well, in the globe paradigm, we would call it gravity.
I
don't know what flat earthers will say.
You don't know. You don't need to go there. You don't need to go globe flat.
Yeah, I don't need to go there because I didn't want to.
Okay, so tell me what the causation for the effect is.
Well, it would be like what we call gravity.
I know that's a word that denotes that you're talking about a cause and effect relationship. That's what gravity is. It's a cause and effect relationship. So what is the effect? We'll go through that first. What's the effect?
The downward acceleration.
What does it cause?
What we call gravity.
No, not what we call gravity.
In the globe paradigm, it's the curvature of space-time.
What is, okay, so the curvature of space-time.
But we don't need to argue the cause. We just need to observe that there's a force.
Okay, so we got you over here saying the cause is the curvature of space-time. Is that a concept or is that something physical that we can test and verify? Choose. Choose.
That's a good question.
I know that. Choose.
I would say that it is a concept that has been tested successfully.
Okay, exactly.
Multiple times.
So let's look into that. Give me one example of it being tested successfully. One. Big G, not little g.
Gravitational lensing.
Okay, and what do you mean by that? That's a mouthful. What do you mean by that?
No, so I forget who did it, but it was Einstein's idea of the experiment of looking at the stars as the sun passes through the sky, and then observing if they appear to shift in their location while they're near the edge of the sun. That would be testing the observation, or seeing if that prediction is
okay. Wait. But you're just seeing something happen. Isn't that an effect?
Yeah, but it was an effect that was theorized by a prediction.
Yeah, hold on a minute.
Based on curvature of space-time.
Yeah, prediction. That's great. That's somebody just guessing at what they think something could be by conjuring an imaginary thing up. Okay, I'm not worried about that. You see something happening. That's something happening. What is causing that thing to happen?
Well, it was a prediction made by the concept of the curvature of space-time, and then it was observed.
I'm not asking about a prediction. I'm asking what's causing it to occur.
Well, the theory was the curvature of space-time.
That's circular. Because you're just telling me that as an idea. You're not pointing out the fact that something's tested. The cause and effect. The effect is you see something happening. The cause is what's making it happen.
Yeah, I still don't understand why you're forcing us to go down this road when all I'm talking about is the downward acceleration exists, yes or no?
No.
If the answer is yes, then that's a force.
I'm not going to reset to that, Kiro-san. We're way too far ahead of that. Now you've gotten yourself in a pickle you don't know how to get yourself out of. You painted yourself in a corner. Now you're going to either tell me how the cause of what you're saying is true, gravitational lensing. Can you provide evidence of the cause for the effect?
The evidence would be like, it wouldn't be proof, but it would be evidence that
you said it. No, we stop right there. Full stop. It's not proof. I don't want whatever it is you're going to provide with the following words. If it's not proof that you're showing me that the effect is what you're saying the cause is, and I don't want to hear it. So therefore,
but you won't even engage in my original point.
Let's kind of bring back the onion layers, right? So you started telling me about a downward acceleration. I told you about, you said little g, the effect. Now you went to big G. And you're saying, well, the warping of space-time.
No, you took me there. I didn't want to go there.
Yeah, it's a logic train. So then we went from there to that, providing how they know that space-time is warping because of gravitational lensing. And then you went to like something that you see in the sun, an effect of something happening. And I say, what's causing that? And you said, we don't have proof of that. So all the way back to there, you don't have an answer for the very thing you think is causing your downward acceleration. How do you like that?
No, it's not relevant to the point I was making originally.
It is,
no,
because
the cause isn't relevant. All you need is the effect is only the only thing that's relevant is the effect. It's a downward acceleration is observed, and it's a measurable force. That's all we need from my concept.
No. It sabotages your position because your fairy tale causation went up in flames with your ability to not say what it is.
But the causation is irrelevant. We don't need to know why electricity is caused in order to observe and measure the effect.
It's cause and effect relationship, right? If you don't know what's causing it, then you just see an effect and say, this is what's happening. That's good. Yeah, I'm clapping for you. Yeah, we all see something happening. All of us do. But there's nothing ascribed to what's causing that, except for in your paradigm, you need this causation to exist the way it does to make coherence out of the nonsense of the Earth being a globe in a vacuum of space. That's why.
The downward acceleration is independent of the shape of the Earth. The effect is independent of the shape of the Earth.
Why did you appeal? If that's true, then why did you appeal to warping of space-time? Why did you appeal?
Because you wouldn't allow the conversation to go forward unless I did.
No, because
that's why I appealed to it.
Dude, it's married to the effect.
No, I'm not. And I'm not even appealing to it. I'm just saying that we observe a downward acceleration regardless of the shape of the Earth, and it's a measurable force. That's all we need to. I mean, do you agree with Jedi right now that we don't observe a downward acceleration? That's a measurable force.
Listen. What this is where you're going to parse it out. When you see something fall like a rock, you can say this has a rate of fall, right? An average rate, because different elements fall at different rates in the medium of air. However, if you apply that universally, it will break. That's why he's saying no. You can't apply it universally to all things that exist in our physical world, like gases, for one. Do you understand this?
Well, I understand what you're saying, but I don't necessarily agree.
I'll explain. If we talk about just naturally observing the physical world around us, we understand that some things go up. For example, when gas is produced, say, for example, at the bottom of the sea, in the seabed, like a methane vent, that gas, when it's produced, goes up through the water and then disperses upwards into the available space above the water. So the gas, when observed, goes up.
There you go. So it's not true what you said.
No, I presented a while ago. I think India was part of the conversation, and he said he was going to look at the paper. I did, but it was a paper that in a isolated
we don't
insulated
live in an
container.
We don't have that. That's not in nature.
You just let me finish.
Nature doesn't have an isolated system, bro. I'm sorry. You have to speak within the confines of our natural world, and that's what we experience. We experience everything within those confines, and we can test and verify those things. Something that you say exists in your little test is not going to be something we go outside and experience. Isolated systems. Where?
It's interesting, I promise, if you let me finish.
I don't care about that, dude. You could say that you take rabbits out of hats, bro. That's not going to make the conversation move forward in regards to us using things outside in the physical world. We're looking for that verification of what you're saying exists, that should exist in applied sciences. Not something that you're just saying, well, this isolated system, therefore outside is like, no. You're trying to make an analogy to what you're saying versus what you want to say about the nature of reality. And that's the thing. You can't compare an isolated scenario to what's happening outside.
No, the point of the isolated scenario is that we do observe a pressure gradient on the Earth. That's not in question, right? So, but the idea is what causes that pressure gradient, right?
You're asking a question, or are you making a statement about it?
I'm making a statement going towards the experiment that I was going to reference. Right, so we observe a pressure gradient. We want to figure out what causes a pressure gradient. We can theorize or hypothesize and go, oh, it could be this or that or this or that, and then we go, well, let's isolate out some things so that we can reduce the variables and have a better control to make some observations. Right, so you have an isolated container that's insulated, so there's no thermal like temperature being transferred from the air in the room into the container. You isolate all these out, and then you look inside you put pressure gauges throughout the container, and you observe a pressure gradient in this closed container, given enough time for the air inside the container to settle, and you observe a pressure gradient in the container.
Right there.
With that, I'm going to finish. I'm going to finish, Jedi.
No, you're not.
To settle, gases don't settle. Gases don't settle in some kind of mass gradient, where you have the atomic mass of gases at the bottom and a lighter atomic mass at the top. It's in violation of the second law of thermodynamics, the ideal mixing of gases. Gases don't settle. We've got caves that are said to have been closed systems for millions of years. And when we go into these caves, it's a even distribution of the mixing of gases, as in the heavier gases in at the bottom and the lighter gases in at the top. This is something that we don't observe in the natural world. The fuck?
Yeah. I was trying to tell him not to go down this road, but he was insistent. So I let him.
My point was that the only force that could cause the pressure gradient inside this isolated, insulated, closed container would be the downward acceleration.
Yeah. Okay. How did you prove? Go ahead, Jedi, if you want to.
Sorry, maybe I shouldn't get involved.
No,
you're kind of saying that there's a downwards acceleration of gases because there's a gas pressure gradient, which there isn't. You don't have an atomic mass density structure from the surface upwards, as in that type of gradient. We have a homogeneous mixing of gases in all contained environments. I don't know where you're spouting from, dude, but this is ridiculous.
Yep.
I've got papers and papers and papers on this, mate.
it's a point that he brought up to kind of solidify. All this stems from the idea that he believes this fantasy of a globe residing within an embedded space, the vacuum. Most people.
No, what I was arguing for would be possible on a flat Earth. I wasn't arguing for the shape of the Earth.
He's even telling you, man, that system right there. How can you say that we're experiencing in our physical world that very thing you're saying with the idea that the downward acceleration is a force when you're saying that and gases don't adhere to that?
Yeah, that's an assumption.
Oh, really?
Yeah, you're assuming that the downward acceleration has zero. You're assuming that that gases have zero. The downward acceleration has zero effect on gases.
Sorry, the second law of thermodynamics will dictate and gas expands into a volume. It doesn't matter about the thickness of a container. The container walls do not attract the gas towards them. Please see kinetic molecular theory. The fuck?
You're saying the only thing that it can explain this. Why are you saying it in that way?
Because of the experiment I was referring to.
It's not an experiment. What is the independent variable within this experiment? You've mentioned a lot of controlled variables, and you've got the dependent variable, apparently, which I'm still going to dispute. But what's the independent variable within the experiment that's been varied and manipulated?
It can only be one thing, Harrelson.
Because you'd have to stop calling it an experiment if you haven't got an independent variable.
Yeah.
So it's back to science class, dude. I get the quietness. Hopefully you're thinking. But you must understand this isn't an experiment or it will contain an independent variable. What is it?
Downward acceleration.
I'm bringing up the paper itself.
Cool. What's the independent variable? Being as you know it, whilst you're going to get it, you can just tell me.
Just tell them.
Downward acceleration?
What?
No, it's not, because you can't manipulate that.
So that's not the
Dear AI. What's the independent variable?
You think he's typing in at ChatGPT, huh? Maybe.
Absolutely.
It's not giving the right answer that he wants to hear because it's saying downward acceleration. He's like, no, not that, because they're just going to tell me that I'm... I can't prove that. You painted yourself into a corner.
I can prove what makes things go downward.
I'm bringing up the experiment itself, so I can just make sure I have the.
That's fine. Just tell us what the independent variable is. Whilst you're going to get it because you know what it is, just tell us.
Or you don't know. Are you?
Or you do know.
I guess for the experiment, I guess the independent variable would be the locate, like the position of the container itself.
The position of the container itself caused what you say, and I highly dispute, a gas pressure gradient within an isolated system.
No, the being as if you moved that to a different location where higher or lower than where we might observe a variation.
We might observe
the downward.
Yeah, we might.
We might. Well, in the future.
Right. No, that
not now. Like before in the experiment. Sorry, I'm going to lose my temper. So not yet then, in the future, not in this experiment, because you said we might.
It would be high
You're
above
giving me
the
itches,
Earth.
dude.
It would be the
you're
height.
Making me all itchy and scratchy, right? It's like, you're either going to give me what I want, be honest, or just not. And I'd really prefer you just to be honest by telling me what in the scientific experiment is the independent variable.
Yeah, height.
Height? What, 6 foot?
Like you want me to say no?
Causes gas pressure gradient, ladies and gentlemen.
You want me to say there is no independent variable? That's what you want me to say.
No. You need.
I would love you to, because there isn't one. You've been at pains to say we keep lots of control variables, and then we just watch what happens. Watching what happens isn't an independent variable. an independent variable is your presumed cause of the phenomena that in the experiment we hope that you varied and manipulated to cause the phenomena.
Right. So if you observe the dependent variable change the pressure at different heights, then if you move it to different, like if you move the container itself to different heights, do you observe a different pressure gradient in the container?
Okay, so that is still a gas pressure gradient. What's the cause of the gas pressure gradient?
It would be the downward acceleration, and then you can control for that by changing the location to where different downward accelerations exist.
That's all I needed. Downward acceleration. You varied and manipulated that in the experiment, did you?
By changing the position, yes.
No, that's just a gas pressure gradient. I need you to cause it, not point of lots of differentials in gas pressure and make declarations. Seriously, dude, you must understand this, right? It is a solid roadblock. You cannot pass. Please be honest and understand.
Yeah, I understand where you're going with it. I just disagree.
You disagree.
This isn't agree to disagree, bro.
If you change the location of the experiment to where there's a different downward acceleration.
Sorry.
You're either right or wrong. That's how this works. You're right or you're wrong. It is the cause of the effect or it's not. It's not agree to disagree. Like he's just like, well, I don't like what you're saying. No, you're either right in what you're saying or you're wrong in what you're saying.
Not subject to your disapproval.
Exactly. This is not right or wrong, or excuse me, agree to disagree genre. This is right or wrong. You're either right or you're wrong. Which one of those do you think it is, Kiro-san? Are you right or wrong?
Well, let's see if we can find Avogadro's law for him, and we can walk through that.
Oh, Yoder just said that. You guys are on the same page.
I was going to bring it up earlier, but he's brought it up, so he definitely needs to understand if Yoder brings it up.
Well, it's funny that he created this isolated system to test with height. He's very manipulating height. So height is the cause, not a downward acceleration. Not a downward acceleration, like he so wants to desperately prove. He's not proving downward acceleration. He's proving that height is a result of it.
It's funny.
The point being is, excuse me, is if you change the height and if that changes the downward acceleration. No. You're
not testing for
that would change the dependent variable.
You want to know what's causing the stratification, right? Why are things being the way they are? And you're saying because I move something up or down, the height of it varying that's what's going to cause the effect. That's causing the effect. The height moving up or down, not downward acceleration. You didn't test for that.
And I'm not saying like as you move it, do you observe? I'm saying you move it to another place and then you observe it in that place. And so if the pressure gradient height is
a cause, not downward acceleration. It's not causing any. Downward acceleration isn't doing jack. Just you moving the container up and down. Height.
Height isn't an independent variable.
I'll
read through this. Maybe it'll add some clarity. So Avogadro's law states equal volume of all gases at the same temperature and pressure have the same number of molecules. For a given mass of an ideal gas, the volume and amount of the gas are directly proportional if the pressure and the temperature are constant. This is why I strongly agree with your observed phenomena.
I think that was probably it for Kiro-san. He ran out of gas.
I think we should just turn away from the door. It's obviously locked and we can't get in. We should just try another way around.
Yeah, he's saying he wants to agree to disagree, Jedi.
You can't do that. This isn't agree to disagree fucking genre.
I kept telling him, dude, I was like, you're right or you're wrong. You're proving something or you're not. You can't walk away from here saying, well, that's what you think. No. That's what we observe and we can test for.
Yeah, it's been a great display of holding standards, with what Miggy was trying to say at the very beginning. We're holding a standard of integrity so that we actually try to find out if these things are really happening or not. And that's been a great 1 hour, 20 odd minutes. So, yeah, thank you. I've enjoyed it. It's been good.
And we started the conversation with Blair. It was intermixed with some other individuals that jumped in. There's been some globe proponents that come in here, but honestly, we want to open up the room to if anybody else wants to jump in and challenge the narrative in which you think the Earth being a globe is. So if you're in here right now, we got, I think, somebody named Lael. Welcome to the room. Spence has joined us at the very bottom. Welcome, Spence. And I don't know your name at the very bottom. TNOUT. Welcome.
Yeah, to the newcomers that have just come in, don't hesitate to ask any questions. No matter how strange you might think it might be, everyone else will learn from it anyway. So please ask. You made it here. Make it count.
Shout out to the homeboys. Yeah, what's up, guys? We got DJ in the house. What's up, homie? Gemsy. What's up, Gemsy?
My question is gravity proven?
What's gravity?
Sorry, do you want the short answer or the long answer?
What I mean is there a force that either pulls things down or pushes things down?
Not that has been scientifically verified.
Okay.
That's the point the other guy was making, Zay, that you came in on. The tail end of. Do you think that there is?
No, I don't really believe. Look, I don't want to get into my own beliefs, but I'm not a globie. But I just want to know, like, do things go up and things go down because of their own, maybe dimensions?
It depends what state of matter you're talking about.
Yeah.
So
what you're saying is like, okay, continue. Sorry.
No, if you got, sorry, I'll start with gases. Gases, because of their temperature, because they are unbonded from each other, are free to move. They move randomly in all directions, right? Goes up, goes down, goes sideways. This isn't comparable to something like a rock, which only has one vector of travel through the medium of the air that's moving around all over the place. The object and the medium relationship, or the medium itself, must be considered, right? So there doesn't appear to be just one vector of travel. There appears to be multiple, depending on the state of matter and the energy that's within that state of matter, like temperature in gases.
Yeah, definitely an object and medium relationship. You vary one of them, you'll change the relationship between the other.
Let's consider the egg in a jar of water. When I drop the egg into the jar of water, the egg sinks to the bottom. If I add salt to the water and make the water denser, the egg rises, it goes up.
Yeah, because obviously the water density has changed, right? So now the egg rises up because the water is thicker. By putting that salt in, you've thickened that water basically, and now the egg is becoming buoyant. That's why it goes up. Interesting, isn't it? And yet you drop a pebble, and it'll sink to the bottom. There you go. What a wonderful thing. Gravity.
So why does the pebble sink to the bottom and not float?
Well, because it's more dense, isn't it?
At which level? How is it more dense than, say, an egg?
Well, the egg would have some air in there. The shape of that egg right? There's air in there, okay? And the molecules that make up the egg is lighter than the little pebble. That's why the
So
pebble
what you're
goes straight
saying
down.
is that the pebble, for its mass, is quite dense, whereas an egg, for its mass, is less dense.
For its mass,
is that what you're
what's
saying?
that? At the moment, we're just talking about
So
the
what
density,
I'm saying is,
the amount of substance in the space.
When I say it's mass, I mean size. No, I just mean for the size of. Does mass not mean size?
No, this is why I asked you what the hell you were talking about when you put the word mass.
Well,
we're not talking about it.
Okay. Explain exactly what mass and size are and the difference, please.
You brought it up. This is why I said density. That's the amount of substance in a space. And what I asked you, are you saying mass is the amount of substance in a space? Because we're talking about density at the moment. Mass is just a concept. At this very stage, we don't need to invoke it because it's just conceptual. We're talking about
what I meant to say.
Manipulate.
Okay, I understand. What I meant to say was, is he saying that for its size, a pebble has more dense material or molecules even than like another thing similar in size, like an egg, but it's got less molecules? Is that what he's trying to say?
That's what we observe, isn't it? That's what we observe. You observe that. That's what you see, isn't it? You pick up a pebble, it's solid, dense, drop it, it goes straight down. Take the egg, in salt water, you put it, and it's now floating there. It's what you see, isn't it? That's what we do. We do what we actually see, and we don't make things up.
What you actually see?
Yeah.
Oh. I didn't know we were so big to where, we could dilute to what we see from, what we
Sorry, we're trying to understand the physical natural world around us. We're going to do as much science as we can. The first step of the scientific method is to observe things happening. So yeah, we're going to be looking at the things that are happening. Do you have a problem with this? What weird behavior.
Yeah.
All right, we're questioning right now why people think that the Earth is a globe. So you came in at a moment where we're having a discussion about why people think there's a downward acceleration and or gravity. So we're talking about that when you walked in and just started rambling. So do you have a way to describe how you know that the Earth is a globe?
I do.
Go ahead.
Because every stance and standpoint that's actually true says that it's a globe and not flat. And thousands of years of science proves our point and doesn't prove that the Earth is flat. Yeah.
Okay, he's gone.
Oh.
My only issue with that is he said for thousands of years, but most of science for thousands of years believed it was flat. It doesn't make sense.
That's fine.
Okay, now I've got an issue.
And it's also not science. Yeah, there you go. Good eye.
He wanted to say that and leave, so that's what the majority of people on Earth say, that because that's all they've been programmed to say. It's just a program that's running. He doesn't know why he's probably even said that.
On TV, everywhere you look, it's just programming.
I've got a question.
What's up?
How is an insect or a bird able to fly?
Huh? Yeah, gravity is not pulling it down. Exactly.
Is it like a greater point about gravity, or you're just wanting to know?
What I mean is like, yeah, like what do you think, like actually, like on a physics level, is happening to make it like get off the ground via its wings?
Yeah, moving air around.
It's called lift.
They create a resonance like bugs do because they're flapping their little bug wings.
Yeah,
and it gives them lift.
So what you're saying is, because like, okay, think about it, right? The insect naturally, it's on the ground, right? It's dense enough that it's on the ground. But then you're saying the wings create a type of lift where the density doesn't.
They ride the medium. Yeah, of course.
What does ride the medium even mean?
Well, that means that it's using the medium by beating its wings thousands of times a second, because that's what they're doing. They're riding the air that they're in. You understand? They're using it to lift themselves up. They're getting lift. That's how they get up.
Well, he just become the.
So it's actually quite a. So it's quite a. It's quite no. I thought it would be a bit more complicated, but it's quite a simple answer. Basically, is what you're saying.
Well, yeah, when you look at it,
I mean, they're applying energy to lift. That's not really like. Oh, they got to overcome the gravitational force of the Earth. Like,
well, that's what I've been told in school. That like, oh my god, they're against the gravitational
you can
pull.
prove it's not gravity. You can prove that they need air to fly. Put bugs in flying bugs in a vacuum chamber and remove the air and see what happens to them.
Yeah, I would imagine they wouldn't be able to fly. Yeah.
Yeah.
Which
okay, so it's nothing to do with gravity. It's air pressure.
Which is interesting then, because like the air is kind of a material in a way. It's just not seen, right? Like if you think about it,
it's a state of matter.
It's a substance. Yeah.
It has physical implications to the world around it. Like when you flap your arms or a bird beats its wings, it distributes that medium around it.
Yeah.
I mean, now get a paper airplane, dude. We can have a lot of fun with this.
Yeah. I used to do that with my kids. If you're really interested as to what happens to insects in a vacuum chamber and also other household goods, I'm prepared to post you 4 videos. Each one is only 5 minutes long. Would you be interested?
Yes, I'll check it out.
Okay, so allow me like 5 to 10 minutes to get it, and then I'll put it in the side chat. So keep paying attention to the side chat, okay? Thank you.
Right.
What paradigm do you think you reside in right now, Zay? It sounds like you don't really adhere to mainstream narratives, so per se.
I don't.
I could be wrong. Do you think the Earth is a globe?
I don't really think it's a globe because, like, I believe governments lie. I believe in like secret societies, and I know, like, there's obviously a lot of lies we've been told, and why wouldn't they lie about the shape of the Earth or the nature of the universe? So the way I see it is, okay, if I hadn't been told, right, that we were on a spinning globe, I'd naturally assume that I lived on a flat Earth, right? And the reason I say that is because I've never actually seen the curvature, and I've been on planes before, right? And when I was on the plane, I never actually saw like a curve, right? It just seemed flat to me. And also when I was flying, it never seemed as if I was like going downwards or going across a curve. It just seemed like I was flying like straight across, more so. I mean, of course there's like hills and mountains that you see, which is like has a shape to it, has a curvature to it, but I mean the actual Earth itself, right? Now obviously people say, oh well, look out at the sea and you can see ships disappear, that's going over the curvature. But then, I found YouTube videos where people were zooming in on those ships and they reappeared, and I was like, maybe it's not going over the curve, maybe it's just going out of those videos.
Sorry, I do apologise. Do you think that you could show us just one of those videos where a boat has disappeared and you bring it right back into view? Love to see it.
Okay.
And I'm sorry to disturb your train of thought as well. I was really interested in what you were saying. So if you want to continue,
that was pretty much it, really.
Later.
That was pretty much it.
I get your experience, though, dude. I understand fully what you were saying, right? Your experience is, and if nobody would have bloody told you, your experience is that the Earth is flat and stationary. Yeah, completely.
Well, agree. I'm also saying that because basically every human agreed with that until very recently, right? Because I've like read history, and it's like every human civilization they just assumed it was flat because the world around us does seem flat. Like we don't really see the curve, right? It's just we're told it's a curve. But you don't really see it.
I hear you, buddy.
I posted one of the videos in the side chat.
Thank you, mate. I really appreciate it.
It's actually not it's a buoy, not a ship, this one, but it's the same concept.
Okay, thank you, buddy. I appreciate that.
Who did this? You did?
No. I've never done it. I'm just talking about what I've seen online.
Okay.
maybe I should do it myself, shouldn't I?
That wouldn't hurt. Would not hurt. We got a lively bunch joining us today. Welcome, everybody. This is 24/7 Flat Earth Discord on the Politics Channel. Dun, 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 dun. What's going on, everyone?
Good morning, 24/7. Good morning.
Flat Hulu, what's going on? Everybody
out.
live? Is
Start of the
everybody
weekend.
live today? Who's alive today? You guys haven't had your morning cup of coffee? Is that what's going on?
I'm up to
bang.
that right now.
Ace Frehley is not alive today.
What'd you say?
Ace Frehley of KISS, he's not alive today. He was not alive. He's no longer
Oh,
alive
man.
today.
What, today? He passed last night or what?
Yeah.
Dang, dude.
Who passed?
Guy from the member of the band KISS.
Oh man.
What, Gene Simmons?
I've got a question.
Who was another guy?
Okay, thanks, man. What's your question?
Do you believe that every like object has a inherent pull?
You'd have to define what a pole is.
You see,
No, like a pull. Like a pull. Like, yeah. Like basically.
Sorry.
Like a gravity pull?
Yeah.
Yeah.
I mean, like, there's like a, I don't know, like, they say that everyone has like a gravitational force, right? Do you believe that? Have you seen that in reality or not?
No.
Are you talking about like every object that has mass has a center or gravity well that would pull it to another thing?
Yeah.
No, it's a mainstream science hooey, dude. That hasn't been validated scientifically. So there's things that do attract themselves to each other for sure. You got, different types of ways that things come together, either magnetic or static or some other force that can be identified.
Okay.
But these are just well-established things. It's not like some mythical gravitational explanation. Like the conversation in the text chat, like Lot Wretch was talking. I don't know. Wasn't that guy a flat earther at some point? I remember seeing that avatar of his. Then he's like some kind of provocateur.
I asked that question to myself. I don't know.
Anyway, he was posting in regards to Kiro-san, kind of advocating for his position. But why doesn't he get on the mic? That would be helpful to kind of iron things out.
We're getting an explanation right now of how, when you drop a pencil, you can predict Neptune with that.
Oh shit, dude. Is that what he's saying? Let me see.
Yeah, Karo-san and the other guy. They both think you can predict Neptune when you drop
But
a pencil.
it would have been using Newton's laws of gravitation of planetary bodies. So
Okay, so that's what I'm asking you.
I'm getting there. I'm getting there. So observing the motion of the planets based on Newton's laws that he came up with, they were slightly off. And so that either means that his laws were wrong, or there could have been something else out there that they hadn't observed yet that could be affecting the motion of the planets. So they made a prediction. They said, okay, if such a body existed, where would it be to create the observation to affect what we're observing? And then they made a prediction of where that planet would be, where that additional body would be, and then they went and looked there and they found it.
Dude, like, what do you mean by slightly? They were slightly wrong. Like, you what standard are you using? Everything's so ambiguous when you speak, Kiro-san.
It would be Newton's laws of gravitation. So observing the motion of the planets, making a direct observation of the planets, and then applying that motion to Newton's equations.
Hold on, Kiro-san.
It's just a pattern.
Based on what model?
Newton's laws of gravitation.
No.
You just observing the pattern of things flying around in the sky.
I know, Flahulu. Hold on.
All right.
I want him to realize if he's using a specific model, there's models that are being used. Which one was it?
Yeah, it would be Newton's laws of gravitation.
No, you don't understand it.
Okay.
That's fine. Because you're observing things in the sky, and the quote unquote planets moving around are adhering to a specific model, a type. The Keplerian model, like Tycho Brahe. What model is being assumed that's being utilized here in your gravitation theory? Reg says Kepler.
I was thinking the same thing, but I wanted to make. I wanted to double check if Kepler's model was out before Newton's laws. I couldn't remember off the top of my head if that was true or not.
I'm asked. That's because he's the idea of gravity working in the specific manner that you're declaring. I think so. I think I'm answering Rich. I think so. But I mean, I wanted Kiro-san to actually tell me, because it seems like you can't just say it's using Newton's laws of gravity and then just saying that. It doesn't work. You have to apply it to a model.
Yeah, I do believe that Kepler's laws of planetary motion was out before, around the same time, or maybe slightly earlier than Newton's laws of gravitation. But
so then, how were they applying it to? I want you to walk us, because you didn't even know this until I just mentioned it now. So how?
Well, I don't know if it's necessary to have a model if you're just
what do you mean? No, wait. No.
For this particular thing,
you need a model, Kiro-san. How do you know?
Right, but the model would just be like observing a pattern.
The significance is you'd have to be able to give a prediction to where things will be at specific times. So you couldn't do that if there wasn't modeled out. You need to have a model and then apply this idea of gravitation to it, like you want to do. There's something very specific about it.
Yeah,
right?
I think maybe, I don't know if this is the answer you're looking for, but if I remember it right, that observing the motion of the planets and then trying to explain mathematically the motion of the planets. So Newton took his equations for gravitation, which would apply on Earth, not just onto planets, and he applied those to the motion of the pattern that we saw of the planets. It didn't quite fit. So either his laws were wrong, or as in they didn't apply to the motion of the planets, or maybe there's some other variable that's out there that they hadn't observed, they weren't accounting for. So they made a prediction and said, well, if there was some unknown variable, where would it be according to Newton's laws, equations? So they added that variable in there, solved for the variable, and go, oh, that would put this planet in this location. Would help if you had this, it would properly explain it would properly match the patterns. And then they go and look.
The variable was? What'd you say the variable was?
Well, the variable, they wouldn't know what the variable is. It would just give them an idea of where to look if that variable did exist.
Well, what variable?
Well, the variable turned out to be Neptune. But they predicted it in the equations before they saw Neptune. Before Neptune was observed to exist.
Based on the Keplerian model?
I don't know if you need... I'm not sure how Newton would have had to apply Kepler's model to make this prediction.
That's the issue, though. If you're saying that it applies to a model that you don't know if it does or not, then how can you say the predictability of that would be such that
it would? I'm saying it would fit with
Kiro-san. You got to hear me to the end, brother. You cut me off. So if you're saying that it applies to the motions of the planets, but you're not specifically giving it some sort of coherence to like what model it's applied to, then you're not. It just can't randomly be to an observation of seeing something. It has to be to a model specific. That's what you didn't supply. You didn't supply that.
And sorry to interrupt, Alfred. This model that he's talking about has also been replaced.
Yeah, but we were asking the model at the time that Newton would have used.
Yeah,
I would agree that it's been replaced because Newton's models had some
wrong.
What was his model, dude? So it's not Keplerian. What was his model?
Not Newton's model, but Newton's equations didn't perfectly predict or follow the motions of the planets. And specifically, they followed most of them, but specifically Mercury was the one that was given issues.
The only reason why I interrupted is because this model, loosely termed mathematical conception, has been replaced. All right,
Yeah,
this is no longer the stuff that we use. The mathematics is all out of whack. One violates the other because of the time component. Mass attracting mass is instantaneous. Now we understand the actions are not instantaneous, or Einstein would have them believe that it takes time or time is distorted. So it's just mathematical models, but we shouldn't reify those mathematical models into this is physically what is taking place. It's just a nice way to describe and maybe make predictions.
But the idea of, so with Newton's equations, the amount that Mercury's orbit was off was like a millisecond a year. It wasn't like it was crazy off. It was very small.
Kiro-san, what profound implications does this specific topic have to the physical world that we exist? What does it imply?
Well, I mean, if the math works when you model the solar system in a certain way, then the profound implication would be that it would imply that that's a true nature of the solar system.
Okay, we've got two models: mass attracting mass and bending and warping of space-time. Which one's true? They both make the same type of predictions, one with a little bit more accuracy, but they work in completely different geometries. Which one's true? If we're going to appeal to pragmatism, which one's true?
Well, the one that makes better predictions.
Oh, which God, is really?
Which is the curvature of space-time.
Okay.
But that doesn't mean Newton's laws are completely irrelevant. We still use them.
That's not the point, though. That's not the point, though. In regards to what Jedi's question was, which one would apply best? And you've chosen one, so you can't go back to say the other one would be better because you've already chosen the one you thought would be the best choice.
It's weird.
Where the accuracy matters, obviously Einstein's would be better because it makes more accurate predictions. But the math that gets you there is it worth doing the math if it's not giving you more accurate than you need?
We're going too far back. We need to go forwards, dude. So are we saying in this instance, being as we've got some models, but we're going to choose this one, that space and time are being physically distorted by mass? Is that the physical reality?
Say that again. I'm sorry. I was reading a DM I shouldn't have. I apologize.
No, that's fine. It's all right, dude. Are we saying that the physical reality is that space and time are being distorted by mass? Is that physically what's happening?
I wouldn't say that it's a definitive proof, but those concepts provide more accurate predictions. So
concepts, lovely.
I think it's more likely to be true than any known alternative.
Keyword concept. You understand that space is the absence of physical stuff and just really height, width, length of a volume. It's not physical of itself. It's the empty space other physical things occupy. Right?
But in this model, it's not the complete absence of physical stuff.
It's yeah, exactly. So we're going to reify Einstein's idea into physical reality. When he knows, and if you looked at it, this is just a mathematical idea that makes predictions by consequence of the mathematics that I've invoked to explain the phenomena around me. The crescendo to this point is space and time isn't physical, mate. It's a concept.
Well, yeah, I don't necessarily disagree, but if it makes
so that's why
if it makes good and more accurate predictions, then it's a good way to think of the universe.
I know, but that's why I asked. Which is true? What is the real physical reality? Is mass attracting mass, or is mass distorting space-time? Understanding that these are concepts, so none of them can be true. The fuck?
And what's interesting, though, is he says, like every other glober would, that basically is in his shoes, that defends this, is it makes more accurate predictions. It's almost like you say this verbatim, kind of like over and over again, to convince yourself that in some way by saying this, it's going to solidify a point that you think that things are happening in the exact way that they're telling you that it is for the Earth to be a globe. But in what way does that actually? I want to know what practical means does that? What value does that have?
Well, I think the value
does it make?
Like the value it would have is like
predictions.
Is that it makes predictions, and then but like I'm saying that if you're using Einstein's concept, and we'll call it a hypothesis, or whatever you want to call it.
No, Kiro-san. I'm asking what practical what does it imply? What things in practicality? What do we do? What do we use? What is it good for?
Well, wherever that level of accuracy is
tell me
is pertinent.
Tell me. Yeah, that's ambiguous. You're speaking like a lawyer. Just tell me directly, what are we using it for? More accurate predictions. You guys say this all the time. I'm pulling you up on it because it seems like I don't think you know what you're talking about. Now, unless you tell me specifically what practical use case it has.
I mean, like in our day-to-day lives.
Now, give us an example of a regular prediction, and then give us an example of a very precise prediction. There you go.
Yeah. What do we use it for?
So, I mean, for our day-to-day lives, probably not much.
Okay. So, what is it predicting? What? You guys say this like a mantra, and you don't even know what it means.
Well, I guess the prediction would be, so Einstein or Newton's predictions was based on like a cause and effect relationship, and then making predictions based on that cause and effect relationship.
This is frustrating. What is it predicting? What?
Like the gravitational effect on objects.
Okay. Like what?
And wherever that matters is where it would apply.
Okay.
So in our day-to-day lives, it doesn't matter.
Give me a prime. So it doesn't matter in our day-to-day lives because we don't use it in practical.
Not in our individual days of lives, but like day-to-day lives. But the things that we might depend on unknowingly might.
Like what?
Well, you know where it's going, right?
No.
Because I think you do, AV. You know it's going to like the orbits of satellites are more accurately predicted using Einstein's theories than Newton's equations.
Yeah. Okay. Oh, that's good. Show me validation of that. I want to see validation of that.
So it would be GPS satellites.
Sure. Show me the validation of that being predicted exactly like the way you said, using what you said it needs to be predicted with. Show me. Show me the money right now.
It would be like the correction of time dilation on satellite, especially GPS satellites, because
all right. That's
very relevant.
That's some more good stuff.
Man.
Show me the method by which it is used in it. I want to see how it's applied. Show me.
I mean, I wouldn't know that because I don't do the actual satellites. So.
You wouldn't know that, would you? So all of this mantra that you guys say over and over, it makes useful predictions. And I'm saying, what is it used for in practical reality? Well, not in our day-to-day lives. Okay, so where then? Well,
it's used in our day-to-day lives.
But because that level of accuracy doesn't change.
Level of accuracy, you don't even know what you're saying. You don't even know how accurate something is because you can't give me one prime example of how accurate it is. Isn't that true?
I did. Like the orbital, the orbit of Mercury is more accurate when you pattern its movement against Einstein's theories compared to Newton's theories. Okay. Right. So that's an example.
What practical use case do we have for that? That right there. What practical use case? Really? Oh, so it's
not in our day-to-day
lives. It's a fun factoid that you guys like to say. We make useful predictions every single time, and yet when I pull you up on one prime example, you're bankrupt. There's nothing you can show. And even in the case where you're saying that it's useful for satellites and how they orbit, and I'm saying, okay, well, yeah, show me where the methodology of how it's worked into and applied on this. You can't demonstrate that to me. I don't have any knowledge on that. No, duh. I'm pointing out the fact that you guys regurgitate this mantra day in, day out, and you don't have one prime example. How funny is that?
I've read the papers that talk about why it's like how it needs to be accounted for something like GPS satellites.
You know what? Everything that you say, Kiro-san,
that's about as far as I can go.
Yeah, everything you say, I can pull you up on. You won't be able to verify. You know that, right?
What
Would you like me to do the
GPS
same
satellites
thing?
don't correct for time dilation based on Einstein's theories?
Yeah, how do you know that's true? What's the point of verification? You know that information checks out. How did you figure that out?
If you measure
Not talking
the
to you.
age.
Quiet. I'm not talking to you. Go ahead, Kiro-san.
Right, but again, that goes back to what I originally brought up first today was the standard of evidence you're applying.
No, prove it. Prove it. Prove it. Can you do it?
Well, you know I can't. Because I'm not the one that's launching the satellites and managing the
That'll be all, sir.
stuff.
That'll be all.
Yeah, but that level of standard is just not useful to hold.
Yeah, it is. Because you guys regurgitate this mantra day in and day out. Oh, it makes useful predictions all the time. It's so accurate. It's useful and it's predicting. Oh, what is it useful and what is it predicting? Well, I'm not, I don't do any of that. Not anything in reality. Well, then why are you saying it? Why is it even being brought into this conversation? God, dude. I'm just showing you guys always do this. Every time you're brought in and showed a prime example, you guys come up bankrupt. There's nothing you have to offer. That's the way it is. I mean, what do you want to do?
The best they have to offer.
Yeah, it's weird because they say this mantra and they feel like by staying in that whole gray area of being ambiguous, they could just keep saying the same thing over and over again and nobody pulls them up on it. Well, I'm gonna. That's what happens whenever I do that. And you've been saying this over and over. You're like, shit, I've been saying it for quite some time and I don't even have an example. Huh, that's weird. Maybe I should have one next time. That'd be useful. But it isn't just you. I'd pull anybody up that's saying that. Why not? You're making the bold claim. It makes accurate predictions all the time. Just so accurate. Any more for any more? Okay, then.
I've got a question.
What's your question, man?
It's about the different seasons and the different stars in different parts of the world. How do you explain that yourself?
Seasons?
Okay, well, actually, before we get to that, do you believe that the sun and the moon move independently?
Independently? What do you mean? Independently?
Yeah,
Well,
it's important.
yeah, no. Come on, that's obvious what I mean. Do you mean the sun and the moon? Do they follow any type of a movement?
Yeah,
like a repeated movement.
It's a cyclical pattern. Jedi, if you want to.
I mean, yes, they move. There you go. That's a simple answer, right? They move.
Yeah, that's what I meant. Yeah.
Yeah.
Sure.
So the sun and the moon, they move, right? So when it comes to like the seasons and different okay, so you must believe then the sun, it also goes kind of up and down because obviously countries have like winter and summer, right? So the sun must.
Sorry, what do you mean by up and down? What, as in altitude?
No, more
As in north
so
and south?
Yeah, that's what I mean.
Yeah.
Wow.
You're the decoder today,
sorry.
Jedi. That's.
I know, mate. I'll go and do my things. it's like otherwise I'm not
I'm gonna need you to decipher
wait.
conversation.
Do you also believe it goes up and down in altitude?
I don't know.
You don't know, but haven't you measured it?
Going up and down in altitude?
Yeah.
No.
How would one figure that out?
By image testing, by watching it closely. I don't know.
No. I mean,
watching what exactly? Like, what are the things that you're even talking about? Do you know what they are to be asking questions about them?
Okay. So I will tell it from my perspective. All my life, I've seen the sun, right? And it looks like, from a human perspective, it looks like it's moving, right? But it seems to get smaller.
What's it? Yeah, but what is it?
It is the sun seems to be getting smaller.
Yeah, what is the sun?
It's just,
what is the sun? Describe to me what you think the sun is.
The sun is a source of light and a source of heat. It gives off light.
Okay, and where is it?
And it gives off heat.
Where is it?
Well, from my perspective, it's up in the sky.
Okay, it's up in the sky, right? Do you know
it doesn't look
else about it?
So let me explain. So obviously the mainstream is that it's like very,
I know what the
very far
mainstream
away,
is.
right? My perspective as a human is it doesn't look as far away as they say it is. It seems it seems closer than what they say. And it seems like the sun and the moon seem to be relatively similar in size as well. Right. That's what it seems like to me.
Right, but you have no idea what it is, how far away it is, what it's made out of, what medium it's in.
Of course, no.
Or whether you're seeing a physical light source or an apparent light source, and there could be a whole bunch of unknowns that that we can't even comprehend about it. So I mean, it would just be there would be so many assumptions thrown in to be able to make specific claims about exactly how it operates. Same with the stars, even more so with the stars.
Right. I mean, because it's so high up and we cannot physically touch it, it's hard to kind of measure, find out what it is, because we cannot go to the sun and touch it and take a sample of the sun in a laboratory and break it down. It's just in the sky far away. But you can, I guess you can measure its travel, right? You can measure how it travels day to day, week by week, year by year.
Were you asking a question, or are you just making these statements? What you're saying?
No, my question, I wanted to know if anyone has any more information about the sun and the moon and the seasons.
No, I mean, as far as our observations go, it's based on what people have been observing over time. So the passage of time, we've been seeing the sun do certain things in its cyclical pattern that we see it in nature. That's basically all we can detail. Things like, the heat we feel coming from it, that sort of stuff. That's just basic. I mean, we know what you know, essentially. Outside of that, what it is probably a greater point that DJ was trying to get you to realize. If you can answer that question, it's either something you know or something you believe based on what you've been told. That makes sense?
Well, yeah, I guess so. But I guess what I'm trying to say is that I've spoken to a lot of people, and they tell me that if the Earth was flat, then the whole world would be lit up with light. Now,
right? But who's saying? Who's saying that?
Now, I don't obviously it's not true, because the sun might not be so big. It might be smaller than what they think it is, so it wouldn't light up the whole world.
Yeah, but that's a positive claim. What they told you is something that they can't back up for themselves. So if they said, well, if the Earth was flat, it would light up the whole entire Earth, then you have to tell them, how do you know that? You have to. So when you're being questioned, you can also pull the people that are telling you that up on how they're making that assertion. Why would they say that? That's kind of weird. Why would you say that the sun would light up the whole entire earth? I mean, you can have a voice to critically think about things that are being told to you too. You don't have to accept that you have to answer that question based on the way it's proposed to you. You know what I mean? That your defense is that you can critically think about what's being said to you. You can, if they said, well, it would light up the whole earth, you'd be like, what do you mean by that? What image of flat earth do you have in your mind? And then they will tell you, which would probably be a straw man of what flat earth is. Most likely, I'd say.
This is crazy.
Yeah, but it's true. Because in the realm that we have this discussion about it, people have assumptions about what they think flat earth is. And they use a straw man idea on what it is to tell you, well, this wouldn't work. And you're like, wait a minute, what flat earth do you have in your mind? Like, what are you thinking about when I say flat earth? And when you do, ask them that, they'll reveal to you what they have in their mind, and it would probably be a straw man. Some concept of a disc pizza earth flying through space.
I've got a question. Are people wrong for believing what they've been told?
Are they wrong as in like morally wrong?
Like are they morally wrong for believing that the earth is a globe if that's what they've been told?
I mean, it's misled belief system. I mean, I don't know about it being wrong. I mean, obviously you could say that it's wrong because it's not right, but I mean, on the fact that, is it going to cause them some type of bad life lived? I don't know about that. I mean, they could live their life generally like a good person, even believing that the earth is a globe, but you know what I mean? They could still do all the things that you do, just they have a different belief system. That doesn't make somebody good or bad, like knowing that. It's just they following information that's not true. They're misled.
This is crazy.
But the part where you talk to them about it, like, I guess where you want to have a conversation with someone is to get them to think about their worldview, like to not be afraid to have that conversation. I think that's kind of the thing that you want an environment to have a conversation like this, is for them not to feel like they're going to be looked at differently if they talk about what the nature of reality is. Because I think that a lot of people have inside them, they don't want to have this conversation because they know what they're going to look like if they even mention it. You know what I mean? Like, people will mock them or do things where they'll make them feel uncomfortable, so they will just not have that conversation altogether. Whereas maybe you would. Yeah, you've heard it, like, even in here, right? People struggle with the fact that they don't know what they know. They are saying words that they think that already are true, and when we ask them, go ahead and explain how you know what you know is true, they don't have a reason for it. Like, I don't know, I'm just saying them.
I spoke to somebody in the server about flat earth, right? And they were all mocking me, and they said to me, they were like, oh, well, one day you'll be able to go to space and then you'll feel stupid. So,
yeah, but they're projecting their insecurities onto you, man. They're insecure. They don't know.
But I was thinking to myself, right? It's never gonna happen. They keep saying, like, oh, one day we'll send flat earthers to space. But it's never gonna happen. So it's a stupid argument. But listen, what blows my mind, and this is what really gets me, is that apparently, I've not tried myself, but you cannot actually measure the curve of the planet.
Correct.
Is that true?
There isn't any. That is 100% true.
But then I once spoke to an older guy who was, he was an engineer, civil engineer, right? He'd worked on bridges, like this is in real life, and I kind of knew him through family or whatever. He told me that when he designed bridges, he did have to account for the curvature of the earth, because I asked him, and he kind of just, when I asked him, I didn't mention flat earth, but he kind of giggled, like he kind of laughed, and then he was like, oh yeah, we have to account for it. So why would he say that if they don't?
he's protecting the stance that flat Earth is silly, and he doesn't want to get into it. Basically, is what he's telling you. And because he works in a field that you have very little knowledge of, he can say that with confidence, knowing that you're not going to be able to outdo what he knows. You get me? Because it's kind of like gatekeeping. I guess you can put it in that way. Because he doesn't actually account for the curvature of the Earth. We know that because we've spoken to many engineers. We have engineers in this room. So we know that that's a lie. You do not account for the curvature of the Earth when constructing, things like
why would he say that to
canals, bridges, like many different things. They don't account
Sound
for
like
curvature.
a LARPer to me and say that to you.
Yeah, but why would he say that to me if he was like, I don't know why he'd lie to me about it. It's just strange.
Well, maybe he's delusional. Like from an engineering perspective, somebody who would say that is really betraying their own understanding of specific tolerances when it comes to dealing with dynamic weights and material imperfections, construction issues, and so on and so forth.
DJ, were you going to say something?
Oh, no, I was going to say what Yoda just said, so it's all good now.
Yep. I mean, they don't account for the curvature. That's a fact.
Yeah. And an honest engineer would be like, we don't need to because the amount of precision we would need is so small relative to how much tolerances that we deal with on a practical basis.
Yeah, there's no way. It doesn't, not even factored in.
Have any of you tried to measure the supposed curve?
Well,
yeah, the whole room.
Yeah, absolutely.
So it would be, it's at a specific. It's like it's not something that's very difficult. It's something that would be apparent. It would stand out if you're going to do like a long distance observation. It would have to be there. The Earth would be obstructing the observer at a certain distance, predictably, right? Because of the geometry of the Earth. Predictably, at a certain distance away from you, the Earth would obstruct your view from things in the far distance. So, according to the radius of Earth, you could just go back to the values that the Earth is a radius of 59 miles, and you just put that into like geometry away from you with the 8" per mile squared drop over distance. And then, of course, like I said, the horizon would be the leading edge of that sphere where you couldn't see beyond. That's the thing, though. If that were true, that would stand out. It would be obvious and it would be true. But it's not. The phrase "we see too far," you may or may not have heard. It goes along with the idea that the predictable distance that the Earth would be with the geometry of what they're claiming it is would be intact if it were true. But that's not true. So we see too far means that we see farther than the predicted distance that the Earth's curve should be predicted to be at. So it's not where they're saying it is, based on geometry.
Another surprise that might surprise you, Zay, is that
Did he cut out?
Jin, you went silent there.
NASA doesn't have that. We don't have that.
Jin, can you start again? You cut out.
Oh, thank you. Sorry about that. I said that NASA doesn't have a picture of Earth from space in its entirety. They don't have that. They don't have a video of Earth rotating on its axis. There you are.
Well, they do claim to have one. They do claim to have one, though, right?
Yeah, they claim to have one, but it's not real, is it? That's the thing.
Oh, yeah, putting it to this guy who's coming in, and he, like, from what I gathered, our first part of the conversation is that he's just coming into this topic. He's agnostic at this point. He's not really one way or the other. So he's kind of like wanting to lean towards, how we're discussing. But yeah, you just have to be exposed more to the conversations. And there's a lot of other different topics that get brought up. So just hanging around this room, you could probably be able to articulate your points a little bit better by gleaning things from what we say. You can glean stuff. I mean, there's tons of material on the 24/7 Flat Earth Discord too. I would actually point you to that if you really want to know more. There's like so much information from videos.
Yeah, I used to be on there a little bit. I just like. Have you ever spoken to a pilot?
Yeah, plenty, of course.
And what did they say to you about what they think it is?
There was a guy. I'll give you this short little thing. I had a we used to do little shows over there on Twitter. Well, now it's X, right? But this guy named Superfly, he passed away as of like maybe was it earlier this year. But he would talk about that him being in aviation for over 30 years, flying every type of plane commercially and whatnot. And he says, never did I once like think that the Earth was a globe for when I would do my flights and such. Anything that I did in my job, I have him recorded on Frontline Unfiltered. That's the name of the account, Frontline Unfiltered. You can look for it, and it's in our previous shows that he came out on. And he would defend it, like he would argue with people that are thinking that the Earth is a globe. Him being a pilot, and he said, his friend was another pilot that he knew that flew at a different, because he flew it mostly like commercially at altitudes up to 50,000, but he said his friend, I think, flew up to like 70,000. So him and his friend were of the same mind that the Earth is not a globe, even at those altitudes. So it's kind of like, even in his day-to-day task from like, doing jobs or flying from one place to another, he never factored in the curvature of the Earth in any way. Nor did he need to, because, he would tell people, I'm just going from point A to point B. I don't have to think of flying over the curve, Pilots don't do that. His name was Superfly.
There's a video that Jen's just put in the side chat if you want to save it for later. It's it's a bunch of interviews with pilots talking about this topic. 28 pilots. So there's a whole bunch of pilots talking about flat Earth in that. And I'll post another one, which is a KLM commercial airline pilot doing like a little presentation about flat Earth, which she actually got in big trouble for.
Yeah, I mean, it's no big deal. I mean, these guys are just telling us what they do in their job. Now, the problem that we have is when there's some who claim to be the pilots that they say they are and then say the Earth is a globe. There's a couple of them out there. Or even most of those guys do believe they're on a globe. They just don't operate their plane as if it were on a globe. You understand what I mean?
Which is strange, yeah.
Yeah, they do their daily task, of doing their job. They could believe they're on a globe, but they don't do their job like they're on one. Like they're not trying to factor in curve or, think about the Earth spinning around or anything.
So as a pilot, right? Let's say the Earth was a spinning globe. What would pilots have to do different to what they do now if the Earth was a globe?
Well, they'd have to account for the curve over distance. And adjust. They'd have to make adjustments for the curve. That would be something.
So they'd have to put the plane down.
Well, not plane. The plane would. It's okay. So if you're going, like, think about it, right? You have a ball, and if your hand was above that ball, and you were gonna follow the surface of that ball, it would be going around that ball, right? Like a basketball.
Yeah.
But a plane flies with its nose up, so it would be flying with like your hand tilted upwards, like around that ball. But it would have to be factoring in that it's going over from point A to point B, a specific amount of curvature that would have to factor in.
Especially would have to put the nose down.
What about not nosing down? I don't know about that, but I would say that it would have to account for the curvature, for sure.
Yeah, it would have to take a curved trajectory. It couldn't be flying horizontally, straight and level. That on a ball, that would be totally impossible. So it would have to follow a curved trajectory. It will still have its little nose up because of airflow.
Yeah,
airflow is crucial, you see, because without the airflow being smooth over the aircraft wings to generate that lift, and the pilot flew horizontally, zero level completely, it would be a battle between the pilot and the plane to keep level because the wind flow. You see, so the reason for the nose up is to set that angle, and then the flow of the wind just flows over the wings, and we, the passengers, have a smooth ride of it, and the pilot has an easier time of flying. You understand?
Yeah, but I'm saying that if it was a globe, right,
Yeah.
How would the adjustment for the plane over the curvature happen? Is what I'm trying to say.
Over distance, over distance and and the speed that it's going, it would have to account for that because it would be getting further away from that surface. So it would have to be compensating for that as it's going over that curved surface. Because it
would have to dip down then at certain times.
No, not dip down. I know what you mean, but it would have to follow the curve.
Yeah, it has to take a curved trajectory. That's what we're saying to you. That's it. It's a curved trajectory as opposed to a horizontal linear, as the pilots themselves say it, straight, leveled flight is what they say. Straight and level.
Every pilot would disagree the fact that they would nose down it like that. I mean, you know what I mean? Like they don't that claim that pilots would have to nose down. I think that's wrong. They're not doing that.
Yeah. Right. The only time they begin to nose down, and they'd have to notice. Hang on, please. The only time they actually do nose down, because they do, is when they are coming into land from a few 100 miles out or something. They start to drop altitude, and you notice the plane's angle is down. It's a downward slope. All the seats, the aisle is downwards. So if you're sitting at the back, you will notice that because it's been flying horizontal. So the plane does nose down as it begins to approach the destination airport. Right. Dropping altitude. Has to.
Yeah, but when it's in flight, though, it needs to generate lift, like Jen was saying, so it'd have to be nosed up a little bit as it's in flight. But it, like I said, it would still have to follow that curved trajectory. You'd have to compensate for that. It'd be a part of something you'd factor in as a pilot. They don't factor that in.
And it would be in the in-flight telemetry data as well. It'd have to be there because and it's not in there as far as I'm concerned. We don't see it, you see.
It would correspond with that. Everything would be as if the Earth was a globe that they were flying over and or in motion. These things would have to be taken into account to some degree. And they're not.
And then what about the rotation of the Earth? Because they say the Earth is rotating as well.
Yeah.
Remember?
I was telling him too. Yeah, you wouldn't have to take that into account either.
This is what I heard yesterday, AV, from a friend of mine. He's a Globie. Don't you know that gravity pushes the nose of the plane down by itself and pilots aren't even aware of it, bro?
No, that's wrong.
You wouldn't have to account for the...
I know.
You wouldn't have to account for the spin because the force is relative.
Yeah, so then it's not accounted for. That's the point that we're making here, Blair. That's the point.
Yeah. Now, Blair, imagine this: you're the pilot. You've left Heathrow Airport. You're heading towards the equator. You're carrying 600 miles per hour. You're heading south. The equator and the Earth itself. The Earth itself is rotating anti-clockwise. That means from right to left. That's west to east as you're heading south. Now, as they say that the equator, it's moving at 1,037 miles per hour. You've only got 600 miles an hour. You're 437 miles per hour in deficit, and your runway is coming from your right. How do you make up that difference to land? How do you? Can you see now? So you do have to factor in the curvature. Sorry, the rotation of the Earth. It would be a problem with a pilot.
You don't have to factor
No, we don't in reality. You don't in reality, but in actuality, if it was a globe that was rotating, you would have to, Blair.
You don't have to factor it at all. This is an easily provable experiment. Go drop anything in your car while you're driving.
Yeah, Blair,
you got it wrong,
fine.
Blair.
Listen,
I'm going to get out. I'll tell you later on.
That's fine. You can say that, but like the different vectors that the planes will be flying from whatever direction they're coming from would be either for or against, or in a different way.
I'm not being
the rotation of the Earth.
I'm not trying to say like, dude. Literally, it's basic physics. I'm not being funny. It has nothing to do with the planet spinning. If you're in a train car, or if you're in a car, or if you're in any moving vehicle, it doesn't matter.
Let me put it to you this way.
If you drop anything, or you jump up and down, you don't go flying into the wall.
Let me put it to you this way, dude.
Dude, literally jump.
I know you're advocating, dude. You're advocating for that. It doesn't need to be taken into account because of what you're saying. So now you're going to have to explain why people do take things into account, like Coriolis. Like in your specific paradigm, that is when something actually, the Earth is spinning underneath the thing that's moving across the top of the surface. You're kind of like in a paradox. The paradox
no, I'm not
is
saying
kind of you are in a paradox.
about proving whether or not it's a globe.
Yeah, you
I'm just
are in a
saying that's
paradox.
basic
So-
physics, dude.
Yeah,
Just
so
go
But what
to
you're saying about hold on, if what you're saying about being in a car, I'm just saying you can drop something and like it's not affected. It's a little bit different because he was saying you're on a plane and the earth underneath you
the
is
same
spinning
concept.
against you. No, but the earth beneath you is spinning against you, right? And you're flying over that earth. When you're in when you're in like a car, you're going like one direction, right? And then you throw something and it's not affected by it. But that doesn't mean it's the same as the whole like planet spinning beneath you and you're trying to go against it.
Dude, it is the same.
Exactly.
different
You're actually on the surface. You're on the surface of the Earth anyway.
Dude, it is the
so that
exact
doesn't
same
work.
concept. You're denying physics.
It's not. It's not.
Sorry,
It's not.
linear motion isn't the same as rotational motion.
No, dude, it is literally the same concept.
No, it's different forces apply.
It actually does not matter. You can literally
Wait a minute.
jump in a train car. You get the same
No,
effect.
but you guys,
don't
yeah,
go
hold on.
flying into the wall.
Blett, hold on a second. You're arguing for the fact that it would not be taken into account or things up in the air would not be affected, but that also goes against your paradigm when you speak out the other side of your mouth and say that hurricanes are affected by the Coriolis force of the spin of the Earth. And not to mention that, but sniper bullets. There's other things that you guys always claim that are affected by the spin of the Earth. So things are affected in your paradigm by the spin of the Earth. Now you're
That's
saying
true.
and you're advocating for that things are not affected by the
What does
spin
they
of
mean
the Earth,
when
like
they
the
say
airplane.
that it's the spin of the Earth? It's wind.
So the spin
What
of the Earth
causes
does not.
that
Are you
motion of the wind?
advocating? Are you advocating for the position that nothing is affected by the spin of the Earth? Is that what you're saying?
Oh my god, it has the most minor effect, sure, but
Yes
like
or
if,
no?
if you jump in a train car, you don't go
No,
flying
answer
into
the question,
wall.
Blake.
It's
Are
a
things
relative
affected?
force. Dude, do you
Blake,
not
are
know
things
physics? Did you take high school
you
physics?
you don't have to keep repeating that. I'm asking you: are things affected when things leave the surface of the Earth?
Dude, if you jump in place, you go flying
Just
into the
answer
wall.
the question. It's a yes or no. Are
Seriously,
things affected?
when you jump in place,
I'm gonna
are
have
you
to hold you
flying
to this,
into a
Blair.
wall?
I'm gonna have to hold you to this. Are things affected when they leave the surface of the Earth by the spin
How
of the
far
Earth?
up?
Doesn't matter.
Actually, no, they're not.
Doesn't matter. Are things answer the question? Are things affected when they leave the surface of the Earth?
You are genuinely fucking stupid.
It's weird.
Just a yes or
Alpha.
no. It's yes or no.
It's really weird behaviour, dude.
You are genuinely fucking stupid.
Right,
Okay,
my friend, let me ask you this. What causes the motion of the winds north and south of the equator? That clockwise and anti-clockwise motion. What causes
Holy
that?
fuck, I'm aware that the wind is caused by fucking spin. On the same note, though, you don't go...
Okay, so if things are being affected by the spin of the Earth, you're saying planes are not affected by the spin of the Earth because of the same physics that you're describing would affect. That's a paradox. You're in a paradox right now.
Dude, do you not fucking get it? If you are literally in a train car
I
and
do.
you jump, do you go flying into the wall? No. If you
It
literally...
depends.
Oh, it depends
If
on
you're
what?
talking about a straight line motion, or if we're talking about a rotational curved motion, different forces apply.
Yeah, if I suddenly shake the train car to the side,
I'm not
then
talking
yeah,
about
sure.
shaking the
You can
train
fall
car. I'm
over.
talking about
But
not
dude-
going in just a straight line. I'm talking. I've said it like 3 times.
Mate, that does not
Rotational
matter.
motion.
That actually
doesn't
does
motion.
not matter.
Doesn't.
If I suddenly... Okay, do you own a car? Like, you can actually fucking test...
Okay, wait a minute. Let me get
What's your language,
When I
lad?
go
What's your
down
language?
a
lad? What's your
roundabout
language?
in my car, different forces apply.
Oh my god, dude. It's the same
I know, it's
effect
hard
at a
for you,
different
isn't it?
scale. It's the same
A
effect
different
at a different
scale now.
scale.
We're just talking about 2 different directions of
Fuck,
travel.
dude, you were actually stupid. You didn't take high school fucking physics.
I did, dude. I went to fucking university. Now shut the fuck
Oh my
up.
god, you have a fucking useless degree. You...
All right.
Dude, what the hell is this ad hominem attack?
Relax, dude.
You're just attacking me. You're not
You
attacking
guys
the
attacked me for the
argument.
last fucking 3 minutes. I'm trying to tell you
I've
it's the
tried
same
to
effect.
explain
Do
your
you fly into a fucking
miscomprehension.
wall? Yes or no? Answer the fucking question.
You're an idiot, dude.
You're a fucking
I've asked you to
retard.
explain the
What did you
difference.
study? What did you fucking study?
All right, we're going to pause him for a second. I'm going to pause him for a second because I asked him something very specific, whether or not something that leaves the surface of the Earth is affected by the spin of the Earth. His answer was a yes and a no. So we need to have clarification whether something that leaves the Earth is going to be affected by the spin of the Earth. Yes or absolutely not. It will be Even if it's a minor degree, it will be affected or it will not be affected. So I need to know this from Blair. He keeps on appealing to people not graduating from high school and whatnot. I just need to know the answer to the question. Will things be affected by the spin of the earth?
Less of the insults, please. Less of the insults and be nice. Go ahead.
Yeah, go ahead, Blair.
If there is no wind, in that case, no, it doesn't fucking matter.
No, it doesn't matter. So a plane flying through the air, is there wind or not?
Come on.
Are you like genuinely stupid? Yeah.
Answer the question. Is there wind when a plane flies through the air? Yes or no?
Yes, but it depends how high you...
Okay, so now that we know that there's wind when a plane flies through the air, is it affected by the spin of the earth? Yes or no?
You're genuinely a dumb nigger, aren't you?
Yes or no? Are you just trying to find your way? No, the weird thing is that, those words don't affect me, Blair. I really want you to stay to the point and show the audience if you know the answer or not. So it's really just making you look bad when you actually throw these ad homs. It doesn't affect me, brother. So I want to know, based on what you're saying that I don't understand, you're saying that it should or should not affect the plane. Go ahead, Blair.
This is such a disingenuous argument.
Bye.
It's up to you.
Dude, you're literally lying to me about basic physics.
You're boring at the moment. You're boring.
Dude, you're lying to me about basic physics.
All right, let's get citations.
I'm not lying to you. I'm letting you like basically walk into a trap of your own making. You said that a plane would not be affected by the spin of the earth, and you made this whole ramble on how I don't understand physics and I didn't graduate from high school. And yet, on the other side of your mouth, you just agreed with Jedi that things are affected by the spin of the earth, like a wind. So then I therefore said, does a plane fly through anything like wind? And is it affected by wind? You said, yeah. So, okay, so is it affected by the spin of the earth, which is the greatest point? Yes or no?
And the example you're giving, that's disingenuous. You literally said
How is it disingenuous? We have planes flying every single day. People get on these planes. There's pilots that have a job. It's not disingenuous. It's an honest question that people want to ask. Inquisitive minds want to know if a plane is affected by Coriolis or not. Based on what you said, we led up all to the place where wind is a factor. And so a plane flies through wind. So therefore, what would be the answer? Go ahead, Blair.
Dude, it's the train argument, but with a fucking planet. You're a retard.
What train argument? But it's not on the ground. The plane's in the air, separate from the ground. Nope, you got muted by someone else. That wasn't me. People are tired of your insults, Blair. And the problem is when you cannot articulate your point, or either that or you have a small mind, either one, you get into this position where you're really upset. You don't need to be. Just say, I don't know. It would be the easiest intellectually honest position to take. I don't know. You could have said that a long time ago instead of getting in your feelings about it. Okay, I can't override somebody else's mute, so whoever muted him, if you want him muted, then he'll stay muted. Yeah, if we have anybody else in here you want to talk to?
I think he's been muted for the TOS violation.
Sure.
I think that's all it was, dude. So unfortunately, because of the TOS violation, I think he's going to remain muted, if not banned, for a certain amount of time. It's just the way things have to be. And I think you pointed it out, right? He's trying to search for a crack in the door because he needs to back out the argument, but claim some type of victory, like he got banned. So unfortunately, that's what you've got.
Yeah, you're not leaving with that, Blair. You know that, right? Because I kept your mic open. So I wanted you to go to the end, but apparently you said words that are going to cause the channel to be in jeopardy, and that's all really you can do. It's because you're upset. You got in your feelings.
Self-sacrifice.
So. Yeah. He threw himself on his own sword, which, fine, be that what it may. But you're not leaving here with a victory, dude. You're taking a massive L for your behavior, number one, and for your inability to articulate your point on what you think you know about the Earth's rotation. You're going to take that massive L when you leave. I don't know. That's not going to sit well, I don't think, with you, but that is what it is.
Throwing insults doesn't win an argument.
No.
Sorry, my do apologise. I thought my point's really valid. And we're talking about straight line motion in his bloody train. It's different to actual rotational motion. So linear motion, rotational motion are not the same. They describe different types of movement. Linear motion is movement along a straight line, while rotational movement is around an axis or a fixed point. Different forces apply. Now I'm going to drop the citation that speaks about the different forces. Just give me a moment.
Appreciate it, dude.
Yeah, no worries. It bugs me. It's a constant argument that we've heard for almost a decade now, right? You know, you get in a train and jump up and down. It's fine. It's not the same. It's a false equivalence. It really bugs me.
Yeah, if we were on Rumble, this conversation would have kept going. It would have kept going. I would have exhausted every point, and he would have just like self-muted. He would have just put himself on mute. There's no escape, Blair. The logic is sound.
Okay. So, continuing. Forces that apply in linear motion, forces cause translational movement, and the force is applied along a direction of motion. In rotational motion, the force applies off-center, creating a turning effect called torque, which causes a rotation. Now, when we're traveling in these paths, for example, when we started driving around in my car and I was driving at a constant rate at 60 miles an hour, I didn't really feel any effect on me apart from the acceleration when I bloody took off. But now I'm stable, things appear to be fine. Like I might be able to throw things up and down in my car and catch them if I'm good enough. Now, if I start changing my vector, rotating around a roundabout, you're going to start noticing that the window next to me is getting bloody closer to my face, and all of a sudden I smash into it because my rotational vector is throwing me away from the center of that rotation. It just bugs me, dude. But anyway, everyone can continue.
Game, set, match. They try so desperately because that's all they can do is just be desperate. But, I mean, all you have to do is keep his composure, man.
Didn't you take a basic physics course? What universe? Blah, 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 blah. I'll tell you what, let's get the bloody textbook and read what it says.
You had a oh hell no moment there, Jedi. Oh hell no.
Yeah.
It sounds like you're having your morning Earl Grey, yeah? Or oh no, you what do you drink?
No, this is afternoon tea now, mate.
Oh man.
It's gone to 4:30.
We're already late in the evening.
Yeah, I'm starting to get the tea and the cakes out.
That sounds like a great idea.
Mm-hmm.
It'd be nice to have a proper tea and cake with you, man. Just chilling.
That would be awesome thinking about it, man. Especially around your new place. Got some land there, dude.
Really?
Your new place.
Oh,
not
mine.
mine.
I thought, yeah. Well, that's fine. If I can't
My
get
new
the UK,
place will be
maybe
coming
the UK.
hopefully sometime before Christmas. So hopefully over the next couple of months, I'm going to be moving anyway into a much bigger place. So things are definitely looking up, dude.
I like it.
Mm-hmm.
All right, keeping to the room topic. If anybody in here wants to go ahead and provide evidence that the Earth is a globe, you guys are welcome to do that. It seems like there's all we've got filled today with is just speculations about the Earth being a globe, and I pulled a couple of people up on what they know, and it's always it ends the same way all the time.
Well, a dead end. A dead end where this person is continually trying to bash the wall down, but they're not going anywhere. But they're just going to keep repeating the same thing, hoping at some point it's going to change. It's not.
They're trying to knock down a wall with marshmallows, and they're throwing them as hard as they can. It's like, doesn't matter, man. You have to either bring something that's like evidently true or not. Like, you have to show. That's been today's morning episode. Like, don't just say show. Who's this guy at the bottom with the little tractor? He's a flat earther, yeah? Iskar? I think his name is. I don't know how to say your other name. Taunt Law? Shout out to Yoder. Whoever else is in here right now. Heretic, what's up, homie? Gemsy. Alaskan Malamute. What's up, bro? Batman. The Batman, bro. Haven't heard you in a while. $20 cups.
See, DJ sneaked in. When did he do that? Or was he been here for ages?
I've been here for ages, man.
I'm sorry, man. How you doing, dude? You right?
All day, yeah. Doing good, man. Hope you're well.
Yeah, man. Doing great. Just waiting for the Friday action to begin. It's been an interesting morning so far, but the whole weekend lies ahead. It's going to be fun.
It was a good day yesterday, man. I tell you that much. Yoder couldn't get enough of it. He's like, dude, I don't want this day to end. Just continual bombardment of.
It was a good day.
Crazy Globers.
Especially going through those arguments and stuff as well, like we did. That was good.
That was fun.
So what happened to Blair then?
Oh, he violated TOS, and then we put him on mute, and then he just exited afterwards, Jen.
Oh, okay. All right.
You know, we wish that that's not the case, Jen, but, I mean, we can't control somebody from being, that obtuse.
Yeah, so, yeah. He was obtuse from the beginning anyway. I didn't like his condescending tone at the beginning anyway, to be honest. So I said to him, condescending, a bit condescending.
We try to give him the benefit of the doubt when we start with them, and then it just, over time, you know how it goes. Over time, it wears them down. They just get tired of it. The mask falls off, and then they go full on, like, anger, whatever it is.
Yes.
They project a lot into us. Yeah, dude. They just...
Yeah. Like I said, it was a display of integrity that they don't like, and they don't want us to hold that level of integrity. But you've got to in a situation where you can't go to the environment spoken of. So you're going to ask every possible question. You're going to take it from the beginning, step by step. Yeah.
Josh is automatically muted. What the heck?
Says,
I don't want to undo anybody's mute. Was he muted for a specific reason?
No idea.
Well, I've asked the room. DJ, do you know if he was muted for a reason?
No, I have no idea. Could it even been for a hot mic? Who knows? I mean, I guess...
maybe he was muted another channel and came in here already muted. We're going to undo someone's mute from a...
I think we can probably unmute him.
Okay. I don't want to step on anyone's toes. I did that yesterday with the arguments.
Yeah, I'm still in pain, by the way.
I got Jen really good. Got his big toe. All right, Josh, you're in here.
You could ask him in Anthony Hopkins' voice.
No. This is the first time I've been allowed in here. I got straight up banned from the VC like 3 or 4 days ago.
What you talking about, Willis?
Oh yeah, I don't know who it was. It was some mod I hadn't interacted with before. But no, I just was called a liar to my face and kicked out of the VC and banned from joining.
Oh well, this is now and that was then. Welcome to the channel, Josh. Hope you're doing well.
Oh, yeah. No, that's all good. Appreciate y'all.
You can tell he's either driving right now. He's on his way to the facility with his Starbucks.
No. I'm taking a detour today. I am spending the morning going to IKEA, and then I'll pop over to the office in the afternoon. I don't have any calls on this wonderful Friday morning.
Get ready to spend a good amount.
No, I'm just getting a bookshelf. My wife and I, our library we've run out of shelf space, so I got to go grab another one.
Bookworm. Okay. Well, we were still debating earlier today before you jumped in here with, is he still in here, Kiro-san? No, he's not in here. Satellites in the vacuum of space, according to what we were discussing the last time. I don't know if we want to pick up where we left off. You're not in front of your desk, so you probably can't pull up information, but I'll go right back to it. We were discussing the materials that are used on the satellite. You don't have to speak directly to the exact specifications or anything. Just saying that if you're saying these materials are being exposed in a thermal chamber, there was an argument for that the temperature that they're exposed to are not the same as it would be if you're exposing them to the exact temperature that we're saying, like in regards to them being at a certain degrees, like the ones that you were declaring. Remember you said
yeah, it's like a couple hundred positive Fahrenheit and to like negative 100 Fahrenheit,
something like that. Yeah, I did kind of steel man you in that way, so hopefully and these chambers are stressing out those components of that satellite. Is that correct? We're still doing good with that?
Yeah, we call it shake and bake.
Okay. So everybody did hear him say that, right? Like, so I'm not misrepresenting him when I'm talking to other people. I'm trying not to, man. I'm trying to keep him the same vein of what he's saying, to relaying it to other people. Because Kiro-san became a satellite apologist, and I know he doesn't know too much about it, but he was saying that it's not that big of a deal when it comes to temperature. So I'm like, well, then why would they stress out the components that way if it was? Again, that was my challenge. So I didn't want to hear anything of what he kind of cut him off. And he was like trying to say that it's not apparently in that environment when you know, in a vacuum, you don't have to deal with the fluctuations and they don't matter as much. You take the air out. So
yeah, they don't. So you know, it's like radiative heating and radiative cooling. It's not convective. It's not like it's not like when you're, you know, in a desert or like in the Arctic, right? The cold is, you're surrounded by air, so you know all of the contacts that the air is making with your skin is, you know, either transferring heat to your skin or transferring heat from your skin to the air. Like that's like there's a very thick medium that's around you, so it allows for a much higher thermal conductivity. When you're in a vacuum, there's you know, like, you know, E-6, E-7 torr. There's like very few particles that are you know, interacting with the like hitting your spacecraft. So most of the heat transfer is actually through radiation as in like radiating, not like you know, radioactive. So like it's if you flip from hot to cold very quickly, it takes a little while longer for the thing to actually like heat up or cool down. It's not like you're teleporting from the Arctic to a beach over and over again.
But you're saying that these components on the satellite are being stressed in some way? Like, what is the way that you can tell that they're being stressed in those environments? How do you know that? Like, I don't know if this is actually speaking to a part that you even declared that you don't have too much knowledge on because it's not your department. But
not the whole spacecraft. I know my specific hardware. It's a laser comm terminal. It's about the size of a kickball, and that is, I own that. That is, there's 4 of them on every satellite.
You could speak on like the stresses that it goes under in that thermal chamber. Yeah.
Yeah. I mean, we have to deal with all of our hinges and motors need like we need to understand what temperature range they specifically are going to experience. So we do a lot of modeling. Basically, like, it's kind of like when you're baking a cookie, right? Like you put the cookie in the oven, and just because the oven's set at 350 doesn't mean every single part of the cookie is automatically going to be 350. Like it comes up to temperature, and you know, the center might be a different temperature than the edge, etc. So we have to do the same sort of modeling with our satellites. And so, you know, I'm able to see like, oh, okay, so this hinge right here, according to our models, is going to experience this range of temperatures. And then we, design based off the materials we're using and the thermal expansion and contraction that we expect to see. And that's, we do like mechanical margin, et cetera, to make sure that we're designing for that simulated temperature. And then when we throw it into the thermovac to actually test it, we, see if we're correct, right? If our hinges and our motors and everything is designed correctly to be able to operate. So we, during the bake, right, the thermal cycling, we still do like, tests to like, move the optical head around, power it on, power it on, power it off to make sure that, shit works the way that we designed it to.
All right. What materials do you guys work with?
It's a lot of
what
aluminum.
Materials that you know of? Say again?
Yeah, it's a lot of aluminum and a little bit of stainless and titanium where we need to augment the thermal expansion. But yeah, a lot of it is aluminum.
Any bonding materials that you use? Like, is there any glues? Is there any rubber?
Hey, you try to avoid that as much as possible.
Any type of sealants?
Yeah, no. We try to avoid things like that as much as possible because that doesn't allow things to compress and expand, right? You end up with a lot of like stress. Stress imbued into the bond. So a lot of things are done with a little bit of like air gapping and with margin on it. Yeah, no. We'll put like. Oh, go ahead.
Go ahead. You go ahead. But like what?
I was gonna say, a lot of mechanical mates, a lot of screws, bolts, rivets, those types of things with a little bit of wiggle room so that they if we have some room to grow and shrink, kind of like what they do with bridges, when they're, exposed to a lot of heat, they can expand and contract and want to make sure that we're still able to.
Very minimal amount of material that you say wouldn't hold up to a stress test. You're saying you're trying to eliminate all that. Being an engineer who designs these things, you don't want to use too many of those, right?
Well, and so that's in areas of the spacecraft where we're not doing any thermal controls. So this is just like throw a hunk of aluminum into the thermovac and like cycle it. If we have like components that we need to use some sort of glue or sealant, like sometimes battery cells come to mind for that. Like you're dealing with components that are more temperature sensitive. Sometimes hyperspectral imaging sensors. There's things on there that like if we just let them be without any other like mitigation strategies, they wouldn't work. So we have like thermal control systems that help stabilize the temperature of specific subsystems. So if you look at spacecraft, sometimes you'll see like these big like gold blankets, pieces like gold. It almost looks like gold tinfoil surrounding.
Gold foil.
Yeah. So it's Kapton. It's kind of like a thermal blanket that they use to help seal in heat if they wanted to keep it warmer. You could also have like actual just heaters, like certain spacecraft have, literally they're basically just like a resistor that they run electricity through to produce heat, and they'll put those right next to the batteries to keep them at an acceptable temperature. On the other side, like if something's running too hot, you'll either do some sort of coating. Like if something is normally like buy it off the shelf and it's like a silver or a gray and it's not super reflective, you might put like a white coating over it to help it reflect more light instead of absorbing that heat. You might also put like a radiator attached to like that component you want to keep colder. Basically just a radiator would be some sort of material that has a really high radiative constant. It's a function of the material, how much heat energy is dissipated through infrared light, and you'll attach it to that to try and get heat out of the system.
You want to find a material that's going to dissipate heat rapidly, so it doesn't conduct it. Is what you're saying? Like,
radiate specifically. Yeah.
Okay, so
heat radiation is the process of thermal energy being converted into infrared light. It's not like on Earth here where you could like sweat or you could have a fan or something to blow air.
But you're simulating that in the thermal vac, right?
You simulate it first on the computer when you're designing these things. Like you have all the thermal properties of each of the materials that you're like the CAD you're building, and then when you actually go buy the material, you use the CNC machine to actually get the hardware and you get a prototype put together. Then you throw the prototype in the thermovac to see how it actually responds to that environment, and then oh shit, this worked. Oh, this didn't work. Let's go tweak this design. And then when it's working well for long periods of time in the thermovac chamber, and it's meeting all your design requirements for mass, size, power, and doing the shit it needs to do as a subsystem to support the rest of the spacecraft or the mission. That's when you start scaling up the production volume of these chunks that you've designed. They end up going onto production satellites.
All right, so I guess I'm still trying to figure out from the part where you're testing in the thermal vac, all the components, right? Everything that you said that you have on that satellite, everything's ready to go. Everything's ready to go after that testing phase. Or there's probably some more steps afterwards, but you've gone to the gauntlet of actually putting it through enough stress to say that it's going to be okay.
It'll work.
It'll go into that environment. So but what I'm saying is, what is the level? How much of the testing are you saying needs to be done before you stamp it with a seal of approval? 30 minutes, 1 hour, 3 days?
Yeah, it's a few days. Basically, you want to characterize. So like the first component that we test for, okay, this is how we're going to do thermal control for our battery. We're going to take one of our batteries, we're going to put a heater right next to it, or we'll take we'll attach a radiator to it, and we'll do all the modeling. And if this is the first time that we've done this with like a new piece of hardware, yeah, we're gonna stick it in the thermovac for days to see what happens if we cycle it. We're gonna figure out like where it fails, right? We do basically the testing I've talked about so far is called non-destructive test. Like we're trying to design for a spec and then we test to that spec, and if it works, it works. We're not trying to cause this thing to fail. But if it's like one of the first units, we're like, hey, it works for like level 2 or whatever cycling we want, or keeping the temperature within this like controlled range that we want. When does this shit fail? And then we figure out how much margin we're working with, right? So if it works, for a few days at level 2, but it breaks at level 3, like I don't know, I might want to go look at the drawing board and see.
What's the farthest level? Is it level 3? Level 3 is the toughest.
I was gonna say I'm just making stuff up. Like level 3, I'm talking like on a 1 to 10 scale, right? Like, hey, we need it to be able to survive level 2 or whatever. Okay. I'm just making up an analogy.
Josh, let me ask you what, taking it from the simplest to the worst scenario environment in that thermal chamber. I'm asking for, like, you're giving me kind of like a stage 1, 2, and 3, but I'm saying for you that this, right? What is the harshest environment that you go to before it goes to its like seal of approval? What is the worst thing that you like, the toughest?
But the toughest environment is the low Earth orbit space environment. That's where we're designing to. I'm just trying to let you know, like, what if we made it go 50 degrees hotter and 50 degrees colder? What if we remove the heater? Like, how long if we don't have the heater will the battery still work? Like we're saying, if we design it to succeed in this exact environment, what happens if our heater fails on orbit? How long do we have before the battery doesn't work anymore? Or if if there's like a solar storm or something, and the atmosphere gets thicker, and we're dealing with drag and friction, and there's like it's a thermal environment we didn't really account for as an edge case. Like, how long do we have? Like, how does the system react to that? So it's like you designed a house of cards because you're like, hey, it'll work if we line everything up just like this. Like, we know that it'll work if we, do XYZ. But if we poke the house of cards, it falls over. What we're doing here is, we'll design for the environment that we're going to operate in. We're going to see how much margin we're working with. So we'll push it over. We'll poke at it. We'll say, oh, what if this fails, or what if this is worse, and see how much margin we're working with.
Yeah, don't we have, according to you, shouldn't we have something established with trial and error already, with components that actually perform in an environment, and then those who, probably cannot? Like, maybe there's some satellites that were sent up that were thought to be working or should work in that environment, and when you found out that they got deployed, they were malfunctioning or whatever. So don't you have like a trial and error kind of like spreadsheet that you're saying, okay, we got all these things over here, that the components and everything, all this stuff that we can look at and say that this works. So why can't we just work off like a cheat sheet, get all this stuff that the trial and error we got that works, put it on something that just continue to continuously improve. There would be like a constant improvement. Like, it'll never stop going backwards. You don't have to go all the way back to the drawing board and go, let's take this new concept into the realm of like how this would perform, and maybe it might work up there. Like, you'd already have something worked out with trial and error. You'd be able to say, we got something, like, we've advanced this far. We don't need to go back 10 steps and then start all over again. We know what works.
Wow, Avi, you've stumbled onto a really, really important topic in spacecraft hardware design. It's called TRL, technology readiness level. If you Google that, it's like an industry standard. Basically, that's exactly what you're describing. Like, the scale goes from one through 9. 1 being like, I have this idea, like, for something like we could put up into space, and then TRL 9 is, yes, this exact piece of hardware has flown on orbit and successfully performed for the past like decade. Like, if I'm talking to a vendor, right, they're going to sell me like a thruster or a battery or whatever, and they say, here's the specs that we designed it to, and it's also TRL 9. I can buy that pretty confidently and say, okay, if I'm operating within these specs, it's going to work, because for them to get the TRL 9 like certification, not certification, but like for them to claim it's TRL 9, and I go kick the tires on it, it would have to have done all of that, in-flight certification, all of that heritage.
It already done it. History. It has a history.
Yeah, exactly.
So that
I've got a question though, Miggy. I'm listening, but I've got a question as well. Yeah. Right. Sorry. Yeah. The problem I'm having with what you're telling me is that when I look at the vacuum of space as it's been described by an American called Scott Henderson from the documentary, from the Apollo Detectives, he's got his charts and it shows us like aluminium, right? When it's subjected to 10 to the minus 4 torr, 10 to the minus 4, yeah, okay. The temperature that aluminium would be experiencing is 1,486 degrees Fahrenheit. That's 807 degrees Celsius. Melting point of aluminium is 660 degrees Celsius. Now, when you go up to the higher torr values, like where you say you operate your satellites are operating, the ones that you're involved with, which is about 300 miles off the Earth's surface, 350 miles off the Earth's surface. That's 10 to the minus 7 torr. Okay? So what happens is that the torr values, the temperature drops, but the separation, that's the outgassing phenomena, happens. Okay? Even at 10 to the minus 7 torr. So, and you can't test 10 to the minus 7 torr on Earth. There's no facility on Earth that can have that vacuum, torr value of a vacuum. We can't pull that vacuum. So I want to know how it is that your aluminium is tested to that level. Do you see? That's my problem. That's why I cannot accept what you're telling me.
It's a proxy.
Okay? That's the problem I'm having.
I'm in IKEA, so there might be background noise. Sorry.
Oh, did you hear what he said?
Do you want to repeat myself?
No. I'm just trying to get away from the speaker. No. You're correct on the E-7.
Yeah, that's right. Yeah, because that's where you would be operating in now. Near enough near the ISS, only because you've got the ISS and then you've got the Chinese CSS, and they're like they're at 350, and then you said yours is somewhere in that region. So that's 10 to the minus 7 torr. Okay, and we don't, on Earth, there isn't a facility you can go to test your aluminium to that level, torr level. So how do you test the aluminium to that point if you're going to go into that environment? Because you're not testing it for the environment, is my point here. I'd like to see how that is done.
I mean, I was going to say the only difference between E-6 and E-7 is the ratio of convective heating versus radiative. So it's not that different of an environment. You might have
actually it is. It's magnitudes of order different. Okay, each minus. Hang on a minute, please. Each minus value is in orders of magnitude different. So please don't tell me it's not different. You're insulting me when you say that. You're insulting Scott Henderson, who's taken the time to do that. So please do not trivialize what each magnitude of torr is. Don't trivialize that. I won't be accepting that here.
I think Jen's bringing a point up that it should be addressed, whether or not it's something you can verify, Josh, or something in your mind you think is trivial. I think it's important, because if he's highlighting something that is significant and you're saying, well, in the case of like what you do, it wouldn't matter. I think maybe you're probably saying that because you need to fill in the gap of something to say and you just want to insert this, or you actually know it's not significant and then you can detail to him how it's not.
Yeah, it's not significant. Yeah, we're talking about single percentage points of error between what we see in the thermovac chamber and what we see on orbit. And this is why, like I said, the TRL9
wait a minute.
Specification
that's the other
is
Josh, that's the other thing though. Like if the level of stress that was put on the material that Jen is talking about is something that is established, then how is it possible that you're saying it's not going to be affected? Like there's something like it has to be followed by a demonstration. It would then?
Yeah, that's what TRL9 is for. That's why.
Well,
we model it and it says it's going to fail at 102, and then we go in the testing chamber, and because we can't get as clean of a vacuum, it fails at 101 or 100 or 99, like a couple percentage different.
Right.
But then we go and actually put it on orbit, and we see that it doesn't fail, right? We don't know where the exact bounds of it is, but we designed it to survive at 80, and it survives at 80 up on orbit.
So
go ahead. Sorry.
I was mentioning something here. Master Yoda put in the text. I think this might be addressed by you, but he put in TRL9 launch facilities are protected by national industrial security standards. So you'll never be able to verify what's going on, like with anything to that level.
No, it's TRL9 is not a facility. TRL9 is a heritage of a piece of hardware. It means that hardware is operated on orbit already, and they have receipts of like, hey, I was integrated on this machine or this spacecraft in the past, and it worked within these specs. So if you also are in a similar environment and you keep it within these specs, it should also work. So it's not like a classification of facility.
I'm going to actually, I misquoted him because he actually said put it in quotes. So he says I put it in quotes to reflect past performance. So yeah, that's he basically.
Yeah, sorry. Yeah, I was going to say though, my point still stands. I'm still concerned as a skeptic here that you're not testing the aluminium for the environment it's going to be in, for the length of time it's going to be in, because you said the other day that they're up there for 7 years, what you said, right?
Correct.
And I don't see any test that you're doing that's to the actual temperatures that you're going to be subjecting it to for the torr value, because of and remember what I said, that outgassing phenomena. Remember, when you put it into a vacuum, it immediately starts to outgas, off-gas, and starts to separate. That's what happens to aluminum or any metal, anything we make, even mylar, what they use on the aluminum, right? So you don't have a facility for that. So I would like to see the tests for myself. That's the only one I'm going to accept. You see, there's lots of standards we've got to keep here. Sorry, but carry on anyway.
It's just something that we were discussing. I think Jen was here for the last discussion. I'm glad he's here for this one. but something that I'm curious about as well. Because there's a lot of things that you're saying, Josh, and not that I'm not taking everything you're saying for what it is, but I want to see where they're doing the testing. Why is that held behind? Is that things that have to be only held behind closed doors based on because of the fact that it's working on technology that can't be used by anyone else, and you don't want to have to show that? Or
no, I mean,
you know what I mean?
Yeah, no. Thermovac testing is not ITAR. Thermovac testing of propulsion systems and avionics, which are two of the subsystems on the spacecraft, are ITAR. But I don't have any good resources I can point to. I can do some research, but
is there any videos that were made to like the process?
Yeah. It's sorry. One second. I grab this bookshelf. That's not hidden behind security.
Well, I would say this, man. Maybe you should finish your shopping and stuff. That's kind of important in your life. But I would say come back and let's have a conversation about how we can get some material so that we can take a look at and maybe scrutinize whether or not it is what we're saying we think it is. Because I'm interested. Like, there's a lot of space lore that is being told to us, and you're sitting on information that sounds like there is something that you could verify. So.
Oh yeah, let me. This bookshelf's heavy.
I do want to, and also I do want to challenge you that Yoder. He's saying it's probably. He says it's not hidden behind security. It actually is. It's proprietary first and foremost. That's what I thought, Yoder. That's my first inclination. That it's the reason why he wouldn't be able to show it to us. But he's saying it's not ITAR. So that means, and it's what's the acronym for? Because it sounds like it's not, proprietary.
Technology readiness level. No, it's so one of my first gigs when I actually was working at NASA, was the publication I was doing was canvassing
T-Mobile
hardware manufacturing companies.
Say it again.
Oh, sorry. Let me. Oh lordy. So one of my first gigs when I actually was at NASA was to develop a report that was called the Small Spacecraft Technology State of the Art Report. So it's kind of like an encyclopedia of hardware that if I wanted to build a CubeSat or a small satellite, I could go out and buy. And so it was a lot of calls to different vendors, looking at their spec sheets, basically kicking the tires on their claim TRL level, because what I wanted to be able to do was say, hey, this is the state of the art. This is like the most cost efficient, most powerful batteries, or the most efficient thrusters for this propellant type, or this is the radiator that you want to use if you're operating in these conditions. Like, I wanted to figure out, or the purpose of the report, and you can literally Google it. It's Small Spacecraft Technology State of the Art Report. I was an author in 2018 on that edition of the product. Basically, I wanted to be able to show spacecraft manufacturers or companies that wanted to go out and build spacecraft, hey, this is hardware you should go look at. Because it's, verified TRL 9. NASA actually went and interviewed and, kicked the tires on their claims as far as like operating successfully. And we verified their claims. And then also, this is stuff that's TRL 5. Like, they've tested on the ground. It seems to work, but they haven't actually flown it in space yet. So, like, if you're a little bit less risk averse and you want to see if you can get better performance and be the person to fly this maybe a little bit riskier subsystem, this is who you would go talk to. So I can tell you without a doubt, like that didn't require any sort of security clearance, and that report is public. I was a student at the time when I wrote that.
Hey, I put in the side chat a link. Is that the paper you're referring to? It's dated 2024. I was just wondering if that's what you were talking about.
I think he said he's busy. I don't know if he can see the side chat, but
no, I got it. So that's the same work product. I didn't write this edition. Let's see who's on it. Bruce Yost, who's the fourth author on there. He and Craig, both of them were my Oh, and Sasha's the lead author. Okay, so I worked with Sasha Craig and Bruce on the 2018 edition. They publish it every couple of years. But yeah, so that is the report that I'm referring to that I wrote the 2018 edition of. They update it every couple of years.
So I guess I don't want it to get lost in the point that you were trying to make, but I'm still looking for evidence of something that it sounds like the chat's mostly saying is proprietary, but you're saying it's not. So,
what's in that report that was just posted? Go check out. You literally, like, I invite any of y'all to go look at that report. I think we defined TRL and like in the pro, like,
what are you talking about? Kiros, the one that he posted, Kiros-san posted?
Yeah. This is, let's see. This defines what CubeSats are. Oh, it does define the TRL on page 5. So this is literally like it's a 460 page report. Like, don't expect anybody to, really read all of it. But this is like as accurate of a canvas of every single company you could go to buy different components for satellites. And these are the specs that each of those components are survivable to. So, like, what were we talking about? Like, you could just pick a subsystem and there's a whole chapter on it.
Yeah, that's great. What we're challenging, though, is the point where you lose touch with the chain of custody. Because it seems like you're good up to now. Yeah, you're good. Well, because it seems like from the testing of this thing and from you're getting information that things have been verified to be working up there. We're moving off into like where it leaves your hands and then you just don't know where it goes. So I was talking about the components like side of it, and I would like to see the testing phase of that. That's one portion of it. But then it goes into like, okay, once you agree that you're purchasing things from, NASA or whatever, or wherever you're getting your
stuff. Well, no, you don't purchase from NASA. If you look at the report, there's like, I don't know, a few hundred companies in there that all are producing their own, subsystems, batteries, solar arrays, etc.
That's great. But what I'm saying is when you get ready to make this whatever CubeSat, then you're doing all of these components that have already been tested with, like you said, TRL9, right? They've already been something that you could say is past that like phase, and you can trust that whatever
has flown before, correct?
All right, so and then you're going to stress. Are you still going to stress it at that point too? You're going to still put it to stress because it's got other components, not just the ones you're purchasing, but
yeah, exactly. It's risk mitigation or risk incursion due to aggregation. So this thing works, but it could be a separate context. Like, it wasn't this specific satellite that it flew on, etc. So it could, we would still take the full spacecraft, right, and throw it into the thermovac and do the shaker table, right? We might not and depending on like the scope of the mission, right? Like when I was working at Astranis, we bought some subcomponents from a few different vendors, and on the first satellite that went up, one of those components failed. That was TRL9, and so we got burned on it because we didn't do enough testing. And so for the subsequent satellites that we were building, they went through a much more strenuous testing campaign. We actually changed vendors too because the shit failed. So yeah, no, if it's something that's TRL9, I'm not going to be as, I'm going to still kick the tires on it. I want to read out of their testing that they did to get to that certification. I want to know, what platforms it's flown on before. But it's not going to be nearly as strict as if I'm building something for the first time by myself or if I'm buying something that hasn't flown before.
All right. So now that we have things that are tested, and in your mind, you're taking them through like a rigmarole of having them like evaluated, then tested, and then I guess given to a company who's going to put them in a vehicle that's going to take them to logistically altitude, which you believe they are going to be set in. And during the process, is there a handoff like that you do that from me to or you to someone that's going to be like, okay, I got you. I'll take care of it from here. Like
it depends. 1 sec. I'm gonna hop in an elevator. So give me 20 seconds.
No, yeah, take your time.
I put in the side chat a screenshot of the TRL levels, the explanation of the different TRL levels. I only put it there just because he mentioned the TRLs.
Yep.
I was gonna say, and if you pull up, I appreciate y'all finding the SOA report. That was a lot of writing I did on the 2018 edition. If you want to go read the one I actually wrote
to this, what he put in the
not the 2024 one. I was one of like 3 authors on the 2018 edition of the
he's in the
report.
I think I have the PDF for the 2018 version, but it's on academia.edu. Let me just verify that it's the right one. Do you remember the primary author for that one, Josh?
He's in the elevator. For most people that... Oh, somebody's got a scratchy mic. For most people that are having this discussion...
Yeah, it should be Sasha Weston.
Okay.
Most people that are having a discussion about this topic, we don't get farther into it because we don't have somebody that works for a company like the way he works for Amazon, the Kuiper program. So I'm asking him specific questions that deal with some of the more internal components of having to deal with an environment such as the vacuous environment they go into. So this might not translate over to the actual direct questioning of if the Earth is flat or a globe. And it might upset some people, but I'm only doing it because I think the rare moments that we have somebody like him that come in here that can expound on some of these things or questions that people might want to ask is the reason why I'm giving it a little bit more a talk time, you know. So just bear with me. I know it might be excruciating. It might be excruciating for some that are just like, just ask him if he knows the Earth is a globe. I get it. I mean, that's not lost on me, guys.
No. The point is. Hang on a minute. Sorry, Jed, I was going to get in there quickly. The point is, it's the globers that use the satellite as a reference for proving the globe, for example.
Mm-hmm.
That's what they say. This is another reason why we're checking it out. That's all. Well done. Sorry about that.
There's a point where somebody like him who works in it's called departmentalization, right? So he works in a certain department. He has knowledge based on that and a little bit outward. But as far as that goes, it's still in that within a department. So he doesn't like necessarily specialize in other fields that work alongside him. So I think getting his unique perspective and asking him questions specific to what he does and seeing the transparency that he's giving and also how it relates to things that Globers say. Because elevating the conversation to a different position to where we're not just saying flat or globe, okay, go away, numpty. Like I think is a better way to kind of find out the mystery behind the things that people say with satellites and such. So, I
found his paper. It's in the side chat.
Okay.
Yeah.
Well done. Well done for your efforts anyway. So appreciate that. I was just going to say the other problem is this. When I look for satellites, right, this is from like 2016, when I was looking for satellites, all the images were CGI images of satellites, no real ones. And then the one time that I did see a real one, or a few times, was when they crashed into people's back gardens, backyards, and they were attached to balloons. So this is why this type of scrutinization is very important, because we've got to find out whether or not they're already up there. That's all there is.
Well,
thank you.
Yoder, did you want to say something before I continue? I thought I heard Yoder. My bad. I'm asking these relevant questions about the components. To me, I think it's important because there's testing that, according to what he was saying, they're doing, and it's not held behind, private doors. So if it's exposed to the public and we can get that information, and there's videos we can look at, I think that would bolster the argument as to like when people are talking about this specific device working in that environment. You know what I mean? We could come at it with a different position now. It doesn't have to be like, no, satellites can't work up there and just leave it at that. We can say this is the reason why they can't work up there. Because in the physical world, things operating in that environment would be exposed to this type of, fluctuations of temperature or vacuous state or whatever it is, like they're claiming.
Yeah, the phenomena that are there that are eating away at the material. Yeah.
Yeah, and we're just going at it from a practical level. I think that gives it more foundation for us to say, no, they can't be up there. Instead of just saying they can't be up there. You know what I mean?
Exactly. Yeah, no. We've got to be methodical as to why we're saying it's not possible. Absolutely correct. You've got the cosmic ray particles. You've got radiation, micrometeorite. These are all problems that these objects are being subject to. Remember, they're in the thermosphere. You know, and like I said, what's his name? Brian Mullins did a very good presentation on how it would be impossible to get rid of that heat. You know what I'm going to do? I'm going to put that Brian Mullins one in this server, actually. I've got it. Hang on a second. Yeah, why not? Good man, Brian Mullins.
Yeah. Sorry, I'm upsetting some of the team. Like, guys, I apologize. Like I said, I do want him to keep like talking about some things that he knows, so I can peer into the mind of somebody who's working in a place. Because I don't normally talk to people that work like in the job that he does. So I don't know. I don't know if you guys have full knowledge of this, but I'm just doing what.
This is.
Ask him about how they achieve trust in a vacuum if it is part of his department.
What'd you say, Necros?
If you can ask him about how they achieve trust in a vacuum, and if it is
achieve thrust in a vacuum.
Yeah.
I don't think he deals with that. That's not part of his department. He's not dealing with that part.
I was gonna say, I mean, we can talk Hall effect thrusters if you want.
You could listen, Josh. Here's what I'm saying. I'm only doing this as a safeguard, because if we go into it and at the end of it you say, "Well, I don't know because I don't specialize in that," then it's going to do disservice to the question. That's why.
Yeah, no. I mean, for propulsion systems, we do thermovac thrusting on the ground too. So it's like, it's like letting air out of a balloon, basically. But
really? Okay, so you do. Can you? So you're able to speak on this then? Because
prop is fine. I'm actually more confident on prop than I am on thermals. Let me get this cart away.
Sorry, I just didn't want him to derail and say that, oh yeah, this is how they work. And he's like, well, I'll tell you what, I really don't specialize in that. Like after like a 30 or 40 minute conversation.
No. I'd be interested in understanding the more context of the question. Like, why don't you think that thrust works in a vacuum?
Simple. There is nothing to push against, because what I understand from different transporting techniques or vehicles or transporting techniques, we do need to push against something. You need that friction, like when you walk, you push your feet up, pushing against the floor, like the car. The tire rubber in the tire is pushing against that road, so it creates that friction, so it push the car forward. With planes, jet planes, or those with propellers, so it does the same thing. It takes the air from an intake and it pushes it against the air that is surrounding the aircraft. Boats do the same thing. Submarines do the same thing. So it comes to...
What's your background in kinematics?
What's my background?
Yeah. I'm just wondering, like, have you built up from ground level, taking like a kinematics course in high school? Like if I start, quoting Newton's second law, like would it go over your head? Is what I'm trying to say.
Yeah, I understand that like every action has an equal reaction. So if you are sitting inside the car, when you are pushing against that the steering wheel, do you think that you will push the car forward? No, doesn't work like that. So that's what you are thinking, that the thrusters in the inside the rocket engine, inside the explosion chamber, is doing. Like you're sitting inside your car and you're pushing with your hands against the steering wheel, waiting for the car to move forward. It doesn't do that. So where is the equal reaction for your action? It doesn't push the car forward.
So it's the expulsion of mass, right? So if we do I agree. If it's a closed system, right, and you draw a boundary around all of the mass in the system, and the boundary is always around all of the mass in the system, you would not be able to get thrust, right? if you drew a control boundary around all of the mass in the system. Let's say we had a rocket engine with the fuel tank is completely full in a vacuum, and we turned the rocket engine on, and the control boundary that we basically have to put a boundary around all of the mass in our system. We drew the control boundary, and as the products of the combustion reaction are being ejected out the back of the rocket, we keep that boundary moving. So the furthest away exhaust, the boundary is still on the outside of that. So we still have the boundary around all of the mass in the system, even though we've expelled some of the mass from the back of the rocket. And that that's exactly what happens. We set shit on fire, and then the products of the combustion. But the issue is, we're not.
I already understand that. So you are just listen. But the boundary that you're talking about is that the walls of that chamber, and you have that.
I'm talking about outside too.
Yeah, that exhaust, that nozzle from where that material, so the matter, the gas that generated by that explosion, so it will be expelled out from that engine. But that's just the material have been expelled. It doesn't push the rocket forward. There is no thrust. Yeah, I can agree with the rocket on the ground. Yeah, when that material is expelled, it's pushing against the floor where that rocket were sitting on during the takeoff, and it's still pushing against the air that is surrounding that rocket when it's going up in the sky. But when it reaches the vacuum, where that material doesn't slow down, because when it's expelled out of the nozzle, and there is nothing to slow it down. Remember what Newton said, that if something is moving and there is no force acting upon it, so it doesn't change its pattern, it won't slow down. So it's the same exact thing. If you have those materials expelled from the nozzle in the vacuum, nothing would slow down, and it will create no thrust at all. So you just have materials expelled out.
But you already accelerated the mass. You're pushing against the exhaust. That is what you're getting thrust out of. The thing that the rocket is pushing off of is the exhaust. It's the gas that's being expelled out of the back of the nozzle. And so why I real quick, why I said if you drew a control volume around all of the mass, right, you draw a control boundary around all of the mass, the thrust would be zero, because it's equal and opposite due to Newton's third. The momentum that you're putting into the exhaust, shooting it out at super high speeds out the back of the rocket engine, that reaction or that action has to have an equal and opposite reaction, and that equal and opposite reaction is the momentum imparted onto the rocket. So that's
No,
momentum. That's why I said thrust is zero.
No, it's the momentum that you are given to that gas that is ejected from the nozzle.
All right.
So the rocket doesn't gain the momentum with that action. It's the gas that is the material that is expelled out. It's expelled with that force.
You need to invoke Necros. You need to violate dual-free expansion. You need to invoke dual-free expansion to get out of this. Go.
It's the you can't.
You cut out.
Be an equal and opposite reaction.
You cut out, Josh.
Yeah, but gas does a workless, energy transferless free expansion. So
not in a vacuum of space.
Yeah, especially in a vacuum. That's what that does. That's what free expansion is about.
Free expansion.
I'm talking about
to slow it down.
Oh, okay. That's why you have a nozzle.
Oh, does that somehow change free expansion?
I'm saying if you expand it through the nozzle at the edge of the nozzle, right as it's exiting, all of its momentum is going in the negative or whatever direction you want it to be. Let's say negative X if the rocket's moving to the right. all of its
so it's
momentum
pushing
is
against
moving
the nozzle, which pushes. Okay, so it's pushing against the nozzle, which
Correct.
pushes back against itself. Wait, so it pushes back against itself at the end of the nozzle. So you net out the force to zero.
No,
that's
it's moving
Newton's
to the
laws,
left.
right? Come on, you're big on Newton's laws.
No, whoa. The aggression is not needed. We're trying to have a conversation here. There's no need to get
pushing
emotional.
against the nozzle pushes back with equal force. Now what?
What pushing it? Yeah, exactly. But it's getting accelerated out the back.
Out.
So
and it accelerates with free expansion out the back. Good job.
You also have collisions on the inside.
I don't. Okay. No, I'm saying the momentum that's imparted upon the gas exhausting out of the back of the nozzle is equal to the momentum imparted on the rocket moving the opposite direction.
Yeah, so no net thrust there. So we're getting it from.
And no.
Yeah.
No,
That's
right. Exactly like when you're hitting your head against a wall. So the momentum will not be given to the wall, and your room won't go forward, but it's your head that will gain the momentum and will be pushed back. And you will, if there is an exhaust, and your head is inside the closed container, there is an exhaust, so your head will be thrown out of the exhaust, and still the room won't be pushed forward.
Right, and I'm sorry to interrupt you right there. I posted a video as to what's just been said about losing the thrust because there's no medium, no wall. It's called Easy Debunk, Rockets Don't Need Air, okay? And it gives a perfect demonstration as when you isolate that nozzle, okay? So to simulate like it's in space, there is no forward propulsion. But yet when you remove the attachment and inflate the rocket, it moves forward. And then you remove that and you put one with holes in it and it still moves forward, but only slowly. So this is what we're trying to show you, that rockets cannot get a forward propulsion in a vacuum. This is what my colleagues are trying to tell you. And I posted the video that demonstrate that. 13 minutes long, that's all. Thank you.
We do this. We do this on the ground all the time. You can throw them in a thermovac chamber, and you put a 6-axis pressure sensor or stress sensor attached to the rocket, and you ignite it, and you get force in the opposite direction. Like this is I don't.
Yeah, there's an important
I don't understand
question.
this.
There's an important question. I think. Are you taking? Now you have to really understand what I'm saying here, Josh. Are you taking that the vacuous environment that these rockets are going to as a foregone conclusion? The answer is a yes or no. Close-ended.
No, not at all. Rockets work in the atmosphere. Rockets work everywhere. It doesn't matter about the medium.
No. I'm talking about the place where your CubeSat or whatever is going to reside in, because your payload, right, is going to land in an area and stay in that area supposedly in a decaying orbit. Now, so do you think that environment is a vacuum, and are you taking that as a foregone conclusion before when you start into how rockets work in that environment?
No. You go E-6, E-9, like whatever altitude you're operating at.
Okay.
You assume it's pretty close, but for the purposes of design, it's almost zero.
Yeah, hold on.
Sorry, what?
We're not assuming in this particular manner. We're trying to figure out that the thing that you're declaring, the place where you're going to actually go to, is a vacuum environment. Now, I'm going to say it again. The place where you're going, are you absolutely 100% sure it's a vacuous environment?
Yes.
Okay, what is the primary knowledge you have for that to be the case?
The telemetry data and the performance of the thrusters that we operate on are very similar to Huron.
You're comparing things that are being tested here on Earth to say that that's how they're working in a vacuum.
I'm saying that the performance of the thruster that we're getting on orbit is it's in line with what we see when we test it in a vacuum chamber on Earth.
Yeah, but within a few percent. But what I'm saying though is you're thinking that up there is a vacuum. I don't hear anything solidifying the point that you have primary knowledge that is true in any way that's being tested by you or anyone that you work with.
Because if I get data from this, if I get a radio signal from the radio that I built and designed, that means that I don't have primary observation of that data.
That just means that the data is what you're getting, but it doesn't mean that it's in a vacuous environment. You're getting data.
No. You're getting data that shows that if I turn the thruster on for 2 seconds, I get this amount of thrust.
Yeah.
Because it's a
foregone conclusion, Josh. It's a foregone conclusion that you're in a vacuous environment. You're just taking the information for granted. You don't really know that. You're just saying that's how it is. It's how it operates.
I'm saying that's how I know that. I'm saying if you turn the thruster on and you get this force, right?
It's a pragmatic fallacy. It's an appeal to pragmatism, because you're saying that the rockets are working in the vacuum you believe is there. Therefore, it works.
So I would say, okay, well then I would say that it doesn't. I would say it doesn't matter if it's a vacuum or not. Then with that viewpoint, because if it operates in the same way as a thermovac chamber on the ground, and I don't really care what the medium is, as long as it behaves the same way as it does on the ground.
What I want to know is, when did you press a button to make a thing produce thrust in outer space? When did you do that?
Yeah.
Mission operations at Astronus 18 months ago.
That's the problem. That's the problem, though. You're trying to make it sound like you're doing something that's affecting the thing up there that's in a vacuum, and I'm questioning that right now. And you're basically telling me it doesn't matter because here on Earth you put them in a vacuum chamber and they operate like you think they do. So therefore,
because you're claiming that you're claiming that I'm making a pragmatism or pragmatic fallacy, and I'm saying
it is a pragmatic
fallacy. that it doesn't matter as long as it behaves the way that I want it to behave.
That's exactly it. That's it, because it works. Therefore, your premise is true. It's in a vacuum.
I don't. Well, no. Okay. Well, then it doesn't matter. Yeah. It doesn't matter what it's in. If it quacks like a duck and it walks like a duck.
Pragmatic fallacy. So therefore, you think the premise is solidified because you're like, well, it works. What do you mean? It's working in a vacuum. I see it in a vacuum chamber. It's working. Therefore, when it's going up, it's going to go to that same environment. But this is the problem. I'm saying there's no point of verification that you or anybody else that's in your industry otherwise. Yeah, this is true.
A vacuum is a lack of material, so it's a lack of drag. So if I'm not experiencing any drag, like I understand that.
Yeah, but it's in the thermosphere.
Yeah, but the point is, there's
exosphere.
Yeah, what's lacking here is the point of verification. You're assuming a lot of information is true to get your premise working. This is what's happening. I'm only pointing out to the obvious.
And then you feel a tug on the end of the hook, even though you can't see the hook.
That's not.
You're assuming that there. No, I'm just saying, like it's a radio and a computer that you build that's just far away. Like that's.
I know, Josh. It doesn't matter. It doesn't detail where the thing is. Doesn't say what environment it's in. That information doesn't tell you that.
If you have a pressure sensor and you have a thermometer,
whatever you like. Not in situ. Not in situ. And I know this by the meteorologist that comes in here. You'd be wrong by that. Not in situ. It's never going to tell you in situ. It'll tell you these ideas of how you can assume that wherever they're at, they can be calculated to be in a specific region to have a vacuous environment and or temperature difference. But it's not going to give you a measurement in situ. Never.
I'd be interested to see a primary source on that. Let me
look at NOAA 1972. I think Yoder even could post it. I don't have the
data. Pulling a reference from 50 years ago. I mean,
no, this is true today, dude. There's nothing that can get a measurement of pressure up in the regions where they say these vehicles are. None. Period. That's absolutely true.
You just need a piezo sensor, and it's a force over an area.
It's not giving you. I'm telling you, man. There's nothing in that environment reading out a measurement of pressure. Guaranteed.
Oh, okay.
Yeah, they're still using U.S. atmosphere 1972 is what Alpha's saying.
Yeah.
I mean, we do. We're gonna say we do that and we map it to the solar cycle. Like, yeah, that's
so not so ridiculous.
Yeah. No, I get it. I'm just saying that. Yeah, okay. It quacks like a duck. It walks like a duck. I'm going to assume it's
but that's
a
pragmatic fact, dude. You're doing it
that's
again.
Fine.
Like
it's fine.
It's not fine.
I'm okay with that. I'm okay with that.
We're
that's
not.
fine. That's okay if it's not okay to you. That's fine.
Yeah,
that's why I don't.
you live in a. So in other words, you're like, I want to live in my fantasy world, guys. You can live in the real is level. However, I'm going to believing this is true because
I'm happy to walk y'all. I'm happy to walk y'all through the proof of conservation of momentum. So how it doesn't matter what medium the rocket's in.
Yeah, we can go through the physics of it, and it does. It has a applied methodology here on Earth, like where we work in. But when you go to fantasy realms and say that it works that way too, that doesn't work, dude. Because not only are they listen, the guys in here were taking you through the rigmarole of how it can't operate in that environment. And fair enough, you're trying to give them rebuttals of how it does based on, however you say it's being tested here. But now my question to you is, even the greater point is, how would you even know they're in that environment in the first place when you can't even tell me that they're there with primary information? There's nothing you can support and say, well, we just know because we got data. Yeah, but the data is not supporting that it's in that environment, bro. This is something that should kind of like put into your mind, like, well, how can I prove that? There needs to be
stuff
something
moves, right? The stuff we don't see friction.
Yeah, that's great. That's great. But like,
just one thing, please. I don't need explanation about the conservation of momentum. I'm not asking you if the rocket won't keep its momentum when it's leaving the surface and entering that outer space. No. That point of my question in the beginning, it was about the rocket will have to slow down in that outer space. So it will have to have a thruster in the front of that rocket. It will have to turn a little bit. So it needs thrusters in all sides of that rockets, in the walls, in the vertical walls of the rocket to make it turn. Because it's not like aerodynamics. You just have wings and you have to turn the flaps, flip the flaps, and the radar of the plane, and the plane will turn. No, you are in a vacuum. So to slow down, you need thrusters.
Well, so are you talking about slowing down? Are we talking about translational momentum? Or are we talking about angular momentum here? Like,
I'm not to point. Just listen to understand what was the point. It's not about conservation of momentum, so it was completely irrelevant to what we were talking about. It is 100%
about that.
The point was about how you achieve trust. So if something like, for example, you have that satellite or that rocket that is still, it is still in the vacuum of space. So you want to make it move. So you have to achieve trust. You have to have an engine that will push that rocket forward, like we have in all vehicles that we use. So we use that thrust system that you push something forward. So you have to do that in space too.
It's like a gun, right? Recoil on a gun is literally you fire a bullet out of the gun. The momentum that's put into the bullet is equal to the momentum that's put back into the gun. That's why you feel recoil. So
but bullets aren't analogous to gas molecules subject to free expansion.
That's why you have a nozzle. That's why you have a barrel.
That also nets out the force with the thrust equally, so you don't have any net translation of motion there.
It equals out the force in all of the radial directions, orthogonal to the bore site of the nozzle. It does not equal out the force,
How was that tested? How was that tested?
What do you mean? It's just symmetric.
How was what you're saying applied? Like, how can we verify? Go ahead, Yoder.
Yeah, and how much thrust is there on the front when you got free expansion out the back? Like, isn't the entropy of the vacuum overtaking whatever release of gas that you have within the chamber?
Well, no, because then we put the edge of the control volume at the edge of the nozzle. It doesn't matter what happens after it exits the edge of the nozzle. That's why I keep saying that the vacuum doesn't matter.
Well, it does. It's freely flowing out, man.
Well, yeah, exactly. But at that exact interface, it's all flowing in the negative X direction. It's all flowing through that circle at the end of the nozzle out to the left. After that, it goes in every direction. It goes up, down, left. But
it's escaping on its own.
Well, no, it can escape on its own. I agree with you.
It does. That's what free expansion is.
We're pushing it as well. Yeah, exactly. But we're pushing it. We're pushing it as well, and that push is where you get the thrust. Like it's hot, and it's
if you push it, if you put something against the path of that where the gas is going, you're just slowing the expansion, but it's still a free expansion. You're slowing the amount of gas that is extracted out of the nozzle, like what you do with the silencer on a gun, and even the recoil is reduced too.
Yeah.
So you're telling me that you're reducing the recoil, but even with that, it's not doing any recoil because there is a free expansion of the gas. The gas is not held down by anything.
Let me ask.
Like
when
it's held radial in by the nozzle. Sorry,
Josh. How? Excuse me, Yoder. How would you test for that? Like what he would say. Is there any way that you could test for that very specific thing?
Yeah, I mean, you could test for the hoop stress in the nozzle. Oh, sorry,
no, not you. I was asking Yoder. I don't know if he's busy right now.
I'd put it in a vacuum chamber and record the results.
But I mean, like
which we do.
Yeah, great. Can you post any?
I mean, it's called hoop stress. You could
go show us.
I'm driving right now. I apologize. But you can Google. We only use. I was going to say we only do this for reaction control thrusters. So they're usually about the size of like a loaf of bread at maximum. Just because the majority of like actual rocket thrusters are.
So it's not going to demonstrate what we need to see, is what you're saying?
No. I'm just saying, like, if you Google test, because if you Google test stand for rocket thrusters, you're going to see them done at sea level. Because most first stage and second stage engines are operating within atmosphere. Yeah, exactly. That's what I'm saying. Exactly. That's what I'm saying. I'm just saying I'm driving.
When are those thrusters? Those thrusters are going to be put in a vacuum chamber, so we can see them actually working.
Yeah, RCS thrusters.
Here comes the yawn.
Jesus, y'all! I work fucking hard. You fill up my. Oh, I did. Yeah, isn't it nice having a cushy white collar job?
Yeah, you're working so hard, which is.
I mean, yeah, I was working till like 9 or 10 last night.
And cushy white collar job, working till 9 or 10. Now it's a hard job. Which is it, hard or easy job?
I'm saying you have flexibility due to it being cushy. I do work long hours. I do have shit outside of work that I do as well.
Sounds really hard.
I mean, obviously, objectively, it's not. It takes a lot of time. It doesn't take a lot of energy.
We're actually talking about where the rubber meets the road here in this conversation, and it seems like it's very lackluster.
Well, I got yelled at for yawning, so I'm not the one who derailed the conversation.
It was cute, Josh.
I meant like whenever you're presenting something, there's a lot of the demonstration phase that we don't ever get to. I feel like it's lackluster every time. Like we're left empty-handed.
I'm not usually sitting on my computer. I would tell you what to Google if you'd like. Like that's not my role here is to answer questions.
For the many years that we've been doing this, we've not only you, but we've talked to many people that work with satellites and such, and rockets, and we never get to the point where there's a demonstration of what they're saying to be true. It never gets to that stage. It's only like hypotheticals and this is what could happen. And
or they give us demonstrations, Alpha, that we've been able to point out the fatal flaws in them.
Of course.
Including these.
But they're what?
It's a perfect example. What you were just interjecting with is a perfect example of why you're told so often that it could be possible, and that you're not being told that it is true undeniably.
Gotcha, AK. Now we're interested in actual demonstrations that don't have fatal flaws.
I agree, and if somebody can put forward one, then I'd like to see it. Not something like, "Wow, this just works," and then you're doing it something where it's not akin to your analogy.
Right, because there's always a special plea. Well, okay, so it wasn't exactly analogous. This wasn't a perfect vacuum that we wanted. This wasn't this wasn't that. Well, you just have to look past this. You have to look past that.
Yeah, I'm tired of that, man. I just want what they're saying, too. A test of it. Just show me. I want to see it. And then, you know what? Maybe that would give your position more weight. We could be like, yeah, if you guys actually said something that you can test, and verifying you've demonstrated to us, you would really do well.
Right.
I would move that would move the needle.
It really would, because if you go to our home server, we've got countless examples of these vacuum chamber rocket test demonstrations that have failed.
Mm-hmm.
Failed to provide the sufficient dynamics that's required.
Yeah, yeah, they don't provide the thrust. They did one in where is it? Sorry to interrupt you there. In where was it? In England, Leeds, near Leeds, a university near Leeds did the vacuum test, and they showed us that there was no thrust. Okay, no thrust coming from the rocket in a vacuum chamber.
In many videos, you see the rocket. You will be fooled if you don't pay attention, because you see that rocket moving inside the vacuum chamber, but it's definitely not because of that thrust built in a vacuum only. No, when you slow it down, when you see it in slow motion, the rocket doesn't move at all till there's materials that are extracted from the nozzle, from the exhaust of that rocket, touch the walls of that vacuum chamber, or build materials pressure inside the vacuum chamber, because it's gas that is extracted of the nozzle. So if it is a closed volume, so definitely that gas will rush and fill the volume, and there will be more pressure than that vacuum that you had in the beginning.
Exactly.
Exactly.
This is a volume. This is an infinite volume. We've got this famous video somebody tried to give to us once of a nozzle thruster hanging from like fishing line inside of a vacuum chamber. And they lit the ignition, and guess what? The thrusted nozzle started pushing forward and swinging on the string, and they said, see, it generated thrust in a vacuum chamber. But what happened is the vacuum chamber had actually pressurized, and what you saw in slow motion was a reaction, right, of the vacuum chamber now being pressurized and not being a vacuum anymore. Space isn't like that. You don't pressurize space by squirting thrust into it. You're talking trillions and trillions and trillions of empty space in an expanding vacuum.
That's the point of verification, Josh. That's what I was trying to tell you. What you can test down here, what you think those rockets are up there doing is entirely different. So I was asking for the point of verification of that actually being the case. This is like the overarching point of you saying that rockets work in a vacuum. I'm like, yeah, how do you know it's a vacuum? Like, so, getting to that point, if it is truly one, then you have like fatal flaws within it. And that's what these guys were showing you.
We've explained why it doesn't work the way that people think is because people assume that gas molecules are solids in a different state of matter. They're not. They're gas. They're subject to different kinds of behavior than solid matter is.
Right. So you can understand.
Newton himself wrote about this, guys. Newton described the nature of gases to expand, and the nature of solids is to contract.
Mm-hmm. Right. So you can understand our level of skepticism, especially as the knowledge we carry on several topic matters regarding satellites and the environment and the shape of the earth. And there's lots of things we are bringing into this that's stating to us clearly something is not correct. They don't line up.
What do we have here?
So the claim is on the forward end of the combustion chamber, there's pressure supplied by the explosion. And that explosion briefly pushes against the front of the chamber, pushing forward the rocket, while the exhaust free expansion pushes everything out the back, while that just gets released out the back without doing any work. Okay, prove it.
Yeah. Yep.
Right, the entropy of the gas overtakes that explosion. So then come excuses. Well, yeah, we know that this is wildly inefficient. We know this is why rocket thrust is so inefficient. This is why we have these little tiny nozzles like hairspray devices, and why we rely on gravity slingshot maneuvers to get through, the solar system.
Hey, you're right.
So here is the other guy. He was muted, Carolson, and I can assume that he's a Glober. So he sent a video that shows exactly the thing that we are talking about.
We're talking about, yeah, for sure.
Yeah. So in the video, that if you watch the video at 10 minutes 12, so you will see the rocket. And tell me, Mr. Kirsten, what is that thick white cloud? Is it the vacuum? Now, are you telling me that vacuums are thick and white?
Yeah, that's why this test can never be replicated in a chamber, because the chamber can be pressurized. So if you have an open area like the vacuum of space, there's nothing to contain. Sorry, that's just a fact.
So if it can't be replicated in a chamber and you won't take anything besides direct observation, you know, even if I say that it's a couple percentage points off of the efficiency in a large versus, you know, on orbit, you know, it's still pragmatic fallacy. I have to physically go up there and show you.
Yeah, Josh, we can't sit here and believe with you, man. We're not going to sit here and believe with you.
Real quick.
Okay, evidentiary hearing, courtroom. Okay,
Well,
trust
exactly,
doesn't get you anywhere.
I get it, but I'm saying, but if I show you video of it operating in a vacuum, you're going to say that we're not actually up there. Like that's not actual video that's taken.
Okay, the fatal flaws that you're going to have to overcome are a bit many, dude. Because you're dealing with a confined space. Number one, yeah. Because here's the thing, man. What's
voluntarily?
What's at stake? Yeah, what's at stake here is that you're making this grandiose claim that this thing is working in a place that's not where you're subjecting it to in a test environment. So there's so many things, right? Like you're putting like one of those rocket boosters.
What is at stake here? I don't understand. This is like one of the most low stake environments I can possibly be in.
Really? Is that your?
Oh yeah,
obviously.
But yeah, no, that's why I set my thesis when I introduced myself to y'all. Like I'm not here to convince anybody. Like I understand the boundaries of this conversation. I'm here to answer questions and exchange ideas, but I think it's fruitless to try and convince y'all.
No, but what it is though is that the conveyance of information coming from you, it seems like you don't know much more than just information that you've gathered from whoever's telling you. There's not primary knowledge coming out of any of these topics. And so for us,
I mean, I just pointed you towards a 400-page report I wrote.
Yeah,
so
I know
you that is primary knowledge.
Great. Yeah, primary knowledge would mean you have an interaction with the testing phase. You understand the way things react because you're going to be like, okay, I've tested these things here on Earth in a controlled environment. Now they're going to an uncontrolled environment where I don't know what could happen. There's multiple variables that they're going to be subjected to. And I can only test for down here. So there's so many different things that could happen that you're saying are just going to be okay. It'll be all right because we tested for down here.
That's why we go test up there too. Like, yeah. So what Kuiper did was
that's okay. That's the other part that you can't provide evidence for. It becomes a pragmatic fallacy when you say, "Well, it works." No. Therefore, it would work in that environment. Trust me. Bro.
No, I mean my first 8 terminals went up on our protoflight mission in 2023. Like we launched 2 prototype satellites to see how the system works in the actual environment. That was our TRL-9. That was the work we did to get to TRL-9 for our system. So we actually went out and did this. Like I don't. But you're saying that they weren't actually up there because we lost chain of command and therefore it's all fruitless.
Yeah, chain of custody. So like if you're saying
chain of custody, sorry.
If you're trying to say that they're in a vacuous environment, I even said the overarching point is you couldn't even tell me that they're in that environment for sure. You're assuming they're in that environment based on information you can't verify. Yeah? How much more clear can I make that to you, Josh? And we can't sit here and believe with you, man, all day long. At some point, you're going to be like, well, take it or leave it, guys. I'm giving you information, but you can either believe me because I believe it, or you don't have to. And we choose not to. We want a point of verification that we can test, demonstrate, and know for sure things can actually operate because we have the laws of physics. So you can't then therefore negate those laws and say, well, up there, we can suspend reality because it's an environment that we can say it just works. Nuh-uh. That ain't gonna
Well, we're
fly.
not suspending reality. Okay. You can do the math.
We are when we're saying that the rockets work in a vacuum in the way that you describe. We're suspending it. We're saying it just works. Just trust me. We got nozzles that are
we
can
go up there and do it. Like I just told you, we did the protoflight testing. We've tested the thrusters in the vacuum of space.
But once again,
I know what you want from me.
Yeah. I don't want a story. I want a point of verification. I want to understand how the methodology and why you can say what you say with confidence, knowing that this is the true information based upon things that can be demonstrated.
So I would point you towards Celestrak then or spacetrack.org. And you can map the altitude of our protoflight satellites as a function of time, and you can see that we did orbit raising, which means that we thrusted to get up to a higher altitude.
Gosh, you're not getting it, are you?
No, it's a first-person ground-based observation that's publicly available.
I'm not talking about how high you can get. I'm saying the environment. The environment. How do you know it is what they're claiming it is based upon information given to you? There's nothing you've done to verify that. You've taken it for granted and say, yeah, of course, duh. That's what I'm saying. I can't be any more clear, Josh. You're just taking information that you think is absolutely the gospel truth and then telling us. You've just taken it for granted that it's the case, a foregone conclusion. I know it's like a little window into human psychology, like why people believe the things that they do.
I agree.
It's amazing.
I'll have to go grab the actual TT&C data channel that we report the pressure.
Yeah, well, I'd like to see it being happening. I'd like to see videos of it at least.
You're a tease, man, because you've been saying that for 3 visits now that I've seen you. You're a tease. Dude.
No, I pulled the temperature data last time that we did that. Yes, I did.
No, you didn't.
Yes, I did.
You didn't.
I didn't show you it.
You were attempting to. I was here.
No,
I would have been like, oh,
I told you the ranges. What are you talking about? Whoa, Jesus.
Yeah, you didn't.
Oh,
well, you can clearly see we're not satisfied, so you'll have to do it again if you want to do it.
That's fine. My goal here is not to make you satisfied.
No, the goal here is to actually produce evidence of the claim that you're making, which obviously you can only do to a certain extent because you're saying here's my evidence, and then the court's looking at it, right? We're all peer reviewing it, and we're saying there's nothing here that shows what you're saying can happen in the way that it does because you didn't substantiate the environment. Do that.
Okay.
Substantiate that in some way. Prove it to us.
You're not able to do that.
Yeah. In some way, verify the measurements that are taken in a location where you say that those things are. Put some meat on the bone, dude. Like, give us something to work with.
Yeah, I want to see them testing to the values that are up there. They don't have a chamber to do it.
Space we don't have that. No, we don't have that ability.
Yeah, Cooper.
Of course not. That's why you can't send things up there.
No, that's not true.
It's true, mate.
Yeah, dude, listen. If it were absolutely true, there'd be measurements in that environment all the freaking time. All the time. And there would be data up the yin yang. You'd come in here, Cooper, and everybody that's just a space believer. You guys would be like, oh, here you go, guys. You're denying measurements. Here are the measurements. There is none. No measurements are being taken. Are you listening to what I am saying to you guys?
Yeah, I don't understand why y'all are getting emotional.
Okay,
no, we're not really getting emotional, with you, man. Please don't register that. That's not what you can. Look, we just want to have some verification, validation. That's the standards we operate here, right? And we're not getting that. And when we don't get that, there's going to be a little bit of an emotional nuance, but it's not against you. Okay, nothing personal. Yeah.
So the part about it is they want us to sit here and believe with them, and we're not going to do that. It's like, no, I'm not going to sit here and believe with you. You can't prove it by measuring it, by testing it, by doing something that verifies what you're saying is true. Then we're not going to sit here and believe with you. You can be here until the cows come home. We're not going to believe with you. It's not going to happen.
That's fine. I did grab primary data on thermals last time. what I was looking
don't
through.
you know all that data is fake, and you're not actually going to the vacuum of space? That's the argument you're contending with.
Cooper,
What
how can you prove
information?
that? How can you prove that true? Go ahead and give us a demonstration how we can prove it true.
Was my summary of your contention with his argument accurate?
No, it was a straw man. We're
Okay,
asking
I think it
for
was pretty close.
no, we just want the measurement.
Yeah.
We want the apparatus that measures.
I was gonna
Sorry,
say,
to be clear,
public,
so you
that's
don't
why
straw
I'm
man
not
the
trying to
argument
debate.
again. No, we just want the device that measures the pressure in the readout of that device.
That's it.
I was gonna say I can tell you the piece of hardware and I can tell you the reading, but I can't screen share or like show video or anything. Like it's not public data.
Type it in the text what you're talking about. Give us the name of the device. Put it in the text.
Once again, I'm happy to go look one at my desk. I'm not at my desk.
That's what you always say.
Dude, that's because I'm only on here. That's why.
Listen, dude.
Wait, real quick. No.
It goes back to my point that you're a tease, bro.
I get it
every time.
I agree. I agree with you. I'm sorry. I join these conversations to while I'm driving, while I'm filling my downtime. Like this is
okay,
not.
all right. That's cool. I've got a suggestion. When you know you're going to be coming in, hang on. When you know you're going to be coming in, get your. You know what we're like. Get the stuff we've asked you for.
That's not the point. That's not the point of why I'm here. That's why I say I don't debate, because I know that I'm. Exactly. No, that's because I'm here filling my commute, my errands, my downtime. This is my.
So in other words, Jen, he's not here to provide evidence to back up his claim. He's just here to tell you what he knows.
I'm not.
And
exactly.
You take it or leave it.
Exactly.
Well, there you are then. Well, then I'm just going to put up. Well, then you're dismissed automatically already with the rest of the other guys who haven't been able to prove their stuff. That's it.
That's
okay.
fine. I'm okay with that.
Ladies and gentlemen, you heard that clearly. This is why we hold the position we hold, because they're unable to prove to us what they say is true. Okay,
and this is coming for somebody who works in the Kuiper program for Amazon, satellite engineer. That's to you guys out there.
Amazon as well.
Regular, Joes that come on here to challenge us. How much more less of a chance do you guys have versus somebody who is actually working in that specific field? Think about it. Make you think, Cooper.
Almost like willful ignorance is the perfect defense.
Not really, no. If I don't see anything convincing, I'm not going to quickly believe. I don't do believing like you. I don't believe nothing. I believe in nothing at all. Okay? You got to prove.
I was responding specifically to AV.
Okay, all right. I thought that was a bit dig at me because I concur with what AV is doing. So there you are.
Mm-hmm. And we do it very well.
That's fine. I don't have any comment on your conduct.
That's why I define how I interact with these spaces right off the bat. I apologize if it's not up to your satisfaction. I'm sorry that I don't spend my time being productive, substantiating my claims in here. I sincerely apologize. Like if I had time to do that, I would definitely spend more time on it. I
know. In other words, a roundabout way is if I really cared about what you guys were talking about in here, I would come up with the backup information. But I really don't give a shit about you flat earth.
Do you notice? I was gonna say, do you notice that I don't get emotional or like?
That's a good tactic, though. That's a good tactic.
I don't care.
I'm sorry. I'm apologizing. Fallacy. I'm sorry. I'm apologizing. Fallacy. Sincerely. Fallacy.
Oh what? No, I'm. You all are human. You all are just as valid of human people.
So are you, man.
That's all.
You're not freaking Spock on the Starship Enterprise that doesn't have emotions. You do have emotions, and sometimes they run around with you in here. So come on, let's stop playing games here.
No, I'm not trying to play games.
Bullshit, dude.
No, I understand. I used to a lot more, and then I set mental boundaries for how I engage with this community.
That's fine, dude. That's fine. But at the same time, dude, we deal with this in the nature of the beast. Sometimes it does get, a bit emotional. But why point that out as if it's a flaw? You are so emotional. Like, who gives a shit? Like, that's how people communicate. So what? So what if it's emotional? And? So what?
Okay, well, I'm just letting you know that I don't prefer to communicate through that manner. Like that's not my. That's not why I'm here.
You want to be like Spock, right? Don't have emotions.
just trying to.
That's illogical. Emotions are not practical.
By emotional, I mean aggressive and more, reaching for
internally. Yeah, you're talking about internally critiquing your worldview, and that's emotional. No, that's being honest with yourself and with others.
Look, in a court of law, when you're behaving the way you're behaving and substantiated things that are coming literally from a false premise, you'd be considered null and void in everything you've said. You understand?
That's why we're not in a court of law.
Yeah. Well, you are anyway here.
So this is the people's court. Yeah, this is the people's court. Right. We're holding it, and there's a standard here.
Honestly, it's more of a I told you, it's more of a sociological interest for me.
Yeah, no, well, that's fine, but you're bringing forth what you consider as evidence, and it's weighed out by the people in here of this court, and so we deem it whether it's something that can be accepted or denied based on what information you're providing. So the evidence is looked at, it's weighed, it's measured, and it's either taken or discarded.
Yeah.
So I'll state that I don't see anything I say in here as evidence. I see it as more of shared experience.
Thank you. There you go.
Yes, and you're very confident when you share that. You make it sound like it's a foregone conclusion. It's a fact, but it's not.
From my perspective, it's just my lived experience. That, like I said, this is
our lived experience. Our lived experience. Our lived experience is that we need to scrutinize everything that we're being told regarding space, rockets, space travel, planets, everything. We have to ask the questions as to how they know what they know. And we're able to understand that. Don't get me wrong. I don't have to be a qualified cosmologist, scientist to understand that. Okay, that's not required.
That's why I'm here for y'all. Like, I want to know how you know what you know. Like, that's why I ask questions about how people
listen to the experts supposedly and scrutinize. Yeah, that's how we know.
How we know is we do research. We continuously don't let. Being a critical thinker is an ongoing task from the moment you put your feet on the ground when you wake up in the morning till the time you lay your head down on the bed. That's a critical thinker's position. And what we hear from these Globers is like, what do you mean? I got to be skeptical about everything? Well, why aren't you going to challenge things in your life? Why aren't you going to put things to the test? Why do you just want to accept everything? That's the question I would say back to those guys.
That is how humanity becomes doomed at that level. That's what happens. Humanity is now in a doomed position. I'll tell you that now. Look at it. Look at the life we're living, ladies and gentlemen. Taking your taxes, bombs are being made, poisons are being concoctions, no safety. Okay, that's just a small sample. Dying in wars that needn't happen. There you are.
Yeah, and everybody's burying their head in the sand because they don't want to ask any questions. Yeah. So we have a society now that's just real soft. Oh, let's not get emotional, guys. Let's all win a trophy. We all get a participation trophy. Dude, that's a fantasy world that people think they're going to live in, where everything's just going to be hunky-dory.
Yeah.
No, it's based to have control over your emotions, especially anger and frustration. Yeah. You should definitely be able to control those, especially in a conversation.
You need to express them in a correct fashion whenever they're needed to be expressed.
Yes, exactly.
You don't need to. You got that wrong.
Yeah, you need to be able to be
expressive.
No, stoicism is based. Control yourself.
Yeah, stoicism, which you don't know anything about, probably.
Yeah, you need to press for results when you're not getting it. That's what happens. So you have to be a little bit stern now and again.
It's the thing about these Globers. They're always about the tone. When you guys getting so upset when you're criticizing their worldview, it always results to that. You criticize their worldview. Well, why are you getting so mad? Like all the freaking time, every time.
And then Blur. Look at the way he turned out to be. Horrible, obnoxious scumbag in the end. There you are, Blur, ladies and gentlemen, who was just in here. Tony Blair.
Lori's spamming crypto stuff in the side chat, I think.
Who?
Yes. Verbal diarrhea, no doubt.
Mine. It looks like the auto mod caught it.
So we're kind and sincere, but then you get the response you get from Blur, and all we were doing is trying to make sure and clarify what he was trying to say was what he was trying to say. But no, his smarmy responses. Don't you F in this? Don't you F in that? You're a retard. Yeah. You're the N-word. You really are the N-word, aren't you? Blah blah blah. As if that's the way to be. See?
Yeah. Can't even compose himself in a conversation where it deals with whether or not he knows what he's talking about. intellectual honesty, intellectual integrity, like all of that's just gone by the wayside.
Yeah. Jumping on a train and jumping up inside a train. I don't live in a train, I live on the earth. Trains, cars.
Hypotheticals, like, these, unrealistic scenarios that you have to be in order to conjure up the idea that the earth is a globe in the vacuum of space it's all fantasy.
Yeah, they come up with stupid things like when you pick a Billy Logie out of your nose and you flick it, does it go forward when the car's going backwards? Do you know what I mean? That kind of lunatic kind of nonsense I'm hearing.
That's crazy.
It is. It really is. So yeah, we've got to keep the level up. We've just got to keep this standard of scrutinization, because that's our life belt, if you understand what I mean. Okay? That's it. Or you're going to sink in the abyss of belief. I don't want to do that.
Let's see. We got some new people that just joined us. We got Newt that's in here. Guys, if you want to chime into the conversation, we're still having it. If you believe you live on the earth that's a globe, present your evidence. This is the People's Court.
Yes, Your Honor. Yes, Your Honor.
I was just listening to you guys talk and argue and shit.
Okay, so XM4 just chimed in. Welcome to the room. We're asking individuals who jump in, if you believe the earth is a globe, please present your evidence. Do you have any, XM4?
Yeah. Well, thank you for listening. Thank you for staying. And
like
my colleague just said.
I'm not really looking to argue or nothing or like debate. I'm just listening to you guys.
This guy sounds so horizontal. It's like, you could be more relaxed if you tried, could you, mate?
He's making you relaxed by just listening to him.
Fuck yeah, I'm almost falling asleep listening to him.
It's like, I feel more relaxed just hearing his voice.
Well, that's okay anyway. I mean, it's okay. He wants to listen. He might get fired up and get a question out there maybe later, but that's fine. Okay, anybody else who's got any questions, please don't hesitate to ask. Doesn't matter how odd or strange. You ask.
Everybody needs to be quiet, man. Quiet.
What's up, y'all?
What's up? What's up? What's up?
I just had to make room on the dance floor, man. We're just kicking it. And we had Josh in here, was telling us about a space fantasy. That's fine. I don't know. Well, what time are you on right now?
I'm chilling. Yeah, just got finished talking to Chocolate, saying he's good and well, y'all.
Yeah, thanks.
I had to call his personal jack and update him on the situation.
How the fuck is it? Why did you not bring him with you?
Would you come in?
Yeah, you should have brought him with you, man.
He's at work, going through his own stuff.
Oh yeah.
That's fair.
Yeah, he's gonna try to pop in though when he can.
Well, if you speak to him before we do, if you speak to him before we do, right, all of our best wishes to him and everything, man. We miss him. Probably doing
tell him I extend a handshake and a salute and get his ass in there quickly.
Yeah,
no doubt. Well, also, Jen, I had some information for you as well. Good flat Earth proof stuff to add to your arsenal.
Thank you.
So, later on, get with you.
Okay. Appreciate that, brother.
No doubt. Because I know you drill into the information, and once you locked on, you don't stop. So I'm like, let me share this with Jen.
Yeah, that'd be nice.
Yeah, it's the we were going over just before you came in, Eli, with Josh and the whole space lore about satellites in the vacuum and how they operate and such. And there's been a lot of assumptions that are being made from the point of someone who works at where he works at, satellite engineer and such. So no point of verification is being done to solidify the point that those things are going into that environment as, we're all being told. It's a lot of assumptions. Your hot mic and AK. Oh, let's see what else is in here. Thank you guys for joining. Go ahead.
How did he take that?
We were.
Who's the hamster humping the phone? The fuck?
It's AK. He's doesn't know how to type on his phone, bro.
The fuck?
Yeah, it was Josh, the satellite engineer for the Kuiper program for Amazon. And how did it go? I think we were on with him for about, was it 2 hours? Something like that?
Yeah, about 2 hours, yeah.
He took us to IKEA with him. He was going to go pick out some bookshelf or something.
Yeah.
But yeah, the whole rigmarole, like rockets in a vacuum, if the vacuum actually exists, like all that kind of stuff.
Yeah, we gave him the test. We shook him up. We picked him up, turned him upside down, we want the evidence. Come on, shake it out of him.
And he said at the very end of all of that, I'm not here to provide evidence. I just want to have a chat and a good time on my way to and fro places.
Yeah.
At the end of it.
Yeah. With his pragmatic fallacies that he displays with confidence.
Rockets work in a vacuum. Yeah, like therefore, the vacuum of space exists. I'm like, really? How do you know that, bro? Oh, they work. Really? So then that means that the vacuum of space exists? Oh, yeah, what else can it be? Of course.
Yeah, I actually brought out, what was it? Brian Mullins is the ISS and the thermosphere, and then the conservation in space. Brian Mullins, Brian Mullins stuff was coming out. Yeah, and rockets do not work in space. Yeah.
Is he back on the scene?
Well, I posted his material in the video, in the server. That's what I did.
No, I know, but is he?
He's not back on the scene.
No, he's not back on the scene.
Same videos from 2018.
Yeah, he's not back on the scene.
You can talk and write books and articles about things like that. Like I can write books and articles about how you can just like Tom and Jerry, you blow air from your mouth so hard that it can just throw your body back. Yeah, that's what they believe. So if every action has an equal reaction, you blow air from your mouth, there is material exhaust from your mouth, so it must throw your head and body back.
Yeah,
he was trying to conflate. He was trying to convey solid mass or solid things versus like gas within like the idea that it's expanding out into a vacuous environment. So he's trying to make it analogous to something solid.
Mm-hmm.
At least that's what he was proposing,
Yeah,
like that example that you see with a bowling ball and a desk chair. You throw the bowling ball one way, you go the opposite with the desk chair. You seen that one?
Yeah, like that science fiction. That science they use in their science fiction movies, like Thor does with his hammer. So he just spin his hammer so fast and throw it when it will just take the body also with it. So they think about those things. So if you take a hammer or just something with weight and you spin it so fast and you just stop the spin instantly, it will just draw you with it. The weight will just drag your body with it.
Yeah, conservation of momentum again, like nonsense.
Yeah, but it's not the thing that the rocket do with the thruster. It's not a rocket that is spinning a hammer and like Thor.
Yeah, you're right. In order for that rocket to move, man, it can't be there. It just cannot be in that area. How can it be there, just suspended? That's just stupid. It can float. As soon as you get past the Kármán line, 62 miles off the Earth's surface, 100 kilometers, you get up there, and now you're weightlessness. And the deeper you go, the more you float. Come on. Ridiculous.
What would happen to a balloon inside a giant vacuum chamber? Just imagine that you have a giant vacuum chamber where the gas from the balloon won't make a difference in the pressure if it's released into the volume of that vacuum. So they think that if you just open the nozzle of that balloon, so the balloon will do exactly the same thing that it does here on the in the air pressure. It will just start flying. No, it won't. It will just deflate without any movement.
No movement, and the gases go everywhere else. But
I'll give you an
just
example.
deflates. Yeah.
I'll give you an example. Yoder posted something in the text chat just a moment ago. Indio 007 has a video that he has on his channel. The flat Earth thrust in a vacuum test fail, and as Yoder pointed out correctly, it's refuted. So, I mean that's RIP, right? The headstone's right there in that video for gas working in a vacuum chamber.
Yeah, and it was Nottingham University that did one of those vacuum tests first in Britain. Nottingham University, they did a really good one. And yeah, the rocket didn't go forward. All the material just came out. Didn't lift up, didn't do anything. Just poured out nonsense.
So I'm looking at Indio's video, but I'm trying to connect, and I don't know if everyone agrees with what Master Yoder said, but he provided an explanation. But I'm trying to connect the concept of if the amount of thrust being applied to the scale in the demonstration I shared was dependent on the amount of gas in the chamber, then it seems to me that you would expect to see as the vacuum chamber filled with more exhaust gas, that it would have an observable effect on the amount of thrust applied to the scale. But when we look at the video, it doesn't show the scale.
Yeah. He said he didn't mention. Hold on. He said, hold on, because you're assuming what he said. I'm gonna interject because I'm reading what he's putting in text. He
just
said,
to clarify, that I'm taking his concept.
Hold on. He says, I mentioned nothing about scales, Kiro-san. What the fuck are you talking about?
I know he didn't. I agree. He didn't say anything about scales, but I asked him how would the collision of the exhaust hitting the opposite wall of the container impart momentum to the rocket, and then he provided an explanation, and it was due to the chamber filling with gas. So then I took that. I understand. So I took that and made a prediction that if that is true, then you would expect that as the chamber filled with more and more exhaust gases continually, that you should have a measurable change of the amount of thrust being applied to the scale that's dependent on the amount of exhaust gas in the chamber.
Not just that.
So you need gas pressure to make it move.
There is the gas that is built in the entire chamber. There is also the column of gas that is in between that rocket nozzle and that wall that is behind the chamber that is slowing down the gases compared to outer space, where there is nothing that have to slow down those gases or change their trajectory.
Exactly.
So there is walls on the top of the container that is changing those gases that are released from the nozzle will bounce from those walls in the top, bounce from the walls in facing that nozzle. So it will create a column of gas in between the nozzle and that wall. So it will help also that rocket to build the thrust.
Yeah, and that those conditions are not in space, are they? It's very empty, isn't it? So when the material comes out of the nozzle, it's going to go out into nothingness. There's going to be no forward propulsion at all, none. And then imagine when you're in the Apollo missions, you haven't got enough fuel, so you're going to try and control all your movements. And if you push too much, you've got to compensate. You're losing all your fuel anyway. If that was a thing, if you could be there. You don't have enough fuel to do anything. It's crazy. Absolutely crazy, you know?
And let me just, because I know he can't speak right now, I'm just going to read text, so hopefully I don't misrepresent you, Yoder, but you're saying, show me, he's telling the Zakiro-san, show me the net force against the bulkhead of the chamber in a vacuum chamber. Then he says, and let's see it move, continuous vacuum. So
exactly.
Right, so that demonstration wouldn't qualify his question because you're and let's see it move because and continuous vacuum, because as the exhaust fills, it's putting pressure into the vacuum chamber. So I understand that demonstration doesn't qualify his question. I'm still trying to figure out how, based on the concepts that you just provided, what I would expect to see if everything you say is 100% true, and that's what we would expect to happen in reality. I would expect that the amount of thrust applied to the scale in the video I shared that amount of thrust should change as more exhaust gases are expelled into the chamber. But
well, the best place to try that, right? And it still wouldn't be simulating space, but that would be the Ohio State vacuum chamber, that big one in Ohio, that massive thing. Let's use that because there's a lot of room there, and then you can bring it down to scale and see what happens. But no one's done that yet because they know what it's going to reveal.
Sorry, Yoda, I don't want to misrepresent because it's already.
Yeah, because that would be the place, the Ohio State vacuum chamber. That NASA owns it, of course. Biggest in America. It might even be the biggest in the world. Probably is the biggest in the world.
I think it's one of the choice of words, largest vacuums that can be pulled within the NASA facility. I think 10 to negative 6. I think they've gotten higher than that, but safe estimate about 10 to negative 6. That's 2 concrete walls that are 6 feet each in thickness. With was it reinforced like steel as well? Because even when they pull the vacuum and they leave it alone for a time, gas, because it wants to expand, still managed to get through all of the tiny micro cracks in the concrete and the surrounding container, and then to the vacuum. So bloody hell.
Yeah, it does. It's pulling the stuff from the outside through the brick. Yeah. That's what I'm saying. Look at that. 10 to the minus 6 they're trying to do there. Right? That's why when I saw the one in the MIT, it was 10 to the minus 7. It was like, if you can imagine a fire hydrant, but just a quarter of the size of an American fire hydrant, right? But with all the heavy-duty bolting on it. And they were testing film and film canisters to see if they would outgas. And they outgassed, and that was 10 to the minus 7. But you couldn't put your hand in there because it was a small one. You know? Right. So, it's not an easy thing to do, to do these vacuums at those levels. At those 12 values of 7, 6. Because I've never seen a 10 to the minus 8 one yet, or 9, 10.
AK, stop picking at your phone, bro. Like a chicken going ham on your phone.
Yeah, it really is. Okay, can you mute yourself, please? Thanks.
Sorry, guys, I didn't know I got unmuted. Like, next time, give me a heads up, maybe?
It's an automatic function. It happens after 40 minutes, or mutes are just automatically unmuted.
Oh, good to know. Thanks.
That and we don't need to give you warning. So, anyway, what else we got in here? Well, it's just us. Pretty lively morning. Good stuff, guys.
Yeah, really was. And like you said, Miggy, at the beginning, we don't often get an opportunity to have somebody working in the industry that we can actually air our grievances. Our what's the word? Dissatisfaction of what we heard with the knowledge we've got. Sure. So you work in the industry, you can help us.
Yep.
Ask him next time when he comes in where his customer complaints department is. We should go and speak to them.
Hash brown 999.
The way he categorized it, wow, I'm just here to have talks with you guys. I really don't care about proving anything. Like, okay, that's just more to our point that even you, who are somebody that works in the field, can't provide evidence. How much more do you think the guys who aren't doing what you're doing going to be able to provide evidence? If you can't even do it, and that's because you work for this stuff, like, you make it really bad for those guys. Like Hiro-san, like Cooper, who else? AK. Think about a bunch of people in this category.
There was a little flaw in his story because he said I thought they worked in a thermosphere. He said the exosphere. That's even higher.
Is that what he said?
Yeah, that's higher up in altitude.
Yeah, it is.
But he said they were in the 300-mile range, 350-mile range. That's the thermosphere where the ISS is, and the CSS, and supposedly, of course, there's a lot of things in that area.
I'm surprised they don't have accidents, or at least say hello to one another, even fly by. You know,
missed it.
What'd you say, Eli?
You missed it.
Yeah.
So yesterday, remember I was going to do something? Well, you actually slipped out right before I went through it.
Ah.
Oh, Jen or me?
Yesterday, remember we were talking and I was like, I'm going to come back from getting something to eat or something going to the ASP.
Shit.
Yeah, that was yesterday.
When you left, you came in here, and that was when I did it.
Well, Lee, think about timing.
As they say, golly.
I'll do it again then.
I don't know if I can. It's too great.
It was just that moment alone.
This fuck is so awesome. I can only do it once. It's amazing.
So I was actually waiting when you were going over the list for you to get to pitch data yesterday, but you never did.
You talking about the flight data?
Yeah, is that on the list?
Yeah.
Yeah, I was waiting for you to get to it.
Yeah, he did. He got to it. He went through the whole list.
Was it? This was actually the one that the conversation we were having with Josh was on the list too as a bad argument.
Yeah, it was number 38 on the list. The one with the data was number 38. I remember.
No, I think it was sooner than that, but I could be wrong.
But yeah, no, I remember it. Number 38 on your list of bad flat Earth arguments, sort of thing. Right, number 38 it was.
But I don't personally have a beef with it per se, like as in
yeah.
Because it is the argument, I think, from what I gathered when we were talking about it, it's attached to more relevant information. It isn't just like I'm going to say that this right here shows that we're flying over a flat Earth, and there you be. I'll walk away now. Like it was more like it was a part of like the information that you would need to supply that we are flying over a horizontal plane based on like the technical information, including with other information. So
that's correct.
That's why I gathered it.
Yeah.
It wasn't just like now, unless you were saying that, like that's different. If you're saying that,
no, that's how I've always been. I've always used it as backup to what I'm saying. It's a preponderance of evidence, as they say. So you're piling up all the evidences, and that's part of it.
So I came in and said, no, the graph itself is actually evidence. And then I was like, let me roll it out. Does anybody disagree?
Yeah. Are you?
So I don't know. I guess let's see if we can knock that off of the list.
Ooh, I like it. All right. So Eli's putting out a challenge right now to the. Are we speaking of the same data though? The flight data, the one we've all seen, is that the one we're going to be?
Yeah.
All right. It's right now being contested. Eli's saying that graph that's showing that horizontal data that shows that a flight in cruising altitude, when it reaches cruising altitude, would be sufficient enough to say that the Earth is flat. So does anybody raise any objections to that?
No.
Just that alone, however, not any more information outside of that. Just that alone.
Just the information on the graph.
Yeah. I disagree with that. It won't prove that the Earth is going around a globe, because the claim from the globers to respond to that, there is the gyroscope is calibrated to be influenced by gravity, so it will tilt whenever the plane is going around that curvature because of some weight or the Schulin, like the one that Master Yoda explained to us, Schulin effect or something like that. It's called like that. So.
Yeah, hold on. I want to let you finish, but I was saying that as far as a bad flat Earth argument goes, this was on the list of a bad flat Earth argument to say that the horizontal pitch data that shows on this graph that everybody's seeing, right? That graph, that would be just evidence of the Earth being flat alone, without any supporting evidence. And Eli is saying that he supports that position. Does anybody disagree with that being solely the reason why we could say the Earth is flat based on that pitch data information? He wants to hear somebody contesting it. And what would be your reason to contest it? It's fair, right? I mean, it's what everybody would like. Wouldn't you want to scrutinize something that you're saying is true by your peers?
And you guys have already been scrutinizing it. It's just I'm here now, and I'm like, okay, well, let me hear it.
Is there any objections?
Yeah, I think it's strong, but it's not foolproof. I think I've heard the argument that on a globe at that distance, the difference between a perfect triangle that would be used for, in this case, using trig and all that, and their alleged drop over distance, there's a difference of maybe 1% or so. So they can argue, oh, well, it's just within a margin of error that, the plane just adjusts over time and, uses it for like a good blueprint, but, blah, 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 type thing. I think Matthew Learns went on about that, and the math came out to be something like that. So, you can use it, but go ahead.
That's one objection. I want to hear, Eli, if you have a response to that before I go to the other one.
Yeah, let's see the math.
Show him the math, 20 cups, if you have it.
I don't have it on hand. I remember Matthew Learns going over it. So you might want to talk about it next time.
Well,
it comes up.
Okay.
So I'm just saying that.
I remember Matthew Learns not talking about it every time I'm around talking about it, especially when he isn't here.
Really? Okay. I haven't heard just a succession conversation about it. So,
well, I mean, either way, I'm going to break it down. So once you see the math, you can go, well, this is what he would have said, yada, yada, yada. And we could go from there.
Right on.
If you want. I mean, either way, I'm just here to expose my position and what,
sure, I think it's worth going into, for sure.
Yeah, hold on a second. But before you do, Eli, do you want to go through that exposition, or do you want to hear more objections? I don't know. But where do you want to go with this?
Oh, everybody put your meat on the table.
Okay. We'll see. We got one more. Master Yoder's coming from a different perspective. He's saying this data that's been fed from the ADRU after being enriched with corrections. It's not raw gyro data. What say you to that?
That's good.
Good point.
Yeah, do you think my point is relevant to that, or is that irrelevant to my point?
This is the point. I'm glad you asked that and spotted that straight away. So this data that we've got is processed data. It's not the raw data. That's the only thing from my position, and I see that's really being put down on the table, the actual data itself. All right?
So the question becomes, as a matter of fact, I'm laying out how it is horizontal, not why I would argue it's not. You see what I'm saying? So when someone's talking about gyro this, gyro that, I'll give you that you're saying, well, no difference. This graph could represent anything I wanted to. I'll give you that. But mathematically, what are they doing for real in reality, though?
Yeah, so this is what we figured out about going through the list yesterday, right? So I know what you're doing. You're using avionics along with the pitch data to further an argument about the trigonometry math used for takeoff and landing, specifically landing, like you've been speaking about. So you're using this in conjunction with this argument. When we use this piece of paper alone and just throw it at someone and say, there you go, the earth is flat, that might be a misappropriation of the information that we've got because it isn't the raw data. You're building upon a premise and making the larger argument where your conclusion is actually based upon trigonometry and the landing calculations at distance using that mathematics. So it's adjacent to this argument.
basically.
Yep.
Okay. Well, at least that then you're basically siding with everybody else yesterday, and it's not a disagreement. Then it's an agreement. Sounds like, unless you.
Well, it sounds like people are saying if you look at the graph, this doesn't tell you whether or not the Earth is flat. I'm still saying that's incorrect. It depends on what you're looking at. So if everyone else is looking at the level,
no. Sorry, it's not telling us the Earth is curving. Right, we can look at the graph and say that it's just showing us level altitude with the ground below. It's definitely not showing us that it's curving, right? It appears most definitely to show that it's flat, but we understand that within the information and technology within the aircraft itself, there's apparently mathematical corrections and calculations that are taking place, and they're really, so we're told, really insignificant, but they do take place. Which then comes back down to us asking them for the measurement that show that it's curving. It doesn't show it in the diagram. So again, it's the wording of how we give this argument out. But sorry to interrupt, I know you were going somewhere.
Okay, so when you look at the data when the plane begins its ascension,
takeoff, takeoff,
and you know that they have to do some math to figure out where exactly they want to end up. I understand what you're saying is that they're saying that somewhere in there's a correction.
Mm-hmm.
There's no correction in that process. So ultimately, that process, as it's shown on the graph, them achieving what they're doing from takeoff to cruising altitude is a trigonometric function, a utility.
Mm-hmm.
That directly right there, if you understand that, and that's what you're looking at on the graph, that is proof that there's no rotating frame of reference.
That addendum that you said, Eli, is the greater point, yeah?
Mm-hmm.
That's the greater point. That you're using that
to bolster. The point is you don't just throw the graph and go, that's it. I guess
exactly. Yeah, that we're in agreement. I think that's the best way to go about it is to because that's what we were discussing. Because it can be a bad argument. That's what the point was yesterday when all these were coming up, and so can many of the other things that we say. Mostly everything we say. If you're not giving context, then you're not. So the list was it was taken out of context by others. You know who they are. And taken to a group saying, hey, look, they're saying all the way this presented is just the way it is. And they were just really bullet points on how we were expounding on the ways that people misuse these arguments. And some are just bad arguments by themselves, but they're not like this one had a very nuanced way of.
And then we were doing the same thing across the street, and I'm like, yeah, no, that's what they were doing. It's and they agreed. It was well, at least Nathan, he's like, oh yeah, I get it. You're gonna just leave it like that. Well, no, typically we do go through it. At least one.
Yeah, and
I always kind of
like was pointed out. Anyway, this isn't actually really directed at anyone personal. This is the wider kind of flat Earth conversations that we have on this server and that they have on TikTok and so on. All bad arguments, or all misappropriated arguments, or some arguments that even when people say them, they miss the beats. They don't highlight the specific areas of the argument that drive the point home. So they're good arguments, but they're just badly used sometimes.
Yeah, I agree. And I know that to be true. I know that to be true with Eli, because he does sometimes come in here and he gets frustrated because some of the things that he hears the argument going and most of us sometimes do as well. But we hear the argument going a different direction. We're like just you can't stop something that's already progressed.
The wrong way. And then Jedi goes, for fuck's sake.
20 K-ups, rise, whatever. So ultimately you have a triangle, okay? And so you have the altitude of the plane, which you're going to convert into feet. And then you're going to take the angle to then get the length of the adjacent. Is that true?
Sorry, could you repeat that? Missed half of it.
So you have the altitude of the plane. So you have you say you get the feet. So you got the measurement in height in feet. You have the angle to the plane. That gives you what?
What were you talking about? What content? Like which example?
In trigonometry.
What was it? 23
with the
right.
The top.
Yeah. Okay. Yeah. All you need is the altitude and the opposite, right? The opposite from the airplane, right? That would be the ground, right? So you have the adjacent and the opposite. You can calculate the hypotenuse, and there was something about they want to get the plane at a specific descending angle based on that. Yeah.
Okay, so that height is real, right?
Okay.
What about 1% into any of that?
What about what? 1% what?
What about 1%, however it was mentioned, fits into any of that?
So for example, if their height is what 30,000 feet or whatever it is, right? The argument that I heard from Matthew was, okay, 30,000 feet, we're going to descend at, what was it, 20 degrees or something, right? On a flat plane, that'll get the plane directly right at the runway. Whereas over a curve, they're gonna assume it's flat, but in reality, according to them, they're gonna be descending an altitude of 30,000 feet plus or minus a little bit to account for that drop that would have been over that curve.
Yeah, let me stop you right.
Yeah, go ahead. Yeah.
From the airport, horizontally, horizontally out to, let's say, give me a second. Hold on.
Yeah, do you have that example there from that article?
Well, I have my own example. I just used 39,000 feet.
Okay.
Give me a second. All right, so I'll just go. Let me see. Okay, so if the adjacent length is 126 miles horizontally, like from you, that's the ground position of the plane, right? Where does 1% of anything factor into that? Because as far as I'm concerned, geometrically, if we're talking about horizontally out from my position at the airport, and the ground is a continuously curving thing, then that would mean it's what? I don't know, 2 miles?
No, the 1% is the 1% bit. I think it had to do with the altitude. So if they're at 30,000 feet, and the math works out that 30,000 feet, they're going to go at X whatever angle, 20 degrees or something like that, for 100 miles or something like that, right? In the ideal case, right, that
the descent angle is 3 degrees. Typically
3. My apologies. Yeah, I just picked a random one.
Did they say 20 degrees or?
No, dude. I just to be fair there, okay. I woke up in the last hour, so I'm not exactly all there to argue this. So forgive me. But whatever the number is, right?
But the
point that was being made is that in the ideal trigonometric sense, okay, if the altitude is 30,000 feet
and they're going to go down at that 3 degrees. That's going to get them there. Okay, the argument had something to do with, the math works out like this, but in reality, over the curve, they would have just descended 30,300 feet, plus or minus that. But they didn't, they just calculated for 30,000 because it was simple math, so to speak. So that 1% is in addition to, like, it's plus 1% because that would have been the extra drop because the curve went down over them. You follow?
Yeah, well, if the curve went down, then in reality, we're talking about 2 miles. This 1% thing, if that's equivalent to 2 miles, that's a problem. Because again, they're gonna end the end of that triangle right at 1,000 feet above the airport. So it can't be that they're actually 10,000 feet above the airport. That doesn't work. So mathematically, I want him to walk me through what is 1% exactly? Because I asked him this initially. Because initially he tried to just make the adjacent longer. That's what he initially tried to do. But there's a problem with that as well.
Yeah, I think it's fair to argue it, dude. Yeah, like he's kind of just assuming that that all these things are taken into account. What you're stating, what the article stated, I remember you brought up. This is the math they do. This is what the planes follow. This is and this is how it's done, right? But he's throwing in there, there's always room for variation, and they adjust over time, and like it's kind of just like a.
Well, I look through perplexity.
An argument of kind of like ignorance or something like that he's throwing out. Kind of like, what if this without anything substantial? So it's more. That's all I was getting at. Right?
I looked through Perplexity AI, and Perplexity AI told me exactly that. And then it gave me the sources for it saying that. And when I clicked the sources, it mentioned nothing, no math about that. It started talking about great circle roots. There was nothing in there. So I was like, how the fuck did Perplexity give me this? Like, it's telling me this rhetoric, but when I go to the sources, it's not in there. So again, I want Matthew or whoever's brave enough to show me what you're talking about.
So I don't know if you guys were you. No, he's not in here. Matthew's not in here.
Okay.
I could go through the math quick too as an example. I don't know because I suck at. I had to really get sit down and get it talk to me and me write it down to really go, okay, at least I at least understand this. Cause I'm terrible at math. The last time, here's the thing. I know that this is powerful because Scott Mackey kept yelling at me you were there, AV. Scott Mackey kept yelling at me to give him the math. And then I got it from Perplexity AI, and I didn't even understand. I understood it, but I'm like, loosely, right? And if I go through it, I'll understand it, but I'm not going through it. I just threw it at him. He didn't say nothing after that.
Mm-hmm.
He still hasn't responded.
Interesting. That he still hasn't responded.
Like I said, sorry.
He's reeling from the shock. That's what it is.
Probably. I would say though, there's another objection about that data. There's Yoder's always, he puts stuff in the side chat. I just want to highlight the fact he says if you want the full data from the NTSB flight from the raw unfiltered gyro data, you need to submit an FOIA. There are specific regulations pertaining to the ADRU's data releasability. And he also put the pitch angle is measured against the ADRU's constantly updated local horizon reference plane. ADRU data is in its raw, unfiltered, and unprocessed form, is proprietary and not releasable, never released, and there appear to be potential national security concerns. This means the pitch data could still be derived from a globe, but the data is literally hidden inside a black box that nobody will open. The princess is in another castle.
See, and that's why I went around that route. Because while I understood that they were going to argue about an instrument in the plane that could be referencing, a globe or whatever, which obviously fundamentally I know can't be the case. I'm sorry I have to say that beforehand, but they've tried to make the argument about something that the world may never know. But my argument, it's not an argument. The fucking data is right there. The data is showing us what they did to mathematically calculate where they have to be. And they utilized a horizontal plane over the surface to do that. That's it. That's all they did. That right there, that brings the question of whether or not you're flying over a ball completely out of it. We don't even need it'd be nice to have that data, but since it's not available, what about the beginning of the flight and what goes into that? We could just take that. And
See,
so
the problem is I can model a horizontal plane. Check this out. I can model a horizontal plane and build a building, and you actually go and measure the building, and it's not horizontal. So just because I can do math on a piece of paper doesn't mean that what happened in reality. You got to actually get the real world stuff. Can't be on a piece of paper.
I get what you're saying, not just but if look, I meant to ask you the other day because I'm trying to figure out how like what portions of what you said could be relevant to what I said. So you'd say, okay, this means that whatever I've measured, the ground is warped in a way that it's not level the way that I measured it, right? Because there's something goes on or whatever. Does that change like the distance of the floor or something? Like how does that work? Like,
well, I mean, if I measure a distance of a floor, right, and let's say it takes me 15 sheets of flooring, right? That's 15 sheets of physical flooring that I lay down, right? But when you lay down flooring, there's a expansion gap in each one, so you never actually get them consistent. So to say that the length of your floor is actually equal to 15 sheets of flooring, it's called a nominal measurement. In other words, it's in name only. So it's good enough for what we're intending to do. And so that's where, like, the argument is always going to be that the wiggle room is in the good enough for intended purposes. So if you chart this out and you demonstrate that it's not good enough for intended purposes and far outside of any wiggle room, then their argument that there's missing data, could be vaporized. But until you finish it, you wouldn't actually know that.
You're saying it's not conclusive.
By that is
I'm saying as of yet it's not conclusive. In principle, it could be conclusive once it's completed.
So like the point so what we was talking about yesterday is, well, we have the data. We can actually just go through the PDF, see what airport it was, get like some type of topographical representation and put more screws into this. So, just doing a little more than looking at the graph.
Yeah, I agree, but it's being said.
I've got the full document stack, Eli. I've got a 470 megabyte CSV file that's a spreadsheet from this flight, and I've uploaded it into Grok after breaking it up into 10 different chunks so that the system doesn't fall to its knees.
Exactly. So before you go on, in the past 24 hours, I've had to correct 2 multi-year flat earthers that you can't just take the pitch data graph line and put it into a spherized program around a curve of a specific radius and actually know the course that the plane took. They didn't understand that one piece of data alone cannot tell you the course the plane took. You'd have to corroborate it with the altitude reading, right? Yet they were ready to commit to, because this pitch line, if I can curve it around a globe and show that it's not congruent, then I've made an accomplishment. And I'm like, dude, you forgot about the altitude.
Yeah, you can't. That's you can't do that.
That's why, like, when in arguments like these, you do sensing sessions to see people poke holes in your argument. You refine it, you get it on paper, you work it out, you get a final draft, then you parse that out before you say, I know exactly what's going on here. Like, for example, reference frames and coordinate outputs, right? If you don't know how they're getting their original reference frame, then the coordinate output's irrelevant.
Right.
So we can't keep making claims about things that are unknowns, right? Reserve your claims until you've parsed it all out, period. That's the easiest way to not shoot yourself in the foot for claims you can't substantiate.
Awesome.
We have somebody. I don't know if you want to continue, Eli. I was going to address new people in here.
No, he needs to continue. He needs to continue doing what he's doing and enlisting as much help from as many people as possible, whether that be critique, whether that be actually charting the data, whether that be getting extra data that will help refine the data, whether, mapping it around an actual map or a model, or even getting the data and using the terrain features from an actual airport, et cetera, et cetera. Yeah, of course it needs to continue.
No, I actually meant with the conversation with you, because I was going to address the new people.
No, I'm done. I'm done.
All right, Eli, were you good enough, or?
Well, I mean, if everybody's cool with trigonometry, we can move on. And when I say cool with trigonometry, I was just going to go through the numbers and everything, but I mean that could be redundant.
Up to you, bro.
I do it when a Glober is here, when it's relevant, and I can be as scrutinized as possible.
I was just gonna say, Eli, would you like to sit down at some point and work out this this airplane descent triangle thing? Because we can do the math together if you want. I'm down for that instead of waiting for Matthew.
I mean, yeah. The crazy thing is, like, yes, I will, because when I enlist AI, when I've looked through Google before I used AI, I came across two formulas or calculations, and apparently there are two more, but all of them give you the same result. So whatever is talked about happening after the fact, I haven't found any examples of anyone needing to do anything on top of just calculating it the way that they did. So when
mute up.
We could go over you want me to go over this right now? The map that I have right here.
Yeah, I mean, if you want to continue, I was asking if you wanted to. I was going to address the guy that comes in here every now and again. He's a Mariner, but if you want to continue, bro, like.
All right, I'll run right through it. So let's say you have a plane at 39,000 feet. So this is a descent calculation we're going to use. Airport is 1,500 feet above mean sea level. So the pilot needs to be 1,000 feet above the airport, which means that if the airport is at 1,500 feet above mean sea level, the pilot needs to be at 2,500 feet at the end of descent above mean sea level, which is 1,500 feet above the airport. So that's 39,000 minus 2,500. That gives you 36,500 feet. So there's four calculations. I only have one here. And it's 36,500 multiplied by 3 will give us 109.5 nautical miles. You can convert that into statute miles. 109.5 times 1.1508, and that gives you 126.0126 statute miles. So that would give the adjacent length 126.0126 miles. So to get the descent angle, we change the statute miles to the feet to get the opposite, and that's 126 multiplied by 5,280. I forgot what. Do that for me. 126 multiplied by 5,280.
Is there a decimal there? 126 multiplied by 5,280 or 5.280?
No, just 5,280.
Okay, 126 multiplied by 5,280 is 665,280
feet that we're going to use. So the descent angle is 3 degrees, and that's all I got. That's how you get all that information. So it's like, at what point do we have to change either the angle or the adjacent length? What do we do to factor in this 1%? Like, how does that work? Where is that expressed?
So in their math, right, the opposite is not a straight line, it's a curve, right? That distance in miles, what's the distance in miles? 126?
126, yeah. 126.0126.
Right. So off, back of the napkin, off the top of my head, if 126,000 miles is the distance from, the ground position of the airplane and where the airport is on the ground, that's a drop over distance of 126 multiplied by 126 squared multiplied by 8, right? If we use the 8 inches per mile squared thing, right? So if we do that, 126 times 126 times 8, that's 127,008. Okay. So 127,008. This would be in inches. So if is it inches? Yeah, in inches. 8 miles, 8 inches per mile squared. Right. So if we divide that by 12, we get our feet. Okay. So it gives us a 10,584 foot drop over distance, which is about, divide that by, 5,280? That's about 2, so 2.0045. So that's 2.0045 miles, right? So there's an extra drop, in their math, there's an extra drop of 2.004 miles. Okay. So
that's my point right there is when they say there's an extra drop of 2 miles, that would most definitely change the length of the opposite, then, wouldn't it not?
No, if the opposite is fixed, this would have an effect on the angle, because it would mean that the angle of descent would either have to be lower, right, a little bit lower at the onset when the plane goes into its descent, or they're allowing for, the plane starts descending at this 3 degrees, but throughout its trajectory, it's adjusting, so it's going a little bit lower, a little bit higher, a little bit lower, than the perfect 3 degrees, right, in the ideal case. Right?
So integrate that over a straight line hypotenuse. Yeah, integrate it over a straight line hypotenuse versus a curve path with the constant reference frame rotating and not translating. So you need both of those overlaid with each other, and again get the error percentages, and then see if all of the forces and the machines are able to operate within those error percentages.
Right.
I still don't know how because when you say we just calculate for an arc, I mean, because if they come out and say that's not necessary, again, they're not saying anything other than.
Nope. They're saying they don't have proof it's arced, is what they're saying. That's all they're saying. They're saying, I believe it's arced, but I don't have proof it's arced because the functional way in which it's done, which is good enough for the intended purpose, it could be treated as a straight line. So if they say that, you then can prove that false by saying, no, it can't be treated as a straight line because here's why. Right? And you need those particulars. So if you come to, like if you came to my job site and says, no, you have to calculate this as a perfect arc, and I say, no, I don't. It's a waste of my time because I can just use a straight line, and in this building, I get the same result. I'm not going to waste my time. I'm not going to build a customer. I'm not going to, have people diddling their thumbs all day. I'm just going to do it with an assumed straight line.
But there's an issue, like, because we're saying we need 2 different data sets, how it will work on a globe plane and how it will work on a plane plane.
No. You don't. See, what I'm saying is you need two data sets to prove the exclusion. That's the problem. You're trying to prove an exclusion. And so without the second data set, you can't exclude it. It's that simple.
Well, it's interesting because someone said we always get into this area where the hypothetical that we never set out to prove anyway is something we can't disprove, and therefore we can't say that it's disproven. I don't get that.
No, you can. You can, though. You can prove exclusions. You can. The people who have rhetorically said you can't in the past who are flat earthers are retarded. Retroactively, I condemn them as retards for their statements. Officially.
Okay.
Yeah, and we can prove that the Earth is not.
Now, hold on, friends. A confession. I also condemn myself for, in those moments, reading the social cues of the room where such people were being praised and rather than critiqued, and I had the full opportunity to critique, but I chose not to critique because I didn't want to be I didn't want to have reprisal from the other peoples in the room telling me that the reasons I was critiquing were for unethical reasons rather than for meritorious argumentation reasons. So I apologize to the community for making that mistake.
I got you. I'm still struggling to understand if you have a linear distance and you have a vertical height and you have what degree of drop you're going to be doing over the land, whether it's changing a little bit, it's still working with the same baseline. I don't understand how
Let me use a building analogy. So the engineer makes the plans. He gives the builder the plans. The builder then executes the plans. Okay? The plans are never exactly what the building looks like. Never. We agree on that, correct? It's practically impossible to create a building exactly as the plans. As a matter of fact, many times when we reach a certain corner, when we reach an intersection of this is supposed to transition to that, it turns out that the engineer's plans are wrong, and we have to make it on-the-field correction from the plans. Now, check this out. If you looked at the engineer's plans, you would have no idea whether we had to make on-the-field corrections or not. The only way to know is to go to the actual building, which is why they have building site inspections. They have engineering plan inspections, right? Stamped by an engineer. Says, yes, I approve of your plans. But then you have a separate inspector go to the actual site to see if the building you built matched the plans that they approved. And when they see a discrepancy, you as the builder have to say, I fixed this for this reason. The inspector will then agree that your reason is valid and then stamp off on the building. Unless those two things are done, there's absolutely no way you can look at plans or math and tell me what the building actually is. It cannot be done.
I agree with you, and I get what you're saying. Now, correct me if I'm wrong. Isn't the plane taking that flight utilizing the planner's plans? And them being successful, like, okay, this is what you say the distance is. I get there. That's the distance. And so this other interjection of something else, like, another house or another building that wasn't in the plans, like, oh, well, let's put this set of data on top of that and then see. I don't get that.
I think it's like this. You draw in the plans, it says a perfectly horizontal floor on the x-axis, right? That's what all the plans say. There's no plans unless you're intending the floor to be curved or diagonal or sloped that come with a flat floor plan that's anything other than a graphic artist literally on a piece of paper drawing a actual straight line with a ruler. That's what they're going to draw. Now, in reality, right, that might not be the case. So they're going to say, I intend a straight floor that's perfectly level and horizontal, but the builder builds it a half-inch off at one end than the other. Now, over a significant enough distance, the half-inch raise is going to be relevant. So I'm not going to tear down the floor when I arrive to test if my guys built my floor level. I'm going to come in, I'm going to look at it, I'm going to say, okay, it's a half-inch out and 50 feet. No reason to change it. Just run it. Right?
I guess the rebuttal that I would have would be your point, which is, well, let's figure out what the pluses or minuses would be.
Right. So I know that I know from experience, right? Roughly, just by looking at the floor and how much it's out, that this is going to have a dramatic effect on the intended purpose of the plans, which is to build a house that you can live in that's not going to fall down. Okay, the intended purpose of a set of plans is not to build a perfectly symmetrical, a perfectly right-angled building. It's to build as close as possible to those goals that fit the intended purposes without violating safety or structural concerns. That's it.
So with that being the case, something being like the intention is to get something level. And the overall result is you can never really get something perfectly level. But we know level exists. If anybody could level something perfectly, it probably have to be the creator. All right. Okay. Anyway, that being the case, we're still talking about horizontal. So it's like, well, if the floor was, again, this goes to your point. If the floor was dramatically not straight, then it's like, okay, well, this is a point against my point.
Tear it up. I'd have to tear it up, right? Redo it or do something to it, right?
See, my thing is, and I'm still working it out. I don't see what the issue is, but I see what you're saying.
At any point in the plans, where what we physically executed in reality deviates from the plans enough that it becomes an issue for the next step. At that step, we have to change it. If we don't, we just run it and make corrections on the fly. You see what I've said there? If it doesn't match what's going on and we could correct it on the fly, right, we just go with it. We don't stop what we're doing and make major corrections. We just alter the next step a little bit to make up for the lack of consistency in the previous step. We never just shut it all down unless it's egregious. And that egregiousness could be A, judgment, or B, specs that we have to meet for safety guidelines.
See, and in that way, I would say, okay, if they're taking, ideally trigonometry, and they're saying, okay, based on this, this is what you have to do in order to get to the airport here from that distance. Any modifications that they have to make in between then doesn't change the fact that they're still working with that distance, though, right?
Okay.
Right.
Maybe not.
Right.
You can still plot it out and find out.
So, say
like
for example,
they might say, "Damn, I'm 200 feet off. I'm however whatever," but that would be still in the frame of this is a horizontal distance.
Yeah,
now,
fair enough. Let me ask you this question. Real quick. I'm driving somewhere right now. I'm driving on the right side of the road. What if I drove on the left side of the road? I'd be on the same road, but I'd be taking a greater distance path. But I would arrive at my destination within feet, right? So it wouldn't really matter to me whether I was on the left side or the right side. It'd be inconsequential and negligible. So the only reason I'm driving on the right side is because that's the law.
Would time also are you changing the time in any way? Because you got more distance, but are you changing the time?
Technically, yes. Technically, yes.
So
maybe this is why planes are never. Hey, Eli, maybe this is why planes are never on time, bro.
No, but pause right there. There's another calculation that includes time instead, but you still get the same result. So that would be accounted for in this idea that we're working with a horizontal frame of reference.
One issue here that kind of like what AI is saying, an example pertinent to what we're talking about here with the airplane. If it's available, it would be interesting to scrutinize an example or like an instance of a flight actually performing this descent over the over whatever 100 miles or something like that, Because, for example, if you look at the data and you see the airplane intended to, let's say there's the blueprint that we're modeling out with the horizontal plane and the triangle and all that stuff, and the plane intends to go down or descend at a 3-degree whatever, right? But the plane actually descends at 3.1 degrees for like half the distance, and then it goes up to 3 degrees and then down to 3.1 degrees, right? It's deviating from the intended course by a little bit, but over such a long distance, right? It may seem negligible to the passengers, right, for their safety, because the whole thing is about, not nosing down so fast and giving everybody like a freaking heart attack, right? But a 0.1 degree difference wouldn't do that, so to speak, right? So if you look at the data and you see that could account for a more sharper angle downwards, right, accounting for this extra drop that would have been needed. Like these types of things, we would need to have data to actually scrutinize,
I understand. I would, you. Let me.
No, hold on. That's not true.
Hold on.
Fly downwards.
Hold on. Let me introduce. Yeah, nobody said.
Fucking JJ. My God.
You're not even on the same side of the street, whoever that was. Anyway, so it's interesting because I was actually given an example of, well, if the terrain includes mountains and stuff, and they have to calculate for that, and there's whatever the case, storms, what have you, actually, they may have to, instead of, for example, 100 miles, it could be 200 miles. At that point, if I could find a piece of data that gets anywhere close to 200 miles.
Sure. Well, let's set the record straight from history. For some people who may not know. Is a lot of people get confused when they're doing this argument. It's because there was rhetoric going around flat earth circles that a plane would have to negotiate raw drop off of a horizontal from its initial position as it proceeds over the globe Earth, because they're mixing a straw man of radial vectors of down with straight grid line vectors of down, and then using that to critique the globe Earth argument erroneously. So the plane's reference frame of down would, if it was a globe, constantly be changing. So if you're not integrating that into the assumed path, you're not accurately addressing their point. And now that's fair if you don't want to do that, but don't pretend that you're accurately addressing what their view is. And again, I have to apologize to the community. There were times where I didn't speak up in the past when retarded flat earthers were making this claim and nobody were scrutinizing the retarded flat earther for making such a dumb claim and strawmanning the globe. And so I apologize. There you go. Keep going.
Now, see, in this case, or in what I'm saying is I'm not strawmanning anybody. I'm just talking about what is practically done. And there's no curved surface anywhere in there, as far as I could tell.
Right. So that's great. So I see. Here's the thing. I know for an absolute fact that I can treat a surface as if. I know that for a fact. I've done it many, many times. Surfaces that are not flat as if they're flat. I can do trigonometry on them. I can make it adhere to the plans. I can make it not actually level. I can make it not actually square. But then the result is still functionally the same. And if you didn't go with a precise, if you didn't go with a precise piece of measurement device, you wouldn't be able to tell that it actually wasn't correct. So I know that for a fact.
When you say flat, do you mean flat like as in as flat as something can be between two planes?
Sure, that could mean flat, or it could mean flat as a floor. Like, obviously a floor is going to be level.
Right, okay.
That's flat like a wall. So the same applies with walls, right?
The distance they're using is a line above the surface that's parallel with mean sea level, though. So it's like we know that the sea has undulations in it. That's not flat. That's not what I'm arguing. We know that as you come in to the land, that the elevation is going to rise. We know that. So it's not really about how flat something can appear and doing trigonometry on it. It's about this distance over the surface is this linear distance, and it's matching the ground. So regardless of undulation, this line is matching up with this area of land. But this line is this line isn't real, other than the fact that it's the distance, a horizontal distance that's parallel with mean sea level.
Yeah, you said it yourself. The line isn't real.
Right.
So how are we going to bring it into reality to tangibly access whether or not that line is actually parallel to a horizontal, which is straight, or a concentric curve around another curve?
Because the plane is traveling the distance and getting to the destination. Now, this is where I guess the contention is, well, what would it be if they, calculated for an arc or this or that? And my only rebuttal has been, but are they doing that though? I don't have any evidence of them doing that.
Why would they have to?
We would need to. Yeah. We would have to have it to scrutinize it.
Right, but why would they need to? So when we looked at the subsystems of the gyro the other day, it said that the rotational it said the rotational vector is so negligible that the systems treat it as a static reference shift rather than a dynamic rotation. So if all of their systems are geared towards ignoring the dynamic rotation because it's negligible, to then say that they would have to have this data, I mean, it doesn't even make sense.
No,
that doesn't mean it doesn't exist.
I'm not saying they would have. No, I'm not saying what. All right, let me go back on if I said they would have to. That is all irrelevant to the trigonometry that they do in the beginning. So you can't even, a Glober can't even make this argument of, well, it could be rotationally this, that, and the third. That has nothing to do with the trigonometry in the beginning or the end. It's a totally separate thing.
Okay.
And that's the practical part. That's what the plane is. The plane, okay, based on my elevation, this is what degree I would have to be to get to the end of this adjacent to whatever line that is. The what is it?
The opposite. The end of the opposite.
That's it.
That's cool. That's great. So once you have all this in the form of you actually plotted it, right, on an actual topographical profile with the distances and the altitudes and the pitch angle at each moment in time as it's approaching, right, then you'd have a really compelling case, if not a definitive case, to which the Globers would also, and it's irrelevant whether the Globers argue back or not. You could be satisfied with, I made my case and I rest my case. Let the jury decide. But if the Glober says to the witness, hey, there's this wiggle room of exclusion that he didn't account for, and here's the numbers, and then the jury's convinced and they say, oh, well, yeah, those numbers actually have sufficient wiggle room so that if it was taking a path of a large arc or straight line, it'd be functionally equivalent. And so then the jury would acquit. So if you care about compelling the jury, you might need an additional piece of exclusionary evidence, right?
I see what you're saying. Yeah, I guess I'm not. I guess I'm not convinced because Matthew didn't come forth with as far as I've seen him do. He's tried to extend the length of the adjacent.
I'm saying you can be convinced. Here's my point. You can be convinced. You could have your theory of the crime and all the facts on your side. The defendant counsel could have a theory of the crime and only specious reasoning on their side. But because their reasoning is more compelling to the jury, so you have to ask yourself, at which stage is this sufficient to prove my case, and at which stage is this sufficient to compel someone who I'm trying to reason with that their position is false? Those are two different worlds. Would we agree?
Yeah, but that's what I was trying to agree with you before you cut me off. Because I'm saying, well, I'm not convinced because I've given the chance for people to do that and they haven't done it yet. That's all I'm saying.
Like so you're saying they're slacking. They're slacking, is what you're saying.
Yeah, that's why I said, okay, well, with Rise, okay, I'll do it with you because nobody else has done it with me. Matthew had maybe I should hit up Matthew and say, hey, let's go over this, or whoever. But
well, check this out. Check this out, Eli. Matthew has said numerous times that he doesn't care to test the Earth because he's already convinced it's a globe, and he doesn't think the test would change his mind about the reasons why he's convinced. Now, that may be what Matthew is. However, Matthew thinks that there's actual value in convincing people that what they're thinking is wrong. And so he should care about you and that you're in error and he has the skills to help you. So you should plead on his heartstrings to get his ass in gear.
Until such time, though, Eli, like I said before, let's work it out, okay? And let's get a. I think Matrix has like a quasi AutoCAD type program that's free or whatever. I'll hit him up, see if I can get something like that, and we'll plot the whole thing out. If you're available tonight, I don't know. You're on the East Coast, right?
Yeah, I'll be here. It's 2:38 right now.
Right, perfect. Okay, let's set out to sit down and work some of this shit out tonight. I'll be available after like 8:30 or something like that to do this. So if you're around, I'll try and get us set up there, and we'll do it.
No problem. Thanks, man.
We will figure it out.
He said 8 to 9, but is it Central, Pacific, or Eastern?
Eastern.
What's up, Alberiqua?
Hey, when I become king of the world, I'm going to make everybody change their time zones to the fractional of their exchange rate. So what's Canadian dollars worth right now?
$1.40.
Right.
Yo, do you know
you
if
have to inflate your time?
Go ahead.
40. No, I'm just making a stupid joke.
My bad.
It's around 70 cents.
I found out from some female lawyer on Facebook. He's like, if you use your credit card in another country, they're gonna ask you to convert it to your country's currency, and you can tell them no thanks, because if you agree to them doing that, they will take a percentage. But if you don't agree to them doing that, they don't take a percentage. Isn't that crazy?
I've used my credit card in Canada a handful of times over the years, and you don't have that option. If your card's denominated in USD, then they charge you. It's hundredths of a percent. It's just like 5 basis points or something. It's a very, very small transaction fee they add to it.
Okay. Thanks, Jay. Always good to hear from you.
Yeah, and good afternoon, sir. Hope you're doing well.
Yep.
That conversation that just ended, I was kind of there for the last little bit of it. That sounded like a decent conversation, though.
Yeah, we're going over pitch data, and I had realized yesterday that, the argument that I use about plane ascension and descension, I never tied that into pitch data because I don't know. I omitted it from my memory because I would hear Brian go pitch data, and I did in my mind I'm like blah 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 blah. But then when I heard him talk about ascent and descent one time, I just latched onto that. And I became a Google warrior, and I looked into it as much as I could, and I was like, yo, this is flat earth proof right here. But I kind of like separated it from pitch data anything. But the truth of the matter is the ascension of the flight is on that graph. And the process that goes into that is represented on that graph. So it's like, if you're going to say that this process right here was, a simplified trigonometrically functioning thing, and at the same time, when a plane is flying level, there's still some sort of I can't even say rotating frame of reference because we just discovered that that's not what it is. So I don't even know where the fuck I'm at anymore, JE. To be honest,
Dude, that's why this exercise, Big Daddy, that's why this exercise is going to be beneficial not only to you, but to other flat earthers, to globers, and to other people who have already made up their minds about the particulars of how these things work. And some of them may have to eat crow about the claims they made or update their thing, because you're going to the way this would actually work is that you get all the data and you start plotting it on a chart, right? Making it congruent with a flat horizontal baseline, right? And then also doing the exclusions where you put the tolerance of a curve against it, right? And you match all these data points together. And then you have a integrated model of those two data points. And then when a glober says it's in the exclusionary data, you can say, no, it isn't, because I've already charted it, and here it is. So you don't have to talk about it. You don't have to use rhetoric. You can use demonstrated plot points and show, here, see this plot, see this time, see this data. Here it is from this plane. Here it is from this airport, right? And then both flat earthers and globers alike will actually have a constructed piece of work that they could reference for their points or arguments from now on. And then that's going to be good for everybody.
Agreed.
And that doesn't mean you have to do all the work, by the way. You and Homeboy might just do certain math and get certain plot points. Someone else may say, hey, look, I've got this chart from the airport about the incoming topographical data. We could chart it against this chart. And then, you slowly build it up. Like the moral of that story is you don't have to wait till it's absolutely perfect before you share it with other people. And even if you finish it and say, okay, I'm done, and this is definitive, and then someone comes and corrects something, you can update it, right?
Yes. So where's the map?
Say, because something's like really grinding my gears about this. So it's not about I mean, I guess you having more of a working knowledge of building than me. It grinds my gears because it's like, well, we're talking about a triangle with known measured values, like, and then it's like, well, let's do something to manipulate this to see how it would work if there was an arc path. It's like, I mean, I understand it's nice to be like, look, I did this, and look, see, this doesn't make sense, or, well, lo and behold, I guess there's no difference really. But the fact that they're using trigonometry, I mean, especially,
check it out, dude. Check this out real quick. You said known measured values. Okay. How does the plane know where it is relative to those known measured values?
Well, the altitude is measured in pressure, right?
Okay. So that's one point.
Because gravity creates a pressure gradient in which there's more of it.
Yeah, we agree. Yeah, I agree with you. That proves the Earth is flat. Good job.
No, it doesn't. That actually proves it's not.
Yeah, it does. No, it proves that there's a striation that's organized up and down versus the perpendicular horizontal, which is parallel to the surface of the Earth, which is flat. So you just proved the Earth is flat. Good job. Gravity's irrelevant to this point. Gravity's irrelevant. Nobody cares about the gradient. Hey, JJ, I know it's hard for you to comprehend. Nobody cares about the gradient. It's not whether there's a gradient or not. It's whether that gradient is curved. Those are two different things.
No, but how do you think we measure air elevation using air pressure? Because we're measuring the gradient.
Hey, watch. Hey, guys, everybody watch how this person completely ignored what I said.
No.
Wow, that was great.
No,
good job.
The reason we know how high we are in an airplane is because gravity pulls air downwards. So we can measure.
The Earth is flat. I agree with you. The Earth is flat. Good job. You're a flat earther. Welcome to the team.
No, it is not.
Yeah, welcome to Flat Earth Gravity.
I know.
Okay, so
look at this guy. Look at this guy. He doesn't even know that the argument is about whether the gradient is curved, not whether it exists.
We got a flat earther who believes in gravity now.
Yeah, flat Earth gravity. I dropped something and it falls. Okay.
We're making progress.
Yeah, I dropped something and it falls. So what? It doesn't fall anywhere.
Yeah, but
no. Why does it fall downward? Why does it fall downward?
Because down is perpendicular to horizontal, which is the flat topography orientation of the Earth.
So is up. Why doesn't it fall upwards?
Because the Earth, which is flat, is below it. There you go.
No, but
Flat
why
Earth
doesn't
has
it fall
gravity,
upwards?
dude.
Yes.
Hey, listen, flat Earth
Why
has
does
gravity.
it fall
How about
towards
that?
the Earth? Why does it go
Flat
towards
Earth
the
has
Earth?
gravity. What's wrong with you? Flat Earth has gravity.
Okay.
Yeah, listen,
Okay, good.
JJ
So
Fish,
we
in
all
case you
agree
didn't
that
know what we
gravity
just did
exists
there, hey, JJ
on
Fish,
Earth.
JJ Fish.
I'm so happy
JJ
it
Fish.
took so
What we
long for
just
someone
did for
to
you,
admit gravity
yeah,
exists.
irrelevant. We
It's
just
not
proved to you
irrelevant because we're
that
on
your claim is irrelevant because you're so dumb you didn't realize we're talking about whether the gradient is curved, not whether it exists. That's how dumb you are.
No, a gradient for pressure doesn't have a shape. And it's
I
a
just
gradient.
Thanks for playing. Good job. Good job. Holy crap.
let
A gas pressure gradient means that gas pressure
Hold on,
changes
JJ.
relative
We
to
agree with
how
you.
high you are.
Perfect. Good job.
Because
No, hold on, brothers. Hold on. Listen. Big Flurf's going to go and respond to what JJ said, and then AK, you can get in, so you're not trying to talk and mutter through people. Okay?
Awesome. Thanks.
So you just listen. It wouldn't be a straw man to say that the atmosphere is supposed to be in curved stratifications. Is that the correct way of saying it?
All right.
So
to clarify,
so the whole point is, for him to say that there's no shape is ridiculous because they're literally claiming a shape. Like we just had someone come in here and argue about the shape of the air that the plane is traveling. So the question is that curved or is that not the case? That's what we're arguing, not whether or not there's a gradient.
All right, listen, AK, pay attention. You're going to go, and then we're going to unmute JJ Fish so they can respond to what was just said. Go ahead.
Yeah, just a quick clarification. Gradients are vector sizes, so they're straight by definition. Vectors are just straight by definition. That's how they work. And what you mean with the gradient being curved is probably the equipotential that where the gradient is formed from. In this case, the pressure gradient, the plane of equipotential being curved or not. So on a globe, a plane of equipotential air pressure or equipotential gravitation would form an ellipsoid, a geoid, or it would form form around the globe. And on a flat Earth, it would be a flat plane.
All right, perfect. So then the contention point you'd agree is whether or not those bands of stratification are actually curved or not curved, right, AK? Before we open it up for JJ?
Yes, exactly. That is the,
all right, perfect,
the point of
So that's the point of contention, right? Okay, great. So let's see JJ respond to that. All right, now hopefully you guys took it there that we're gonna control the tempo of the conversation so everyone gets to make their point rather than talk through each other. For the love of God, go ahead.
Sorry, I wasn't contesting to the premise or like the actual dispute you guys are having over like light curves through refraction. That wasn't my point. I was simply just saying that the only reason we know how high planes are, because we said, how do you know how high the plane is because the gradient of gas pressure, which is what we would see with gravity and not a one container, because there is that gradient.
That's the thing you interrupted. That's the thing you interrupted Elijah to say. I'd really rather hear what Elijah had to say than your interruption.
That's all I had to say, which is that you can't know how high you are.
Okay, shut up now. Can we hear what Elijah had to say before you interrupted him?
Gradient.
And we went through all this shit.
Let me hold on real quick. So I know how they have the height. I'm murky on how they have the distance. I know I've read it. I glanced over it. Give me a second.
All right. In the meantime,
oh shit. In the meantime, what?
Oh, I didn't think you would be that quick. Sorry.
AK, he yielded to you. For the love of God, take advantage of it.
All right, sorry. So the argument that we wouldn't be knowing how high we are without gravitation is wrong, because that's an argument from ignorance. Just because you can't imagine why the atmosphere would stratify and form a pressure gradient like that over flat Earth doesn't mean that it has to be wrong.
Sure, but it does. I mean, actually, it does contradict the laws of physics. Like everyone, like the flat earthers correctly described the laws of physics with the containers and the boxes. Gas should spread out equally, but that's not what we see.
Yes, if there was nothing.
No, we don't say equally. We just say fills available volume. Rarely does anyone ever say equally.
But it doesn't. Only the Globers say that in the form of a straw man, dude.
Not perfectly equally, but they should distribute out around the entire thing, not cluster in one side, one wall. Have one vector force pushing them all in one direction.
Okay, great. You're still not answering the question of whether that is overall curved or not. As AK pointed out, it wouldn't matter. So good job.
It does matter because the laws of physics demand that if we are on a flat plane and we are in a container, there would be nothing bringing them down. There would be no downwards vector.
Wow, dude! Holy crap! I can't believe you said that. Holy crap, dude! You failed.
It's called gravity. It's called gravity. What's wrong with gravity?
Yes. Okay, because gravity from the flat earthers is not a thing. They don't think that gravity mass attracts other masses.
Oh my goodness, dude! Listen, do you think? Let me ask you this question, Brenda. Before you go on, just a question, Brenda. You can answer this question. Do you think flat earthers believe that things that are more dense don't go down? Is that what you think they mean when they say, I don't quote unquote believe in gravity, according to you? Do you honestly think that's what they're saying, for goodness sakes?
No, they're saying the reason things go downwards. They don't believe that they don't know. From my understanding, they don't have a good explanation of why things go down. Do you?
Doesn't matter. You don't need an explanation for why they go down if they're more dense than their surrounding medium to witness that occurs. Holy crap.
No. But
holy crap. What is this, amateur hour? Is this amateur hour, bro?
No, but that's the issue. So you'll say, oh, we agree things go down, but you don't agree with the idea or the concept of gravity because that would contradict the idea that that's what.
No. You're wrong. We agree with the phenomenon. We don't agree. Hold on, friend. We agree with the phenomena that I already described. What we don't agree with is your causal claim that this is caused by a giant ball. How hard is this for you to grasp?
All right.
Okay, so then hold on. If you agree with the phenomenon, though, why do you think it's going down? And how do you think we derived 9.82?
Doesn't matter. It doesn't matter, dude. You are literally distracting. No, hold on. I'll explain it to you. Okay, check it out. If you think that that's happening because the Earth is giant and curved, and flat earthers say, no, the Earth is not curved, then the actual argument is whether the Earth is curved. Yeah, it's Ed Masto, as usual.
Open mic. Right.
So go ahead.
You've got the proposition wrong. We don't claim that things go down as gravity. That's not the claim. You get that?
Yeah, JJ is actually getting confused.
No, I have
the claim.
Hold on.
And you don't have an answer to it. I also made a claim.
What the fuck, bro?
That's a straw man.
Excuse me. So that's not your claim, Brenda, and that's not ours either. So why is it relevant?
What the issue is that our experience of gravity, our understanding of it, our calculations of it, our measurements of it, everything, our laws of physics don't contort with a flat Earth view. They confirm a globe time and time again, and the altitude altimetry altimeter thing is just more evidence of it. Like, you can't explain. It's just more things you can't explain. The stratification of the gradient of gas pressure. It's like Listen, you got to start looking things up.
JJ, that's an argument from ignorance, though. Like, not having an explanation for something doesn't mean that opposing a different explanation is wrong.
What's the different explanation?
It's not just that you don't. It's not just not having an explanation, because I don't have an explanation. Scientists don't have explanations for many leading questions in physics and in the universe. It's that it don't seem to, in fact, explicitly say it doesn't matter. Who cares? So questions that are actually seemingly relevant and probably important, you just are willfully ignoring, willfully not looking into, willfully pretending like you don't care about, because they contradict and would unravel and don't make sense with the worldview that the Earth
it's
is flat.
independent of that, bro. You can be a glober and disagree with the current rhetoric about gravity.
You can have disagreements with certain rhetoric and certain models, but the idea that it is a thing, that the current model of gravity is true, that we are being pulled down from the center, like the Earth's mass.
Yes, there's globers that disagree with that. Wow, shocker!
No,
right?
no.
But what disagrees with the edges of gravity are happening on a technical level where they don't disagree with the fundamental premise that we are on a round Earth being pulled down by a force that relates to the mass.
Yes, there are globers who disagree with that rhetoric.
Okay, well then send me the most prominent globers who
Michio Kaku,
scientists or physicists who
Michio Kaku.
No, he doesn't. He doesn't.
Michio Kaku is no.
Michio Kaku does not reject gravity.
He rejects the notion that it's a pull to the center of the Earth.
No, but
I love how you guys. I love how you guys. Hey, chill out. I love how you guys just use the word gravity. Check this out, friends. I love how you guys just use the word gravity as if everybody means the same thing when they say that word. For the love of God, learn how to parse out your particulars. Holy crap!
Well, it's based on a shared understanding, right? So sometimes people mean general relativity, and sometimes they mean classical gravity.
Yeah, but we were talking about what he was saying.
True. This is true.
Not about general relativity, was we?
No, but this is true. Like we were talking about when we say things go down because there's a relationship between the mass of objects in space and the attraction. Flat earthers generally don't believe that. And they actually are hostile to the word gravity itself.
Yeah, they don't have a substitute explanation.
Who cares?
For why we have
whether the Earth is flat or not.
Who cares? Well, they care enough to go
independent of whether the Earth is flat or not, bro.
I do have a substitute explanation. I actually have a substitute and explanation, and it actually works perfectly. You want to hear it? It's called transmutation hyperplane omnidimensional retroactive Famicom. There you go.
Yeah,
Can you write that down?
You're gonna have to post that in the chat. I did not even hear the last word.
Let me tell you. I know listen. If my we call it PNR for short. If my PNR is correct, then we would experience that when we drop something in a medium and it's more dense than the medium, it would travel towards the Earth. I do see something that is more dense than the medium travel towards the Earth. Therefore, PNR is correct. I rest my case.
That's affirming the consequence.
What is PNR?
It's circular reasoning. It's circular reasoning. Good job, Brenda. You recognized your own error. Good job.
Please post this thing that you believe. Post this thing, the substitute that you think is more believable.
He was just illustrating.
Then you can just look. How do you derive down? Basic
he's
question.
not getting it. He was just illustrating how the idea of gravity came to be, and that it's in essence circular reasoning. JJ, I wanted to circle back real quick to your ultimate major argument. Like the reason why you wanted to point it out is cohesive, right? It's sound, but the thing that you were using in order to make your point was the wrong thing, because it was the altimeter was not actually having any different readings between if the Earth were flat and if it was a globe. So
an altimeter is not measuring shape of the Earth; it's measuring air pressure.
Altimeter. altimeter.
Yeah.
Exactly. And on a flat Earth, we don't know exactly why the air stratifies, but if it did stratify that way, then it would do the same thing and read the same way that it does on a globe. So there's no difference there. So you can't use it in order to point out how the flat Earth can function in reality.
No, because the laws.
No.
But my point goes to something deeper, which is whether or not we are in a box container or whether or not we're on a planet that is, orbiting in space, pulling things.
All that is irrelevant to the ability to exploit what actually is. There's no reason why you need to understand why it is or how it is in order to exploit that it is.
Yeah, but we
it doesn't make any sense.
Why and how things
that's
are.
Just gibberish.
That's like when you mastered something so much that you can exploit it in ways where you can turn one chemical into another.
So I can't exploit little g.
Then yeah,
so I can't exploit little g unless I know fundamentally why little g is.
Like if I say, I can exploit plants, but I can never truly answer the questions of why is the sun or water good for a plant. You can. It's called a microscope. Like we can answer, and we have these questions.
Yep.
And the fact that you are willfully ignorant,
for thousands of freaking years that didn't understand photosynthesis.
That they collapse, that you cannot comprehend them, given the flat Earth worldview, because they just cannot fit with it. Like our experience of reality does not fit with a flat Earth worldview, which is why you constantly hear stuff like, "Who cares? I don't care why I see what I see. It's not important. I don't care." Like, it does matter. Don't look up. Like, really?
Yeah.
Come on.
It's just copium. It's copium. Right? So the claim is not that things go down. Right? That's not the claim. The claim is that classically mass attracts mass. That's the claim. Answer that. You have no answer because you have nothing to replace it with.
Okay. To be fair, though, personally verifying or validating that mass appears to attract mass is very difficult, and the effect is claimed to be very, very, very minuscule compared to the mass that compared to the masses that we typically can interact with and manipulate. So it is reasonable how someone can question the validity of that, given that they can't directly, easily test them and test it and verify it themselves.
Actually, you can send things. You can send things, and you can go upwards and see what happens. You can do tests like detecting gravitational waves. Sorry.
Icefish. Thousands of students do this every year as undergraduate physics students, right? They do the experiment, right? It's a common experiment. You know what it is. It's the Cavendish, and they verify that mass attracts mass.
But we also have to acknowledge the fact that on that scale, and that on that sensitivity, our experience, our physical experience, should actually be governed by electromagnetic forces and not by gravitational forces, even if gravitation is something that does actually occur in reality. I still can understand how someone. All I'm saying is I can understand how someone can question it and how it can be a topic of conversation that this is not universally accepted as a fact by the sheer volume of validation and implication that it has. So given that this is in question, the flat Earth and the globe are not actually in conflict with each other with the air above it.
They're fundamentally
experience a downward force for whatever reason on the globe. It would be gravitation, which would directly imply that a chunk of dirt that big would collapse into a sphere. On a flat Earth, it must be another reason.
Icefish is correct.
Hold on, we can quickly just confirm, just some more evidence that what you just said is accurate. With gravity's true, things should just collapse into balls in a vacuum. So I implore you to look up at the moon and other planets and notice what the shape of almost everything you see in space is. Balls.
Yeah, that's a genetic fallacy.
That's not a genetic.
Listen, JJ.
But it's not.
What would you expect in a vacuum? And you're correct. It would be a bunch of balls.
JJ, we know at night.
We see balls.
Yeah, we know. Listen, we agree with you that when you go to bed at night and look up, you see balls. We agree.
No, very fucking telescope. Have you ever looked at the moon?
In your claim, it's not. In your claim, it's not gravity. In your paradigm, it's not gravity that is forming
It is
those
gravity.
things. Just try to listen and let me finish. It's not gravity that is making those things into balls. If you just use gravity, so everything will attract every piece, and it won't make a ball. It will make different shapes, but it's
True. That's why you have asteroid belts and stuff
oh
like
my
that.
God!
Planets
They
are
are
like
shaped. They are shaped as balls, they claim, because they are spinning at a specific rate. For example, and the shape is for the ball shape, it's different because of the speed of that spin. Like, for example, if the Earth is spinning faster, it won't be an oblate sphere, but it will be flatter than that. So it's
That's
because
still not
No, I agree. Yeah, nothing. No, I'm not saying everything's a perfect sphere. There's other factors.
If you just put gravity and those objects going into the edge of space because of that explosion of the Big Bang, it will form droplets.
Big Bang was not an explosion.
Like
it was
tear
not,
shapes.
Necros, the Big Bang was not an explosion.
The Big Bang, that is not an explosion. That sent things at max speeds toward the edge of the universe. So those things won't form a spheroid or a sphere. But
what are you talking about? You've lost the thread, dude. Right?
It's more like a big blow.
Why is the sun, moon, Mars, Venus, Jupiter, Saturn? Why are they all spheres?
I'll answer it. I'm
looking forward to it.
No, hold on. I'll answer it. It's a very simple answer. So, the reason why things that are not the Earth are something that what they are is because they're not the Earth. I rest my case.
Yeah. No, maybe you should let the
literally.
Maybe you should let
Can you one time take the question seriously and give an explanation?
You're just asking why You're asking why reality is the way it is. You're trying to be God. You're saying, well, this rock why does it fall?
So what?
All right. So who decides the borders of what we should investigate scientifically?
So we do.
Why do you investigate space balls scientifically?
At which point does scientific investigation, is deduction not a viable tool or a good tool to investigate reality anymore? Is it your personal boundary? How high you've been? Is it the technical boundaries? How do you know the technical boundaries?
It's not. We can investigate. Deduction. It's not even logical deduction. It's like someone seeing an orange and deducing that the orange tree must be also shaped like the orange. So why you see oranges
that's not analogous.
The orange, that's what you are doing. You are sitting on an orange tree. You see oranges.
The logic is analogous. That's actually what you were doing.
They're not different. They're not.
What they're saying is like you questioning why do oranges exist the way they do? What's the difference between orange and lemon? It's like they're just very clearly different, and there's no way to know why that is and where this difference comes from because they are just those two objects, and all you can experience is those two objects, and you can't look any deeper into it. But then someone comes along and invents a microscope. So with that kind of mentality, nobody would have had any reason to have telescopes, to have microscopes, to like invent like leather or fake leather or whatever else. Like there would be no progress with that kind of mindset.
That's correct.
What you were given in nature is what God intended, and that's all there is.
Right, that's correct. Flat Earth is the death of the mind, the death of inquiry, the death of science. It stultifies.
Is that why you spend so much time in here?
It stultifies scientific inquiry and makes everything into just ad hoc rationalizations that make no sense at all and only serve to support a fundamentalist, literalist interpretation of a holy book. That's all.
So why do you hang out in here with us so much if it's so detrimental to your mind?
Cry harder.
Next time service. Public service.
There we go. Quiet. Peace and quiet. I like that. Right?
You could also log off if we're so detrimental. Have peace and quiet that way.
Yeah, because you spread lies that deceive people, right, and destroy lives.
Well, they're not going to shut us up. So why are you here?
They destroy marriages.
Yeah,
they
why are you here if you're not going to make us shut up? Why are you here?
Because it's lies. It's based on lies.
Minds. Okay, so Master Yoda, there's a couple reasons why someone that fundamentally thinks this community is toxic and
well, why don't you ask them what they think instead of try to read Brenda's mind? Good luck with that.
No, I'm not trying to read Brenda's mind. I'm trying to give you a more holistic couple of reasons why someone would do that.
I wasn't talking to you.
Okay, but you were asking when. Okay, sorry.
Yeah, I wasn't talking to you.
Okay, sorry.
Have a white night.
Now you're talking to me though, right?
All right, listen. We've steered away from the topic into personal commentary. All right, let's get it back to the topic.
Topic was?
Yeah, I don't know. You ask your question, AK.
How does the horizon work on a flat Earth?
Well, it gets up really early in the morning, and then it does its work all day, and then at night it goes away. There you go.
Okay, Overlord, can you take any question seriously at any point and give a factual
No. You said, how does it work? You said, how does it work? So I'm describing work.
Yeah, okay. Okay. The horizon is not a person, and you personified it.
Okay.
So you did not take my question seriously, because when you ask how does something work, not someone, something.
No.
Then you're asking about the mechanisms and the inner explanations of that thing, and not about personifying that thing.
AK. The problem is your question was incoherent. Because the term work is incoherent to be applied to a horizon. Horizons don't do any work, okay? So rephrase your question.
Okay, again, when you're asking about how something works, then you're asking about the mechanism, and then you're asking for an explanation of the mechanism of that thing.
Okay, perfect. So let's work on it. What's a horizon?
The horizon is how far we can see. The characteristics of the horizon that I wish to have explained is
no, dude. Wait a minute, dude. You're making up your own definition here. So are you talking about are you talking about a vision horizon, or are you talking about the horizon of the Earth? Why do I have to do the work for you to explain what you mean?
Horizon of the Earth. Okay.
Oh, the Earth. Okay, so you're talking about the horizon of the Earth, right?
Well. It's
yes or no. It's very simple. Holy crap! It's just yes. I'm talking about the horizon of the Earth. There you go. Correct.
Depends, because that's still a vision horizon.
Now, so now it depends. See how weird that was.
Overlord, you mentioned a vision horizon. You acted like there's different horizons. Okay, you acted like you didn't know what I was talking about with the term.
Horizon comes from point of reference. It is where the sky meets the ground relative to your point of reference. So horizon of the Earth is a nonsense.
Right. So JJ, we're trying to teach AK how to actually make proper claims. Okay. So he then changed his tune to it depends. So I want him to say what he means by the horizon. Okay. His definition, not yours, JJ. So he can pick his definition or the definition, and whichever context it applies, then let me know what he means by it. Okay, you don't know what he means by it at this point in time yet, JJ. So let's see if he can tell me. All right, go ahead, AK.
Oh, okay, cool. You unmuted me. Okay, so I mean the extent of our vision, or how far we can see, given clear and free view on the Earth.
There's no such thing as clear and free view on the Earth unless you remove the air.
Let's say the turbidity of the air is very low. So there's no discernible.
Okay, so if that were true, if that was the case, and you just took the standard air model of the distribution, right, and you put it through the Rayleigh extinction coefficient, that would make the maximum visibility approximately 350 miles. So are you talking about 350 miles away from me? Is that what you're talking about?
That's not what I'm observing day to day. typically the horizon is very, very much closer, even though it does not appear to be caused by the turbidity of the air.
Yeah, but that's fair enough. Fair enough. But you told me it's the limit of how far I can see. So for example, let me give you an example. Let me give you an example. Hey, shut up. Let me give you an example. Thanks. Let me give you a physical. Dude, if every time I talk, you say sorry, I'm just muting your dumb ass. Okay, we're not playing that game. Okay, listen, AK, I'm going to make it clear for you. I get to speak when I want to by acquiescence or force. You pick. So I'm just going to give you an example, then you can reply. Likewise, where I live, sometimes it's very foggy, and I can't even see from the one end of the road to the other or the mountain range. So if it's as far as I can see, then that means that the horizon is changing from day to day. So is that the horizon you're talking about? Go ahead.
Took you some time to unmute me. So yeah, I just remembered the definitions. Sorry, I was a little bit. Didn't have this conversation in some time. What I mean with the horizon is where the sky appears to meet the ground, the line where the sky appears to meet the ground, and obviously
you want to know how that line works. You want to know how that line works? Is that what you're saying?
Why that line? Okay, so I'm interested in 3 characteristics of that line. Given free view, so you're like at a higher point. There's like the area around you is lower in elevation than you are. Generally speaking, you're not inside a house, a room, or something that would obstruct your view outside, or in a street surrounded by buildings, obviously, right? Also, we're not talking about foggy days where you can barely see beyond your hand or anything like that. We're talking about conditions where the air appears clear. So in those conditions, I know I have personally observed 3 characteristics of that line that make me wonder, why does this happen? Right? The first one is, that line appears to get further and further away the higher I am compared to my surrounding area.
Okay, what about it tells you it's further away?
Just the locations that I can see. The locations that I can see and the locations I cannot see anymore.
Okay, so what you meant to say was objects between me and that line, all of a sudden I can see them, and so I'm assuming that line must be further than those objects, right?
Yes, because if it was not further, it was closer than those objects, then that is where the sky appears to meet the ground, and then above the ground, when the line where the sky appears to meet the ground is where the sky cuts off the ground, right? That's how that line forms. Like,
whoa,
that's what that line.
That's where the sky. Means. How can the sky cut off the ground? That makes no sense.
Yeah, the line where the sky appears to meet the ground. The meaning of that sentence is that above that line is sky and below that line is ground. That's how that line is perceived. How you can talk about that line as a perception in the first place. Does that make sense?
Well, what do you mean by below that line is ground?
Okay, so what does the sentence, the line where the sky appears to meet the ground, mean?
No, I didn't ask you that. I said, what do you mean by the ground is below that line? Like, what do you mean?
The ground.
Yeah, I asked you.
The ground. I mean the anything on Earth, anything like the area around me, locations on Earth, the ground,
water, maybe water,
surface
too.
of water, for example, as well. Exactly.
Okay, so I've witnessed where I'm looking out across water, and at first glance, it appears that the color field of the sky, being a light blue, is down in my field of view to approximately the middle, and then it looks like below that line is a darker blue, which is the water. And so I look and I say, okay, that's the horizon. That's where the quote unquote water is below. But then I see an animal jump out of the sky in behind that line or above that line, depending on how you're looking at it from a 2D plane. And then I know there's actually more water beyond that line.
Yes, of
So
course
if you
there's
were to
more
say the
water beyond
ground,
this. Of
it's
course,
below that.
of course there's many more locations on Earth than you can see at any one time.
Oh, holy crap, dude. You take your medication today, brother? It's okay, dude.
Did you?
Calm down.
Hey, let's take it together. Come over.
Hey, man, it sounds like a
yours,
party.
I need mine.
Anyway. Pay attention. So you said the water, pay attention. You said the water itself. AK, we're not playing this game, dude.
You're playing games too, dude.
Okay,
don't tell me that you don't know what is typically meant with a horizon.
I don't care, dude. I'm going to ask my question in completion, and then you can respond to it. You can't respond to it until it's asked. So you said the ground or the water is below that line. I told you that I can actually witness and see for a fact that there's actually physical water beyond that line. So did you mean the physical water has to be below that line, or did you mean it just looks like it is? So there's the question. Go ahead.
Me? Okay. If I didn't say exactly that, then I'm sorry. I have misspoken. I thought I said it appears below that. It appears below the line. The sky appears above the line, and the water or the ground appears below the line of the horizon. Does that make sense?
I agree with that. So, yeah, we agree on that. Sure.
Okay, so when you get higher in altitude, my observation is that the horizon, the line of the horizon, recedes further away from you, as by measure of the location you can see between you and the horizon line. That's how you can determine how far away the horizon appears.
Okay, well, I would change it, and I would say, as the higher you go, you can see more things between you and the horizon. I wouldn't categorize it that the horizon itself extended in distance per se.
No. It appears further away. That's exactly the same thing as you just said. It appears to be further away.
But I'm phrasing it in an entirely different reason for a purpose.
Okay, so the first thing is it appears to be further away. The second thing, it appears to be lower in the field of view as you increase the altitude. So if you were to measure the angle between, if you were to measure, let me explain it quick. If you were to measure the angle between, if you were to measure the angle between eye level and
shut up! You're fucking interrupting him.
All right. Not going on to a second point, dude.
No. It's not a second point. It's just I want a list of all the three characteristics that, in combination, all of them together.
Okay, listen. If you want to give off a bullet list, hey, pay attention, AK, pay attention. Hey, bro. You want to use our airtime to say your list? Then do it in efficient bullet point manner, and then we can go through this one by one.
No,
you haven't, dude.
Bro.
I tried to, and then you insist on rephrasing it and phrasing it in a complicated way and taking apart what I'm saying. I'm not making this long right now. You are.
All right. Okay. So here's what we'll do. You got 3 points. You got 3 points. Here's what you're gonna do. Name the points, then do a short exposition on the 3 points. Go ahead.
Okay. So the distance where the horizon appears. The apparent altitude angle, the altitude angle where the horizon appears, and the fact that it appears to be cutting things off from the bottom up. Even when details in the top are seen, the bigger structures in the bottom of things may be hidden by it. So those are the 3 characteristics.
All right, so you already told us your number 1 exposition, so move on to point number 2. Go ahead.
Okay, so with point number 2 is if you were to take any instrument with which you can determine where your eye level is and compare it to where the line of the horizon appears, you will notice that it will appear to get lower below eye level as you increase in altitude significantly. And the third one, as I said already, given that you can see an object that appears to be behind the horizon, when something appears behind the horizon, it typically means that you can see the top of a structure or an object and not the bottom. Even when smaller details are still visible in the top, a larger structure at the bottom may still be obscured by the horizon. On those three combinations, I have a hard time understanding why.
But on that last one, you say it seems to be obscured by the horizon, because if you said it was, you'd be just inferring and putting on a mental construct on what you actually see. Because what you actually see is you just...
It appears that way, yes.
Don't see but the fact of the matter is you just don't see the bottom, right? That's the fact of what you're seeing.
Yes, exactly.
Okay, perfect.
That's what it appears obstructed means.
Right. So your first one, that the horizon changes distance. Okay. Sure. So you're saying, how does that work, quote unquote? Yeah, it's easy. When you raise an altitude, the angular relationships of the propagation of the objects to you and the light changes. And equal altitudes are not equal angles, according to the law of triangles. So you'd have a different amount of information coming in at each angle that you can resolve. So it'd make perfect sense that as the higher you go, you can see more of a surface. So let's put that on the side for now. Secondly,
can I? Sorry,
no, it's my turn to do my list. It's my turn to do my list now. Right. So I'm going quick here. Secondly, you said that line drops an angle. Well, I already described to you that I can witness that line not actually be where the water is, and therefore if it was a different day, then it would be at a different spot in my field of view, and that's caused by the reflection of the sky on the water. And so I can't actually truly tell where the horizon is sometimes. Secondly, things being cut off from the bottom up. Yeah, sure. We witness that sometimes. Also, I'm on a lake right now. My feet are actually in the water. And there's a pier across the lake, and I come all throughout the year, and the boat across the lake disappears from the bottom up some days from the top down, some days sideways. The same with this rock over here. And this lake is very small, right? So I witnessed that. Yeah, sure. Now, I know for a fact that there's nothing in between me and the object over there, right? So when I look out there and I see it changing from day to day and time to time, my assumption is, based on all the three things I've just told you, that how the horizon works is optical effects. So that would be the category, and then maybe you could parse out the particulars. Go ahead.
Could I break in quickly? No, I'm on your side on this, okay? Because honestly, we have instruments out here where I work. I work by the offshore industry as an ERV vessel, which is basically an emergency response rescue vessel. Our radio systems also work with these exact same things when you say refractions, and wavelengths. They also work with, depending on weather, they can reach further, and depending on like current atmospheric conditions, it really depends on how far you can reach with VHF, depending on that, because VHF only fires in a direct line of sight. In comparison to such as MF and HF radios, which do reflect on the atmosphere above you, not the atmosphere, but the ozone. I can't remember the name of it, but yeah. So I can see what you mean, but also the same physics work regarding radios. That's all I had to say.
All right. Overlord, you misunderstood my question. My question is to have an understanding of the horizon line, including all of those three characteristics, not an ad hoc explanation for each one. And so for the first one you gave, I already have some issues. That is that the explanation you gave for there being more ground between you and the horizon, where the horizon line appears, when you get further up, is the compression angles, basically. So that, perspective, basically. that does not track for me, because if that were the reason for this to happen, then I should be able to make the horizon to reveal even more ground, depending on the magnification I'm using. When I'm using binoculars, I should reveal 20 times more ground between me and the
no, that's not true.
The horizon, because the angles have changed by a factor of 20.
No, they haven't. They haven't. Listen, pay attention real quick. The propagation angles from you to your lens haven't changed from the target to you.
That's true.
So, and the only way to increase,
the light know which angle it is to me?
Hold on real quick. The only way to increase any packet angles that are already coming in at a fixed propagation angle is to increase your aperture size, not just simply zooming in.
Okay. But increasing the aperture size would be zooming in.
No, zooming in is not functionally equivalent to increasing your aperture. It's not.
Yeah, but if I increase the aperture, I still don't make how much ground I have between me and the horizon line.
Because the propagation angles from the target haven't changed. The only way to change those angles is to change your angle to it by raising an amplitude.
Okay, and how do but just real quick excursus into vision here. When I'm viewing something, I'm seeing light that is basically scattered off or sent or emitted by something, right? Scattered off from something or emitted by that something. That's what I'm seeing in the end, right? That's the physical impulse. How does the light that is being scattered off or emitted at a target know which angle it is which it is relative to the ground, for example? How does the ground factor into that?
It doesn't know anything, dude.
Okay. Yeah, but how can that angle be relevant?
How does it know? Dude, you just asked me if the light doesn't know, how is it relevant? Are you kidding?
Yeah, how can the angle between me and a point basically change if I see that point?
I'll tell you what, bro. Did you watch the 8-minute optics videos that we told you to watch like 17 times by now?
I'm sure I did. I'm not sure which one.
Which those angles of propagation relative to the observer and showing what portions of the ground and objects would be within those packet angles. Like we've had that for years.
Sure, I'm sure I have seen it. I'm not sure which one you're referring to right now.
It's the one. Look, we have. I'll get it. I'll post it, and you'll be able to recognize it. Hold on.
I hope so.
I mean, you literally could just do this with a pen and paper, and it'd take you less than 10 minutes to figure it out. But this video is awesome because it's less than 10 minutes. All right, man. Hey, listen, I'm going to go on mute for a second so I can get that for you. But first, I got to put on my jacket because this lake is freezing.
All I can say is that right now on my horizon, I do have oil platforms physically within my eyesight right now. On every direction I look. Far away, close, very close.
Cool.
Yeah. Some of them we can speak with, some of them we can't speak with.
Okay.
Yeah. Why is that? Well, because there's a curve. Oh, of course there's. Because our VHF radios, when they're out of sight of their antennas, they just don't talk to each other. But if you go into a helicopter and you fly up from that platform, you can hear me clear as day when I speak in that radio. But the second you go down below that horizon, you can't hear me. Not at all. Not the slightest. And to be honest, that only proves your point right, AK.
I mean, I'm still like
radio length. Radio length is the same as light, just in the wavelengths that we can't see, and it's just the way that it's much more controlled.
Yeah,
you go on.
I mean, the same, like the explanation given for why things, why the bottom of things can't be seen when they appear beyond the horizon. It's also like it can't be just optical effect. It can't be just weather variations, right? Because I can have this effect together with the whole revealing more ground between me and the horizon as I increase in altitude together. And when I have recording observations and where I'm far removed from the ground, so I'm like at a cliff or actually more like in a mountain range, then and my observation line doesn't go close to the water or to the surface of some water or something, then I can get very, very, very consistent observations between a very wide range of weather occurrences. I mean, try thinking. He did this. He showed it. He proved it by going to this site near south of Blackpool, I think, and observed Blackpool Tower, and behind it Dow Craig. And he did that for hours on end on multiple different days where the weather was changing a lot in between. And we saw the tower flicker a little bit and the mountain flicker a little bit because they were far away.
Yeah, okay. And what do you do from that? Because I'm still confused. What is your point about that? What does that mean to you?
Okay, so Jim, I'm sorry if you missed the start of the conversation. I'm very confused by that because you were present for it. But yes, I'm trying to understand why the horizon occurs as it does, including combining the three characteristics at the same time, that it appears to lower compared to eye level as we go higher up in altitude, that things beyond the horizon appear to the bottom of things beyond the horizon is not seen, while smaller details at top are still seen, so it appears cut off by the horizon, and the fact that the horizon appears further away, the line of the horizon appears further away, the higher increase in altitude. Or, speaking another way, the horizon, there's more ground seen between you and where the horizon line appears as you increase in altitude. Those three characteristics combined together, and I don't understand why that happens.
Welcome to Flat Earth. Yeah, thank you very much. Well said. You took the words right out of my mouth. And remember, once you're above the Earth, the horizon, the sensation I get is that when in a hot air balloon, for example, as I'm going up, it appears that the horizon is rising with me. But I know that optical illusion and a phenomenon.
It's not even an optical illusion. It's actually it's an optical illusion because when you measure it, it appears lower.
And you're not allowing me to speak now.
Yeah, don't
what is this? I listened to your shit for the last 30 minutes and I asked one question. What does it mean to you? You explained everything. Now it's my turn. Can I do that? Thank you.
Sorry.
Shut up now. Right. When I'm finished, then you can speak. And what I was saying was this. As I was in the hot air balloon rising up, the horizon appears to be rising up with me due to the fact, as you said, as you go up, you are increasing your view, the expanse, because you're rising up. Okay? And then the horizon is always below you anyway, because you're above the Earth. It's just a sensation, which I call an optical illusion, because I know the horizon is below me. You know what I mean? Because I can see it. It's not dead on my eye level, no. But it appears to be rising up. You're seeing more of the land the higher up you go. And then with the ship going along the ocean, that the whole of the ship is there, even though the water might be obscuring it. The ship's not disappearing as you think. It's there. You're conflicting things. They're making it difficult for yourself to understand. It's not that difficult to understand. Welcome to the
I'm not thinking that the hole is not there anymore. I'm just saying that it appears cut off by the horizon.
Well, just be cut off by the water as well.
Yeah, the only observations, observations you're going to be able to show with ships and the ships appearing to disappear bottom up, right, is when you have ocean swells,
right, that probably aren't accounted for in many of these cherry-picked images of boats.
I'm not talking about ships.
I agree. Hold on. Let me finish talking. Let me finish talking, or I'll mute you. Simple as that. Okay, you asked a question, and you're getting an answer now. Okay, so we can replicate things disappearing bottom up over a flat surface just by manipulating the temperatures in the room. Okay, so there are refraction effects called sinking, for example, right, where something that is not geometrically obstructed appears to disappear behind a horizon, right? And it's not caused by physical obstruction, right? This is a mainstream explanation for why this can sometimes happen. Other than that, right, ocean swells are very, very common in the ocean, obviously. Okay, so every time that I've seen a ship or something else appearing to disappear bottom up behind a horizon, there has either been ocean swells, right, or there's been noticeable miraging effects, or it does fit the textbook definition of what sinking is.
Mm-hmm. Yeah, well, I have made multiple observations where that is not a suitable explanation.
Okay, let's present one then, and let's go over it. How did you account? How did you account for the things that I mentioned?
I'm sorry, I don't have it on my phone. I have it on my laptop. I'm not on my laptop right now, so I can't present it right now. And I'm also lost writing right now anyway, so I couldn't present it even if I had it
Well, just
on my
explain to me how you accounted for those potential explanations.
What do you mean? Which explain? Okay, there has not been any noticeable effect, miraging effects.
It's not a notice. It's not something. Okay, so what would you notice? Right, this is what you would notice according to the effect. Right, it's basically a very mild version of an inferior mirage. You're not going to notice
there has not been
a strong
inferior mirage.
Huh?
There has not been any inferior mirage. Sorry.
It's not an inferior mirage. It's a mild version of an inferior mirage. It doesn't have the total internal reflection. It's just something that would appear to be sinking behind the horizon, even though it's geometrically
I was just talking about miraging effects. I was getting to the rest. You are talking about sinking,
what
right?
JJ just posted, I'm talking about sinking. Do you need definitions? Do you need citations? And examples?
No, I don't. I'm well aware of what it means.
Okay, well, explain to me what it is and why it happens.
Exactly what you just said right now, actually. So sinking is when upward refraction occurs. So the upward refraction would lower the image of a target. Let's say target of a target to compared to its actual position, and that can lead to the lower end of the image of a target being obscured by the ground before that target, appearing obscured by the ground before the target, even if it actually isn't obscured physically on a straight line between the observer and the target. Now, sinking wasn't present because the atmospheric conditions for sinking weren't present. And
what are the conditions for sinking?
Conditions for sinking is that the density through the sight line, the density gradient is upward, basically. So higher density above lower density. Because light refracts to the denser medium.
Okay, so how did you validate that? That's correct. And how did you validate that that wasn't the case in the observation that you made?
Because my observation was through a great range of altitude differences and over great distance. So I took the data of multiple different radar stations along the sight line to confirm that the atmospheric conditions were very uniform throughout this.
No, that doesn't calculate the temperatures vertically along the entire way, right?
Oh, the weather stations were at different altitudes along the sideline as well.
Right. It's constantly changing. It's fluctuating consistently, right? So
yes.
You could absolutely
Also, the image was very stable. Also, there was very strong side wind present over a large area. Also, the observation wasn't happening close to a body of water or along the surface of the body of water,
but close to a body of water.
But rather through a lot of unobstructed air, in which. Yeah. In this case, the standard model of the standard atmosphere almost always applies very accurately, which has an downward density gradient. So the denser air is below the less dense air.
Yeah, but it's primarily controlled by temperature when we're talking about atmospheric refraction.
Over thousands of feet, the temperature lapse rate is also very very predictable. And plus, over thousands of feet, the main driver of the pressure of the pressure differences, and therefore the gradient, the density differences in the different air packets, are not driven by temperature anymore. They're driven by the pressure.
Still driven by temperature. We can have miraging effects up in mountains.
It's driven by over larger areas, over larger height altitude differences. It's driven by pressure. The pressure lapse rate is bigger. Causes a bigger change in density than the temperature lapse rate, which is why you have like roughly per 300 feet. You have about 1 degree Celsius, or what does this work out to? 5 Fahrenheit, the temperature lapse rate typically, and over the same location, obviously, and you have a pressure. You're lowering in pressure. So with lower temperature and the same pressure, you would expect a higher density. But what you experience over a couple of thousand feet is that the location at a couple of thousand feet always has a lower density of air than
you would have looming then, right? So you would have the opposite then. If you're claiming you have the opposite,
typically, right, over unobstructed view, not close to the ground, you should have looming in over long distances. Yes, through when making long distance observations through the air, and through and as you said, when you're close to the ground, very close to the ground, especially near water, because water has a very high specific heat coefficient, then you have vastly varying, hugely varying, basically unpredictable effects, and you have typically, usually, actually always, temperature driven density gradients, but those go away as soon as you remove yourself further from the ground, make the observation line, remove from the ground further, and don't make it close to surfaces of water.
Okay, and just simply, the sun isn't shrinking.
What the hell? We're not talking about the sun, Damas. Put yourself on mute. Put yourself on mute. We're not talking about the sun. No one said anything about the sun sinking then. What the hell are you talking about, Fish? We're literally not talking about that at all right now. Yeah, so it would be good if you could present your observations and your temperature readings and whatnot. I don't know why you're bothering taking the temperature readings if you're saying the temperature doesn't affect it.
Again, do we agree that in mountain ranges, the pressure, the density of the air is lower, always lower than at sea level?
Yeah, absolutely.
Ambient air. Okay. Yeah. So do we agree that there is a temperature lapse rate? So given the same general climate change, same general weather conditions, it will be warmer further down in the valley than it will be up at the mountain.
Yeah, it's going to get colder as you go up higher.
Okay. Yeah. Okay. So do we also agree that at the same pressure, a lower temperature of the same volume of air means denser air? Colder air usually typically is denser, right? In our
colder is
bodily
denser.
experience.
Yeah.
Okay. Yeah. So all those three facts combined mean that over thousands of feet, in the case of like mountains, the pressure lapse rate has to overtake and dominate the effect of the temperature. The pressure gradient has to overtake the effect of the temperature gradient in terms of the density of the air, because higher up at the mountain, the air is colder, but it is less dense.
Mm-hmm.
Because it has a lower pressure. So the pressure lapse rate has to dominate the temperature lapse rate in terms of the effect on the air density. Otherwise, we won't get the air being colder up at the mountain but less dense.
And it's not wrong. The density of the air on the top of mountains, it's dependent of how much moisture and humidity you have there at the ground.
Moisture is completely negligible in this case.
No, it's not negligible, but because sometimes the formation of clouds, you see them, you see it at the top of mountains, sometimes below the top of mountains, and you are on the top of the mountain, you see clouds below you. So sometimes they are in the top of the mountain, and it's dependent of that temperature and how fast is the accumulation of those gas. Water vapor that is there. So the accumulation, if the accumulation is faster, you will have cloud formation and it will be denser than the bottom of the mountain.
I agree. You're drifting off course here because the saturation pressure of water vapor in air is driven by temperature again, right? Yes. And the effect of water vapor in the air on the density of air is that higher humidity means a little bit less dense, but it has a very minor effect. If you look up at the applications of it, which are just measured empirically, basically, and then
so that's why we get better effects on the ocean level.
Doesn't have minor effects. It have major.
It has a very minor effect.
Okay. You're comparing mountains to ocean now. Ocean level. Why is it we get greater effects than we do in the mountains? The only other factor that's there is excess humidity.
But
but what? You're saying humidity has a minor effect. You've got all of the other things available.
Look it up.
High temperature variations.
You can look it up.
But you've got excess humidity.
The density of air depends on its humidity, and you can see that it has, compared to the temperature and the pressure, very minor effect.
No, it doesn't.
So why is it, if it's such a minor effect, that there's such a great variation at ocean level?
Because there's more temperature variations, there's more temperature gradients and more temperature gradient changes. Because water has a...
So why did you have to bring it up in the first place then? Why did you have to use your mountains as an example to prove that it doesn't do anything? Why did you have to drag it away from ocean level to prove up in your mountains all these things happen? You're the one that dragged the conversation away, not Necros.
Because I'm talking about... So I'm trying to...
You're talking about what? And just another thing, do we agree? Do we agree? And do we agree? Your conversation is not conditional. So next time you try to box DJ in, be warned.
Huh? I'm sorry. I didn't. Sorry if I offended your little sugar.
No, you didn't. But what you do it all the time, AK. Yeah, everything's conditional for you.
Okay, so I'm trying to understand why the horizon.
Okay, what you're doing. What this sounds like to me. The things that you're stuck on
that don't cut it. I'm giving explanations that don't cut it for me because I have a set more. I'm fairly knowledgeable about the things that might affect it, which is why I can't understand how it works and. But the explanations are kind of hand-waving away things that I have already taken into consideration.
Well, and that's the point. Your issue earlier, when I first come in earlier...
I'm not...
Okay, breathe. You can do it, mate. Okay, stop stressing.
Controversial.
Okay, you can do this. Stop stressing. Just take your time, bro. You're going to flip out. I don't want you to do that.
I don't think I've learned anything from him.
Okay, you came in very...
Okay, so, Jen, hold on. Okay, one of your objections was things disappearing bottom up. And you hand-wave dismissed that right at the start. You said it's not possible off the get-go that this can be anything. Things disappearing bottom up. You don't understand that.
It can't be due to sinking, yes. Because I'm all but certain that it's
because you've what?
That the conditions for sinking were not present.
So, bottom-up instruction. Check this out. Whoops, wrong number. Where is that photo there? Done. Twonga, pull your head in. The difference between those is elevation.
Huh?
Inside chat.
Okay, yeah.
56 past the hour. You're right. Notice how the bottom of the bottom can is obstructed?
Is it?
You're joking.
Yes,
Look at the difference between the two cans. Top can, bottom can. Notice the blue stripe on the bottom of the cans. One of them is thick. The other one is thin and does not have a metal band at the bottom.
Really? What is that highlight underneath the
reflection off the floor?
Gray strip. You say it's off the floor. It's on the
reflection
blue,
off of the floor.
It's on the blue strip of the can, though.
What is on the blue strip of the can? What are you talking about?
Okay, on the right side of the can, in the bottom right corner of the can, a little bit towards the left. If you go,
Okay. You're trying to overread it. Look at the blue stripe. Compare the two images. Remember doing that as a kid? Here's image A, here's image B. Let's compare the difference. What's the difference between the blue stripes on the cans?
Okay, one appears much thinner, yeah?
Excellent. Okay. The only difference in those images is the elevation of the camera.
Okay, so you claim.
Also, now it's just a claim. Hey, check this out, AK. Check this out. You made a claim earlier of all these observations. We're yet to see yours. So your claims are null and void.
Okay, dude, calm down.
You calm down, AK. You're the one whose dog ate your homework.
Okay,
so I'd like to. That's certainly. I'd like to respond to this. I think that this is relevant in what AI might have been talking about, where you can, have a floor that's flat enough, but not flat perfectly. Who's to say that the surface of this floor doesn't have slight deviations that would actually have the floor obstruct the can?
So, Maverick, Matrix, do you think this? What are you saying is the explanation for this? With this,
I'm just showing you that this can happen on a flat surface because you said it can't.
Okay, I'm not saying it can't.
You did earlier. It was quite clear.
No, I didn't.
Yes, you did.
No, I didn't.
That's why I came in. That's why I posted the cans up earlier.
Hold on. I said that.
So sinking's the cause there.
Hold on. What? Sinking is the cause there? I don't think so.
No, that's what you're saying sinking is the cause. Well, show sinking there. This is great.
No, I said that sinking isn't the cause.
Okay, welcome
I
to Flat
didn't say
Earth.
it can't happen over a flat surface. You just showed me it happening over apparently flat surface, and that is fine. I'm asking how does it work in combination with the fact that the horizon appears further away as you increase in altitude, and that that it appears lower below eye level as you increase in altitude.
Well, as you increase altitude, common sense, AK, you go up, the ground will appear to go down. I'm sure you could have worked that one out. Don't say no, because that's what happens. You are going elevated. AK, stop trying to overcomplicate yourself. You're trying to make yourself sound more intelligent, and you're burning your own self, and you don't even understand that. If you put a tennis ball on the ground and you jump higher, is the ball getting lower than what you are?
Okay, but due to perspective...
Excellent. So as your elevation changes, things will look like they are lower than you. Well done. We're getting somewhere.
Matrix. But according to perspective, things appear...
Well, you didn't mention anything about perspective. Things get smaller as they get further away.
Yes. Things get smaller as they get further away. Exactly. So the distance between me and the ground when I increase in elevation, so that same distance will appear smaller the further and further I get away.
Yeah, but the angle is that small. So you're telling me, okay, stop and breathe. Okay, you don't have to get your word count in, JJ. The great JJ, listen carefully. JJ.
Let me finish my sentence, please.
Okay.
Let me finish my sentence, please.
Okay, you're just going to keep rumbling on with stuff. Let me answer the individual components. Let me answer the individual components. It will make it easier for you to understand.
One fucking sentence. I'm not hearing a single word you're saying because you don't.
Because you don't want to. Because you don't want to, AK. That's the problem. So you don't want to listen to people.
I can keep talking until you let me finish one fucking sentence, and then okay. So the ground will appear to rise up. Now I don't understand why it would appear to rise up less if I increase.
It's not rising up.
It's not. It's not actually rising up, but it appears to rise up, right? And simplistic null hypothesis would be due to perspective.
So now you've got me to answer 3 things. That's great. This is why I wanted you to shut the fuck up so I could answer the first question. With your angle of resolution, you looking out over 40 miles, the difference of something that's only 10 foot high is fuck all. Your ability to resolve that is going to be so minuscule, you're not going to even notice it, mate.
Okay, but that would be more of a thing that would affect.
It wouldn't mean anything. That's the problem. You're using it as some kind of holy grail I don't understand. Come on, dude. So things rising up. The problem is when you get elevated, shut up. Shut up and listen.
Can you calm down first.
All right, we're going to help you out so you can listen. When you elevated, things appearing to rise up, right? The problem is when you're up in the air, you don't have a comparative to go, hey, look, it is just you looking at the horizon. Your eyes are attracted to the largest, most obvious thing there. Ta-da! The horizon. If you have something there that actually shows level, when you look across, it will be slightly below you. I wonder why. It's supposed to be. You're elevated. Now that's different when you're on the ground.
It's supposed to be.
Say what? So you've picked one fucking word out of everything. If I say the word hot dog, are you going to be hung on that for the next 6 weeks?
No.
Okay. You know how you guys claim ships disappearing bottom up is your proof of curvature?
You guys, not me, no.
There's a thing called foreshortening, all right?
Okay.
So what happens is, with perspective, there's a convergence point.
Uh-huh.
Appear to converge up, top down, left to the right, right to the left. Yeah. And there's a center point of your vision, basically.
Uh-huh.
When you are watching or observing a ship, the problem is you are only short. You're only 6 foot tall. I'll assume you're 6 foot. The ship is, 150 foot high. You're only close to the bottom. As per the laws of perspective, everything will converge at a center line.
Mm-hmm.
Your vision on the ship evenly. The problem is your vision line is close to the bottom. So as the bottom goes up, the top goes down, left to the right, right to the left. The bottom will hit your center line first. That is why things appear to disappear bottom up. It is to do with your positioning in relationship to the thing that's disappearing into the distance. And then, on top of that, you've got all these other things. Humidity, air pressure, temperature, and all this other weird shit going on.
Mm-hmm.
Right.
So, I still don't get why the horizon line should be slightly below eye level, but
because you're above it.
Okay,
it's a flat plane. Okay, easy observation. A chessboard. You probably play chess. You get down eye level and look at the chessboard. Now lift yourself up. You are now above the chessboard and your eye line is drawn to the horizon, the back of the chessboard. That's what's happening.
No, the horizon is not where the back of the chessboard is.
AK, here's a simple answer to that. Your eyes are above your feet.
Yeah.
He wouldn't get that.
There you go.
That doesn't...
Are you expecting the ground to be above your feet, your eyes?
Okay, guys... How about you
Okay, you've got two choices. Okay, just listen. You've got 2 choices, flat or curved. Okay?
Huh?
If it's curved, it should drop away at... wait. Just wait. If it is curved, shouldn't it drop away at an even more excessive rate than flat does?
Huh?
The crap.
No, okay. No, I'm premising the flat.
No, it wouldn't. What are you doing? Okay, you've got a choice. It's a flat plane, horizontal, or it's a sphere. As you get elevated...
Oh my God.
You're false economies of no consequence here. We're trying to understand how the horizon works.
Get muted, bro. Listen, for the love of God. Matrix, put some effort into figuring out your game so that when the audience is listening, when they hear AK and then it goes to your voice, they're not getting stabbed in the eardrums.
It's turned down. I've got it all good, I thought.
Yeah, take a break and go listen to the live stream. Take a break and go listen to the live stream and find out. Because what you just said was actually fine. What you said previous was ear rape.
Because he was shouting.
But I'm not shouting, bro. That's volume.
Hey, AK, why don't you make a claim?
Because I'm not making a claim. I'm asking a question. I'm trying to understand something here. And the explanations I'm given, they're just not getting through to me, or I'm having some other hang-ups of it that I'm not getting to voice.
God, this is just terrible. You know, we've given you several explanations, even the most simplest one. Hang on, don't interrupt me. Fuck. Pay attention.
Are you busy?
Yeah, you've been told that your eyes are above your head. That's the best explanation you can receive. Simple. Okay?
It doesn't make sense to me because due to perspective, if I have like some undetermined long, like if I draw things out to the vanishing line in perspective, that would be at eye level.
I'm not going to entertain this
So
anymore.
The horizon is below eye level because something cuts short my vanishing line. Okay, fair enough. But why does it drop lower when I increase in altitude? Because
you're increasing altitude.
The horizon that things start to vanish also gets further away. So, and due to perspective, that should then rise, that should cancel. Why does it not cancel each other out? What's the mathematics behind it? What's the formula? How can I predict those effects?
Because you're increasing your angle of view.
I want to get an understanding. Okay, just so that you know, like what my benchmark is. I want to get an understanding where I can of the horizon that is so far that I can derive from that understanding. I can look up the existing the physical correlations and laws regarding the relevant things for the horizon, and I can then go out. I can then take a situation or an observation site.
You won't be able to do it perfectly because you don't know.
What I should be seeing regarding the horizon when I go out.
You won't be able to, bro.
And then go out and confirm that.
Okay, we get it. I get it. You won't be able to do that perfectly because of the variables that you won't be able to account for. But whatever variables are involved in limiting your ability to see across the surface of the Earth, right? There is this other factor involved, which is angle of view. Right, so the information is being squeezed into such a small, tight angle from ground level, right? And then as you increase, right, more information opens up. So you've got the same information, right, or similar information being allowed to be resolved, but more because of the increase in angle, right?
So that can't be a factor. Because I've already made the observation that how much ground I see between me and where the horizon appears does not depend on my resolution. What you just described should make the horizon heavily dependent on your magnification, on your resolution. So when I use binoculars, I should see the horizon much further away, or should see much more ground between me and the horizon than when I don't use them. With your explanation.
Maybe not doing this in the hills.
He wasn't talking about the angular resolution. T-Dub was talking about the angle of view.
The angle of view, yeah, but the angle of view was okay. The angle of view was relevant because of how much information, how much more information is crammed into a smaller angle at a further distance, and that is due to perspective. So when I increase my magnification, I increase my angular resolution, and then I stretch out that information again. Because my field of view from in my eyes, what I can see sharply, stays the same in angles, right? But when I use binoculars, I magnify it, so the real field of view that I'm actually looking at shrinks, and it stretches it out over the field of view of my eye.
All right, let's not forget that I mentioned there might be other variables involved, like environmental conditions, all right? Sorry, AI, if you want to take this, you can. Because I was going to bring up the chessboard thing, but that's cool if you want to take it. Oh, it looks like you got a bad connection. No, please, AI, because you can articulate this way better than I can, or somebody else might be able to.
So the environmental conditions, I do understand. I do understand they affect the observation. I don't understand how the when I mitigate those factors by removing myself further from the ground, not making the observation very close to a body along the surface of a big body of water, I still have those three characteristics that the horizon has, but they can't be that heavily influenced by a variation of the weather conditions anymore, because they become much more predictable and much more stable. So they are a known factor, and they can't be explaining that.
Like, because I don't know about others, but I would tell you that I don't know how far I'm seeing.
Okay.
Right. I don't know what information is out there that I can't, that my eyes can't make any sense of.
Okay, so you can't give me an explanation either then?
No, but I can give you the... Okay, AI, if you want to say... I was going to bring up the chessboard thing, like with the chess squares, the chessboard squares, but if you want to take
That's perspective. I do understand that. It doesn't help me in understanding why the horizon occurs the way it does. With all the mitigations and all the specific,
so if you had,
all the experimentations I can do.
Yeah, great.
Maybe I'm just gonna revisit the video. Overlord sent, and I'm gonna circle back to you guys later.
Yeah, do that. Take a break. Right. Yeah, take a break.
Thanks. That was more fruitful than usual, anyway. By the way, yeah, Overlord, you're really heavily roboting right now. Anyway, see you.
You're roboting. You just have to take your field of view. I know that he left, so I just want to say my idea about the thing, about that point. So you take your field of view as like a triangle. You draw it as a triangle. You draw the observer and that field of view that will be an angle. So the angle will be in your eyes, and those lines will stretch out away from your eyes or the eye of the observer. So when you rise up or get more elevation, so that angle, so those lines that are stretching away, going away from your eyes and diverging to create an angle. So that's the angle of view. That's the field of view, sorry. When you are rising up, so that line will go away and touch further distances in the surface. So you will be able to see more area because of that field of view that is getting greater when you are rising up in the sky, or you are getting more distance from the floor. So that angle gets bigger and bigger and bigger more you go up, and gets smaller when you do the opposite. So that's why you see more distance to the horizon. So the horizon will get farther away the more you get you are rising up.
It appears to do that, right? Right. Yeah. Exactly. Because let's say you've got like a checkerboard with, and the squares are like 1 meter by 1 meter, and 1 meter squared, right? And that extends out and like in front of you, like, I don't know, 200 kilometers, just give it whatever distance you want, right? And you're looking out across the surface, and okay, so your optical limitations, not to mention your other unknown environmental conditions, going to play a factor as to how much of that surface you can see. But you're looking out, so eventually you're not going to be able to make out the difference between the different colored squares if they're black and white, right? If they're all black and white, like a chessboard. They'll just blend. They'll just eventually won't be able to resolve those squares and see that they're actually squares and they're different colors, right? It'll form, your limitation of view, right? And so you can see some of them. You can see that some of them are, but as you rise up, you're going to increase that angle, and you'll see more squares. But the same effect will still take place based on your angle, right?
Right.
There'll still be a limit.
Yeah,
and then you keep going up. You'll be able to see more and more and more and more and more.
Yeah.
And
what I've experienced. One thing that I want to say that.
Hang on. Can anybody hear me here? Can anybody hear me,
dude?
Yeah. Mic check.
Sorry.
Hey.
Right. I was just going to say something. When you're going up high, especially in a hot air balloon, the things that your eyes will not be able to resolve what you're looking at there because you're too far from it. But things underneath the basket that you're in, you can see clearly, even though you're rising up. And then eventually, you might not be able to see that if you go high enough. That's what you're saying, basically. I don't know what's his name. AK.
But AI is really good at articulating this, way better than me.
All of you already explained that to AK, but I want to point to something. So AK was a little bit dishonest about that thing. So even he was dishonest or really completely bricked, because the guy understands that on a flat surface you can have a horizon. The point in contention, the point that he have a problem with, how that horizon move forward when you are rising up or you're gaining altitude. So the observer is gaining altitude. You explained already with different, everyone explained it with his own words, but the main thing was explained to him that the angle of view is getting greater when you are rising up. So that angle, that line of sight, the things. Not the angle, sorry.
The horizon doesn't move forward. Right, the horizon doesn't move forward.
Doesn't it appears? The horizon appears at farther distances. The horizon is just an optical phenomenon because of that field of view and created by that perspective thing, and dependent to the atmospheric conditions around the observer and the surface of water. So the field of view. I always say the wrong word, which is the angle of view. No, the field of view is getting greater when you are gaining altitude. So you see more.
There you go. See more of what?
More of the surface, more of the field of view. So you see more of that surface. So the limitation of your vision, which is that horizon, which where the sky meets with the surface, appears at farther distances than before when you were at the surface.
How is it appearing at a farther distance?
Because your field of view is getting bigger when you are rising up, so you see more of the surface than when you have a small.
Okay, fair point. So if that were true, then rather than the horizon dropping as you raise in altitude, it should actually raise in your field of view as you raise in altitude.
Yes.
It rises with you because the horizon doesn't always appear at 6 foot above sea level when you are at 100 meter above sea level or 10,000 foot like an airplane.
Can I mention something?
The horizon rising up, but it doesn't reach the eye level exactly because of different phenomena. Like
one second.
Empty horizon.
Okay, the thing you're trying to resolve in the distance, all right? There's a distance. Your eye line has a distance, right? Your line of sight is a distance, right? Now, as you raise up, you increase that distance. So you've got two factors at play. You've got opening up the angle of view, but you've also got that line of sight gets longer to the same thing that you're trying to resolve.
So from very high up, using a strong camera, how far can we see? Further than we see in real life.
Yeah, who denies that? By the way, you said if you went up, how far can you see? Further than we see in real life. How does that make sense? Isn't every observation you do in real life, or is it in fake life?
Based off the Rayleigh criteria and angular resolution, if you go high up and you have a very strong camera with a very strong lens, you should be able to see way further than we do see. Like, what is the furthest image we have?
That already happens. We already see further than we do see. How does that even make sense?
No, consistently to see like vastly further than we see. Not
Yeah,
like
we do. Listen, when you go up in high altitude, you already see more of the Earth than you should if the Earth was a globe. So good point. You just destroyed the globe.
I understand because you have refraction, but I'm saying theoretically we should be able to beam a light. Where does it stop? Where does it stop? Where does it fall off? Because satellites cut out at some point. Do you know when it is from a ground station?
What do satellites have to do with seeing anything?
Like, how far does light travel?
It depends what for medium.
Light travel distance. There you go.
Depends through what medium, right? So light doesn't travel to the bottom of the ocean, does it? Even if it's noon above, it's dark down there. Because of the medium, it becomes opaque over distance. Same with the atmosphere, right?
If you're high up and you aim a laser or a beam of light, not like a little clicky light, like those pulses that they do for SLRs, satellite ranger imaging, or VBO or whatever. How far until the light? I mean, because theoretically, why are satellites? When should they cut out? According to if you think there's no curvature coming in.
Like Jedi told you, it depends on the medium. So if you just point that laser in the medium of water, it will just go so much less distance than if you point the laser in the dry air. So yeah, depends on the medium where you are. Even if you say that you are high up in the sky, still depends on the medium and how much particles you have in between you and that target that you are trying to point the laser to. So how many particles of dust, water vapor, droplets of water.
Okay, and but we get consistent connection to a satellite above us. So, and there are points when it cuts out. It's not like it's like periods. It's a distance after a certain amount. It's not like
your calls drop when it rains.
What?
I was just asking if your calls dropped when it rains.
I don't know. I'm saying,
wasn't the argument about seeing things at a distance? Right now, you're talking about satellites.
Right, because the limit we were talking about. Thanks, DJ. You can see because there's many optical illusions, as you all know, and you keep saying, "Oh, you can't trust your eyes. You can't trust that angular resolution, Rayleigh criteria, all this other stuff, optical illusions." So I'm like, then why do you keep demanding and dying on the hill of, "Oh, look at what I saw," or "What do you see?" I'm saying, let's get fucking, those invisible light fucking pulses that we used to measure actual long distances and do things like GPS and see how far it goes.
Like, for example, radio waves being transmitted horizontally till how much it wasn't? It was 2,000, and after that it was 10,000 kilometers.
Yeah, radio waves.
Yeah, it was already done.
Yes, but I'm saying, how far theoretically?
Can I welcome you to that? It was 10,000 kilometers.
Yeah, because we have things, because it can bounce off things.
Now,
so I'm saying in a straight path. I'm just saying, no, hold on. Assuming no refraction, how far should they be able to travel?
So both tests were done for different distances. For the first, which was a receiver on 2,000 kilometers, and the other test by the same person, it was 10,000 kilometers. Are you telling me that that person were aiming at something in the sky and then trying to ricochet the signal to the surface? So the same thing that you would say if we talk about laser beams stretched on above large bodies of water, you would say again that laser changed its trajectory?
I'm talking about pointing up. If you're pointing sideways, a radio wave, yeah, you're going to have curving or light, a lot of it, because lower you are, denser it is, higher the refractive index, no shit. I'm talking about if you aim, let's just say if you aim upwards, how high do you think we could, do you think the satellites, let's just go with satellites. Do you think satellites are as high as we say they are? I think they are. Or how do we measure how high a satellite is?
Easy to measure, but it's not a reliable measurement.
Yeah, unless you're claiming,
you can do it by yourself now if you want. Just take the angle of dishes for satellite TV, and you take all those angles of a specific satellite. Like, for example, we take Astra, and the angles of those dishes in different countries. It will give you an elevation angle. So triangulation to that, but it's not accurate because you don't know what is oh my god, that signal, how it is transferred. Is it a radial transfer? Is there repeaters in the sky above those dishes? You don't know anything about that, but you can have measurements that are not reliable.
What do you mean we can't know what we shoot back and forth? Yes, we can. We are the ones doing it. Like, what do you mean? Like, humans can't know what technology they're using?
Some people can know. You can. So, can you tell me if it is really a satellite at 35,000 kilometers up in the sky, or just a repeater hanged up on a balloon and different repeaters that are distributed on like spider web? So up in the sky, so it will just repeat the signal to those dishes that are pointing to a specific angle that you will get from the internet. If you research the angle where you will point your dish.
Wait, so they're in a spider web, so they're staying in the same spot?
Who knows if they are staying in the same spot or moving and they will be replaced by the other, like circulating. So one will move forward and the other will replace its place.
Okay, well, hold on.
Yeah, cool story, bro. I'm sick and tired. Hey, hold on, brother. Hold on. Hey, listen,
don't know when you can literally look.
No, get muted, fool. Get muted. Hey, Necros. Stop speculating on his burden of proof. Thanks. He has to prove his case, not ask you how to prove his case with all alternative hypotheticals. Holy crap. Why do you think he's asking you, do you know how it's done? So that you can go down the red herring hypotheticals ad infinitum, dude, and never get to an answer.
In reality, it wasn't even hypothetical. I've done that. So you can do it now. You just take the angles of every dishes in different countries, and you can.
That doesn't prove anything. That doesn't prove anything. That doesn't prove anything.
That's what I told him.
There you go.
That's what I told him.
Cool.
But it's not hypothetical.
Perfect.
It's what I've done it.
And what result did you get?
35,000 kilometers up in the sky. Like if you take, for example, I just give you an example, Astra or Nilesat. I did with 5 different TV satellites, and it's 35 point something till maximum 36,000 kilometers up in the sky. by triangulating with the different dishes in different countries.
Okay, cool. So if you triangulated it, then that means it would be at a given point in time directly above some point on Earth, right?
Supposedly, following their claim, it's I think it's the geostationary. It's just stationary above some specific GP point on the surface, and it's not moving against the. It's going with the spin of the Earth.
So did the location that you triangulated, was it above the GP point that they claim?
No. I took Morocco, Egypt, and France.
All right. So if it was above that GP point, would that answer why the horizon appears to, not be exactly at the midline of your field of view? Would that answer that question?
At all, it's completely irrelevant to that point.
Exactly. So let's see what JJ has to say to prove that it's relevant to the horizon by making their own case rather than having you make it for them. Go ahead.
Okay, I was saying we can see them moving. I'll post it in chat. And it matters to horizon because all this shit about optical resolution and angular this and Rayleigh's criteria, if you can't find a way to stand behind how far you should see and when, and you're just going to float back on, there's all this shit getting in the way, that's why you see all this stuff that you would see if it was round, then I'm saying let's not rely on what you can see with your eyes or camera, and let's use the most accurate way we have of measuring large distances, which is pinging light signals back and forth. We know how fast it travels in a medium. If we can shoot it upwards, so it's not going into low elevation, high air pressure, high air refractive index territory, then it's going to get even better. But even if you are pointing it there, we can take measurements like air pressure, temperature, so on, to account for it, which we do. So let's use that. And if you use that, you're going to get to a globe. Stop doing the observation stuff if you're going to complain about angular resolution. And
who did it? Show us the test that was done then, that accounted for all the things that you just mentioned, that proves globe. Go ahead, post it. Was it just a hypothetical?
Yes, correct.
What?
It better not be globe. Listen, friend, before you go on.
Test. You should listen to what I said.
Yeah, I know. He said that. He said just give him one example, dude.
No, he said cite the test that I gave that counted for all these things.
Oh my god! Holy crap, dude!
Yeah, JJ, you started. You entered the word "if" into that. That's how you started. And if you just go shooting light at it back and forth with each other.
Yeah, I posted satellite data in this chat before. It got deleted, but you can just look it up. Just Google what does satellite data tell us. Look up satellite data. Look up any data.
Oh, so light traveling in a path you'd accept as a measurement of the Earth?
If you were accounting for everything that affects the light,
okay,
and you're using the light, and it depends what type of light and how you're using it, as an accurate, good way to, because there's many things that get in the way, obviously. So the strongest method we have of measuring distance is, at large, long distances that you can't see very well at, is signals.
Okay. So you would accept a direct measurement of the surface to see if it's curved or not using a method that involved light, right? All things being equal.
Yeah, I mean, I would look at and I have at many measurements, but again, all of them come down to the flat Earth ones can't give you the raw data on temperature, air pressure, elevation, all those things. The other one, and you don't know what camera and stuff. It's like there's a whole bunch of bullshit. So, stop relying on, oh, look at this picture, look at that. Just get, what's the strongest
We have
way?
observations that have all of the details that you just mentioned, right? The camera used, the temperature, right? The water temperature, and all of those things.
No, but across all of the parts of the area. Like, so if you're shooting a line across a large distance, it's not homogeneous. And so there's that too. And then it's like, I could send an image of the Earth from many different agencies. You would say they're all fake. How do you know the image is real? How would I know the image that you're sending is real?
Yeah, well, the ones that, let me just say something quickly. The ones that are supposed to be coming from NASA, right? Some a flat earther by the name of, what's his name? Put on the plane, subjected some of the LRO, that's the Lunar Reconnaissance Orbiter pictures, and they were proven to be faked using the latest digital analysis software app, basically. And he proved that those pictures were not taken from space. And yet they're in the library, NASA's library, Lunar Reconnaissance Orbiter. You click on it, and this is what the public get to look at. So, they've been proven to be fake.
Okay, send this proof of fake, and I want to see if I ever actually sent this fake shit, and let's see if it's relevant. I just sent images in the chat, different space agencies confirming the same thing. Like, I could send you this time and time again. Like, the best physical observation you could have, if you're going to go off of observation, is go up as high as you can. And we have. But you won't accept that because it must be a lie. So it's like the best optical evidence you have, you won't accept. The best, hard data evidence with actual, satellite laser imaging, won't accept. The satellites are moving. You can see them from ground. Look up like Starlink satellite chains. They move. So it's not some stationary thing. They're real.
And geese fly in V's.
Yeah, they're on helium balloons. We're not. I'm not saying that helium balloon.
Where's the globe link?
We don't have to say that, right? This guy is just going on blind faith, right? Can't confirm any of the things that he's talking about. And when we go out and actually make observations over the Earth, it backs up that it can't possibly be a globe, and they don't have a single observation here on the Earth that matches up with the globe. Just blind faith in things that they can never ever confirm.
You just have to understand that imagery is not an evidence. Videos and imagery and also testimonies, they are not considered evidence.
But yet, in a court of law, when somebody was, just for example's sake, someone got murdered, photograph was caught of the individual, okay? And then the witness who saw that takes the photograph to the court. They look at the guy, that's him, he's in jail. There you go. So, how do we win here? What are we saying, about imagery? Okay?
Well, the best images show a globe.
No, they don't. No, they don't show globe. They show a fake imagery of globe is what they show.
Now you're going to say they're fake.
A fake
That's
imagery.
Yeah, if you have to say every image that you don't agree that
it's a fake imagery is what they show.
Then you're not going anywhere.
Of a globe. Of a globe. A fake imagery of a globe is what.
Better images are those of Superman. They are made of with better cameras.
Okay.
So, out of all of the pictures of Earth, I want you to go pick the one that is Earth. Go pick the one that's real.
Yeah, and then show us how you validated that.
Yeah, I sent 3 that are all the same fucking view from 3 different space agencies.
Yeah, and how did you validate any of those?
how did I validate that there's not an international conspiracy with,
No. How did you validate that they're true images of the?
Well, because again, which is also asking, how am I validating that these thousands of people across all these countries are lying to me? So
no, I didn't say that.
Yes, it is. No, it is because that would no.
I'm asking you specifically. No, I didn't ask you about who's lying or not.
The same reason when you send stuff,
just answer my question?
No, the same because
how did you validate any of these images? You said you posted images of the globe from space that are photos taken from space. How did you validate that's correct?
The same way I can validate, or you can validate any of the stuff that you've sent, any picture, any measurement, anything from anything else.
How did you validate these?
Same answer.
Okay.
Same answer.
Hold on. We validate our things by saying you can go do this too, and other people go and do this.
You can't go up, right? I cannot go up that high, so I cannot validate it.
You can't validate
it. The way that we validate ours.
No, but my point is, okay.
Hold on a second, JJ.
No one who has gone up that high,
JJ,
has said otherwise. They've all validated it. That's the whole point. It was validated by other countries.
You just said that you can't go up that high, so you can't validate it.
I personally am not.
Stop talking for a second. Don't make me mute you, man. Don't make me mute you. Just let me respond. Okay, so you just admitted that you can't go up high enough, so you can't validate these. You have to have faith in the people giving them to you. Whereas I saw a whole bunch of long-distance observations that didn't make sense on a globe. Right? I scrutinized them, and then I actually went to a different large body of water myself, and I did about 20 different observations of my own, which validated the information that I was being given. Okay, so I don't have to say that I can't validate it because I validated it myself.
How did you validate that? Oh wait, hold on. How can I validate that your validation is valid?
I'm not asking you to validate it. I validated it for myself.
Well, I can't validate. How can you validate that you validated?
So you could go and replicate what I did at any large body of water and validate my observation for yourself. So then you would also know.
You cannot validate that every circumstance is the same.
Whoever's trying to jump in, stop it.
Look, if my whole point was we should not be using bullshit like stuff that is high volatile, like, oh, what did I see at this one time? What did you see there on this? Like eye stuff that you can, what did you personally see? If you're going to, hold on. Yes. Yeah, hold on. If we're going off of personal observations.
We should just go off faith, should we?
No.
Blind faith.
If you use satellite laser ranging, you use radios, you use signals, that's actually going to give you. Hold on. My initial point was all this, like your optical, what you can see with your eyes in the camera, is going to be way less trustworthy than data you get from signals that you can send and measure. So if we're going to be talking about how do we, prove this and that, I don't know why flat earthers, you guys keep going on about what did I see, this and that. When it comes down to it, you keep explaining, the reason we see all these things that we would see if it was curved is because of stuff like the Rayleigh criteria and all this angular other stuff. So I said, then maybe try out some more, hard data.
No, you were saying just looking at photos from space.
If you wanted to use the best observations, the best observations possible, which was go up as high as you can. Go like who has gone the highest? Who has used the highest? Like who has had the best point of view? And then we look at what they saw. It is a view of a globe Earth, and the only way to refute it is to claim they're lying.
So you can never validate.
It's only 27 people, bro.
Wrong.
Yeah,
like the only way
is faith-based bullshit. But you just spoke for
27. No, 6. I'm sorry. Was it 6? Those who went to the moon, because that's the highest point.
They're the only people that claim to have gone far enough away to see it like that, bro.
Did those people launch the orbiters that took those photos? No, they didn't. So again, if those people were lying, these other space agencies, these other companies, these other countries would not all validate it as the same thing, but they do. So JJ, the conspiracy is either tens of thousands of people across all these countries and continents and all.
JJ, come on, man. You've been waffling on for a long time. I just want to ask you one question, right? Could those images that you're showing easily be faked?
No, not on that scale. No.
You don't think that those images that you just posted, those little blurry images in the side chat there that you used as your proof, do you think that somebody could easily whip that up in CGI software?
No, not without getting caught. Not without that. No.
Really?
No.
You don't?
Yeah.
So
not with the system.
Those actual images, hold on a second, be honest here. Right? Those little blurry images, could they easily be made up and faked? In general. So you don't think that someone could create a replica of these in CGI software very easily?
Oh, like create
Obviously
an image?
They could, just in general.
These
could easily just be fake, right? And
it's not possible. The images that we see that they're all releasing are all coordinated live. It's just the likelihood that is hold on. Because if they're not all fake in coordination, because they'd have to be coordinating now. Like the amount of assumptions you'd have to make to believe they're not accurate, it's just it fails credulity. So
his question was clear. Is it possible to make some pictures via software on a computer and create something that is not a photograph like that you sent? Can someone do that? Don't tell me unless if they are caught. No, I'm not asking you if they will be caught or not. I'm asking you the possibility.
Yeah, I already answered that.
If it can be done.
I already answered that. And then we moved on to the next step is logically, those would not be faked. It would have to be a colluded effort from all the different.
That's not illogical. That's not illogical.
Yeah,
and by the way, it's only
the people who
hold on, friend.
Built these,
friend. Thousands of people or millions of people doesn't make it more or less logical. You're using the wrong word. No, it doesn't.
It does. It does. Like it defies logic. That people.
No, dude. It defies your credulity, not logic. There's nothing illogical about 5,000 versus 10,000 people colluding together. And by the way, that's only one assumption.
It is.
If there's a coordinated effort that everyone's agreeing to, that is one assumption. One, not many.
Logical, because if that is the case, that all these things are fake, then the assumptions that underlie that go against basic logic and basic reality.
Yeah. Okay, perfect. Describe one logic string that proves what you just said. Go ahead.
If it was the case that the data that is used to create and measure and position these images is not accurate, then the people who collect that data, there are different people who collect different raw data that is all used in these images, in these ranging, with satellites. All of those people collecting different types of data from different stations and different organizations would all have to be either one, giving incorrect data,
using a model,
two,
using a model,
What? No. This is raw data.
Or three using a model,
raw data measurement. So they would
give us an example of one. Give us an example of one. Give us an example of one of these raw datas.
Oh yeah, like GNS positioning data.
Get us an example of one. Not just the name of one, like an example, like the actual numbers.
Okay, an example would be the time it takes for a laser or to bounce from a satellite to a ground station, or ground station to a satellite, and back. The people who do the VLBI measurements, data.
Yeah, get us one.
SLR.
Get one. Again,
get one. I've already done that. I posted that in the chat, and then you guys deleted it. So we've been down that road.
Who deleted it?
If you had, I don't know, Batman, another guy. We've been down that road. If you're saying, if you don't think they exist, you will lose that game. You put money on it. I'm not going to waste time demonstrating to you.
Okay, give me a minute here. Give me a minute here. Okay, whoever's deleting posts that are data sets from somebody who's attempting to prove their case when asked, stop it.
I posted raw satellite data over 20 times. Kept getting deleted.
How long ago was the post? Because
I did this over this. I did this over the span. I did this over the span
of a program that deletes text messages after a certain period of time.
It wasn't that. This was a few weeks ago or last week or something like that.
This happened several times.
Then it's going to be naturally deleted by the program that Politics Server has governed.
It's not that. People were deleting them because he was just kept posting them over and over again. So his original claim was that there's lasers aboard satellites, okay, that are shooting signals back towards the Earth.
No.
And bouncing off ground stations. Don't lie.
Where I said that they were shot.
No. You just butchered it, right? You were completely wrong, and you admitted this later, right? You admitted your mistake. This is all on live recording. Don't lie right now. You said that there are satellites. Your whole argument, there were satellites that have lasers on them, right? And the satellites shoot the lasers at ground stations on the Earth, and then get the signal back, right? And then you were trying to show raw data from that, right? And then during the research, Amish, Yoda, right, he looked it up and said, actually, that's completely incorrect. There's no lasers on these satellites at all. India was there as well, right? And then you said, oh, yeah, I was completely wrong about that. The lasers aren't on the satellites at all, right? And then you kept saying that you posted raw satellite data, which when I analyzed it through AI, it said, no, this is not the type of file format that would show raw data. Okay, this has actually been processed, and right, you couldn't explain any of the data or validate that it was raw, and then you just kept spamming it, right? So someone started deleting it, right, because it was just chaos at that point, and that's all that happened.
Okay, fair enough. So it wasn't actually data for evidence that was being censored; it was spam that was being censored. Okay, that's different. Oh wow.
No, hold on. What you just heard was a series of bullshit. My claim.
Okay.
Yes.
Yeah. Cool story. Yeah, we could prove it. Yeah, we could prove it.
Say at one point that the laser is shot from a satellite to the ground station and back. I incorrectly said that. It is shot from the ground station to the satellite and back. I was talking about the round trip measurement. Whether or not it's shot from the satellite or from the ground station first was not irrelevant. So he keeps trying to pretend like there's some gotcha thing. Like the whole point was I was trying to argue that satellites are the ones shooting lasers, and that's the point. No, the point was the raw, like the time it takes for a signal to go back and forth from a ground station to a satellite is the data. That is the data. And he has to pretend like the argument was, oh, satellites shoot lasers. He's wrong.
Well, the other thing was that it wasn't raw data.
And we've been over this. Point number two is that it is the actual data that is given to you, like that you can read. That was the format. It was a text format. It literally showed all the measurements that they gave, time in seconds, time in milliseconds, every piece of data that an output gives out, that the satellite gives out, was there in the structure. That AI, I asked it too. How would it come out? That's how it comes out when you read it. When you look at satellite laser ranging imaging, how long did it take to go back and forth from a ground station? And you line that data up because you don't want to look at other data. You want to look at how fast it takes for it to get back and forth, over several different parts of the day. Then that's what you would get. You would get rows of different sets of data sets of numbers coming from a direct link from the satellite from the organization that posts all the satellite data going back decades from all the satellites. So their argument was, you don't know if it's been tampered with or altered, or you can read it in a text format and it's sorted chronologically. No shit, but that doesn't mean it's false. So they have to misrepresent the argument as lasers are shot from satellites and not the distance, the time it takes to go back and forth shows is actual data. And two, the data it's not false. It's still data.
That's what I've
done.
And
I was not spamming it.
That's what I've done. I just translated the data the day you sent it translated it to text, and it doesn't at all have any measurement about the curvature, the overall curvature of the Earth, radius, or anything about that. But what it does have, highs, lows, like things that you can have on a flat horizontal surface.
No, the cutout. No, look at when it cuts out, and look at the change in the time it takes to reach. Look at the change in time across the day, and when it cuts out, that's not going to line up with a flat surface. It would not cut out like that. It would cut out much later. But I will say, I have posted it before, and I posted like one random one. You should just look it up. I gotta go, but you should just look this up.
It will cut out later, you said. Because you compared it on a flat surface?
Yeah, he just bailed.
On a flat surface, it will cut out later. Is it because they did the test on a flat surface and they saw that it will cut out later, and then they did it on a curved surface and they found that it didn't cut out at that point, it cut out earlier? What?
If somebody starts talking, then the other people will want to interrupt them, and then it'll get a conversation going.
I have an image that proves the Earth is a globe.
Mm-hmm.
Okay. Can I get permissions to post on the side chat?
I didn't get a chance to interrupt you. Say it again.
You can just DM it to me.
Well, wait, is it because he's hushed, or is it because he has a too
is he
low of
just
a level? It might be.
Yeah, it's probably hushed. All right, let me 1 second, Kibo. All right, try post it now.
Okay, yeah. Got it. I posted it. So this demonstrates that the Earth was measured curved.
Okay, who measured it curved, and how did they do that?
The Public Land Survey System.
Okay, and what measurement did they take? What did they use to measure the Earth curved?
Surveyors, land surveyors, and whatever tools they used back in the 1800s.
Okay, so who did that? Show us the observation. Show us the data that goes along with it.
All right. Here's the Wikipedia article about it.
All right, so explain it. Where in the article does it give me this information?
The whole article.
Oh, so this, you know what an elephant hurling fallacy is, right?
No, what's that?
It's when you just like hurl like a whole stack of information that would take a hell of a long time to read through, right? As kind of like as your evidence, rather than actually having your evidence cited from your source and ready to go.
Right. Because do you understand exactly what was done? Like, have you evaluated the information, understand it, comprehend it, can articulate it or summarize it? Or do you just have this vague notion that this represents something that you're not sure about?
Well, I think it's an interesting point that hasn't been, like, I haven't seen it discussed before. So, obviously, like, I'm assuming they probably used some sort of theodolite or whatever, instruments were common in the 1800s. But,
okay, well, assuming's not really going to help the conversation move along, is it?
yeah, I don't know, like, what information would I need to research to, like, have a more definitive.
It's a you problem. It's definitely a you problem if you want to make claims that you have globe evidence, right? And then you might want to have something ready to present that you actually understand and have like documentation and talking points, right? That you actually have researched and understand, right? Empirical evidence would be nice. Like we present. Like the counter, yeah.
I just want to say it'd be different if you said, "Hey guys, like, I'm not sure about all of this. I don't understand it. I haven't looked into it. But apparently, this here is claiming to be globe evidence. Like, I'll post it for you if you guys want to peruse it at your leisure. That's cool. Like, I might do the same later. But I just thought I'd share it with you guys. Like, that's a different thing, right? Than saying this definitely proves the globe.
Right. But even if I did know all of the information in detail, like, you still wouldn't be taking my word for it, right? So, because I could be.
You would want to have more to present than just trust me, bro.
Well, it's not trust me, bro. It's trust the Public Land Survey System, bro.
Yeah, okay, and show us what they did, right? You'd have to present what they did and how it validates the Earth as a globe. Because when we actually go out and test the Earth using these devices, right, we don't detect any curvature.
All right. Yeah. So I can ask AI.
No, right. What you should do is you should read it, and when you encounter something that you're not sure of or don't understand, then you could use AI as a tool to help you gain more understanding about what you're reading.
Used a combination of classical surveying instruments Gunter's chain, surveyor's compass, transit
Right,
or
so-
field, solar compass, Jacob's staff.
Okay, do you know what do you know what a land parcel / cadastral grid system is?
Not really.
Okay, so what you posted is called a public land survey system. Okay, so what a public land survey system is a land parcel / cadastral grid system, right? So you don't even know what you just posted, right? You don't even know what that is. Right, so you could...
I know, like, it's used to distribute parcels and, stuff like that.
What's a parcel? What's a parcel?
Like acres of land, certain quantity or number of acres or something.
Okay, so just basic research on it, right? It says that it's not a geodetic measurement of planetary curvature. It's a way to divide, describe, and register land, township, ranges, sections over a region. It does not measure or assert global shape.
Well, so the thing is that,
Hold on, let me continue, right? Right, so adjustments for curvature are built in. Okay, the PLSS acknowledges that you cannot maintain perfect square mile sections over large areas because meridians coverage due to Earth curvature, so it includes automatic correction lines and lets certain section boundaries deviate from perfect squares to accommodate for curvature, right? So they don't actually measure any curvature, they just add it in, right? Pre-assuming the globe. So this isn't people going out and actually taking empirical measurements to prove that Earth's a globe, right? This is just presupposing it's a globe and then dividing the grid system up, and just adding, this is just like another model where they're just adding the data into a spherical coordinate system type of thing.
Yeah, I posted the screenshot from your source that you posted with the dimensions of curvature. They're in the same paragraph. And the preceding paragraph I posted right after, where it says why curvature is going to be considered. And it literally says right in here that they're doing rectangular plotting, and then they have to, after they take the measurements, they then adjust them post facto. Right? So just like DJ said, this seems to corroborate that they're altering the measurement with the presupposition, as is shown in that paragraph, that we're measuring rectangular plots, but because we already know the Earth is a globe, we then have to put it through some other transform. So like he said, it doesn't seem to show that they're measuring raw curvature at all.
Well, I think the way it worked is basically they were trying to line it up with the latitudes and longitudes, but then they're like, oh wait, the latitude isn't going in a straight line; it's curving, So they had to readjust and make the line,
Right. So they took their rectangular straight measurements and then curved them to a matrix of a latitude line, which is a model of the sky being superimposed onto the ground. So they're synergizing two things, not just measuring raw curvature.
Right. So the sky is a sphere, but the ground is flat?
No, the sky is interpreted as a celestial sphere, which is observer-centric, right? Latitude and longitude are from the sky, right?
Right, but the observer is on the ground, right? So
right.
How would a flat Earth...
Let me ask you this question. It's very simple. So wherever they are, like you said, they have to synergize their measurements with this assumed model. The problem is that when they do that, they actually have to curve the down direction to preserve the angles to the celestial, because the actual raw measurements don't match the assumption of mapping the celestial sphere onto the ground. They actually have three models that they have to synergize together, and it results in curved plumb lines. In fact, I could quote this from you directly from Helmert, Higher Mathematical Theories of Geodesy, the Grand Poobah himself. Yeah, let me get it for you. Post it in here for you.
Give me a second here. Hey, you know what? I'm just going to go to the main server and pull it off of there because I was going through my personal files on this device and it's not fast enough. So let me go over here. I actually have this saved with a bot command on 24/7 Flat Earth Discord for easy retrieval.
So does relying on the sky for navigation and surveying, does that provide inaccurate results?
Well, I mean, if it provided 100% accurate results, there'd be no need for any transforms, correct? So it's not well,
like a projection?
Yeah, projections, transforms, synergies, reductions, etc., etc. Look, Helmert's book is like two volumes, hundreds of pages each, all with mathematical transforms.
Well, because the sky would map to a spherical Earth perfectly, but if you try to map,
no, it doesn't though.
But like the spherical sky doesn't map to a flat Earth perfectly.
Yeah, it doesn't map to a globe Earth either.
It doesn't?
No.
No, look at this. Look at this. What I just posted here, homie. Check it out. So this is from Helmert's book, which I apologize I didn't bring the link in with this, which will take you straight to his book. You can read it yourself in PDF form. So you could see there. Look at the image of that hill and see how they have so many different 90-degree angles at different heights. And they have the reference ellipsoid, the geoid, the Earth's surface, and the plumb line is curved.
Mm-hmm.
Right? That's because they have to take the real world measured data and then synergize it with a model, which itself is synergized with another model of the sky. So it's not the case that they're just taking raw measurements and giving you the raw measurement. That's not what's happening.
Okay. So you believe that plumb lines can point in a direction other than down?
Dude, pay attention real quick. This graphic that I'm showing you is an attempt to synergize these models into a conclusion of the Earth's form based on different data points that can't be translated one for one. So they have all these matrices of transform, and that forces them to curve the plumb line on this piece of paper. That doesn't actually mean the plumb line is curved in reality. They're doing all this to preserve coordinate systems.
Yeah. So I agree on a spherical Earth, the plumb line wouldn't necessarily point down. It would be close, but it'd be slightly off. Depending on if you're next to a mountain or something. But on a flat Earth, isn't down just down? Like there's no gravity.
Well, on a flat Earth, you're not assuming that the sky maps one for one to the territory, right? Like globers do, even though that's not even true in the globe model. The flat Earthers are under no obligation to synergize the interpretation of the sky with the ground. The ground is simply an object, right? It has structure, and whatever the structure of the ground is, whatever interpretation of the sky doesn't change the structure of the ground. No different than Helmert doing this synergy, which requires him to curve the plumb line, actually changed the shape of the hill. The hill is the shape it is. These coordinate systems and mapping systems overlaid on the hill being forced to be curved is just a construct of his imagination.
Right. But if there's a sphere around a flat Earth, the only way you could see the totality of the sphere would be if you were able to go on the opposite side of the flat Earth and view the opposite side of the sphere, right?
No, dude. It's not a sphere around a flat Earth. It's a celestial sphere from the observer's standpoint.
Yeah, the observer who's standing on the Earth and can observe based on the shape of the Earth, like that's
right. It's the appearance. It's the appearance of a sphere, which you can reverse engineer into a spherical coordinate system from the observer's standpoint. But the actual shape of the sky is not necessarily a sphere. It's just called the celestial sphere.
Uh-huh. But you can map
because
out
you can't observe the entire celestial sphere simultaneously. You have to translate yourself over the surface, right?
Right.
And so it appears as if the sky, depending on how you're thinking about it, is rotating around you. But that's just based on the observer. It doesn't mean the shape of the sky is a sphere.
But couldn't you map out the celestial sphere as a sphere if you were to, draw it on a ball, right? All the constellations and everything.
Sure, you could pick arbitrary points and do it, but the problem is that doesn't actually map to the ground one for one, which is why they have to do all of these transforms.
But you wouldn't.
Not to mention the fact. Hold on. Not to mention the fact that in order for it to be a one-for-one map with just a larger concentric circle, that would mean the initial reference had to have been a circle in the first place. And since the surface of Earth's water isn't curving to make a circle, then that assumption is false.
So in order to
in other words, you presented us a model of interpretation that assumes the Earth is a giant ball. We presented for you a claim that the water, which is said to be wrapped around a ball, is actually straight and not curved. So ours is actually tangibly measurable in reality and could be validated, whereas yours exists in a hypothetical matrix model interpretation of the sky superimposed on the Earth sprinkled with a bunch of mathematics. Go ahead.
Yeah, so based on my understanding, I don't believe you would have to distort at all the sky in order to depict it on a sphere.
Excellent. So that's well and good, but Helmert would disagree with you.
Who's Helmert?
I mean, the guy that wrote the book, dude.
Oh, this book? From Image?
Yeah, higher mathematical theories of geodesy. I'm butchering the title a little bit. Considered the grand poobah of the field.
Mm-hmm.
The big dog, the cheese master.
I see. And do you believe, is there any accurate way to measure distance on a flat Earth for like over long distances?
Sure.
Because I know like people will say, oh, a plane is not a tool for measuring distance because there are jet streams and things like that. So how would you go about like measuring the distance between countries, for example, or continents?
Well, that's a good point. Since most of them are displaced by water, right? You'd have to take a boat or a plane, right?
Right. You'd have to know the average speed. You'd have to know if there's a jet stream, or I guess there's streams in the water too.
Right, and you could do knots. Listen, you could do knots on a rope, but you need thousands upon thousands of feet of rope, which then they themselves would either be floating on the water or sinking on the water, depending on what type of rope. So you could use a physical mechanical means, but that's impractical. So most people don't. Most people use models that they've already, had it ready at hand, and then, like you said, they just use a basic speed equation or something. What's interesting, though, is that a lot of ships, especially in the south, and it's coming from the south to the north, they have to do what's called boxing. And boxing is when they arrive too early because they actually got there way faster than they thought they would. And so they actually have to stay offshore just doing squares in the middle of the ocean until they're allowed to come into the port.
what's the reason for them arriving too early?
Because their plotted trajectory and speeds are not correct.
Like there was more wind than they expected?
Or maybe there was less curvature than they thought existed. That could be a reason as well.
Yeah, because that would be interesting because, you know, the globe model makes predictions about distances between continents. So if we could even find one example where the distance doesn't align with the globe's prediction, then that would just debunk the globe.
Yeah, fair enough. But guess what else? The globe model also predicts that the surface of liquid water, which covers 70% of the known territory of the acreage of the surface of the Earth, is actually curved. And you just measure it, it's not curved, and therefore you apply the physics of water and all the laws and principles extrapolated over 70% of a surface, since it's not curved. Therefore, if 70% of a surface isn't curved, then the totality of an object can't possibly be a ball wrapped around itself. So that would also disprove it.
Right. But if every single prediction that the globe model makes for distances turns out to be accurate, that could only mean that it's on a ball, right? Because how would you explain that a flat Earth distance?
He just explained it to you. Hang on, he just explained it to you. You didn't even acknowledge what he said. He explained it to you, and you just went, yeah, but. Okay?
Right. Well,
long distance observations, right? Look, the magnet, you didn't understand the ramification of what he just said. He's told you 70% of the Earth is water. It's meant to be curving. It's not curving. We've measured. It's level, right? And you just went, but, and carried on. You know, you don't want to learn anything by the sounds of it. That's all.
No, I understand that his position is that water has been measured flat and level. I just disagree. I disagree with that. So I'm trying to find.
You're disagreeing with nature then. You're disagreeing with the nature of water now. That's what you're doing.
I'm trying to find something that doesn't involve refraction whatsoever, so that way we can have a common ground and find truth.
But water is level. Water is level. Wherever you find it, it's generally level water.
Well, it's not level if you spin a bucket.
Sorry? Well, but then you're spinning the bucket now, aren't you? You're spinning the bucket now. You're creating, and that's the water is in the bucket. Put the water outside of the bucket. Can you do that? No, you can't. Okay? Get real here, man.
I mean, water conforms to whatever forces is acting upon it.
That might be true, yes. Okay, yeah, right. But then it can take the container. But if you put it on the outside of your bucket, it's not going to do the spinning, is it? It's just going to fly up, isn't it? Weak argument.
Yeah, but
you know. Okay, so get real. All I'm trying to say is get real. And my colleague there, hey, I gave you a real explanation in real life, real time, and you just went, but. I don't understand that. You're not wanting to learn. You're ignoring natural life. What you actually know, you can see and touch. You're ignoring that for something that we cannot measure. You haven't even measured it. You haven't even gone out and said, okay, let me go measure the curvature of the Earth and shut these guys up. That's what you should be doing. That's what I'd be doing, for sure.
Well, based on my understanding of science, I feel like trying to use light to measure the flatness or curvature of the Earth is unfalsifiable either way.
No, it isn't. You just have a very, very low understanding of the limitations of refraction, right? Very, very low understanding of it. I've spoken with you before, and the fact that you're not ever presenting any observations and you're just presenting horse shit like you tried to present earlier just shows that you're just kind of coping at this point. You're in cog dis. You're not being honest with yourself.
Exactly. And the expression of horse shit was, excuse me, but unfortunately that's what you're giving us at the end of the day. Heaps of brown stuff. Just get real. Can you get real? Can you get real for a moment in time? Just get real with the thing. Yeah? You haven't gone out to check for yourself. That's the problem. That's the real stuff. Go out and actually look. Take what you've been given, right, and compare it. Comparison. That's what you're going to do now, isn't it? Take the data and go and compare it. Go validate it.
I mean, why would I look at light that's bending to determine the shape of the Earth?
Light doesn't always bend, as you put it, like dramatically. I mean, water is always level. That's for sure. Long distance observations are being made. Okay,
So the light's
you have to go and do
bending,
it, though. You have to go and do it. You haven't even done it yet. You're refusing to do it before even doing it.
the bendy light's just flattening all. It makes it flat in all of the observations. This bendy light just magically flattens everything out to make curvature completely undetectable always.
Yeah.
Well, and
why would the U.S. military rely on its weapon systems, targeting systems, range finding, and targeting computers? Why would they use light that's bending to engage with their enemies? It's kind of weird. Like, why would they use that? I know why. Because it's accurate. That's why.
Thank you. That's it. And then the bunch of Brazilians that they customized their laser beam, and they had each separate beams, a cluster of beams, and they had to hit a target. Well, 20 miles away, I think it was, 24 miles. And it's called a total station. So it's like a receiver. Okay? And they shot it across the Lake Titicaca. Okay? And then you see the receiver flashing out as the laser beam hits it. And it was designed to not diverge, but converge. So it's a focused beam, several beams. I don't understand you, man. You're not even prepared to go out and check. You can't come in and be like that. You're going to be exposed. We'll strip you down, okay? You haven't gone to check. Can't say we're wrong, unfortunately. You just can't even begin. You haven't got a case. You haven't got a case. Bunch of hearsays is all you got.
So, do long-distance laser observations, do those lasers always go perfectly straight?
Well, I haven't done it enough times to say every single time they're going to do that, because that would require, let's say, 100 times. I haven't done a laser beam test 100 times in my life.
Because,
right. So the long distance targeting that the military does with lasers, and they hit the target accurately. Do those lasers always go perfectly straight?
No.
Okay, let's say that's true. So that means you can use a laser that's not always going perfectly straight to get very accurate implementation, right?
Uh-huh.
Okay, so then the fact that it doesn't go perfectly straight would be like a measurement of tolerance, not a measurement of quality, as if they can't be used, correct?
Yeah.
Right.
But my problem is, I have no way of knowing what that tolerance is and how accurate that tolerance is. So I don't trust light as a way to measure the Earth's curvature.
Well, the military touched it up, but the military are using it all the time.
Think about it this way: he has no way of knowing if these measurements are correct. But then how would you know how any measurements are correct?
Exactly.
Ones that don't use refraction, I can understand a little bit better.
What ones are they?
For example, like distance measurements.
Have you done that? It's a question I keep asking you.
Yeah. What distance measurement are you talking about?
Yeah.
Well, like flight times, for example.
But that's not.
How about the distance to a target? How about a distance to a target that I'm engaging with a weapon system on a combat vehicle, and the laser tells me how far away it is, but then adjusts the ballistic trajectory of the barrel depending on the round I have, and when I fire, it hits the target. How about one like that?
Well, no, because then, you're potentially dealing with some other factors.
Okay. So again, we went back to lasers are accurate, dude. They're very accurate.
Yeah, but lasers are, according to the globe model, lasers are bending closely with the...
Yeah, but the globe model doesn't exist, you see. That's the problem. And lasers are a precision instrument. It is a precision instrument. They use it to cut sophisticated and difficult shapes used in all manner of industry. Laser.
Well, hold on just a second, Jen. I want him to finish making the silly statement that he was just halfway through making.
Sorry.
Because he's shooting himself in the foot. So go ahead and finish the shot.
Yeah, what was I saying, Lily?
You were saying that you think lasers curve around follow along with the curvature of the Earth or something along those lines? Is that what you were getting at?
Right, yeah. Yeah, it follows closely to the curvature of the Earth according to the globe model.
Really? Where did you get that information from? Where did you get that information from?
The Wikipedia article on atmospheric refraction, 76R.
It says that lasers will bend around perfectly with the curvature of the Earth due to refraction. It doesn't say that.
Yeah, well, depending on the refractive index, it could be 7/6R, or it could be even higher.
It doesn't say that anywhere on the so that still doesn't align, right? That doesn't say that a laser will bend or follow the curvature of the Earth in all different weather conditions at different locations over different distances and using different spectrums of light in the lasers. It doesn't say that on the atmospheric refraction page on Wikipedia, which I've read about 10 times.
You're always going to have some degree of refraction.
Yeah, but why did you make that statement that the laser beam will follow the curvature of the Earth? Where did you get that from? Because the way you said that you got it from doesn't say it.
Well, you know 7/6R, right?
Yeah, what is that? What is that? I know all about that, of course.
That means that the light is traveling at the same radius as 7/6 of Earth's radius.
Can you tell me what in that equation what represents the light though? What represents light in that equation? Which figure? Is there a letter? Is there a value? Like which part of that represents the light?
Well, it equals to the curvature of the light, right?
All right, perfect. I'm glad you said that. Now, watch what happens if what you said is true. You ready? If the light is traveling at a 7/6 radius compared to the radius of the Earth, that means that all light exists 1/6 of the radius above the surface, no lower and no higher. You see the problem?
Well, no, because the center of the circle is not necessarily in the same center of the Earth.
Yes, it is. 7/6R. The R is the radius of the Earth, and therefore it's in the center of the circle all the time. So you're misunderstanding this equation.
Well, no, two circles of the same radius don't necessarily have the same center. It's kind of
okay. So then that would defeat your whole point, dude. If you can have any arbitrary center of the radius, which is 7/6 greater than the Earth radius, and you put that radius point on the surface, that would mean that the light is thousands of miles above the Earth. How does that make sense?
So from wherever the light emerges, that is the edge of the circle of its radius. And then from there, it will curve downwards at the radius of 7/6R, right?
Holy moly. And right, so if the center of the radius is from where the light emerges, okay, that would make the arc thousands of miles off of the surface of the Earth.
No, I'm saying, okay, if you shine a flashlight, right, and let's say you shine it 4 feet off the ground, well, the edge of that circle is 4 feet off the ground. It's not necessarily aligned exactly with where the center of the Earth is.
Why would you change your apparatus from a flashlight, from a laser to a flashlight, and then offer a different scenario?
Laser works too.
That laser lights conform to the curvature of the Earth. So then now
the problem is. Sorry, go on. Sorry, I interrupted. Sorry, say that again, please, Tactical Droid.
Why are you changing? You're saying, I don't trust lasers. Lasers curve and conform to the curvature of the Earth. And then you offer another example and use a flashlight, which is a worse example of a form of light across a distance.
Yeah, I don't trust flashlights either.
Then why are you offering this as an option?
Well, whether it's a flashlight or a laser, the direction that you point it, that is, or that point where it originates from, is the place on the edge of the circle. So
right.
then,
but you've got a problem. You've got a problem. Your equation is a geometric equation. It's got nothing to do with optics. Why is it being assigned to optics?
Well, the question is does atmospheric refraction exist?
No, the root of this dilemma is the Earth curving, and does it have an R in order for the equation to be valid? When you're making your observation to identify the curvature rate of Earth so that you can get a radius value, you can't assume the radius value already exists.
Well, did you know that a flat Earth has a radius value?
How does that work?
So the radius of a flat plane is infinite.
How does that work?
So, the larger the radius of a circle, the flatter it becomes until you reach infinity, and that's an asymptote where basically at infinity is when you have a flat line.
All right, so then is your radius across a horizontal plane, or is your radius value in your equation below your feet and ever extending down? Which is the radius that you're trying to appeal to?
He's wrong anyway. That's not true, what he said.
Explain it to me.
Because he phrased it as a flat line has a radius, but what he meant to say was that something with an infinite radius at any given point could be perceived as a flat line. He's trying to equivocate both as being equal when they're not. One of them is actually flat, and one of them is curved. Good grief.
But basically,
don't get me wrong, dude, because an infinite radius is incoherent.
do you agree that...
So you're appealing to incoherency. Good job.
Do you agree that if Earth does have a radius, then atmospheric refraction would, in fact, work?
No, I don't think we'll be agreeing. We won't be agreeing with you here, mate. I'll tell you that now. Not in the frame of mind you're bringing into the subject matter.
You don't even know anything. When you say atmospheric refraction, right, you have no idea what you're talking about, man. You're just butchering everything you're saying. It's crazy.
Yes, brown stuff.
Almost not even worth responding to, man.
This is it. This is why you're getting this kind of response. Brown stuff and butchery. That's all you're doing.
Yeah, he fucked up the whole radius thing too. You can't have right. It's asymptotic. You can approach infinity and get an ever flatter and flatter and flatter surface, but it never reaches it. Like he's speaking to it as if it's a numerical value that you can actually work with. You can't, dude. Doesn't make any sense.
You can kind of work with it a little bit.
It's not going to prove anything.
Can you put infinity into an equation and manipulate it? Divide by it, multiply by it, and all that, and get a coherent outcome?
So you just put like 9999999 a whole bunch of times, and then you basically...
Thank you fucking very much, right? So you're approaching it using real hard value, right? Thank you. It's asymptotic. Like I said, can't use it as if it's a real value, but you were speaking as if you could. And I have an infinite radius. That doesn't make any sense.
I don't think anybody here would argue that the flat Earth is perfectly flat to an infinite degree, like down to the very atoms. It would like perfectly be straight.
That's not the point. That is not the point. What you were speaking to about having an infinite radius, it doesn't make any sense, dude.
So, like, if we look at the flat Earth, right, and if the left side of the flat Earth is even one atom higher than the right side of the flat Earth, then it technically has curvature.
Dude, if you have a plane with variation, okay, that averages out horizontally, sure, it's curving up and down, up and down, up and down, averaging out horizontally like a sinusoid, right? You take a sinusoid, just plot it on a graph, it's going to go up and down from left to right forever. Doesn't mean there's a radius to it.
but it's not perfectly horizontal down to the infinitesimally small degree, right? There's going to
I
be
didn't
some
say that.
variation.
I didn't say that. I didn't say that.
So then,
What's wrong
therefore,
with you, dude?
there is
What's wrong with you?
there is curvature, even on a flat.
All right, great. I'm glad you said that. So check this out, 20 Cups. 20 Cups, you ready for this? You ready for this? So he just said, if something has an infinite radius, it's flat. He said that, right? We all heard it. He agrees.
Yeah.
So guess what? Yeah, guess what has an infinite radius?
What?
The celestial sphere.
That's true.
Oh my goodness, guys. Let's retire. Woo! That was too good.
It was good. It was good. The other good response I liked was somebody said to one of the characters earlier on, "You're the one with the dog ate my homework." I thought that was such a quick response. The guy that said he couldn't present his stuff because he's not at his computer. I said, "Well, you're the one that had the dog eat it."
Yeah, brother. So check this out. Listen, lines, and points, once they reach a certain distance, they're, from your vantage point, they're functionally equivalent to infinity. And so they can be expressed in quaternion lines, right? And those can be expressed as rotations rather than translations around a central observation point. But the functional radius is infinity. So by his own admission, he just said that when we look up at the sky, we're looking at an infinitely flat sky. Congratulations. So if the sky is flat and you said it's mapped to the Earth as a globe, how does that make sense? It would only make sense if the Earth was flat.
Yeah, but it's flat in a big circle.
Oh, awesome. So it's a giant flat circle orientated horizontally, which is congruent with the physics of water and the surface of the water, which is flat. Good job. So you agree the Earth is flat. Good job.
Flat earthers are retarded.
No, was he talking to me this morning when I mentioned this, that this was the celestial sphere and the paradox?
No, I wasn't here this morning.
Okay, because we were talking about that this morning.
Yeah, obviously the celestial is not a sphere. It just looks like a sphere because we're standing on a spherical Earth, right?
Holy crap, dude. You actually don't know why it looks like a sphere, do you?
Yeah.
You don't know why. Even though I just explained it.
Well, because if you're standing on a flat Earth, then the sky would look flat. If you're standing on a globe, and it would look spherical.
That's
Wrong, dude. Wrong. You totally missed it. You totally missed it. But that's okay.
If it's standing in a Home Depot, it looks cubical.
Listen, let's not mock him for not getting it. Let's help him get it.
Okay. I'm listening.
The reason why it looks like a sphere is because from your vantage point, every point is of an equal range, which is infinity, and then it can only be displayed as distribution of angles, which are going to be radial around the observer's standpoint. So it's going to look like a sphere around you. Not because it is a sphere, but just because that's the nature of its angles compared to you.
Yes.
So the object you're standing on, so check this out, the object you're standing on wouldn't change that. The angles of propagation from you, from the light, and from the ranges wouldn't change regardless of the object you're standing on.
Mm-hmm. Yeah, so maybe I'm using the wrong term when I say celestial sphere. Maybe there's another term, but what I'm referring to is the map of all of the constellations.
Yeah, we know what you meant. No, we know what you
that
meant.
may be the case. Yeah, that may be the case, but the thing is that the mainstream, which has done all of this modeling, right, they call it the celestial sphere, and they use it in that manner. So that's what they're doing. So if you have an alternate theory to the mainstream adopted theory, by all means, you can have it. But that's not the way that they made all of this construct around us, that the world is a globe and the observation angles to the celestials can actually inform us about geometry, not only in the present, but also in the past. to where they retro-engineered their assumed location in free space relative to initial expansion point and created an entire religion and creation story around it. Yeah, those are two different things, my brother.
Yeah, yeah. And what you've described is the mainstream with your celestial sphere. You haven't said anything that is alternative yet. So I'm yet to hear it.
Well, what I'm curious about is like when you guys say that atmospheric refraction won't work, you say it's because we're assuming the R value, but that implies that if the R value exists, then atmospheric refraction would work.
It only exists as an assumption at this point.
No,
and obviously there's an R value on any spherical radius, yeah. But, the Earth is not measuring as a sphere.
The definition of atmospheric refraction has nothing to do with an R value or a globe, right? It's it's an effect that takes place within a single medium, that you have a change in the refractive index, right? It can happen inside a room of a house, right? Or it can happen over an observation over a lake or over land, right? It's not dependent on the Earth being a sphere at all, right? It can be misused in certain ways, right? Where people might try to bake the radius value in to try to use it to explain or reverse engineer certain observations and things like that. But in itself, right, the definition of atmospheric refraction says nothing about the Earth, a globe or anything like that.
Real quick, for DJ's benefit, earlier when he was talking about the concentric circles, one being R and one being 7-6R, and that you were then focusing the circle arc on the observation point, you wouldn't even need a 7-6R to do that. You could have two circles with the same R and move the center point of one around the other so you get an arc that you assume is the light ray that would reach the observer from the target. So you don't even need a bigger radius, which means it makes no sense, because we actually know what they're doing with the 7/6R is they're inflating the radius of the physical Earth and assuming a straight ray between target and observer. So it's not the case that they're applying it to the arc of the path of the light. That's not what they do. All right, go ahead.
Well, an arc has a radius, and that radius could be different from the radius of the Earth.
Okay, one more time, friend. When they attempt to use this 7/6R, it's applied to the Earth, assuming straight rays of light. They're not applying it to the arc of the light. They're applying it to the curve of the Earth in order to assume a straight ray that's passing over a lower hump. Okay, so they're actually inflating the size of the Earth to lower, via the circle segment formula, the apex of the arc to be a lower altitude, to give you the impression that you should be able to see an object that would otherwise be occluded by a higher arc in between point A and point B. So it's just a sleight of hand trick.
Right. Well, so yeah, it's like you can see farther as if you were on a ball of 7/6R, but that's just because the light's arc is traveling at the same radius as a Earth of 7/6R.
No, it's not necessarily because it's traveling at the same radius, dude. Holy crap.
I mean, obviously they aren't saying that refraction makes the Earth physically bigger, right?
Well, then how come they can't model it any other way?
Yeah, exactly. It's geometric. It's a geometric equation.
It's just relative, right? It's either the Earth getting bigger or the light's radius is getting bigger, to achieve the same effect.
There's one thing you're not going to be able to validate, right? You're not even going to be able to show a single observation in reality that matches up with standard atmospheric refraction 7/6R, right? So you can go and try to find an observation that includes accounting for that, right? Presupposing a globe, presupposing the radius, adding that 7/6R in, right? Find one observation that aligns with that. You're not going to find anything even close to that.
Well, that's because refraction is much stronger at 1 foot observer height over ocean water.
Show it anywhere.
Oh, bro. Says who?
But is standard refraction a form of...
Does that mean you can see further the lower you get?
Yes.
Yeah, I've never seen a single observation that matches up with your standard atmospheric refraction. Not even close, dude.
Well, earlier you said that atmospheric refraction doesn't have the R value in it, but standard refraction does have the R value. So
it's completely
crap.
different.
Let's not pass over what he just said, though. He said, if the Earth was a globe with refraction, the lower you are, the further you can see.
Yes. That's true. Because low to the ground has a higher refractive index.
That wouldn't be 7/6R then.
Would be much greater than that. Probably like 1,000 over 6R.
Dude, you have no idea what you're talking about.
You could see your own ass.
Yeah, so atmospheric refraction, especially when low to the ground, is primarily dominated by temperature gradients, right? Not the gradual decrease of the atmospheric pressure as you raise in altitude, right? That's completely superseded by temperature gradients. And the lower you are to the ground, right, the more temperature gradients are responsible for having a change in the refractive index. It's got nothing to do with having a specific light bending a certain way when you're lower to the ground. That's absolutely ridiculous, right? What if you have a warmer layer of air closer to the ground, right? It's going to be the opposite as if you have a cooler layer of air close to the ground, right? Like if you have hot concrete or if you have cold water or something like that, right? It's going to create either a warmer layer closer to the ground, which is going to have a lower refractive index, or a cooler layer will have a higher refractive index. It's like a inversion. It's called an inverted temperature gradient or inverted refractive index gradient. So you really need to learn like these basic claims from the globe side about how it even works.
Well, it's very complicated to understand.
It's really not. It's actually really pretty easy. You could like learn all the basics in one day doing research.
Each medium has a different refractive index, and then
we're talking about observations through a single medium.
Well, no, because the atmosphere is not a single medium.
Yeah, it is.
Using the temperature gradient, temperature affects the density.
It's a single medium, dude, and you can have a change in the refractive index within the single medium. That's what they call atmospheric refraction, dude.
So,
so check this out. If I have let's check this out, friend. I have a pan. It's made of iron. Okay, a single medium iron. The whole thing's iron. When I put it next to some heat, part of it's hot and part of it's not. It's still only one thing.
And that is the characteristics of steel, isn't it? That it absorbs that heat and it spreads it all the way around gradually. Same with the atmos, varying temperatures, but it's still one medium.
If it was one medium, then the density of the atmosphere would be uniform throughout.
It is one medium, mate. It is one medium. Air.
One. Hey, medium. You know that when metal gets hot, it expands, and it expands at different rates, which is why you can't fit two pieces together. If you cut one when it's hot and you cut the other when it's cold, you have to actually wait for them both to expand to cut them so they fit. So you're wrong, sir.
I mean, it's the atmosphere is a fluid, right? So
now you're getting somewhere.
And the fluid changes density throughout, changes temperature throughout.
Right, it's one medium still, though.
No.
Oh, here we go again. So it's not air then.
It is air.
Right then.
Okay, so it's all air. And then sometimes there's pockets of not air.
No, there's pockets of denser air or less dense air, which would be a totally
within the same. No, they're within the same medium, dude.
Yeah.
Like, why are you focused so hard on this word medium? Why don't you just accept that it's one medium that has different pockets of density and heat distribution at any given time because it's dynamic, anisotropic, and non-homogeneous. There you go. How about that? Is that good enough for you?
A medium is not just the material or the substance itself. It also includes the density.
Holy crap, dude. Dude, nobody in their right mind would say that this iron pan is two mediums just because one end is hotter than the other. Are you kidding me, dude?
Technically.
Yeah. Okay, cool. I'm glad you said technically, because that means that you could prove it with a citation demonstrating that that's how it should be considered. Can you get me one of those?
Dense air and
Can you get me? Hey, bro, I don't need an explanation. I need a citation. Do you know the difference between the two?
Uh-huh.
Yeah, get me one. And then I'll allow you to continue using that term. Otherwise, you're going to have to refrain from using it.
Okay.
I mean, essentially, you're saying that a gradient is an infinite medium. Is infinite mediums, sorry.
Yes.
It's ridiculous.
Hey, guys, it's Make Up Your Own Words Day. Jen, you go next. Hey, Jen, you pick one. You pick one and you go next, bro. Go ahead. Make up a word.
Let me make up a word. Combobulated. There we are.
Hey, if the Earth was combobulated, it would be flat. The Earth is combobulated, therefore it's flat. Wow, that was easy. All right, so let's not focus on the word medium, and let's focus on the actual qualities that you're trying to talk about, which is the differences in temperature and density. And okay, focus on that, so we don't have to get pedantic over what the word medium means. For goodness sakes.
Right. I'm just saying that dense air is different from not dense air.
In what way?
The one is dense and the other one's not as dense.
Okay, that's great. How's that relevant to the discussion?
And therefore, refraction, when it goes from the more dense side to the less dense side, it can refract and bend in a certain angle.
All right, finally, you made progress in your claim. All right, hopefully someone else will critique it, because I got to go on mute.
Depending on the difference between those two densities is the angle that you get.
No, dude, you're confusing like Snell's law with like a gradual gradient change within a single medium, right? So you're confusing Snell's law formula where you have like two separate mediums that have different refractive indexes, and then you have the light, right, travel on an angle from one medium into the next medium, right, and then it's going to deviate, okay, and you can use Snell's law to do the calculations of that, right, based on the angle and based on the refractive indexes of each separate medium as the light goes past the sharp boundary layer, right? The sharp boundary layer is like one of the key things that you're going to need to be able to use Snell's law. The difference between Snell's law and atmospheric refraction is that you have a gradual change in the refractive index. It's not a sharp change, right, where it like instantly deviates. Okay, so the change in the refractive index is primarily controlled by temperature, and it's just going to be a slow change, right? It's going to go slowly warmer to cooler or cooler to warmer, and it's going to go higher refractive index to lower refractive index, right? So it's completely different than Snell's law, and it's in a single medium.
Does Snell's law work if you have three mediums?
We don't live in three mediums.
Yes, it does. It's demonstrated in like high school textbook.
Okay. What about if you have four mediums? Does Snell's
you've
law
got like
work?
an air to a prism back to air again. So you're going to get three different angle changes.
Yeah.
Okay, how about 732 mediums? Does Snell's law still work?
Well, I mean, you'd have to have a powerful light, though.
Snell's law.
You'd have to have a powerful light.
Hold on. Snell's law. DJ mentioned that there has to be a transition layer, a thermodynamic boundary layer. This is a molecular boundary formed by the bonds of molecules. You don't have a surface with gas molecules in order for you to get an angle off of, but you do when you have bonded matter providing a molecular boundary, a structure that can provide that transitional layer to change the phase of light. That's what's happening. The phase of light is actually changing.
Yeah, and then as the light goes through all these mediums, that light's going to weaken. By the way, it's going to weaken. Can't have the same potency.
Yeah, look, Kiba,
And
you're completely
furthermore,
wrong.
it changes based off a wavelength.
Yeah.
Oh, sorry, go.
Yeah, Kiba, no one, even in the mainstream on the globe side, right, is going to agree with what you're saying right now. Okay,
Yeah, so
like the subject matter experts on the globe side will say that exactly what we're saying to you, right? How the air is just one medium, and you can have a change in the refractive index within the medium, right? And it's primarily controlled by temperature.
So my point is that with a temperature or density gradient, Snell's law is still applying. It's just continuous rather than a single instance. Like it happens throughout the
Well, it's
entire.
not Snell's law. Snell's law is a very specific case. This is more of a generalized quote unquote refraction. Okay. Now here's the problem. The more refraction you have in a gradient index medium, the more chromatic dispersion you have based off a wavelength, which should start to separate the colors out, which means if this is truly happening the way the globers say, then you'd start to see rainbow bands of light of objects off in the distance. Nobody ever sees that. So,
yeah,
the world should look like a hippie's lounge room.
That's right. Yeah,
So
terrestrial refraction is BS.
The same. Like if you go to any .edu website, okay, you go to the optics section, you're going to see a section on Snell's law, right? And it's going to define Snell's law very specifically, okay, just like we did. And then you're going to have another section called atmospheric refraction, right? It's going to have two different sections because you have two different things to deal with here. Just like we explained to you, they're not going to have atmospheric refraction in the Snell's law section, right? They're not the same thing.
Right, and if you're hitting a target with your laser beam at 24 miles away, it means the Earth isn't curving. You're hitting a target. And then don't forget, AI said to you, military applications, hitting targets, lasers 60 miles, painting a target away. So unfortunately, you're just not winning with this curvature thing. It's not there, man. And you would need to go out there to know that, though. You haven't gone out to investigate yet. Don't forget that. It will become apparent when you actually go look for it. You had never seen the curvature of this man. He's going on like he's seen the curvature of the Earth. If you've seen it, you would have a photograph of it that we could see. Present us what you see. Because that would be knowledge.
I posted a screenshot showing it's called the differential form of Snell's law, which is continuous throughout a gradient.
Yeah. What about the curvature of the Earth, physical curvature? Have you seen that? Because that's what we're talking about really at the end of the day. Have you gone out to... Yeah, where did you see it? Where?
Mr. Sensible's balloon.
Okay. So, and you have pictures then, surely? Surely you would have had your camera on the go there.
Yeah, I have pictures here. I can post them.
Present them. Present them. Let's see what you got. And I know DJ's thinking already what camera, what lens, and et cetera, et cetera.
Oh no, I've already got counter screenshots of this exact same video.
It was a rectilinear lens.
Yeah, so how come the horizon flattens out constantly as the camera angle changes? And how come the yellow line and the black line, right? The yellow line at the top is convex and the black line at the bottom's concave because it's barrel distortion. Rectilinear lenses aren't like a solvol for barrel like they still have barrel distortion and just general distortion.
So every lens has some distortion, but the difference is that the picture that I posted, because it's on the bottom half of the lens, the distortion is actually making it flatter, but you can still see curvature. Therefore, it proves the curvature.
Yeah, but I've got screenshots from the same video that shows it flat when it's at the bottom of the frame as well.
Right, but every lens has some distortion, so you just happen to find the one screenshot with a little bit of distortion
Well,
visible.
it's not going to, if there's no distortion, it's going to always be this like that, isn't it? It's not going to change, right? The fact that it changes shows that it's a lens effect.
And there's a lot of horizontality there in that shot anyway. A whole lot of horizontality. I don't see curve. Unfortunately, this man doesn't understand, does he?
If you compress the image horizontally, you'll see curvature.
No, compressing is not what we do here. We don't compress.
Hey, guess what? That's what I would expect with a rectilinear lens, by the way.
Really?
Yeah. How do rectilinear lens distribute the distortion? Because they have a certain orientation to distribute the distortion in a manner that preserves certain qualities at the expense of others. Do you know what they are? I'm not going to tell you the answer. I'm going to demand that you go find it out, since you presented this as your evidence.
Linear rectangles.
Okay, dude. So you don't know what you're talking about. Great.
Not exactly.
It's fair enough, and I'm not chastising you for that. I'm just saying that there is sources out there that can tell you the way in which rectilinear lens distribute the distortion, right? And then you could apply it to the image, and then you'd understand more what you're talking about, rather than just presenting it with the kind of like an ad hoc explanation that you had. So I'm saying, like, you should do that legwork and come back with that citation, and then you can pummel DJ into incoherent oblivion and make fun of flat earthers, and then dance on our graves.
Well, yeah, but that starts getting into the weeds, and then people's like attention span starts waning, and then it's like
It's not that much weeds, dude. It's really not.
Yeah. And then you can also, why not just try a regular lens and just take a picture, about the rectilinear lens. Why not just take a normal picture with a normal lens? What's going on here?
There's no normal lens, bro. That's the problem.
Well, yeah.
So are you saying that rectilinear lenses are sort of correct for certain image errors or whatever, right? But at the expense of ignoring others, like focal length or something?
It's just the least distortion of any lens that you could find.
All right, so your claim is because you've got the horizon. Kibi, you've got the horizon at the bottom of the frame, right? So you're saying that, right, you can still see curvature, because the horizon's at the bottom of the frame. So as you move that horizon up higher in the frame, you're going to see more and more curvature, right?
Right.
Okay, so here's screenshots from other points in the video where it's much higher in the frame, and there's no curvature.
Yeah, but that's diagonal.
Yeah, well, so now we've got lens distortion.
Yeah,
as it pans around and goes diagonal and whatnot. Then all of a sudden, now we've got lens distortion. And I've got more screenshots where it's flat across the bottom of the frame as well.
When you're taking an image that is not in the correct orientation for the lens, then it's going to have more distortion.
There you go. That's a clue. That's clue number one. If you actually go do the legwork and find the citation, you're going to find out something else interesting.
But the point is that the image that I posted, barrel distortion, if it were flat, it would cause a convex shape. But what we see is actually a concave shape. Am I wrong?
There's all sorts of different barrel distortion, right? Go look at pin cushion distortion and whatnot. Different lenses behave differently, and who knows what orientation he has the lens at, right? Because you can easily flip the footage, right, in your post-production software to make it look like it was oriented a certain way.
Yeah, check this out too. If your camera isn't properly pressurized, then the air and the stuff within the camera is going to alter the image and create a lensing effect that's additional to the regular lens. So when they do high altitude photogrammetry, they have to specifically count lenses that go through the process.
Are there any lenses which have pin cushion distortion at the bottom and barrel distortion at the top?
Listen, dude, it's your piece of evidence that you presented as conclusive. You have to provide that data, not us.
He totally skipped past what you said, AR. That's just crazy.
Yeah. All I'm going to say is a flat earth. That's all I'm going to say when he asks that question. It's a flat earth, mate. Prove it a globe. Go ahead.
Sorry, whoever was speaking before I spoke, I was having some like technical issues. I couldn't hear you properly.
Well, here you go. It's not curving in this one. Right? It's higher in the right. It's oriented like you want it to be. It's higher in the frame, and it's flat.
Well, yeah, but the string is blocking the curvature, so you can't see it properly.
Oh my god.
But I could find an image where the Earth is on the top and has curvature. The Earth is in the middle and has curvature. The Earth is on the bottom and has curvature. Right? Normally with distortion, you have like differences depending on how it's oriented.
Well, it changes throughout the video, right? It goes all over the place. If the camera tilts or anything, right? It goes from convex to concave to flat, right? Different points in the frame. We're seeing all sorts of different things, proving that there's lens distortion. So you can't say that there's no lens distortion. I've just shown it in images. But you're saying that the line that's slightly concave is blocking the Earth curvature, which would be convex. That doesn't make sense either.
Yeah, it's obstructing the view.
It's a tiny little thin line.
It's a tiny little thin obstruction.
Think about what you just said. Look at the image and think about how dumb what you just said was.
Light can't bend around obstructions, so that proves it.
You know what else? Light can't bend around abstractions either.
Unless there's butane involved.
So no globe curvature then. Right, there we are. Flat Earth again.
Oh, so the only way to model it is with extreme examples that would be equivalent to us living on a giant ball of fire or a giant frozen ice cube, which we don't live on. Good point.
Wait, why would it be fire or ice cube? What do you mean by fire?
Because of the extreme alterations in temperature and density that would be necessary for your claim to be true. Like your feet would have to be frozen and your upper body would have to be on fire.
I disagree because Mick West, his simulator, he was able to show with just a couple degrees of difference that you could get very long distance refraction.
Over what scale?
Over, you mean like in terms of vertical or horizontal, or? I can look up the video.
Did he do it at his dining room table, or did he do it out over a 75-mile frozen lake?
Well, he did it on a computer.
Oh, great. That's awesome. For a second there, I thought you had an actual demonstration.
No, just a computer model.
But I trust him to use accurate, data and math and all that.
And what data did he use?
I don't know. I wonder if he published what he probably did, right? Like his methodology. Probably has it somewhere. So it's metabunk.org/refraction. I'm looking to see if he has his methodology listed somewhere.
So we already know his methodology. Assume the Earth is curved, alter the path of light till it fits the observation in question, and then claim that that altered path actually occurred in reality. That's his method.
Well, I'm assuming he got his math from, credible scientific papers on refraction, right? Probably.
Yeah, probably right, bro. Yeah, probably. Which one?
You don't get it. He still doesn't get it. So, for example, like Walter Bislin, when he attempted to say, you know, how can this observation or that observation happen? He just puts it in his slider, slides the refraction to a radius of 60 million miles, then says ipso facto, this must have been what occurred. Holy crap.
That's exactly the same thing Mick West has done on his computer model. Same thing.
I can't find his methodology.
Right, because it's nonsense, right? It's just using ray tracing. So he's just bending. It's just like sliders. Why would he lie?
That's a joke, because people always ask, like, why would NASA lie? No, but,
Anti-flat earthers lie all the time, right? They'll throw their own mainstream. So like they'll throw their own people under the bus, right? Just to try to make a point in an argument that they can't admit they were wrong about.
Well, yeah, like I'll throw Neil deGrasse Tyson under the bus any day of the week.
You're also throwing all of the experts in atmospheric refraction under the bus when you talk about that as well. And when you talk about lasers perfectly bending to follow the curvature of the Earth, you're throwing everything under the bus.
Well, I don't care how much of an expert they are. If they're blaspheming against the globe model, then they're wrong.
No, you're the one that's doing that.
I found a video from Mick West, technical analysis is or whatever. I'll post it in the side chat.
Yeah, Mick West has never presented any real-world observations at all.
Well, this is his methodology.
He's a video game programmer.
Yeah, that's his methodology anyway. So you can take it or leave it.
What's his methodology?
Well, I have to watch the video. I just barely found it, but just sharing it in case anyone's curious. Looks like he has some good math in there.
Yeah, Mick West is just a stain on society, mate. That's all he is, man. A stain on society.
He's got some good math in there. It's got an R value. That's nice.
You know what's interesting is game developers actually, they use typically flat planes as their...
Well, because that's what it is. Flat Earth. Of course they have to.
Yeah. There is like Star Citizen and stuff like that. Like, what's the other one? No Man's Sky, that have like spherical worlds.
They still need a horizontal baseline before they could get their circle.
That's something they don't understand, Jen. They don't understand.
What does that mean?
Software developers, when they're building their world to be a sphere, but they start with, when they open up their computer screen to begin with, they'll start with an X and Y grid with Z as an elevation. And they'll construct this 3D world, this spherical world, based upon that coordinate system. And you guys don't get that. That's why we tell you it's all just a mathematical construct.
Yeah, I've done that equation on a game development thing before. I was playing around with Unity and I turned a cube into a sphere based on like certain.
Yeah, but let's be clear. The orientation of the XY coordinates relative to the computer screen you're looking at is a convention. They could have made it diagonal. And then every time you open up your computer, there'd be a diagonal XY coordinate.
Yeah. But there's still, obviously there's still a grid of XYZ in space, whether it's a flat Earth or a sphere, right?
But that would be the point, though. You can take that grid and you can construct any model, any shape. You even just said you took a square and you sphered it up. That's the whole point. Mathematically, all these things are interchangeable, where you can make a model. You can make a weird model and say, oh, the math, the datum, it works. Those points, they work mathematically. So then, therefore, this is the shape of the Earth. It won't be a sphere and it won't be flat. It's just a whole nother shape. But because it worked out mathematically, if you were born into the world and you were taught that weird shape, and then all the math lined up to that, then you would be in here right now saying, guys, the Earth isn't a globe or flat. Like, I know it. I have the math to prove it. And then you'll show us a weird shape. But that's the same thing. That's equivalent to what you're doing right now, saying it's a globe, guys. We're telling you, dude, your math created that model, that globe, that your reality. That's all it is. It's a mathematical construct. When you're talking about surveyors earlier, they're taking an angle to a distant object with a straight line here. Then they're going to apply math to then make it become the mathematical construct that you've been talking about for the past couple hours. Maybe you're going to eventually get this or not. But I think I heard AI wreck you about 20 times already. So I just wanted to jump in because it's getting difficult to listen to you ignore the facts that you just are not grasping. And not to knock you down, dude. Maybe you're just not ready for that, to click yet. I don't know. But keep asking questions. I think maybe people giving you the answers eventually, you'll hear the truth that you need to hear. I don't know.
I agree. If you use light, the Earth measures flat. I'll just, raise the question.
Okay, so you just admitted you don't have a single observation that matches up with the globe. Right, so there's no observations that prove a globe, right?
Well, I'm sure
it's just light makes it flat somehow.
I'm sure a white swan wouldn't prove the globe, though. It would just prove that refraction.
Well, there is no white swan, is there? You don't have one to present.
If I find a white swan, would you accept the globe model?
Well, so
not because we still have white swans.
Yeah, so you would have to account for all of the possible variables if you're making a hyperspecific claim. We're not making hyperspecific claims, right? We're testing the globe and we're getting orders of magnitude differences. Okay, so if you want to make a specific claim, a hyperspecific claim, like this perfectly matches up with the globe, then you're going to have to account for the things that could skew the observation.
If I were to take a long distance observation on a flat Earth on a day where the visibility only permitted me to see 1.2 miles far, that doesn't prove that it's a globe, right?
No,
that would be a terrible day. Yeah, that's a terrible day to choose to go and do an observation, dude.
Yeah. That'd be heavy, thick fog. That would have to be heavy, thick fog, because that's the only experience I've ever had that I can't see a mile. Get out of here.
Yeah, but we're looking to 1.3. So yeah, not heavy fog. That's got 5 meters right in front of your face. No, not that. But yeah, it's going to be the atmospheric conditions, and as it clears up, you'll see further.
Yeah.
All right.
But a globe earther would argue that it's not necessarily that it's clearing up, but that the refractive index is changing throughout the day as the temperature changes because the sun and stuff like that.
No, they wouldn't argue that unless they were completely bricked, right? Then they're not gonna. They're just gonna say, "Oh, it's really foggy, and that's the reason we can't see very far." You're not going to see a crisp horizon line or anything like that. You're just going to see a foggy haze in the distance that you can't see far through.
Right, that's it. And then you have to have your fog lights on when you're driving, obviously.
Driving through the fog, you're like, "Oh, today matches up with the globe, right? Because it's really foggy."
So you're saying if I could only see 1.2 miles or so and the day appears to look like a clear day with no fog, you would accept that as proof of a globe?
Show me an observation where the horizon is 1.2 miles.
That's not even an accurate analogy because nobody's saying that the horizon means you can only see 1.2 miles away. Holy crap.
Yeah. Crazy.
What that means is that that's where the apex of an arc of a tangent line from your observer's point would intersect the Earth. It doesn't mean you can't see anything beyond it. Holy crap.
Think about that big mountain.
Yeah, but that's when curvature starts to drop.
No, dude, come on, man. You wouldn't be able to see more water.
Hoping against hope, against hope, against hope.
Yeah, you shouldn't be able to see any more water beyond the horizon at 1.2 miles, right? If there's like a boat at like 2 miles or something like that, right? Or a mountain or a city or something like that. You're still going to be able to see those things, right? Not in this foggy day that you're talking about, though.
Yeah.
I'm not talking about a foggy day per se. I'm just saying that you could argue that the visibility wasn't as good on one day versus another, right?
We always say that. That's our position. Sometimes you can see the island of Oahu from Kauai. Other days you cannot see it. It's just one of those things.
Right. So even if I found a picture of a 1.2.
Yeah, try to find one. Good luck with that.
Yeah, please find one, please. I'd love to see it myself.
I can find one, but if I found one, would that mean you're now a globe earther?
No,
we can talk about it. We can talk about it once you find it.
Yeah, how could it? Because the next time we'll see one that's 29 miles away, I'm going to see. Get out of here, man.
That's my point, is it doesn't prove anything, right? It just proves that the visibility
proves the Earth is not curving, man. Definitely proves that.
Is the horizon horizontal?
It would look horizontal on a globe as well, though.
Is the horizon horizontal?
Yes.
Okay, then. You know that horizontal is not a property of a sphere?
Yes.
All right.
Okay, then.
That's it. Can never accept a horizontal with a circle. Never going to accept that a horizon is a sphere. No chance. No chance.
Yeah, I can't accept that the horizon is anything but horizontal. And your horizon is also known as your limiting circle, right? Your limited circle of vision, because you can turn 360 degrees, but you can only see so far horizontally.
He's offering the picture from 1.22 miles. He's going to try and get some observation like that.
If there are 39 miles above sea level, then the horizon stops being horizontal and it starts being curved.
When?
39, kilometers, sorry. 39 kilometers. Wait, is it?
You've got the mathematics to go with that. 39 kilometers.
Yeah, that's 40 kilometers.
I have
24 miles, basically.
Okay, no.
I have the Mr. Sensible video, which shows when he saw it.
More junk.
But when he saw it, now I want the maths that shows that that's the altitude that you would perceive left to right curvature on a sphere with our radius.
Yeah, he also did the math, and he showed what the curvature would look like from that, so I can post that.
Yeah, that'd be awesome. Thanks, mate.
Yeah, how did he show what the curvature would look like? Through a simulated lens?
I bet it looks horizontal.
With what field of view, right? What focal length was the simulated lens in the software? These are things that you haven't thought about these things, have you?
That graph behind his bald head, that is the curvature that he calculated would be expected according to the globe model at that altitude.
Yeah, so what software is he using? What simulated lens is he using? And what's the field of view?
He's not simulating a lens. He's just doing the base mathematics for what it would be at that altitude.
Right. So Mr. Sensible right? Neil deGrasse Tyson says that even from 3 times that height, he did the math, he did the calculations, and you wouldn't see curvature from 3 times that height. But Mr. Sensible knows more.
Neil deGrasse Tyson is controlled opposition.
Controlled opposition? How so?
He's controlled by the Flat Earth Society to lie and to smear the globe model.
Have you got proof of that?
I was just going to say that. You want a proof of that?
Like an email or something?
Yeah.
The fact that he, he's supposed to be this expert, but he constantly says dumb bullshit that's wrong.
Yeah,
so does the Flat Earth Society.
You're pouring some kind of conspiracy into this, that he's actually doing this on purpose to play some kind of role. Have you got evidence of that, or are you just going to pour more scorn upon the man?
Well, either it's a conspiracy or he's just an idiot.
So no, then. Right.
You ever listen to everything he says in full context?
So I promise you, at the altitude that guy, that Red Bull guy was at, you absolutely can see curvature. That is not going to be flat, like he said.
So you can see curvature, but in the camera that's on the screen inside the gondola, that's a horizontal horizon. Because there's multiple views from the Felix Baumgartner jump. Some are very, very curved. One inside the gondola is horizontal.
Yeah.
So this is why we asked the question, would the real earth curve please stand up? Because it goes all over the place, depending on, I don't know, what optic he used, blah, blah, blah.
Well, he's using a freestyle.
Yeah. Even if he didn't have that inside view, it can't be argued that the outside view lens or GoPro, whatever.
I'm just saying, if you take out, don't even think about what the shape of the Earth is. If you just think of a ball, like a basketball, right, and you predict what the curvature of the basketball would be, that is the math that is used by Mr. Sensible for that graph behind his head. Has nothing to do with Earth. It's just
what's the focal length of the simulated lens, and what's the field of view?
Oh, I don't know. Probably.
I have no idea. You have no idea, do you? Do you think that would make a difference?
Yeah.
Yeah, it would make a huge difference.
Well, okay.
Bisson has a similar argument where he compares ISS photograph, I think it is, very high altitude anyway, photograph, and then he runs it through a simulation and shows that he superimposes the simulation curve with the photographic curve, and it matches.
So I don't recall him going into depth about the math, but I could have to go back and check and see.
Yeah, so see how the footage, right? The screenshot that I just posted. Hey, T-Dub, can I just delete that? Can you post it again? Just so my pictures line up. Sorry.
Oh, yeah, sorry, man. Sorry. Yep, go for it.
Yeah, no, you're right. I just wanted him to look at this, right? So this is a frame from his video. Okay, and then you've got the simulation underneath it. It doesn't line up, right? We're seeing a flat horizon at this point in the video.
Oh.
Uh-oh.
Hello, everybody.
Hello?
Hello, how are you all?
Oh, very well, thank you. And yourself?
Thank you for
I'm pretty good. What's going on here?
Well, we're discussing how flat the Earth is. No, we can't find that curvature, basically.
That's a curious thing to discuss, I think. But okay.
Well, this is a
There's
flat Earth
plenty
server.
of you here.
Welcome.
Are you watching? Are you watching a television program or
what?
No.
No.
Are you doing a debate thing or?
Yeah, we're doing question and answer or debate or whatever you want, really.
Cool.
Do you have any questions about the topic?
What is the topic? Sorry, I'm just blazed in here. I'm like an idiot. I'm really sorry. I imagine you think the Earth
I've got a
is
question. I've got a question for you.
Go ahead.
What is that in your profile picture?
I think that in my profile picture is just a nebula that looked slightly like a cat.
Okay.
Does that make sense?
Well, I don't know.
See it? I see the cat.
I'm not sure that's a real nebula or a real cat or anything like that.
No, it's definitely
But, you know,
not.
it's a bit of fun.
Cat profile pic. You're not here to troll us, are you?
Well,
I am not here. I'm not here to troll. Hey, listen. First of all.
It's pub kicking out time.
It's a joke. Welcome, man.
Yeah, come on, man, because you this is a flat Earth server. How did you get in there?
Yeah.
You must have checked first.
You're just on here.
Well, you must have checked first, surely.
I know what you guys are chatting about. Listen, I'm not gonna mug you off or anything.
Yeah,
Listen,
I was joking about the cat thing.
Listen,
man.
most of the time, pretty much most of the time, I think you guys get the better of me, right?
Oh, let's see. Never mind. I digress.
I don't think it's a flat Earth. I think you're all wrong. You lot disagree, and you have arguments that are stronger than mine when it comes to that. But you know, here I am. I'm not here to
The only reason
call
why
you
we've got
dickheads or anything.
The only reason why we've got strong arguments is because first of all, we were told about the globe, and I carried a belief for a while, 48 years, and then I went to check it. Now you're probably in the same situation, maybe not the same length of time. But
Not really.
yeah, I was just going to say not the same length of time, of course, but you would need to go and check it as well, and then you could say we're wrong, perhaps, if you find that the Earth is a globe. You see.
Well, one thing, Jesus, one thing I
yes
want to be clear about is that I found that trying to argue against any of you, I am completely unable to do that.
Yeah.
Not to say that I don't believe it, but I'm definitely not coming here with the position to say you're all wrong, you're all idiots or anything like that. Anyone, because I do not believe that.
But why would you say that is? Like, what is it that you're lacking?
I don't think I'm lacking anything. I don't think you're lacking anything either. I think it's extremely interesting how there is such a difference of opinion, and this particular opinion, I find it extremely interesting.
Right. So, could I just see if we have common ground in this respect? Do you agree that everyone observes and treats the Earth as if it is a motionless plane?
Well, I certainly do. I remember lying on my back and looking up as if it was some sort of globe-like. No, hang on, steady on. Not globe-like. Some sort of like fishbowl-like thing. So yeah. I'm not here to say, oh, it's a globe. You're all stupid. Definitely not here to do that. And I've been here before, not for a while. I really admire you people. You're unlikely to persuade me that
you people.
Yeah, that's. I'm sorry. That's pejorative. I really admire you guys.
That's all right. Sounds like you're having a good night, anyway.
That sounds like a use of euphemism for you sound drunk, which is fair.
No, yeah. Appreciate your candor, man.
Yeah, I got really wound up with certain. Sort of. Listen, I'm not counting you in this, but like pseudo-scientific, particularly medical things, and I got upset about it, and essentially, I listen. I'm of no consequence to you guys whatsoever. But I found you to be thoughtful and respectful, and I've really enjoyed speaking to you over the years. I definitely don't agree with your proposition about the situation, but I've really enjoyed speaking to you guys, and I mean, no disrespect whatsoever, and if I come across like that, I definitely disagree with you. But I certainly don't mean
Yeah,
to.
but why do you disagree? Why do you disagree?
Because the evidence is abundant.
That's where you're wrong there. Well, you would have presented it to us and you would have had a strong case against us and you'd be giving your case, you'd be winning here in that sense. If there's hang on a second. The word abundance.
Go ahead. Sorry, go ahead.
The word abundance, that means you've got a lot to choose from. So you must have a big case. Come on, man. Abundance of evidence. Come on, man. You'd have a strong case. You should be able to put us in our place.
I know very well that you have looked at various things that convince you.
How did I get here?
I'm not sure.
People keep moving.
Kicked out of a different room. Yeah.
Yeah, that's rude. I find that's rude to you guys.
Just puts you into a random room. Yeah.
Listen, I'm definitely not going to be able to convince you that you've strayed from the path, am I?
Is he a flat?
You evolve. Am I a flat? Is he? What?
Is the Earth flat?
Yeah, the Earth is indeed flat. Yes, it is. Yes, without a doubt.
I've been up there. I've been up there, and it's pretty round. I'm going to say it.
It's
up there where?
Hold on, Jim. Been up where?
In the air.
You've been up. Okay.
Pretty high up.
What altitude? Pretty high. What altitude?
30,000 feet.
30. I've been to 36,000 feet.
Yeah, I don't remember exactly.
I haven't seen any curvature from up there.
It was a big flight. was a long flight.
It's a long flight. Okay, 36,000
Yeah.
feet, 12-hour flight. I didn't see any curvature. We got a problem, haven't we?
What do you reckon?
Did you look outside?
What do you reckon is going on?
Fuck me.
It's so odd. It's so odd that
Oh,
you.
now we've got the drunk man coming back again.
Sorry.
Man.
It's really odd that you.
Never apologise for your existence. You're here for a reason.
I'm not apologising for my existence, but it's really odd that you. I apologise for interrupting.
No, I love you.
I knew it was coming at some point. It is almost midnight on a Friday night, and some drunk idiot was going to tell the other one that he loved. I knew it was coming.
I'm not drunk. I'm hungover.
That's so funny.
That's the worst
All
time.
right,
That's the one you love them.
I tell you what, fellas. Sorry for interrupting. Just look up.
Look up. Does my redemption draw nigh, or something?
Look up. Look up what? Was that like an unfinished sentence? Or...
Well, look at the procession. Look at what happens around you.
Okay. The sun, moon, and stars appear to move across the sky.
Yeah, what's complicated?
Nothing. The sun, moon, and stars appear to move across the sky. It's nothing complicated about their motion across the sky.
What do you think is happening?
The sun, moon, and stars appear to be moving across the sky.
And what do you think they are?
I don't know, dude.
Really?
But, yeah, I really don't know because I haven't been there.
In 2025, you're not sure?
Yeah, I still haven't been there in 2025. I can only go on a story that I've been told that I can't verify for myself. So it would be a belief, not knowledge. So I don't know.
I think even at this stage, you're an astronomer, aren't you? You watch these things, don't you?
We look up at the sky all the time, yeah. We watch them move across the sky. I still don't know what they are. I'm trying to figure out where this is going.
Really?
Yeah. I mean, so far you agree with me that the sun, moon, and stars move across the sky. We seem to have a ubiquitous agreement about this. The question about what they are doesn't even pertain to the subject at the moment.
Right. Okay. Okay.
So you told us to look up, and we watched the sun, moon, and stars move across the sky.
Sure.
And?
Well, if you can't...
told us to look around us.
Draw conclusions about that. I mean...
Yeah.
I find that really difficult to...
Sorry, the conclusion was in the description.
To reconcile.
The conclusion was in the description of the sun, moon, and stars moving across the sky. That's the conclusion. The sun, moon, and stars are moving across the sky. Have you got another story or something else you want to add to this?
There are many other stories, as you well know, and yours don't really add up, do they?
What? They don't add up. When I go outside and do what you said to observe the world around us and look up, we can describe the sun, moon, and stars moving across the sky. Got to this point. My God, now he's interrupting me. I literally got to this point so everybody was clear. So because I thought you were going to continue.
You can draw your own conclusions. That's fine.
Yep, sun, moon, and stars move across the sky unless you want to add something else. Or do you not? Are you some kind of secret king?
Say again, sorry?
Do you want to add something else, or do you not want to add something else like some kind of secret king? You've got a secret. Or are you going to tell us?
Secret king?
Yeah. Let's not get bogged down in fucking terminology, dude. Is there more to what you want to explain to us, because you said look around, look up. We have. We've described the motion of the things. Now you're saying we should be drawing conclusions. The conclusions I draw is the sun, moon, and stars are moving the sky. Unless you wanted to add anything more.
You've drawn your own conclusions. That's fine. If that's what you reckon, well, good for you.
Unless there is something else you want to add, because so far you told us just to look around. We have done. We're looking up, like you said, and we're describing the motion of sun, moon, and stars across the sky. Now, is there something else you want to add to the conversation? Or no, just want to babble through me now, do you? Okay.
Yeah, he's pretty much just described the extent of the experience, right? Like, there's no more that you could possibly add to that without imagining things, right?
Yeah. That's good. That's a good one.
And he has come to his conclusion. He has come to his conclusions. He has his conclusions via painstaking investigation. Yeah, you understand, and there's a lot of time spent there. Okay, so he hasn't just made his mind up following a trend. He's come to his conclusions through investigation. Have you investigated? I don't think so. You don't sound like you have.
I didn't claim that.
Exactly.
Either. But,
so you're disagreeing without even investigating. You're disagreeing. You see.
Well, it sounds like you guys must be right.
We know what we know. Put it that way.
Yeah. Good.
Yeah.
Good.
And
Good luck with that.
That's not believing in things either. That's
good luck with
actual
that.
Knowledge. Real knowledge.
Yeah. No, I accept that. Good luck with that.
Do you understand?
I'm enjoying it.
Yeah, no, I hope I understand.
I've acquired over 63 years now.
I hope I understand. I hope I understand. I probably don't understand because you are all so much wiser than me, but I hope I understand.
Do you understand that we wouldn't be here if we were wrong?
Yeah, that's good. Yeah, okay. Yeah,
it's not a good argument.
Yeah, brilliant.
Lots of, go to the vegan channel.
I really don't want to be rude to you guys. Good luck. Thanks. You're a bunch of fun. Thank you.
Cheers, mate. Thanks, dude.
Yeah, good.
Cheers, mate. Yeah.
Good luck to you as well. Good luck to you as well. Yeah,
thanks.
Good luck.
Thanks.
Have a good life. Have a really good life. Yeah.
I hate long goodbyes.
Yeah. You know what I mean.
If I
have another one for us. Have another one for me.
If I started a Discord server,
have two for me.
If I started a Discord server where my whole premise would be talking about how leprechauns are at the end of rainbows, like that wouldn't last because it isn't real. And then I wouldn't go to that every day because like I would be debunked every single day. So when a Glober comes to a place where there's truth being told, it's weird to me. Why do they keep coming when they clearly have been debunked and we're sitting on the side of truth? This is why the truth stands. The truth lasts.
I can explain why you don't see the leprechaun, bro. They're invisible.
Well, there you go. Let's get that Discord server going. Let's get that server going. We're talking about invisible leprechauns, which is true.
Invisible leprechaun vegans.
That was rather condescending. Good luck, though. Did you notice?
Right.
Yeah, of course.
Yeah.
Wasn't lost on me.
That's right.
I mean, all you guys were wrecking Kiba earlier, all of you, and he still had his position. So at this point, that conversation's not for him. It's for the people listening that they can get what's being said and explained, and then hopefully they walk away with something way more valuable than obviously Kiba will, or is he even able to.
That's right.
We have to remember that even some of the best arguments with globers are going to be the reasons why they will turn a glober into a flat earther. Not even us, it's them.
That's a nice sentiment. Like even if Kiba's a loser, he's still a winner in some respect. Yeah.
Exactly. We got to give him a thanks, a big kudos.
Even
Hey
if
guys, we
Keeper's a
got
loser, he's still our star player. Nice.
Exactly.
we got Master Uguay in the text chat saying that some flat earthers proved the globe. Saying that, what did he say? He said Mark Sargent and Bob Nodell proved the globe, but he doesn't want to watch the video that I posted for him about a guy that claimed that Bob proved rotation, but Bob is in the room, right? I told him, give it a listen. He says, nah, that is cognitive dissonance.
Yeah.
Put your fingers in your freaking ears because, holy crap, somebody was Johnny on the spot and had a refutation right there ready to go.
Yeah, I think I know what video you're talking about. Hopefully it's the same one. But yeah, there's literally a video of Bob explaining in
Yeah.
detail.
Yeah.
And those Globers, they still, this many years later, they're still bringing up that incident. It's crazy. It's like they
Yeah.
must be new
I've
to
had
the
to
argument.
explain it to them all the time. That
That's all
he's
right.
explained himself so many times. Come on, man.
Last night or early this morning, rather, Uguay already admitted that the horizon is horizontal and that he can't experience it as curved, but that he experiences it as curved when he's walking. So he can't experience it as curved unless he's walking.
Oh, blimey.
Yeah, that's how freaking lost Uguay is.
Maybe Uguay is a stock account of like Peter, who said he could prove it by his bike trail. You remember that argument?
I remember that one.
He said because he rode a bike. He proved the Earth is a globe when he rode a bike.
Well, they should be grateful that flat earthers showed up and finally gave them something to appeal to, because apparently before that wasn't proven, right?
Right.
Right.
Thank you, flat earthers.
It
No, the Earth's
appears
a globe
that
now.
Uguay has left the. No, he's back. There he is. Hey, Uguay, go ahead and mic up, man. Because we already talked about the horizon and how that's horizontal. And you want to talk about tangential lines, right? I don't give a fuck about tangential lines when horizontal is not a property of a sphere.
Yes, and you need that straight line to have a tangential one. You're using another straight horizontal line. Without it, you couldn't even have a tangential.
That means a globe Earth is. That means a globe Earth is being built off of a flat Earth.
Yeah.
He's probably a disco ball earther.
Yeah. Disco ball.
Bunch of flat mirrors on a round ball. It's his theme
disco ball. Disco ball. Disco ball. Disco. Let's go.
Yeah, right. Falling off into the realm. It was a good. It was a good. Oh, go ahead. Sorry.
I want to poke at Uguay because he's broken. Because he already admitted that the horizon's horizontal and that he cannot experience the Earth as being curved. But then he says that he experienced it while he's walking.
And he dropped out.
Yep, of course he dropped out.
He just wanted to come in and hear what we were like, hear the response, because obviously he wasn't getting a bite in the text chat.
He's scared. He's scared because I already cooked him, and he knows that there's no getting out of it. He has two options: run away, which is what he's doing, or concede that what he said was absolutely preposterous.
Okay, so because we've been doing a lot of internal critique lately. All right, so who agrees, right, with this sentiment that either way, right, either way, with Bob Nodell's gyroscope, it's affirming the consequent, no matter what conclusion you draw.
Oh, okay. So if there is ether that my gyroscope will process, my gyroscope processes, therefore there is ether.
Right. It is it's affirmative consequent, and we could really get down. I mean, we've talked about it. We've been this dead horse so many times. We can even talk about how they will put a they'll calibrate it to have movement even when it's not moving. So then, because it moves when it's standing still, well, then the Earth must be moving. But it's given a value, a mathematical value, no different than a video game when it has numbers, and the further away you go, it's going to create a distance for you. But if you stop, if there's an algorithm though that's going to project how far you're supposed to be, but for some reason it stops calculating that, it'll still give you a measurement because it's going off an algorithm, and it's just numbers. That's all it is. It's just an algorithm.
Yeah. Are you saying it's got nothing to do with internal components, mechanisms?
That's what they are. Yeah.
The mechanisms that are in there, then they're going to give you a value. But if you calibrate it to give you a value that is constantly moving, then
what I said.
That's where it comes from.
Yeah, that's what I've been saying since 2016. I said that's the only way it can work. And I said I'm like the old, the Stone Age man with my clubber. I'll smash it open and have a look in there because that's where you're going to find the truth, right? Because we know the Earth isn't rotating, so they have to make a mechanism by which it's telling you it's rotating when it really isn't, and that's a deceptive kit right there. Yeah.
Okay, but what about the Foucault's pendulum? What makes the Foucault's pendulum, right, not a necessary antecedent consequent relationship?
Yeah, I would say because the damn thing is in a building, right? Mm-hmm. It's in a building, and it's meant to be rotating because the Earth outside is rotating, but you're in a building, and this thing is processing left and right. I don't see how that would facilitate a rotation unless you got magnetic linkage at the top.
Yeah, for instance, at the Griffith Observatory, sometimes you'll see that pendulum not swinging at all, and then you'll say, "What happened?" And the tour guide will tell you, "Oh, it's not turned on right now." Okay, so then the Earth isn't spinning because we didn't turn it on. Okay, awesome.
There you go.
That makes logical sense, right, guys? You have to turn it on for it to start showing precession, but it's not going to swing on its own. It's not going to process on its own. You have to turn it on.
And, it's just silly. Really is stupid.
You satisfied with that answer, T-Dub?
Yeah, I mean, there's. I'm sure if Amish was here, he'd probably say, "Well, and other people too. Where is the data sets from multiple places, different people, right, et cetera, et cetera? Like, what's the controls, et cetera? Where's the data?"
And
Plus,
then
there'd be some people that argue because it is often presented to us as a scientific experiment, right? And there's people that argue that there's no observed natural phenomenon, right? So no dependent variable.
Mm-hmm.
Yeah, and then we could even go into as far as how many times have they said they're setting it up and it didn't work right, so they reset it up again, and they'll keep doing that until it gives them the values that they are looking for. Yeah. That's very biased, extremely biased.
Just sounds like the Cavendish experiment to me.
Yeah, I dropped
it is
one.
the Cavendish experiment, but with one ball, isn't it? And if you can't set it up right, you've done the experiment wrong when you don't get the right results. It's the same type of fucking shit.
Exactly.
Cavendish
well,
has only
I
got
would
one
expect
ball.
that I would expect that if something is, if it's at rest, in the vertical plane because of the Earth's center of gravity. But the Earth is also spinning like anything else, like a carousel. Like I would figure that the effect would, tilt, the chain, take it off of plumb, to some degree. Because why would gravity stop it from doing that if the Earth is spinning? I don't get it.
Right, because you can set up a pendulum on a carousel and get it spinning pretty fast. It's going to have an effect on the pendulum, regardless of whether you begin swinging it or not. Like, you can be at rest, then you start spinning that carousel. It's going to move that pendulum. That pendulum is going to process.
Yeah, process. Yeah.
Other arguments that I've heard presented regarding Foucault is that, like, where's the measure of the orbit or the galactic orbit, right? I don't know how, like, valid an argument that is, whether, it's kind of going into the weeds a bit, but what do you guys think?
Well, I'm currently proud of the work that I'm doing. Especially because it's not like, I got something wrapped in a bow. I got something that was critiqued, and essentially we tried to reason away how we couldn't know something either way. And I don't like to leave it in the you prove it Glober lane. It's like, no, I'm just gonna go prove this right here. I don't care what they do. It's nice trying to wriggle this in and assert dominance.
Have you gone through the math yet? With
no, not yet. Still waiting on him. Should be another couple of hours. But what I sent you is a question thread that I had went through, basically trying to figure out any possible way that they could factor in the surface of the Earth, since they're saying at that distance or at certain distances, you're going to have to account for the curvature of the Earth. I'm looking for how they do that. And the only way that I can see how is the way that I've shown y'all yesterday, and that was ridiculous. That's all they're saying. It's like one can say, you're calculating wrong. And I'm like, well, all of the sources that I found are telling me to do it exactly this way. And the problem is they're giving the result like Google gives the result to the distance to the horizon. And it's like, well, the pilot would be adjusting for this. The question is, but do they? Does the software? Because even if they say the software is going to help them calculate, that still leaves them with the terrible result that I know they're not working with.
Sorry, dude, I'm reading through your thread that you sent me, talking to a Complexity AI, and I've just got down to the TCAS thing, the traffic collision avoidance system. for me personally, this is why I started speaking up the other day when I was talking about an aircraft that's 100 miles away from you at the same altitude as you is still 1 mile below you, because it's 100 miles away. The curvature is 1 mile downwards, even though you're both at 35,000 feet. To your horizontal, subtract that, you've still got a mile deficit. So this would have to be taken into account or be referenced somewhere within the TCAS system. That's the traffic collision avoidance system, because we're dealing with other aircraft that are relative to the aircraft's position in the sky. So I want to look at this. Sorry, I know it's not directly your point, but I just stumbled across it in your thread and it reminded me of what I was talking about earlier.
No, I saw that in there too. Everything is in there. Like, I even tried to do the math wrong. I'm like, okay, well, what would the chord be instead? Forget the art. Ooh. Turns out they don't do that. Oh, my bad. Okay, sorry. Like, it's everything is in there, and like the emphasis on the ground speed, again, having to do with the horizontal distance. That, like, there's no, they keep on saying it, and then they keep on telling you what you would have to do to account for it. And I'm like, well, I mean, when I did the math on that, they're like, no, there's no way. So if it ain't that, tell me what it is, because yeah.
Just trying to think of aircraft that don't rely on these systems, go very far back into the past before we find an aircraft that hasn't got computer navigational assistance and what.
That's what I was going to bring up. Yeah, because Eli mentioned that. Like, do they? Well, what about have they in the past? And was it recorded?
Yeah.
I mean, according to the math, the difference is not negligible. That it would most certainly have to. They're literally telling you what. First of all, there's no way you can fiddle with the height on the opposite. Like there isn't any way around that.
No.
Like, the height is the height. And so because you're at your height, somehow we've determined that if you're gliding and descending with the pitch at 3 degrees, you'll decrease in like 300 and something feet per minute or something like that. And it equates to, again, all of this is linear distances. So, I mean, and that's what actually, that calculation is what gives you your adjacent distance along the ground. Now, it's specifically because I asked, I'm like, yo, okay, well, you're saying all of this. So what about the tangent from me to, like, just the horizontal and what I would have to account for, the topography of the real Earth, right?
Yeah.
And it's telling me, and I'm like, oh dear. And it's also telling me they do that. And I'm like, oh dear, okay. If they're doing it, they're doing it.
Wow. Yeah, I like this as soon as you started bringing it up. It seems to me really cut and dry. It is what it is because it has to be what it is. So it's that then. There's no additional adjustment for something that it is actually, but it's just bullshit, dude. I love this as soon as you brought it up. It was simple to me. And yeah, really, you can tag it on, especially to the end of the pitch data, because the pitch data tells you when the plane is also landing.
Yep. And it's like, so in one case, like, as far as we've heard, we argue against, well, how off can it be in relation to this hypothetical horizontal? Because nothing can be perfectly horizontal. And then there's how do we know that horizontal isn't changing? It's like, well, pick one. Like, pick one. You're gonna say it is horizontal, but it's off because of like whatever. That doesn't change the fact that still. You know. And it's always the most quietest. Like no one has said. The last person that said you're a liar, show me the math, was Scott Mackey. That was weeks ago. Like nobody is biting on this.
Well, if I was a global, I wouldn't do really, unless I could prove continual tangential adjustments within the mathematics, not within the fucking flight dynamics. Just show me the mathematics. DJ, wake up.
Let's close in the chat. Let's get ready to rumble. Welcome to 24/7 Flat Earth Discord, the best place on Earth to talk about the Earth. Bring your best globe evidence or concede to the fact that the horizon is horizontal.
And I've kind of always like my methodology for sussing out good and bad arguments. Literally, have always been fielding it with whoever was available that I thought was the best of the best. I never went through back channels and went, let me talk about this secretly to someone. I always went, hey, this is where my mind's bringing me. What do y'all think? Right or wrong?
Yeah, man, for sure. Yeah. Kind of been the same way as well, especially over the last year. Kind of having to think out loud with you guys, because I don't know the answer, but if you all understand where my mind's at, you can see where I'm coming from, especially with regards to celestial poles and shit.
Yep. And I always ask, like, am I seeing this wrong? Am I wrong? Like, and I wait, and weeks go by, and I go, I guess I'm the champ. I don't know. Like, people have come out and told me, well, hold on now, this doesn't make sense, and I'm going, all right. Like the other week when I was talking about the elevation and looking across, apparently a river is nowhere near as wide as the ocean. So I don't know why I thought that was any kind of distance across the west side to New Jersey, but it's nowhere near like when I'm at the beach. So I definitely had to concede that.
Oh dear. We live and learn, mate.
But it's like, look, I make mistakes fast so I can win fast.
It's the way to play.
You got me thinking about this anti-collision system thing.
TCAS. Yeah, I've been thinking about this for a while. Multiple aircraft in the air at altitudes where
it literally says they have to calculate and adjust for the different apparent altitudes because of the curvature of the earth. Show me where. Tell me how. How they doing that? I know they're saying that. Show me how they doing that. Because every time I click a link that I want, every time I click a link that supports me, this shit's there. Every time I click a link that supports the calendar, the shit's not in there. I'm like, ooh, that's even weird, huh? Like, start playing with the numbers when you read stuff, in something that's questionable, click on the little number that, the little source that goes with it.
Yeah.
All right. Because it's got me thinking, they're saying it's a tangential plane, right? Horizontal. But that means that they can't treat, right, with distance along that horizontal, a point on that horizontal as being perpendicular to vertical. Because at that point, perpendicular to that vertical there, you are. So that's a contradiction of the definition of horizontal, right? But are they treating local horizontal tangent planes as intersecting when they're trying to figure out with their anti-collision systems?
I don't know. The so far that I've got in my head is, even if you and another aircraft are at the same altitude, or even if you and the other aircraft is at a higher altitude relative to your tangential horizontal, they're still below you. I can't get my head around that.
Right.
Because it's just the very simple math of over 100 miles, there is 1 mile, give or take a few feet, of Earth curvature from the horizontal. So you've got curved lines and people being at equal altitudes, but not on the same tangential horizontal. And I'm thinking planes are going to start crashing all over the place.
Right,
Wait,
because even at 100 miles away,
I thought it was 2. I thought it was 2 for 100 miles.
Well, they're going pretty fast, so even at that distance, they're going to be coming up on you pretty fast, right? So I don't know.
Fuck knows, mate. Some of these planes fly. Sorry, Eli, what did you say in the background, mate? I didn't catch.
Oh, no, I was saying I thought it was 2 miles.
100 miles is 1 mile.
Okay. So I looked up 200 nautical miles because, they said that commercial jets actually come in from that far. Oh, great. Know how much that is?
Go on.
Like 30 fucking something feet. 30 something thousand feet.
Fucking hell.
Wait, are you talking about to land?
Yeah. The extra.
Like they start preparing landing from that distance?
No, if it's 200 nautical miles, then the calculation below the tangent is like 30 something thousand extra feet.
Right.
Blow it, Globers. Blow it.
Yeah, that 100 miles to 200 miles, that's the sweet spot. That
Wait a
shows
minute.
the exponential rate as well.
Time out. Did I just say that in 200 nautical miles, when they drop 36,000 feet, they're going to be at 36,000 feet?
Kind of. But I kind of understood what you were trying to say, I think.
But is that the distance from the runway that they have to start preparing and start dropping, like lowering, or what? Do you know?
Yeah, it could be anywhere from. It depends on. It could be not that far distance from 10,000 feet with smaller personal planes. It could be from like 36,000 feet, 39,000 feet, be around 100 miles or so, something like that.
Yeah, I can imagine that for your big ones. Yeah.
And if there's mountains, actually, that would also be that would increase the distance that you would want to work with because of the topography and all of that. So they often, it could be 150 to, again, 200 nautical miles that they begin, depending on the topography. You still reading through it, Jedi? What part you up to? I kind of wanted to read it together, but I guess I'm gonna have to do that again anyway. As soon as what's his name gets off.
I was skipping through it, man. Came out, I made myself a drink. I just started thinking about that Tika shit.
It seems well. It is kind of long, but it's like as we were talking earlier, like me not being a weasel trying to find my result. I search things trying to find the results that'll go against me so I can work it out. And
Yeah.
so I keep asking it questions based on what y'all are asking or whoever was asking me, whatever. So I'm asking it follow up questions. And I'm like, I'm not finding anything that's going against me. I'm sorry. I'm trying real hard. You can see it in all the follow up questions.
Yeah,
Like
I can,
what the
man.
hell was I doing on cord lengths? What the fuck did that have to do with anything? I wanted to know.
Well, yeah, you're just covering all the bases, man. But you're right, there is a lot of stuff here, that's for sure. What if the adjacent is 200 nautical? Yeah.
Then you start thinking when it's talking about inputting the radius of the Earth, you're like, oh, they're gonna make it some super small, minuscule thing for some reason somehow, but they don't. They don't. It does nothing. It does nothing at all.
What? Right. Just looking through the chat, we got lots of names in here so if anybody's got questions, subject room, please feel free to unmute yourself, introduce yourself, for your question. If you got a point that was discussed earlier that you want to rebut or have a rebuttal for it, like I said, unmute yourself, tell us who you are, and you can stake your claim. But welcome everybody to the chat. There might be some people that are new to the channel, so let's call out some names. I can see Alexi and Benny the Bloke. Welcome to our channel, guys. Like I said, if you've got any questions or points that you want to raise, then please feel free to unmute yourself.
I thought that was a very friendly, very professional, welcoming. It was a shame that nobody responded to it.
Yeah, fucking ungrateful bastards.
What's everybody doing? What's everyone up to? Nobody wants to talk right now. What about Chalupa? Chalupa!
I was going to ask quickly, Eli, do you have a moment? Do you want to jump in another challenge just to test my connection and shit like that before we do our thing? I'm thinking of doing it a bit earlier. Had a thing.
Dang, bro.
Yes, sir.
Where did you get the radio quality mic?
This is my studio setup. Never really on it, but yeah, it's my shtick.
You sound like AI.
Yeah. I got a good mic.
Not the person,
Mixer
like
and
not AI overlord.
Okay.
I can hear myself feeding back though.
Did you program your? I was going to say, did you program yourself so that I could battle AI?
Hey.
Ooh, you're feeding back real bad out of your microphone, 20 cup.
1 sec.
Yeah, just push it on push to talk. That should work. Just push it on push to talk. That should work. You want to go to the other chat or private chat or the other chat or private chat or?
Yeah, let's do that.
Have you guys heard Mick play the piano? Oh shit! I can still hear myself.
Me too.
Freaking amazing piano player. Mick, you have to do another performance for us on here sometime.
Thank you, man. Appreciate that.
It's
Sometime.
freaking outstanding.
I'm gonna try and find Eli. Do you guys know where he went?
Probably the home server.
Okay, I'm gonna go check it out there, and I'll be back.
I want to hear 1,000 miles.
All right, then I'm just gonna ask my question again. Does anyone have a really good resource and explanation of how the horizon works?
It's horizontal, which is not a property of a sphere. You've been here long enough and should know this.
That's not an explanation.
Yeah, it's a perfectly reasonable explanation. Is the horizon not horizontal? No, the horizon's not horizontal. Then what is it?
Hold on, that's a property.
Yeah, of what? What is horizontal a property of?
The horizon. The horizon is horizontal. That's an adjective. It's a property of the horizon.
You.
Yeah.
All right.
Exactly.
Awesome. So,
Can you? Sorry. What was my question? What did you hear me asking? Yeah. Okay. So you were not
It was ambiguous before. Yeah, how does it work? That's ambiguous. Like it was ambiguous when you first asked, and when you asked AI Overlord.
Okay,
and it's still ambiguous. So maybe give more clarity to your question.
Okay.
Like, are you saying why do we have one? How is it produced?
Yes, I want to be able to understand the mechanism well enough that I can derive a mathematical description for it that predicts what I should be seeing, or how far away I should be seeing the horizon, how far away it should appear, what should happen when
There's
observing.
always atmospheric conditions at play, dude, right? So it's always going to be apparent. It's always going to be like in a slightly different place. So it's not something you're going to be able to calculate a distance to.
Well, given that atmospheric conditions are known, you can still predict what you would observe, or you could. Or another way is like I do understand the effect that atmospheric conditions have on the vision. So, given that I know what distortions atmospheric conditions introduce, and if I have an understanding of the horizon that gives me predictions, then I could back conclude from the difference between my prediction, if my understanding is correct, and the observation. I could backtrack from that to what were the atmospheric conditions present, and I could then compare that again to the actual measured weather at the time. So it is useful in either case.
Yeah. The thing is, this is one thing I guarantee you're not going to be able to present us with, right? An observation that matches up with the globe where all the conditions have been accounted for. I've never seen that. That's for sure.
What do you mean with all the conditions are being accounted for? And that's not what I asked for, is it? Neither is it what I claimed.
I didn't say you claimed anything. I just said something you're not going to be able to produce.
So the
horizon's not geometric. Do you agree the horizon's not a physical geometric product of a globe Earth? Do you agree with that much at least?
But I'm asking that question, so...
Yeah, well, you don't have any evidence that such a thing exists in the first place.
Okay. What does that have to do with understanding how the horizon actually works?
When you says how it works, what do you mean in regards to what? In regards to the formula?
Did you listen to the entire since the beginning, or?
No, I just heard you say, "How does the horizon work?" And then I said,
"Yes."
Okay, so in regards to the formula,
I want to be able to understand the physical principles and how they work together to make it appear as it does. Well enough that I can derive a mathematical description for it, for example, yes.
Yeah, okay, so at least you're along the right path here. It would be a geometric formula or calculation, should I say, which would be derived. It's not empirical. Just like I heard someone say earlier, that horizon does change depending on visibility and the way we are seeing through the sky in general. So if you have an understanding that even though you don't know the distance to the horizon per se, but then that's why the formula has the height of the observer is where they're going to account that for. So then you're gonna be able to then formulate this according to an assumed radius value, and then when you apply that radius value, and you're taking
radius.
Yeah, exactly. That's an assumed thing. A radius
Apu,
of 3959.
you're completely missing the point. Is that
Okay.
possible? Okay. Yeah. I have a hard time understanding why does the horizon occur as it does. Right? I'm having a hard time understanding that. I'm having a hard time finding explanations, getting help with that. It's a whole clusterfuck for me.
Okay, so the
Get
horizon.
specific, dude. Get specific.
So the horizon is where it appears that the sky and the ground meet, correct? The surface meet,
Exactly,
correct?
yes.
Okay, what don't you get about that?
Why does it occur the way it does? Why does it
Because
occur at all?
that's the way we see. That's how optics works. So something that you have height, right? Now the ground that you're standing on, the further away it goes away from you, it's going to start to lift up. Okay, just optically though. Optically, it looks this way. Just like when they show you, you're looking down a hallway, and the floor that you're standing on goes up, and the ceiling that you're standing under
It's just
tends to go
perspective,
down.
basically, right?
Exactly.
Because the distance between you and the ground is also a distance that has an angular size, which gets smaller as it gets further away, right? Yeah. That's already the first thing. All right. So you basically, I'm a little bit paraphrasing here, but are you saying, are you going along the lines of the horizon occurs because of some resolution limit of like us not being able to resolve things any further away, and that's why there appears to be a line. Okay, then there's two characteristics that I don't understand. If that is the reason, fundamentally the reason, again, discounting atmospheric effects. I understand those. If they're an integral part in the explanation, then your explanation wasn't complete, right?
No, we didn't even get to that point yet. We can that's the second part to it. Then you can include all these variables because of optical phenomenons that are going to make things in the distance look one way or another. But we're not talking about those things per se. We're talking about the horizon, and then that horizon is what we've learned it to be. That's represented by the vanishing point. So with that angular resolution, that has a part to that as well.
Okay, so if that is the core principle behind why we perceive a horizon in the first place, then the distance that the horizon appears at should be directly correlated with the magnification and the aperture that you're using. So when I use my binoculars with 10 to 20 times magnification, or binoculars with 15 times magnification, it should be accordingly 20 or 50 times further away, appear 20 or 30 times, 50 times further away, because it's a function of what can I resolve of the angular resolution, and that increases in direct correlation with those magnifications or apertures. This does not happen. And secondly, if perspective was really the core fundamental principle behind perceiving the horizon in the first place, then I would expect to raise to eye level. And yes, okay, we didn't get to atmospheric conditions. That's possible that there's general sinking going on. I don't know why that would happen over bigger altitude differences, but let's just say it's a possibility. We didn't look into the distortions yet. But there is a very clear pattern that the horizon appears lower the further you increase the altitude. So
can I jump in on that one quickly? I just want to give you a possible cause in some scenarios for that. Right? Because as we get higher, we can see much further. And when we can see much further, we have much more atmosphere to look through. And that atmosphere can form a blockage of the Earth in the distance. So it will make the apparent horizon look like it's much closer. And because you're looking at it from such a vast distance, right, it's going to look somewhat like a line, right, like a semi-distinct horizon line. But you've actually got an atmospheric deck of opacity, for lack of better terminology, right, blocking the what you could actually see, like when you could actually see further.
I see. So the distance to the horizon increases further as you increase in altitude, but increases less far than it should compared to perspective because of the opacity of air. So
no. There's a blockage, right, blocking you from seeing more land, right? So it's just the apparent location. It's just an apparent location where the sky and the ground meet. So you're still kind of, sort of, technically looking at a horizon, but there's a blockage there, right? You can't see it properly. Just kind of like if you've got like a mountain range, right? You're standing there and you've got a mountain range, and you can still see where the ground and the sky meet. But if the mountain range wasn't there, you could see further, right? Or like a cityscape.
I see. I see. So this is a very interesting explanation, and this makes sense to me so far. I can wrap my head around that. But if I introduce the third factor that I have observed personally with the horizon into this, then I kind of don't see how that keeps matching. And that is that while those two things that I've mentioned so far are true, it's also possible to, at the same time, see the top of a structure, more in details in the top of a structure, while a much larger base of it is not visible at the bottom. Now, if your explanation for it not rising to eye level or it dropping further below eye level, the higher you rise with the turbidity and the blockage to atmosphere was true, then I shouldn't be able to see that object that is beyond the horizon at all.
Yeah. Okay. So I think the problem is when you say beyond the horizon, that's not, you're just saying that you're going to see beyond the vanishing point, where anything.
Yeah, anything at a